All right, let's take a look at our quiz. For the first question, we're asked to solve each word problem. And so here we have when 2 is multiplied by the sum of 2 times a number. And whenever I see a number, I like to cross that out and just put x, y, z, whatever variable you want to use. Then we have and 3. The result is the same as. So I'm going to actually cross that out and put equals. We have 5 less than 7 times the difference of the number. So let's cross that out and put x again and 1. Then it says find the number. So I'm going to start out by just rereading through this with the x in there and the x in there and the equals in here and see if we can come up with an equation. So when 2 is multiplied by the sum of 2 times x and 3. So the sum of 2 times x and 3 is 2x plus 3. And we want 2 to be multiplied by that. Again, because this is a quantity, you want to wrap this in parentheses and put a 2 out there. I think this is the part here that trips up a lot of students. And then we have the equals here. We have over here 5 less than 7 times the difference of x and 1. So start with the difference of x and 1. So that's just x minus 1. I'm wrapping it because it's a quantity, and 7 is being multiplied by this quantity. And then we have 5 less than that, so I'm going to subtract away 5. Okay, so from here I'm going to multiply 2 times 2x. That's going to give me 4x. And then 2 times 3 would be 6, so plus 6. And this equals 7 times x would be 7x. And then 7 times negative 1 would be negative 7. And then subtract away 5. Okay, so over here I would do negative 7 minus 5. That's negative 12. And what I'm going to do is subtract 6 away from each side of the equation. Cancel that. Subtract 7x away from each side of the equation. Cancel that. And we'll have 4x minus 7x is going to be negative 3x. This is equal to negative 12 minus 6 is negative 18. Let's divide both sides of the equation by negative 3. This will cancel, and you're going to have x is equal to negative over negative is positive. 18 divided by 3 is 6. So this is the answer we want right there. The unknown number, or the number we're trying to find, is 6. Okay, let's look at the second question. So again, we're asked to solve each word problem. So when 3 is multiplied by the sum of 8 times a number. So let's cross that out and put x and 8. The result is the same as, I'm just going to put equals, 6 times the difference of 3 times the number. So I'm going to put x there, and 4. Find the number. So again, just read back through it. So when 3 is multiplied by the sum of 8 times x and 8. So this one's a little bit tricky. So you have 8 times x, that's 8x, and 8, again, you want a sum here, so that's why I have plus, and 3 is multiplied by this sum. Okay, so this is a quantity here, so make sure to use parentheses. This is the most common mistake, is to not use parentheses there when you set this up. So let's put equals. Then over here you have 6 times, so 6 times the difference of 3 times x and 4. So the difference of 3x, so 3x, and 4 is 3x minus 4. And again, 6 is multiplying by this difference of this guy, so this quantity. Okay, so let's move this down here a little bit. Before you start, if you want to make this a little bit easier, you can actually divide both sides of the equation by 3. So this would be gone, and this would be a 2. And if you don't want to do that, that's up to you if it's a little bit advanced for you, but it's just a little bit quicker. So you can just drop the parentheses here. So this would be 8x plus 8. This equals, here this would be 6x minus 8. Let's subtract 6x away from each side of the equation. That's going to cancel. And let me subtract 8 away from each side of the equation. And so let's actually cancel this. 8x minus 6x would be 2x. And this equals negative 8 minus 8 would be negative 16. Divide both sides of the equation by 2. Let's show this 2 as canceling. You're going to get x is equal to negative 16 divided by 2 is going to be negative 8. So this is the answer I want right there, negative 8. Okay, let's look at the third question. So again, we're asked to solve each word problem. And we're told when 3 is multiplied by the difference of a number, so let's cross that out and put x, and 5, the result is the same as, I'm going to put equals, negative 4 times the sum of the number, let's cross that out and put x, and 2. Find the number. So when 3 is multiplied by the difference of x and 5, so the difference of x and 5 is x minus 5, and 3 is multiplied by that, so that quantity, again, use parentheses there, it's very important. So we'll put equals here. Then you have negative 4 times the sum of x and 2. So negative 4 times the quantity x plus 2. So for this one, I'm going to distribute. So this is 3x minus 15. And this equals, this is negative 4x minus 8. Then from here, let's add 15 to both sides of the equation. That'll cancel. Then let's add 4x to both sides of the equation. And so this will cancel. So you're going to have 7x is equal to negative 8 plus 15 is going to be positive 7. Let's divide both sides of the equation by 7. You're going to get x is equal to positive 1. So we want this guy right there. All right, let's look at question 4. So we're asked to solve each word problem. So we see the quotient of a number, so let's cross that out and put x, and 3 added to 2 is the same as, let's cross that out and put equals, 15 less than 2 times the sum of the number, let's cross that out and put x, and 1. Find the number. So let's go through this again. So the quotient of x and 3, so x over 3, is added to 2, so plus 2. And we see that this guy is going to be equal to 15 less than. So I'm just going to put minus 15 out here because I know I need to subtract 15 away from something. We have 2 times, let me put 2 times, the sum of x and 1. So the sum of x and 1 is x plus 1. So this is a quantity, so make sure you use parentheses. So this is how we would set this up. I can multiply everything by 3 to clear this denominator here. So this would be a 6. Let me actually move this down here. And then this would be a 6. And then this over here would be a 45. Okay, so what I would do here is actually just subtract 6 away from each side of the equation now. Let's get rid of that. And so what I'm going to have is x is equal to 6x plus 6 minus 45 and then minus 6. So this 6 minus 6 is going to go away. This is basically 0. So what I'm going to do here is actually just subtract 6x away from each side of the equation. So that's going to cancel. And you're going to have negative 5x is equal to negative 45. Let's divide both sides of the equation by negative 5. That will cancel. You'll get x is equal to negative over negative is positive. 45 over 5 is 9. So 9 is what we're looking for. All right, for question 5, again, we want to solve each word problem. So the quotient of a number, again, that's x, and 7, less 3 is the same as, so let's cross that out and put equals, 41 added to the number, let's put x there, divided by 2, less 2 times the difference of the number, let's put x, and 1. Find the number. Okay, so let's start with the quotient of x and 7. So that's x over 7, and then less 3. So that just means subtract away 3. This is equal to, you have 41 that's added to. So I'm going to put 41 and then plus. You have x divided by 2. So this is just x over 2 like this. Then we have less 2 times, so minus 2 multiplied by, let me actually slide this down a little bit, the difference of x and 1. So the difference of x and 1 is x minus 1. Again, this is a quantity, so you need to use parentheses. So the LCD here would be 14. Maybe I don't want to do that just yet because I'd probably be better off cleaning up first. Let me go x over 7 minus 3 is equal to 41 plus x over 2. Let me distribute this. So this is negative 2x. And then this is going to be plus 2. So let me clean up so there's just less stuff to do. 41 plus 2 is going to be 43. So let's put this here as plus 43. Let me actually make that a little bit better here. And then over here, let's just add 3 to both sides. Let's put 3 over here like this. Get rid of this. So this would be 46. So now if you want to clear the denominators, let's multiply everything by 14. So multiply this by 14. This cancels. It gives me 2. So this is 2x over here. So this over here will be 2x. I'm going to multiply this by 14. So 14 times this. This would cancel and give me a 7. So this is 7x. This is 7x. Now let me actually subtract that away from this side and subtract that away from this side so it would cancel. I'm just going to erase it. Let me actually scooch this down a little bit more. So I'm going to multiply this by 14 and this by 14. So 14 times negative 2x would be negative 28x. So this would be minus 28x. I'm going to add that to both sides of the equation. So I'm going to put 28x over here like this. Let's get rid of that. And then 46 times 14 is going to be 644. So let's put 644. Let me slide this down a little bit. Let's work through this. So 28 plus 2 is 30. 30 minus 7 is going to be 23. So this would be 23x here. So 23x is equal to 644. Let's divide both sides of the equation by 23. This will cancel. You're going to get x is equal to, let's punch that into the calculator. So 644 divided by 23 is going to give me 28. So this is the answer we want right there. All right, let's take a look at our quiz. For the first question, we're asked to solve each word problem. And we're given here that 3 consecutive integers have a sum of 78. And then we want to find the integers. So a very simple problem overall. Remember that consecutive integers differ by 1. So something like 15 and 16, or let's say 81 and 82, you always can just add 1 to get to the next one. So if I start with, let's say, x, well, that could be my smallest. So I'm just going to put SM for smallest. And then the next one, I would just add 1. So x plus 1, this would be the middle. I'm just going to put MI for that. And then the largest would need to be x plus 1 and then plus another 1, so x plus 2. So x plus 2 we'll say this is the largest. I'll just put LG. So the idea here is that we're told that the sum, let me highlight that, the sum is going to be 78. So all I need to do is add x to x plus 1 to x plus 2, set that equal to 78, and solve, and I'll know what the smallest one is, and then I can figure out what the middle one is, and then the largest. So let's go x plus 1 plus x plus 2. Again, set this equal to 78. Let me slide down here. And so x plus x would be 3x. And then plus 1 plus 2 is 3. And this equals 78. Let's subtract 3 away from each side of the equation. Let's cancel this. We're going to have 3x is equal to 78 minus 3 is going to be 75. Let's divide both sides of the equation by 3. And so this would cancel. You're going to get x is equal to 75 divided by 3 is 25. Okay, so that's the smallest one. So this is going to be 25, right? That's the smallest one. Then the middle one is 26, and then the largest one is 27. And again, you can do this on your calculator. 25 plus 26 plus 27 is going to give you 78. So we're looking for this answer right here. Okay, let's look at question 2. Again, we're asked to solve each word problem. So we have here that 6 consecutive even integers have a sum of 162. Find the integers. So you have to know that when you work with consecutive even integers or consecutive odd integers, they differ by 2. So in other words, with consecutive even integers, let's just start with something like 2, then you go to 4, then 6, then 8, then 10, so on and so forth, but you're differing by 2 here. To go from 2 to 4, I add 2. Then to go from 4 to 6, I add 2. I just keep adding 2 to get to the next even integer. So knowing that, you could start with something like x to be the smallest, and then the next guy would be x plus 2, and then you just keep adding 2. So then you would have x plus 4, and then you would have x plus 6, and then you would have x plus 8. So this is 1, 2, 3, 4, 5. So I need one more, so then x plus 10. And again, getting an equation going, you're told that the sum is 162. So let me highlight this again, the sum of 162. So you need to add all these together, and let's just do this the long way. I know it's quicker if you just kind of eyeball it and do it, but let's just do it the long way. So x plus 2 plus x plus 4 plus x plus 6 plus x plus 8 plus x plus 10. Okay, I'm going to set this equal to 162. So I already know that there's 1, 2, 3, 4, 5, 6 of the x's. So this is 6x, then plus 2 plus 4 is 6, plus 6 is 12, plus 8 is 20, plus 10 is 30. So this is 30. This equals 162. A very easy equation to solve. Let's subtract 30 away from each side of the equation. And so this right here is going to cancel. And what we have here is 6x is equal to 162 minus 30 is going to be 132. And so to finish this up, let's divide both sides of the equation by 6. And so this is going to cancel. And what we're going to have here is x is equal to 132 divided by 6 is going to be 22. Okay, so this is the smallest one. So coming back up here, this is 22. Then again, you're just adding 2 each time. So this would be 24. This would be 26. This would be 28. This would be 30. And lastly, this would be 32. Let me make this 3 a little bit better. Actually, the whole thing. So let's make the 30 there a little bit better. So coming through and looking at my answers, I want this guy right here. Again, 22, 24, 26, 28, 30, and 32. If you take the time to punch up the sum on the calculator, you will get 162. All right, let's look at a similar problem now. So for question 3, we're asked to solve each word problem. And now we have 4 consecutive odd integers summed to negative 144. Find the integers. So again, consecutive odd integers or consecutive even integers, they differ by 2. So you'd have something like 1, then 3, then 5, then 7, then 9, so on and so forth, but they differ by 2. Okay, so that's what we're looking for. So what we would do again, just like we did in the last one, so x, then you would have x plus 2, and then again, you would add 2 again. So if I added 2 to this, I would get to x plus 4. So x plus 4, then x plus 6. I just keep adding 2. So this is 1, 2, 3, 4 of these guys. And again, we're just going to sum this and set it equal to, in this case, it's going to be negative 144. So x plus 2 plus x plus 4 plus x plus 6 is equal to negative 144. So it's 1, 2, 3, 4 of the x's. So let's put down here that we have 4x. Then 2 plus 4 is 6. 6 plus 6 is going to be 12, so plus 12. And this equals negative 144. Let's subtract 12 away from each side of the equation. That's going to cancel. And so we'll have 4x is equal to negative 144 minus 12 is going to be negative 156. Let's divide both sides of the equation by 4. And so we'll have x is equal to, let me show this is canceling. We know this is negative. 156 divided by 4 is going to be 39. So x here is negative 39. So this guy is going to be negative 39. And then I'm just going to keep adding 2. So this would be negative 37. And this would be negative 35. And then lastly, this would be negative 33. So we're looking for this one right here. So negative 39, negative 37, negative 35, and negative 33. This is the answer we want. Again, if you take the time to find the sum, you will get negative 144. All right, let's take a look at question 4. So we're asked to solve each word problem. So we have 5 consecutive multiples of 8 sum to 400. Find the multiples. All right, so hopefully you remember the definition of a multiple from pre-algebra. So a multiple of a number is the product of the number and an integer. But generally speaking, when we generate a list, we would start with something like 8 times 1. So this is 8. Then I would do something like 8 times 2, that's 16. Then 8 times 3, this is 24. Then 8 times 4, this is 32. Then let's say 8 times 5, this is 40. And you can keep going forever and ever and ever. So the idea here is that we have 5 consecutive multiples of 8. Okay, so here, let's say something like 8, then 16, then 24, then 32, then 40. This would be 5 consecutive multiples of 8. Okay, and we want this such that the sum is 400. So how are we going to figure this out? So what we need to do is actually think about the number here, the integer that is multiplying 8. And I'm going to start with the smallest one. So for example, I'm just going to say the smallest one is x. And then the next one in the sequence, I'm just adding 1 each time. So then I'm going to have x plus 1, then x plus 2, then x plus 3. And then lastly, because there's 5 of them, I would have x plus 4. So again, if you started here, and these are not the integers we're looking for, but if I started here just going through, I'd have 1, then add 1 to get to 2, then add 1 to get to 3, then add 1 to get to 4, then add 1 to get to 5. Okay, so that's basically the idea here. And in each case, notice that you have to multiply by 8 to get that multiple. So that's exactly what we're going to do here. And so I'm going to start with 8x, and then I'm going to have 8 times the quantity x plus 1, and then 8 times the quantity x plus 2, and then 8 times the quantity x plus 3, and then I'll finish up with 8 times the quantity x plus 4. Okay, so the idea here is we're going to add these guys together, and the sum is going to be 400. So let me actually just erase these commas here, and I'm just going to put some addition signs in here. And hopefully you don't go through and distribute this in each case, because you can obviously factor out an 8. If you don't notice that, it's okay. It's not that big of a deal. But you can factor this out here, okay? And let me set this equal to, again, coming back up here, the sum was supposed to be 400. So let's put 400 here. Okay, so pulling the 8 out in front of parentheses will give me the x plus 1 plus x plus 2 plus x plus 3 plus x plus 4. And this equals 400. Before I do anything, you could divide both sides of the equation by 8. So let me divide this side by 8 and divide this side by 8, just to make it simpler. So this would cancel. 400 divided by 8 is 50. So let's write, and I'm just going to go x plus x is 2x, plus another x is 3x, plus another x is 4x, plus one more x is 5x. So 5x, and then plus 1 plus 2 is 3, plus 3 is 6, plus 4 is 10. So plus 10 is equal to, again, 400 divided by 8 is 50. And now it's a really simple equation to solve. Let's subtract 10 away from each side of the equation. This cancels. You're going to get 5x is equal to 40. Divide both sides of the equation by 5. Let me make this 5 better. And so this is going to cancel. And we're going to find that x is equal to 40 divided by 5 is going to be 8. Now, what does that tell me? Let's go back up. Again, if x is 8, so if this is 8, then the next one is going to be 9, then this is 10, then this is 11, and this is 12. But this doesn't answer our problem, right? Because again, we want 5 consecutive multiples of 8. So we would have to start with 8 and multiply by 8. Then we'd have 9 times 8. Then we'd have 10 times 8. Then we'd have 11 times 8. Then 12 times 8. So in other words, this guy right here, 8 times 8 would be 64. Then you would have 8 times, in this case 9, that's 72. Then you would have 8 times 10, that's 80. Then you would have 8 times 11, that's 88. Then you would have 8 times 12, that's going to be 96. So what we're actually looking for is this right here. You have 64, 72, 80, 88, 96. Again, you can sum those numbers on your calculator. You'll see that you will get that 400 right there. Okay, let's look at question 5. So again, we're asked to solve each word problem. So there are 3 consecutive odd integers such that twice the smallest added to 3 times the largest is the same as 15 less than 4 times the sum of 2 and the middle integer. Find the integers. So again, we have 3 consecutive odd integers. So x, and then x plus 2, and then x plus 4. So this is the smallest, this is the middle, this is the largest. So we say that there are 3 consecutive odd integers such that twice the smallest. So what is twice the smallest? That's going to be 2x added 2, so plus 3 times the largest. The largest is x plus 4. So 3 times the quantity x plus 4, make sure you use parentheses there, is the same as, that's equals 15 less than. So I'm going to subtract away 15 from something. 4 times the sum of, so 4 times, I'm going to have some sum. Let me slide this down a little bit. So the sum of 2 and the middle integer. So I'm summing the middle integer, which is x plus 2, and then plus 2. So I might as well write this as x plus 4. Let's just put this as x plus 4 like this. And so from here, I'm just going to solve this equation. So we would have 2x, and then plus, let me fix this 2 real quick. We have 3x, and then plus 12. This equals, this is 4x, and then plus, this doesn't look very good, so let's fix this 4 here. So 4x plus, this would be 16, and then minus 15. So 16 minus 15 is 1, so let's just erase that. 2x plus 3x is going to be 5x. So let's erase this and put a 5x here. And what I can do is just subtract 4x away from each side of the equation. So that's going to cancel. 5x minus 4x is going to give me x. Let me subtract 12 away from each side of the equation. That's going to cancel. So this equals 1 minus 12 is negative 11. Okay, so this is going to be negative 11. And then add 2, you're going to get negative 9. And then if you add 2 again, you're going to get negative 7. Let me make this 9 better. Okay, so thinking about if this works out, there are 3 consecutive odd integers such that twice the smallest, so 2 times negative 11 is negative 22, added to 3 times the largest. So 3 times negative 7 is going to be negative 21. So if I add those 2 together, I'm going to get negative 43. So this is negative 43. Then we have is the same as. We have 15 less than. So again, I'm subtracting 15 away from something. 4 times the sum of 2 and the middle integer. So the sum of 2 in the middle integer. So the middle integer is negative 9. If I add 2, I get negative 7. And I want 4 times negative 7. That's going to be negative 28. So if I do negative 28 minus 15, I am going to get negative 43. So we see that we have a match here. The left side is exactly equal to the right side. So the 3 integers we're looking for, it's going to be negative 11, negative 9, and negative 7. All right, let's take a look at our quiz. So for question 1, we're asked to solve each word problem. We have that Betty and Samantha are siblings whose combined age is 51. 1 year ago, Samantha was 2/3 as old as Betty is today. Find the age of Betty and Samantha. So what I'm going to do is let a variable like x be equal to, I'm going to use Betty's current age. I think that's a little bit easier. So I'm going to go BET for her current age. Again, you can write it all out if you want. I'm just going to use abbreviations here to make it quicker. And then for Samantha, how can we model her current age? Well, it says here that a year ago, Samantha was 2/3 as old as Betty is today. Let's start with the 2/3 as old part. So 2/3 as old as Betty is today. Well, Betty's current age is X. So I would just want 2/3 X. But this is not going to represent Samantha's current age because this is her age 1 year ago. So to get to the current time period, I need to add a year to this. So I need to go plus 1. So this would represent Samantha's current age. So let me put SAM for Samantha there. And then from here, we just need to figure out how to get an equation. And it tells us the combined age is going to be 51. So really all I have to do is say X plus 2/3 X plus 1 is equal to 51. Let me make this better. And what I can do is subtract 1 away from each side here to get things started. You'll have X plus 2/3 X is equal to 51 minus 1 is 50. Let me multiply everything by 3 so I can clear that denominator. So I would have 3x plus 2x is equal to 150. Again, just multiply everything by 3 there. 3x plus 2x is going to be 5x. So this would give me 5x is equal to 150. Let's divide both sides of the equation by 5. And so this cancels. You'll get x is equal to 150 divided by 5 is 30. So x is 30. Remember, that's Betty's age. So this is going to be 30. And then 2/3 times 30. 30 divided by 3 is going to be 10. 10 times 2 is 20. Then plus 1 is 21. So this is 21 for Samantha. So I'm looking for this answer right here where Betty is 30 years old and Sam or Samantha is 21 years old. Okay, let's look at question 2. Again, we're asked to solve each word problem. And now we have that 3 classmates, Jackie, Mason, and Parker, have a combined age of 48 years. 1 year ago, Mason was the same age as Jackie is today. Jackie is 4 years older than Parker. Find the age of Jackie, Mason, and Parker. Okay, so let's think about this. When you have more than 2 names involved, then what you usually want to do is think about the person that's involved in each comparison. So you have Mason and Jackie, and then you have Jackie and Parker. So I'm going to use Jackie. So I'm going to say that we're going to let X be equal to, let's just do we'll write the name out. So Jackie like this. And this means her current age. I'm not going to write it all out. And then if I want to model Mason's age, it says 1 year ago, Mason was the same age as Jackie is today. So that basically means that Mason is a year older than Jackie. So what I'll say here is then we'll say X plus 1 is equal to Mason's current age. So Mason's age, or actually let me just put Mason here. And then for the other one, it says Jackie is 4 years older than Parker. So that means that Parker is going to be 4 years younger than Jackie. So I can say then X minus 4 is going to be Parker's current age. I'm just going to put Parker. All right, now it says that the combined age is 48 years. So let's take these guys. So the age of Jackie is X, plus the age of Mason is X plus 1, plus the age of Parker. Let me make this 4 a little bit more clean. The age of Parker is X minus 4. This should be equal to 48. So then X plus X plus X is 3X. And then you have 1 minus 4, that's minus 3. And this equals 48. What we're going to do from here is add 3 to both sides of the equation. And so let's cancel this. And so from here, let's go 3x is equal to 48 plus 3 is going to be 51. To finish this up, let's divide both sides of the equation by 3. This would cancel. And we're going to get x is equal to 51 divided by 3 is 17. So x was the age of Jackie. So remember, this is 17. Add 1 to this to get the age of Mason. So he's going to be 18. And then for Parker, it's 17 minus 4 or 13. So we have Jackie is 17, Mason is 18, and Parker is 13. So I want this one right here. Again, Jackie is 17 years old, Mason is 18 years old, and Parker is 13 years old. All right, let's look at question 30. Again, we want to solve each word problem. So on a field trip, a teacher is trying to determine the age of 3 students. We have Aya, Molly, and Mary. She is told that 4 years ago, Aya was the same age as Molly is today, and Aya is 2 years older than Mary. Additionally, she knows that the difference of Aya's current age and Molly's current age is the same as Mary's age 9 years ago. Help the teacher find the age of the 3 girls. So when you have a problem like this again, if you look at the comparisons, you have Aya and Molly, and then you have Aya and Mary. So I'm just going to start by saying I'm going to let x be equal to Aya's age. Because again, she's involved in both comparisons. Instead of putting Aya's age, I'm just going to put Aya. I think we know what this means. So then coming to the next guy here, it first tells me that 4 years ago, Aya was the same age as Molly is today. So that means that Aya is 4 years older than Molly, or Molly is 4 years younger than Aya. So we'll say x minus 4 is going to represent Molly's current age. So I'm just going to put Molly there. And then, additionally, what can we say about Mary? Well, it says that Aya is 2 years older than Mary. So we can say then x, which is Aya's age, minus 2, because again, she's 2 years older. So I need to subtract away 2 to get to Mary's current age. So this is going to be for Mary's current age. All right, now to get an equation going, it tells us that additionally, she knows that the difference of Aya's current age and Molly's current age. So let's stop there. The difference of Aya's current age, so that's x, and Molly's current age is x minus 4. Now you have to use parentheses here. So minus the quantity x minus 4. If you don't do this, you're going to get the wrong answer. You have to subtract away the whole quantity because this is Molly's current age. It says is the same as, which means equals, Mary's age 9 years ago. So how old was Mary 9 years ago? It was x minus 2, and then I need to subtract away 9 from that. This is her current age. Take away 9 more. That gets you to her age 9 years ago. So let's just solve this real quick. We'll come back up and get the answer. So this would be x minus x and then plus 4. Again, I'm just distributing this negative to each term inside the parentheses. If you need to go plus and put a negative 1 there and distribute it like that, it's really up to you. So then over here, I'm just going to have x minus 2 minus 9. Okay, so x minus x, that's going to cancel. So really, I just have 4 is equal to. So you'd have x and then negative 2 minus 9 would be negative 11. So let me add 11 to both sides of the equation, and you basically have 15 is equal to x, or you could say x is equal to 15. Okay, so that means that Aya is 15 years old, Molly is 4 years younger, so she is going to be 11 years old, and Mary is 2 years younger than Aya, so she is going to be 13 years old. So Aya is 15, Mary is 13, and Molly is 11. We want this answer right here. Okay, let's look at question number 4. So it says to solve each word problem, we have that Stephen, Leslie, and Natalie are joint business owners. 10 years ago, Stephen was twice as old as Natalie is today. 5 years ago, Leslie was 1.5 times as old as Natalie is today. If the difference of Steve's age and Natalie's age is the same as Leslie's age 5 years ago, what is the age of each person? All right, so let's think about this. We have, again, with the comparisons, you have Stephen and Natalie, and then you have Leslie and Natalie. So again, my choice here, to make it easy on myself, is just to let x be equal to Natalie's current age. I'm just going to put NAT for that. So then let's go to the next person here, and I'm just going to use the first comparison. So it says 10 years ago, Stephen was twice as old as Natalie is today. So how old is Natalie today? She's X years old. What is twice as old as that? It's 2X. But again, this is going to be 10 years ago. So I need to get this to the current time frame. So what I need to do is add 10. So I'm going to go plus 10, and this will be equal to Stephen's current age. So I'm just going to put just put Stephen, I guess. That would be fine. So we have 5 years ago, Leslie was 1.5 times, or you could say 3/2, as old as Natalie is today. So again, I'm just going to put then. I'm going to start with what is 1.5 or 3/2 times as old as Natalie is today? Well, she's currently X years old, so I'm going to put 3/2, or again, you could put 1.5 if you want, 3/2 X, but this does not represent how old Leslie is today. This is 5 years ago. So what I have to do is add 5 to get to the current time period, okay? So this is going to be for Leslie, so Leslie. Okay, so that's her current age. Now, to get an equation going, it says if the difference of Stephen's age and Natalie's age. So let's stop. What is Stephen's age? It's 2x plus 10. And then what is Natalie's age? That's x. I'm just subtracting away x. It says is the same as. That means equals Leslie's age 5 years ago. Well, Leslie right now is 3/2 x plus 5. Well, 5 years ago, we just subtract away 5, and we'll go back to this. We'll just get rid of that right there. Okay, so let's solve this really quickly. So what I'm going to do is say 2x minus x. Let's just do this in line. This would just be x. And let me actually just subtract 10 away from each side of the equation. So this is over here. So this is gone. And what I want to do is clear this denominator. So multiply everything by 2. So this would be 2x. This would be 3x. Let me bring the 3 down in line. And this would be negative 20 here. And so what I'll do is subtract 3x away from each side of the equation. So this would cancel. I'm actually just going to erase it and write this as negative 20 here on the right. 2x minus 3x would be negative x. So to finish this up, you could divide both sides by negative 1 or multiply both sides by negative 1, but basically it just changes the sign of each. So you get x is equal to 20. We could say that Natalie is 20 years old. Stephen is what? 2 times 20 is 40, plus 10 is 50, so he's 50 years old. And then Leslie, if we have 20 divided by 2, that's 10. 10 times 3 is 30, and 30 plus 5 is 35. So she is going to be 35 years old. So the age of each person will say Natalie is 20, we say Stephen is 50, and Leslie is 35. So we want this answer right here. Okay, let's look at question 5. Again, we want to solve each word problem. So 3 partners, Jim, Mike, and Alvin, are trying to guess the ages of each other. They find out that in 3 years, Mike will be the same age as Jim is today, whereas in 2 years, Alvin will be half as old as Jim is today. Additionally, they know that the difference between Jim's age and Mike's age is 1/6 the age of Alvin. Find the age of Jim, Mike, and Alvin. So again, when I think about this, I'm looking for, we have here Mike and Jim, and then we have Alvin and Jim. So I'm going to let x be equal to Jim's current age. Again, I'm just going to write Jim for short. And then when we think about this, it says that in 3 years, Mike will be the same age as Jim is today. Well, that means that Mike is going to be 3 years younger than Jim. So I'll just say then, take Jim's age, which is x, subtract away 3. That's going to be Mike's age. So I'm just going to put Mike for that. And then the other guy is going to be Alvin. So let's figure him out. So it says in 2 years, Alvin will be half as old as Jim is today. Well, if I think about half of Jim's current age, that's 1/2 x. But again, this is not going to be Alvin's current age because it says this is going to be in 2 years. So this guy right here would be his age in 2 years. So I need to subtract away 2 from this to get back to the current time period. Okay, so let's put this as Alvin's current age. I'll just put Alvin for that. And then to get an equation going, it just tells us that the difference between Jim's age and Mike's age, so Jim and Mike. So you have x minus, again, use parentheses, x minus 3, this quantity. It says is, so that's equals 1/6 the age of Alvin. So 1/6 multiplied by the age of Alvin, which is 1/2 x minus 2, this quantity. We see that we would have x, again, this is going to change the sign of each term. If you need to go plus -1 and distribute this, that's up to you. This would be minus x and then plus 3. And this equals, let's distribute this. This would be 1/12 x. And then we would have minus 2 and then 6. There's a common factor of 2. So this would be 1/3. Okay, so you could clear the denominator at this point. I think it's probably easier just to get rid of this first. And that way we don't have that. And the LCD here would be 12. So multiply everything by 12. This would be 36 is equal to, this would be x, then minus 12 times 1/3 would be 4. So from here, I'm just going to add 4 to both sides of the equation. And so what I'm going to get is x is equal to 40. Okay, so Jim is 40 years old. Mike is going to be 37. 40 minus 3 is 37. And Alvin, 40 times 1/2 is 20. Then minus 2 is 18. So Alvin's 18 years old. So we see that our answer here is that Jim is 40. We have Mike is 37 and Alvin is 18. So we want this guy right there. All right, let's take a look at our quiz. For the first question, we're asked to solve each word problem. What we have here is an Air Force plane left Nairobi and flew toward Jakarta at an average speed of 155 miles per hour. A cargo plane left sometime later, flying in the opposite direction with an average speed of 260 miles per hour. After the Air Force plane had flown for 5 hours, the planes were 1,815 miles apart. Find the number of hours the cargo plane flew. All right, so to set this up, I would use a table if you're struggling. So on the next page, I put a little table here. It's blank. We're just going to put the distance formula in. So I'm going to put D for distance is equal to R for rate times T for time traveled. Okay, so when we think about it, we have an Air Force plane and a cargo plane. So let me put A period, F period for the Air Force plane. And let me just write out cargo for the cargo plane. And let's just fill in the table and see if we can get an equation going. So coming back and thinking about this, we are given the rate for each plane. So for the Air Force plane, it's given to us as 155 miles per hour. So it's right there. And then for the cargo plane, it's given to us as 260 miles per hour. So let's fill in the table. So this is 155 miles per hour, and this is 260 miles per hour. Now, in terms of the time, for the Air Force plane, it's given. So it says after the Air Force plane had flown for 5 hours, so it's going to be 5, the planes were 1,815 miles apart. So the time here for the Air Force is going to be 5. Now, what's the time for the cargo plane? Let's go back. Well, that's what we're expected to find. It says find the number of hours the cargo plane flew. So let's let x be equal to that. Let x be equal to the number of hours for the cargo plane for the, we'll say cargo plane. And if you want to make that short, just put number of hours cargo, or maybe just put cargo. You know what it means. So I'm going to go back and just put x there. So we're going to put x here. Now, we know how to get the distance. We just multiply across. So 5 times 155 is 775. So that's the distance for the Air Force plane. And then for the cargo plane, it's 260 times x, or just 260x. Now, in some of these problems, you end up setting the distances equal to each other. In other problems, you have to sum them and set it equal to a number. So what type of problem do we have? Let's go back up. If we think about it, in this case, what we have is they're flying in the opposite direction. So in other words, let's say this is the starting point. One is going this way and one is going this way. And it doesn't have to be left or right, but I'm just giving you an illustration. In other words, at the end of the day, the distance between the two has to be 1,815 miles. So in other words, measuring from here, where one plane is, to here, where the other plane is, again, they went in opposite direction, that's 1,815 miles. So you take the distance from one of them plus the distance from the other, it should sum to that amount. So if we come back, I'm going to take this 775, which is the distance for the Air Force plane, then plus this 260x, which is the distance for the cargo plane, and I'm going to set this equal to 1,815. All right, if you want to work with smaller numbers like I do, I would divide everything by 5 just to make it easier. You don't have to do this. Of course, if you're using a calculator, it's probably a waste of time. But I'm just going to do it. I'm going to divide everything by 5. So this would be 155, then plus, this would be 52x, and this equals, this would be 363. All right, so from here, let's subtract 155 away from each side of the equation. And so this is going to cancel. Over here, we would have 52x is equal to 363 minus 155 is going to give me 208. And then to finish this up, let's divide both sides of the equation by 52. And so we know that this guy right here is going to cancel. And we'll get x is equal to 208 divided by 52 is going to give me 4. So coming back up here, x was the number of hours for the cargo plane to fly, and that's going to be 4 hours. So this is the answer we want right there. Let's take a look at question 2 now. Again, we want to solve each word problem. And so Matt and Jack left the Science Museum at the same time. They traveled in opposite directions. We have that Jack traveled 20 miles per hour faster than Matt. After 5 hours, they were 400 miles apart. Find Matt's speed. Before I do anything, let me just let x be equal to exactly what we're trying to find, which is Matt's speed. So Matt's speed. And we're just going to bring that down to the table. We know Matt would be going at a rate of speed of x. And then in terms of Jack, he's going 20 miles per hour faster than Matt. So it's going to be x plus 20. So let's go down. Let's fill this in with Matt. And let's fill this in with Jack. Let's say this is distance is equal to rate of speed times time traveled. And again, we said x was going to be Matt's average speed in miles per hour. And Jack is going 20 miles per hour faster than Matt. So let's put this as x plus 20. Okay, let's go back up and let's think about our time. So it tells us that Matt and Jack left the Science Museum at the same time. Then over here it says after 5 hours, okay, they were 400 miles apart. So the time for each person is going to be the same. It's going to be 5. So let's put a 5 here and a 5 here. And we know how to find the distance. We just multiply. So the distance here is 5x. The distance here is 5 times the quantity x plus 20. Now again, am I in a situation where I need to set the distances equal to each other, or do I need to sum them and set it equal to some other amount? Let's go back up. And what does it say? It says, again, they traveled in opposite directions. So just like the last problem, we're going to sum the distances and we're going to set it equal to this amount here, where it says they were 400 miles apart. Let's come back and we'll say 5x plus 5 times the quantity x plus 20 is going to be equal to 400. Again, you don't have to do this, but I'm going to divide everything by 5 just to make my life easier. So this would be x plus, this would be x plus 20, and this will be equal to, this would be 80. Okay, so x plus x is 2x, so we'll have 2x, and I'm just going to subtract 20 away from each side of the equation. So this will be equal to 80 minus 20 would be 60. Let me actually show this as canceling so nobody gets lost. And we'll move this down here. Let me make that a little bit better. To finish things up, let's divide both sides of the equation by 2. This cancels. You get x is equal to 60 over 2 is 30. So x is 30. And again, that's Matt's speed, and that's what we're trying to find. So it's going to be 30 miles per hour. Okay, let's look at question 3. Again, we want to solve each word problem. And so a jet flew to Jacksonville and back. The trip there took 4 hours, and the trip back took 5 hours. So what was the jet's average speed on the trip there if it averaged 156 miles per hour on the return trip? So in this particular case, what we'll do is we'll let x be equal to the speed on the trip there. So I'm just going to put speed, and we'll just go maybe there. Again, you can make the notes for this when you're writing out your problem on your own as detailed as you want. I'm just trying to maybe put something that's more concise. And I can't make the e's today, so let me try to make that one more time. So the speed there. So let's go ahead and fill out our table. Let's go down here. Again, we're going to have distance is equal to the rate of speed times the time traveled. And then really the scenarios we have the trip there, and then we have the trip back. Now let's go up and let's see if we can fill this out. So the trip there took 4 hours. So we know that. And also the speed there is x. So the speed there is x and the trip is 4 hours there. So the distance is 4x. And then in terms of going back, it says that it took 5 hours and it averaged 156 miles per hour. So this is 5 and this is 156. If we multiply the two together, it's going to give me 780, again for 780 miles. Now, how do we get an equation going? Well, think about it. A jet flew to Jacksonville and back. So the distance is the same. And I know in the real world, a jet might take an alternate route going there versus coming back. But for the sake of our word problem, we're just going to assume that the distance is the same each way. And so we're going to set the distance for the trip there equal to the distance from the trip back. And then we'll solve that and we'll have our solution. So we'll take the 4x and set that equal to 780. Very simple equation to solve. We're just going to divide both sides of this equation by 4. We're going to get x is equal to, let me show this is canceling. 780 divided by 4 would be 195. So coming back up here, we want this one right here, which is 195 miles per hour. Okay, let's look at question 4 now. So we're asked to solve each word problem. So we have Stephanie traveled to the recycling plant and back. It took 1 hour less time to get there than it did to get back. The average speed on the trip there was 75 miles per hour. The average speed on the way back was 60 miles per hour. How many hours did the trip there take? So again, I'm just going to let x be equal to what we're trying to find. So x is equal to the number of hours, and I'm just going to put there. Okay, again, you can make your notes as detailed as you want. So let's go down here and fill out the table. So distance is equal to rate times time. And again, we have there and back. So there and back. And we already know for this type of problem, we're going to set these two distances equal to each other and we're going to solve, just like in the last example. So let's go back and let's see if we can fill everything out. So the speed on the trip there was 75 miles per hour and the time is x. So it's 75 and then x. So this is 75x. And then for back, we have 60 miles per hour and it says it took 1 hour less time to get there than it did to get back. So to reverse that, when you're going back, it takes an hour more. So if it takes x hours to get there, it's going to take x plus 1 hours to get back. Let's go 60 for the rate, and let's go x plus 1 for the time to get back. Again, it's 1 hour more than the trip there, or you could say the trip there is 1 hour less than the trip back, however you want to think about it. So we'd multiply here. This is 60 times the quantity x plus 1. And again, because it's the same distance in each case, we're just going to set these two guys equal to each other. So I'll say that 75x is equal to 60 times the quantity x plus 1. All right, so I'm going to divide everything by 15. So 75 divided by 15 is 5. So this would be 5x is equal to 60 divided by 15 is going to be 4. So this would be 4 times the quantity x plus 1. Again, not necessary, but I like to work with smaller numbers. So this would be 5x is equal to 4x plus 4. And so what we do from here is subtract 4x away from each side of the equation. And so this is going to cancel. And then from here, 5x minus 4x is x, and this equals 4. Okay, coming back up here, again, x is the number of hours that it took to get there, and that's what we're trying to find. So this is going to be 4 hours. All right, let's look at question 5. So again, we want to solve each word problem. So here we see that Daniel left the Candy Shack restaurant and drove toward the state park. 1 hour later, Jacob left the same restaurant driving at 60 miles per hour in an effort to catch up to Daniel. After driving for 3 hours, Jacob finally caught up. What was Daniel's average speed? So once again, I'm going to let x be equal to Daniel's. So Daniel's, and let me make this e a little bit better. So Daniel's average speed. Okay, that's what we're trying to find. Let me make this e better. Now let's go down, set up the table. We have distance is equal to rate of speed times time traveled. Now we have two guys there. We have Daniel, let's just put Dan. And then we have Jacob, let's just put JAC for short. And then let's go back up. For Jacob, he drives for 3 hours and at 60 miles per hour. So for Jacob, the time again is 3 for 3 hours and the rate is 60 for 60 miles per hour. 60 times 3 is 180, so he drives 180 miles. Then for Daniel, his speed is represented with x. In terms of the time, if we read this part right here, it says 1 hour later, Jacob left. Okay, so if Jacob left an hour later, that means he drives for an hour less than Daniel does, right? Or you could say Daniel drives for an hour more. Let's use x for the rate. And then for the time, I'm going to add 1 hour to Jacob's time. And so 3 plus 1 would give me 4. And so this would just be 4x right here. Now, again, we have a scenario where the distances are going to be equal because, again, here you have a situation where they leave from the same place and they catch up. Okay, so that's the key part right here where it says in an effort to catch up, right? So after driving for 3 hours, Jacob finally caught up. So they left from the same place and they catch up. So they drive the same distance. Let's come down. And so what we'll do, again, is just set these two guys equal to each other. So 4x is equal to 180. Let's divide both sides of the equation by 4. This will cancel. And so you'll have x is equal to 180 divided by 4 is going to give me 45. So Daniel's average speed, again, that was represented with x, that's going to be 45 miles per hour. So this is what we want right here. All right, let's take a look at our quiz. For the first question, we're asked to solve each word problem. So we have how much of Kyle's fruit punch, which is 10% fruit juice, must be mixed with 3 gallons of Steven's fruit punch, which is 50% fruit juice, to create a mixture containing 25% fruit juice. Okay, so as you saw before, I like to make a table for these just to organize the information. The main idea here is you have 3 guys here. So Kyle's fruit punch, you're going to have Steven's fruit punch, and then you have your final mixture. So let's go down here to the table, and I'm just going to write Kyle here, and then I'm going to write Steven here, and then I'm going to write mixture here. So this is the end result. So generally when you set up a table, you want some sort of unit of measurement. So in this case, we're working with gallons. So I'm just going to put gallons here, and we're going to go back, and we see that the question actually asks us how much of Kyle's fruit punch we're going to use, but it tells us specifically that there's going to be 3 gallons of Steven's fruit punch that's being used. So let's put in here that for Steven's fruit punch, it's going to be 3 gallons. For Kyle's fruit punch, let's say we're going to use X gallons. And then for the mixture, we're adding this one with this one. So it would be X plus 3 gallons. Let me make this 3 a little bit better. Now, we want to think about the amount of pure fruit juice that's going to be in each one of these guys. So I'm going to put a percentage here, and this is going to be for the percent of fruit juice, and we're going to write this as a decimal. So let's go back, and it tells us that Kyle's fruit punch is 10% fruit juice. It tells us that Steven's fruit punch is 50% fruit juice, and the mixture is going to be 25% fruit juice. So this will be 0.1, this will be 0.5, and this will be 0.25. So again, I'm just writing these as a decimal. And then we would go through, if we want to find the amount of pure fruit juice, so this is in terms of gallons, so pure fruit juice, what we would do here is just multiply. So 0.1 times x, that would be 0.1x. Again, that's the number of gallons of pure fruit juice that we have from the Kyle's fruit punch. And then we multiply across here, 3 times 0.5 would be 1.5. And then here we would have 0.25 times the quantity x plus 3. So hopefully you see what we need to do here. Remember, the amount of pure fruit juice that we end up with in this mixture, this guy right here, can only come from these 2 sources. So from this guy plus this guy. Okay, so that's where it's coming from. So that's how we're going to create our equation and get a solution. So I'll say 0.1x plus 1.5 is equal to 0.25 times the quantity x plus 3. All right, so what I'm going to do here is multiply everything by 100. So this would be 10x plus, this would be 150. This would be equal to, this would be 25 times the quantity x plus 3. Now again, if you're using a calculator, all this stuff that I'm doing, it's kind of irrelevant, but you could actually divide everything by 5 now. I think that's pretty clear. I like to work with smaller numbers. So if I divide this by 5, I get 2x. Then plus, if I divide this by 5, I'm going to get 30. And this equals 25 divided by 5 is 5. Then times the quantity x plus 3. Okay, so from here, let's say we have 2x plus 30 is equal to, this would be 5x plus 15. And then what I can do now is subtract 30 away from each side of the equation. So let's do that. Let's also subtract 5x away from each side of the equation. Let's show this is canceling and this is canceling. And so 2x minus 5x is going to be negative 3x. This will be equal to 15 minus 30 is going to be negative 15. Let's divide both sides of the equation by negative 3. This would cancel. And so what we're left with is x is equal to, negative over negative is positive, 15 divided by 3 is 5. So x is 5 here. X represented the number of gallons we wanted to use for Kyle's fruit punch. And again, that's going to be 5. So I'm just going to circle 5 gallons here for my answer. All right, let's look at question 2. So we want to solve each word problem. So Glenn created a metal containing 98% nickel by combining 9 milligrams of pure nickel with 1 milligram of another metal. What percent of the other metal was nickel? All right, so let's make a table. We know we have this end mixture, which is 98% nickel. We have pure nickel, and then we have some other metal. So let's go down here, and I'm just going to start by saying we have this other. So this is the other metal. And then we're going to have the pure nickel. So let me put pure. Again, you can write whatever you want for reference. And then I'm just going to put the mixture here. So this is the one in the end. Again, this one was 98% nickel. Okay, so this is in terms of milligrams. So I'm just going to put mg here to abbreviate that. And if we come back up, it says 9 milligrams of pure nickel and 1 milligram of another metal. So I'm going to write this guy right here as 9 for the pure nickel, 1 for the other. And then if you sum the two, that's going to give you the amount for the mixture. 1 plus 9 is 10. Okay, now let's think about the percentage of nickel in each one. Again, I'm doing this as a decimal. Well, for the pure guy, I know that's 1. And let's go back up. The end mixture is going to be 98%, and we actually need to find the percent of the other metal that was nickel. So let's go back down. I'm going to put this one as 0.98. That's 98% as a decimal. And this one I'm just going to put as X because we don't know what it is. Again, if you multiply across, this is going to give me the amount in milligrams of pure nickel. So I'm just going to put pure nickel here like this. And I'm just going to multiply across. So 1 times X would just give me X. Then 9 times 1 would give me 9. And then you would have 10 times 0.98, which would be 9.8. I think most of you can eyeball that and see that this needs to be 0.8 or 80%, so that would be the answer. But just to give a complete answer, let's start off with the amount of pure nickel in milligrams from this other mixture. So that's X. Let's add that to the amount of pure nickel in milligrams from the pure nickel that they're working with. So that's 9. This should be equal to 9.8. And again, it's really easy to solve this. You would just subtract 9 away from each side of the equation. And this right here would cancel. So you would have X is equal to, if I do 9.8 minus 9, that's just going to be 0.8. Or again, that's going to be 80% as a percentage. So coming back up, we want this answer right here, which is 80%. All right, let's look at question 3. Again, we're asked to solve each word problem. So 3 gallons of a saline solution was mixed with 2 gallons of a 50% saline solution to make a 74% saline solution. Find the percent concentration of the first solution. All right, so we know the first solution, the percent concentration is unknown. The second one is 50%, and the mixture, or the end result, is 74%. Let's come down here, and let me just put the first, let me put 50%, and let me put 74%, because that's the end mixture. Again, how you label this is really up to you. I know that we're working with gallons here, so this is going to be my unit of measure there. So coming back up, I know that it's 3 gallons of saline solution, so this is the one that's unknown. So that was mixed with 2 gallons of the 50%. So let's come back here, and let's put 3 here, and let's put 2 here. So 3 plus 2 is 5. We know the end mixture is 5 gallons. Okay, let's think about the percentage here. Again, we know that this one's 50%, it's 0.5 as a decimal. We know that this one's 74%, so 0.74 is a decimal. And this one, let's just say it's X, that's what we're trying to figure out. And again, if we multiply across, we're going to get the amount of pure saline, so pure saline, in terms of gallons, right? So 3 times X would be 3X, and then 2 times 0.5 would just be 1, and then 5 times 0.74 would be 3.7. And again, setting up an equation is easy. You're just going to take this plus this and set it equal to this. The amount of pure saline in gallons from this guy right here, your first solution, plus the amount of pure saline in gallons from this solution right here, the second one, the 50% one, has to be equal to the number of gallons of pure saline in this end mixture, right? The one that's 74% saline. So let's go 3x plus 1 is equal to 3.7. And so again, you can clear the decimals if you want. There's only 1 there, so let's just do it. Let's just say this is 30x plus 10 is equal to 37. Again, completely unnecessary. I'm going to subtract 10 away from each side of the equation, and let's cancel this. We'll have 30x is equal to 27. Let's divide both sides of the equation by 30. So this will cancel. It'll be x is equal to 27 divided by 30, if you punch that into your calculator, is going to give you 0.9. And of course, you could put 9 over 10 if you wanted to do it that way. Let's go back up and say 0.9 is going to be 90%. So this is the unknown concentration, or the percent concentration of the first solution. It was 90% saline. Okay, let's look at question 4. So we want to solve each word problem. So we'll have that Pioneer's premium molasses, which costs $1.86 per pound, is made by combining cane molasses, which costs $1.65 per pound, with beet molasses, which costs $2.35 per pound. Find the number of pounds of cane molasses and beet molasses required to make 8 pounds of Pioneer's premium molasses. So what do we have here to go on the table? With the end mixture, that's called Pioneer premium molasses. So let's just put Pioneer. And then we have the cane molasses and the beet molasses. So let's come through here, and let's just put cane, let's put beet, and then let's put pine. Okay, I think that's good enough. And let me make these E's better. So can't seem to make the E's. Let me make that a little bit better there. Okay, so this is in terms of, if we go back up, pounds, right? So everything is in terms of pounds. So let's put pounds here for our unit of measure. Let's go back up. So it tells us at the end, they want to make 8 pounds, right? And we're asked to find the number of pounds of cane molasses and beet molasses. So we don't know either of those. We know the sum is going to be 8. So we could let this be x, and this could be 8 minus x, or again, you could reverse that. It's really up to you. As long as x plus 8 minus x gives you 8, you're good to go. So let's come through here and now think about the price. If we come back up, we see the price per pound in each case. Okay, so let's grab that, and let's say the price per pound. Okay, so for the cane molasses, it's $1.65. For the beet molasses, it's $2.35. And for the mixture, it's $1.86. So this is 1.65. This is 2.35. And this is 1.86. So what we're going to do here is actually find the total cost, or the amount they're going to spend. So let's go total cost. And just think about if you were buying something by the pound. If you're buying hamburger meat, and let's say it's $10 a pound, and you buy 2 pounds, we spent $20. Well, it's the same thing here. They have X pounds, and it's $1.65 a pound, so the total cost is just 1.65 times X. Here, it would be 2.35 times the quantity 8 minus X. And here, it's 8 times 1.86, which is 14.88. So again, when you think about these, all it is, it's very simple. The total cost for this guy right here, this N mixture, this Pioneer's premium molasses, it comes from the amount spent on this, the cane molasses, plus the amount spent on this, the beet molasses, right? That's where it comes from. So we can just say 1.65x plus 2.35 times the quantity 8 minus x has to be equal to 14.88. And when we find x, we know the number of pounds for the cane molasses, and then we can go 8 minus x to find the number of pounds for beet molasses. So let's come down here. And again, you can just clear the decimals. So let's multiply everything by 100. So this is 165. X plus 235 times the quantity 8 minus x equals 1,488. All right, so what I'm going to do here, I'll have this 165x plus 235 times 8. Punch that into a calculator to get 1,880. Then minus this would be 235x, and this equals 1,488. So 165x minus 235x is going to be negative 70x. Let me actually subtract 1,880 away from each side of the equation, and let me cancel this. And let's put that this is equal to 1,488 minus 1,880 is going to be negative 392. Okay, so to wrap this up, let's divide both sides of the equation by negative 70. So this would cancel. We're going to get x is equal to, again, let's do this as a decimal. Negative divided by negative is positive. 392 divided by 70 is going to be 5.6. So 5.6 is going to go right here. So this is for the cane molasses. And then 8 minus 5.6, which is 2.4, is going to be the amount for the beet molasses. So let's come back, and we're looking for 5.6 pounds of cane molasses and 2.4 pounds of beet molasses. We want this guy right there. All right, let's look at question number 5. So again, we're asked to solve each word problem. So we have here that Willie wants to make 7 milliliters of a 55% sugar solution by mixing together a 40% sugar solution and a 90% sugar solution. How much of each solution must he use? So what we have a 40% sugar solution, a 90% sugar solution, and then an end goal that's going to be a 55% sugar solution. All right, so the first guy was 40%. Then the next guy was 90%. And then the end mixture was 55%. And let me make this a little bit better. Now, we know that the units, we were working with milliliters. So let me put milliliters like this. Let's go back. Well, we don't know how much of each solution he's going to use. We only know that the end result is 7 milliliters, right? So if we come back, we can just put a 7 here. And again, like we've been doing, we can let one of these be x and the other will be 7 minus x. Again, you can flip this around. It doesn't matter. X plus 7 minus x will give you 7. So we're good to go there. Then you want the percentage. Again, we're going to write this as a decimal. So this would be 0.4, this would be 0.9, and this would be 0.55. So I'm just going to put pure sugar. And again, this is in terms of milliliters. So this will be 0.4x. This will be 0.9 times the quantity 7 minus x. And this will be 7 times 0.55. Punch that up on the calculator. You're going to get 3.85. Okay, so we already know the deal. We know we're going to take this guy right here, the amount of pure sugar in milliliters from the first guy, plus this guy right here, the amount of pure sugar in milliliters from the second guy, and set that equal to the amount of pure sugar in milliliters from the final mixture. So we'll go 0.4x plus 0.9 times the quantity 7 minus x. So let me make that better there. And this should be equal to 3.85. Okay, so let me multiply everything by 100. So this would be 40x, and then plus this would be 90 times the quantity 7 minus x, and this equals 385. So from here, let's clean up. Let's say that we have 40x plus 90 times 7. You could do 9 times 7, that's 63, and then put a 0 at the end, so that's 630. And then minus, you'd have 90x, and this equals 385. So 40x minus 90x would give me negative 50x. I would subtract 630 away from each side of the equation. So let's put equals here. Let's cancel that out. And so 385 minus 630 is going to give me negative 245. So to finish this up, let's divide both sides of the equation by negative 50. And so this is going to cancel over here. So this is gone. We'll have x is equal to, we know negative over negative is positive. 245 divided by 50 is going to give me 4.9. So coming back up here, this would be 4.9. So this is the amount in milliliters of the 40% sugar solution we're using. And then 7 minus 4.9 is going to be 2.1. So let's put 2.1 there. And this will be for the amount in milliliters of the 90% sugar solution we're using. So let's go back up. So we want this answer right here, where it says we have 4.9 milliliters of 40% sugar solution and 2.1 milliliters of 90% sugar solution. All right, let's take a look at our quiz. So we're asked for question 1 to solve each word problem. We have that Nicole, a grocery store clerk, has $675 in $5 bills and $20 bills only. If she has 10 more $5 bills than $20 bills, how much of each type of bill does she have? So in other words, we want to find out how many $20 bills she has and how many $5 bills she has. So I would use a table for this. Let's go down here. We're going to have 2 categories. So we're going to have $5 bills, and then we're going to have $20 bills. So I'm going to let this column here represent the number of bills that I have for each. So for the $5 bills, let me just say that we have X of them. If we think about it, it says if she has 10 more $5 bills than $20 bills. So that means when I think about the number of $20 bills, it would be 10 less than the number of $5 bills. So for this, I would just go X, which is the number of $5 bills, minus 10. And for this column, what I would put is the value for each one. So in other words, each $5 bill is worth $5, right? But I'm not going to put the dollar sign. I'm just going to put 5. Each $20 bill, I'm just going to put the value as 20. And I would multiply across to get the total value. Okay, so this is where students get lost. So the total value is what you're always looking for with these problems, because they give you, if you go back up, a total value here, right? So this right here, this $675, that's the value, okay, of the bills. So what you need to do is get your total value for each one. So you'd multiply across. 5 times x is 5x. And then 20 would be multiplied by the quantity x minus 10. You could just say that's 20x minus 200. So let's say this is 20x minus 200. And the idea here is that I'm going to take the total value from the 5s plus the total value from the 20s and set that equal to 675. Again, that's the total amount of money that's told to us in the problem that the grocery store clerk has. So coming back, what I'll do is say that I have 5x plus 20x minus 200, and this equals 675. And so 5x plus 20x would give me 25x. So let's say this is 25x and then minus 200. This equals 675. Let's add 200 to both sides of the equation. And so this is going to cancel. We're going to get 25x is equal to 675 plus 200 is going to be 875. To finish things up, let's divide both sides of the equation by 25. And so this is going to cancel. And what we'll have here is x is equal to 875 divided by 25 is going to be 35. So coming back up here, the number of $5 bills, that was x, so this is 35. And then for the number of $20 bills, it's going to be 35 minus 10, or 25. So this would be 25. So going back up, I'm going to want this answer right here that says that I have 25 $20 bills and 35 $5 bills. Okay, let's take a look at question number 2. So we have solve each word problem here. And Lauren, a local candy vendor, has $980 in her bag. The bag contains $1 bills, $5 bills, and $20 bills only. If the number of $1 bills is 3/5 of the number of $5 bills, and the number of $20 bills is 5 more than the number of $1 bills, how much of each type of bill does she have in her bag? So we're going to have $1 bills, we're going to have $5 bills, and we're going to have $20 bills. So let's put $1 bills, let's put $5 bills, and let's put $20 bills. It looks like the $1 bills were involved in each comparison. So when we think about the number of bills, let's let X be equal to that. And so let's go back up and think about the $5 bills and the $20 bills. So for the $5 bills, it says the number of $1 bills is 3/5 of the number of $5 bills. So that means the number of $5 bills is going to be 5/3 of the number of $1 bills. So let's write this as 5/3 times the number of $1 bills, which would be X. And then for the number of $20 bills, we're told here that the number of $20 bills is 5 more than the number of $1 bills. So the number of $1 bills is X. So the number of $20 bills would be X plus 5. Okay, so once again, with these types of problems, you need to know the value for each bill or coin or wherever you're working with. In this case, each dollar, you're just going to put 1. Each $5 bill is going to be 5. Each $20 bill is going to be 20. So then you're going to multiply across to get the total value. So the total value, let me erase this and put this as an O. That's a little bit better. And so you're just going to multiply across. So I'm just going to say that this is 1 times X or just X. This would be 5 times 5/3. That's 25/3 times X. And then this would be 20 times the quantity X plus 5. So 20X plus 100. Let's just replace that and put 20X plus 100. So again, the idea is to sum the total value from the 1s, the 5s, and the 20s and set that equal to what we got here was $980, right? That's what's in her bag. So coming back down, I'm going to say X plus 25/3 times X plus 20X plus 100 is equal to 980. All right, so I'm going to clear this denominator, but let's clean up first. There's a few things I could do to make this easier. X plus 20X would be 21X. Let me write plus 25/3 X. What I'm going to do is just subtract 100 away from each side of the equation. So this equals 980 minus 100 is going to be 880. And let me multiply both sides of the equation by 3 now. So 3 times 21 would be 63. So this is 63X. Plus, this would be 25X, and this equals 880 times 3 would be 2,640. Okay, so 63X plus 25X is going to give me 88X. So this equals 2,640. Let's divide both sides of the equation by 88. And so this is going to cancel. You'll get X is equal to 2,640 divided by 88 is going to give me 30. So X is 30. So the number of $1 bills is going to be 30. The number of $5 bills, 30 divided by 3 is 10. 10 times 5 is 50. So there'll be 50 of those. And then 30 plus 5 would be 35. So there's going to be 35 $20 bills. So let's go back up. And I'm looking for this answer right here, where there's going to be 30 $1 bills. There's going to be 50 $5 bills. And there's going to be 35 $20 bills. All right, let's take a look at question number 3 now. So again, we're asked to solve each word problem, and we have that Julia purchased her weekly groceries using change only. She paid a total bill of $25.10 using quarters, nickels, and pennies only. There was 2/3 of the number of quarters as pennies and 2/3 of the number of pennies as nickels. How much of each type of coin did Julia use to pay her bill? So here we have quarters, nickels, and pennies. So let's write out that we have nickels. Let's say that we have quarters. And let's say we have pennies. Okay, so again, this is the number, which we're going to model. This is the value each, which we can fill out right now. Let me make this a little bit better. We know a nickel is 0.05, a quarter is 0.25, and a penny is 0.01. Okay, let's model this guy right here. We'll come back. If you look at both comparisons, you have quarters and pennies, and then you have pennies and nickels. So let's use X to represent the number of pennies. So coming down here, I'm going to put X here. And then in terms of nickels and quarters, well, it says there was 2/3 of the number of quarters as pennies. So that means I have 3/2 the number of pennies as quarters. So this would be 3/2 X. And then it says 2/3 of the number of pennies as nickels. So the number of pennies is X, so 2/3 that amount would be 2/3 X. So I'm going to actually convert these into fractions because converting this one into a decimal is going to be an infinitely repeating decimal. So let's actually convert this to 1/20. Let's convert this to 1/4. And let's convert this to 1/100. Let me make this 4 a little bit better. Okay, so multiplying across 2/3 times 1 over 20, 2 would cancel with the 20 and give me a 10. So basically, this would be 1 over 10 times 3 or 30. So this is 1 over 30 times x. Then here, this would basically be 3 over 8. So 3 over 8 times x. And then here, this would be 1 over 100 times x. So again, the idea is that the total value from the nickels plus the total value from the quarters plus the total value from the pennies, and let me mark this as total value. When we take that sum, we set it equal to the $25.10. So let's put 1 over 30 times x plus 3/8 x. Let me make this 8 a little bit better. Then plus 1 over 100 times x. This equals 25.10. So what I'm going to do here is find the LCD. So you have 100, you have 8, and you have 30. Well, 8 is going to be what? This is 2 cubed. 100, this is 2 squared, or 4, times 5 squared, or 25. And then for 30, it's 5 times 6. So it's 5 times 2 times 3. Okay, so the LCD would be what? You would need 8 or 3 copies of 2. You would need times 25, which is going to be 200, right? Because you need 2 copies of 5. And then times 1 copy of 3. So this is going to be 600. So I'm going to multiply everything here by 600. So let's see what that gives me. 600 divided by 30 is going to give me 20. So this would be 20x. And then plus 600 divided by 8 would be 75. 75 times 3 is 225. So this is 225x. And then plus 600 divided by 100 is 6. So this is 6x. This equals, if I do 600 times 25.10, I get 15,060. So from here, I'm going to combine like terms on the left, 20x plus 225x plus 6x. This would give me 251x. This equals, again, 15,060. Let's divide both sides of the equation by 251. So this is going to cancel. We'll have x is equal to 15,060 divided by 251 is going to be 60. All right, so coming back up here, there's going to be 60 pennies. And then 60 divided by 2 is 30. And then 30 times 3 is 90. So there's going to be 90 quarters. And then 60 divided by 3 is 20. And 20 times 2 is 40. So there's going to be 40 nickels. So I'm looking for this answer right here, where there's 90 quarters, 40 nickels, and 60 pennies. Okay, let's look at question number 4 now. Again, we just want to solve each word problem. So we have that Madison High School sold $9,086 worth of tickets to their football game. They received all payments in cash and with $20 and $1 bills only. If the number of $20 bills received was half that of the number of $1 bills, how much of each type of bill did they receive? So in this case, you just have $1 bills and you have $20 bills. Again, this is the number of bills. This would be the value for each. And again, this would be the total. This would be the total value. You could say that x equals either one of these. It says specifically that the number of $20 bills received was half that of the number of $1 bills. So if I let x be equal to the number of $1 bills, then 1/2 times x would be the number of $20 bills. For the value each, this would be 1 and this would be 20. Multiply across to get the total value, this would be x. And then 20 times 1/2 is 10, so this would be 10x. Again, the total that they're taking in is $9,086. So this one's going to be real easy. Basically, you just get x plus 10x, which is going to be 11x, is equal to 9,086. Come down here. I'm just going to divide both sides of the equation by 11. So that cancels. You get x is equal to 9,086 divided by 11 is going to be 826. So that tells me that there's going to be 826 $1 bills. And then half that amount, or 413, $20 bills. So coming back, I'm looking for this answer right here. 413 $20 bills, and then 826 $1 bills. All right, let's take a look at question 5. Again, we're asked to solve each word problem. So Alejandra has a piggy bank with $34.75. Her piggy bank has pennies, nickels, dimes, and quarters only. The number of nickels is half the amount of dimes. The number of quarters is 7 more than 3 times the amount of nickels. Lastly, the amount of pennies is double the amount of quarters. How much of each type of coin is in the piggy bank? In most of these situations, you have something that's involved in each comparison. Here, you don't have that. So you do have nickels that occurs when we talk about the nickels and dimes, and then with the quarters and nickels, but then you have pennies and quarters. So because nickels is involved in more comparisons, I would just start with that. I would let x equal the number of nickels. So coming here for the number, let's put n for nickels. Let's put d for dimes, q for quarters, and p for pennies. Again, if you want to write it out, that's up to you. Just going to abbreviate. And then this is going to be x. And then going back, we need to figure out a way to model this one, and this one. So let's think about the dimes. It says here specifically that the number of nickels is half the amount of dimes. So that means the number of dimes is going to be double the number of nickels. So if x is the number of nickels, then 2x is the number of dimes. Then for quarters, it says specifically the number of quarters is 7 more than 3 times the amount of nickels. Again, the amount of nickels is x, so 3 times x would be 3 times the amount of nickels. But then we want 7 more than that, so we have to add 7 to this 3x. So let's come back and say this is 3x plus 7. And then we need the pennies. And with the pennies, it says lastly, the amount of pennies is double the amount of quarters. What we can do is just double this amount here, the amount for quarters. So I would have 2 times the quantity 3x plus 7, and that's going to give me 6x plus 14. Okay, so I just multiplied the modeling of quarters by 2 to get my pennies. So this is going to be 6x plus 14. So we already know in this column here, we're going to put the value for each. So the value for each. And in terms of coins, let me make this each a little bit better, a little bit cleaner so everyone can read it. In terms of coins, a nickel is going to be 0.05, a dime is going to be 0.1, a quarter is going to be 0.25, and then a penny is going to be 0.01. So we're just going to multiply across to get the total value. So this is the total value here. So then to start over here, let's go 0.05 times x. Here you'd have 0.1 times 2, that's 0.2, then times x. Then here you'd have 0.25 times the quantity 3x plus 7. So let's do this off to the side. So 0.25 times the quantity 3x plus 7. Let me bring this decimal point down where it's supposed to be. So 0.25 times 3 is 0.75, and then times x, and then plus 0.25 times 7 is 1.75. So let's write in here 0.75x plus 1.75. Okay, let me get rid of this. Then the next one we have is 0.01 times the quantity 6x plus 14. So 0.01 times the quantity 6x plus 14. So 0.01 times 6 is going to be 0.06, then times x, and then plus 14 times 0.01 is going to be 0.14. So this is going to be 0.06x plus 0.14. So the idea here is I have the total value from the nickels, and then the total value from the dimes, the total value from the quarters, and then the total value from the pennies. So I can add those together and set it equal to the total value from her piggy bank. So how much is in the piggy bank? It's $34.75. So what we'll do, we'll take the 0.05x, then plus 0.2x, then plus 0.75x, plus 1.75, plus 0.06x, plus 0.14. Again, this would be equal to 34.75. Okay, so again, not necessary, but I'm just going to multiply everything by 100 to clear all the decimals. So this would be 5x plus, this would be 20x plus 75x plus 175, plus this would be 6x plus 14 is equal to 3,475. Okay. On the left-hand side, we have a lot of like terms we can combine. You've got 5x, 20x, and 75x, and then also 6x. So 5x plus 20x would be 25x, then plus 75x would be 100x, then plus 6x would be 106x. And then plus, over here, 175 plus 14, that would give me 189. And this equals 3,475. What we'll do from here is subtract 189 away from each side of the equation. And so this right here is going to cancel. Let's slide down a little bit. And so what I'm going to have is 106x is equal to 3,475 minus 189 is going to be 3,286. So what I'll do from here is divide both sides of the equation by 106. And so we'll see that this is going to cancel, and we'll have x is equal to, if I divide 3,286 by 106, I'm going to get 31. All right, so coming back up here, x is 31. So that means 2 times 31 would be 62. 3 times 31 would be 93, and 93 plus 7 would be 100. So this is 100. And then 6 times 31 would be 186, and then plus 14 would be 200. So this is 200. So this tells me that I have 31 nickels, 62 dimes, 100 quarters, and then 200 pennies. So I want this answer right here. Again, 200 pennies, 31 nickels, 62 dimes, and 100 quarters. All right, let's take a look at our quiz. For the first question, we're asked to solve each word problem. So we have that a certain amount is deposited in a savings account, which pays 10% annual simple interest for the first year, 11% for the second, and 12% for the third. If at the end of the third year, a total of $22,440 was earned in simple interest, what was the original amount invested? All right, so a very straightforward problem. Our goal is to figure out what was the original amount invested. So you could just let X equal that. I'm just going to put everything on the table. So let's come down here. And for my table, remember for the simple interest formula, you have I, which is the amount of simple interest earned, is equal to P, which is the principal or amount invested, times R, which is the rate as a decimal, then times T. But again, you've noticed for most of these problems, we don't even need a T because the time ends up being 1. And if you multiply by 1, you leave things unchanged. So you have your first year, you have your second year, and you have your third year. And in each case, the principal is not going to change. So I'm just going to let the amount that was invested be X. So this is X, and this is X, and this is X. But what does change is the interest rate. So based on the year that you're in, and coming back, it says 10% for the first year, 11% for the second, and 12% for the third. So we're going to have 0.1 for 10% as a decimal, then 0.11 for 11% as a decimal, then 0.12 for 12% as a decimal. And to get the simple interest earned, again, we're just going to multiply across. So this would be 0.1x, this would be 0.11x, and this would be 0.12x. So let me move this decimal point down a little bit. Now, how do we get an equation? Well, it tells us in the problem that after the third year, the total that was earned here was $22,440 in simple interest. So all we have to do is take the amount of simple interest earned from the first year, which is this 0.1x, plus the amount of simple interest earned from the second year, which is 0.11x, then plus the amount of simple interest earned from the third year, which is 0.12x. Once we sum those amounts together, they have to be equal to the 22,440. So let's say we have 0.1x plus 0.11x plus 0.12x. And this equals, you're going to have 22,440. Okay, so again, if you're working with the calculator, it's unnecessary. But if you want to clear the decimals, you can multiply everything by 100. So let's just do that real quick. This would be 10x plus 11x plus 12x is equal to, I'm going to put 2 zeros at the end of this number. So I'm going to put a 2, a 2, a 4, and a 0, and then put 2 zeros at the end. So put a comma here, and let's put a comma here. And so from here, I have 10x plus 11x plus 12x, and that's going to give me 33x, and this equals 2,244,000. Okay, so to get x by itself, obviously we just need to divide both sides of the equation by 33. And so this would cancel here. You're going to have x is equal to, if we punch this into the calculator, 2,244,000 divided by 33 gives me 68,000. So this is 68,000. So this is going to be the original amount that was invested. So coming back up here, we want this answer right here. All right, let's take a look at question 2. So we're asked to solve each word problem, and we have that Rob purchases a car using a 7-year special loan package. The loan package allows him to pay only simple interest for the first 2 years of the loan, followed by 5 years of normally structured payments, so principal and simple interest. Throughout the loan, he will pay a rate of 18% annual simple interest. If at the end of the interest-only period, the total payments were $6,930, how much was the amount of the car loan? All right, so this problem can be tricky, and the reason it can be tricky is because there's extra information, or you could say unneeded information in the problem. So a lot of people make the mistake when they set up their formula of using the 7 from the 7-year special loan package. But if you really get detailed with it, what it's saying here is that we really only want to think about this interest-only period. So it says if at the end of the interest-only period, the total payments were $6,930. So that's pure interest. So if I'm setting up my formula, I equals P times R times T, well now instead of the amount of simple interest earned, it's the amount of simple interest paid. So we're just using the formula in a different way. So I'm going to put 6,930 for that. So that's something that is known. We'll say this is equal to, we don't know what the principal is. So I'm just going to write P for that. And then times, we know the interest rate is always 18%, no matter if you're in the first 2 years of the loan or the remainder of the loan. So I'm going to put 0.18 as a decimal. Now, the T, the time here is what's tricky. Again, we're thinking about only the first 2 years of the loan because that is where we're just paying the simple interest. So this is going to be a 2 in the place of T. So all we really have to do is solve for P, the principal, or in this case, it's going to be the amount of the car loan. So 0.18 times 2 would be 0.36. So 0.36. You could multiply everything by 100, but I think because this is such a simple operation, I'm just going to divide both sides by 0.36. So divide both sides by 0.36. This would obviously cancel. And so P is going to be equal to, let's punch this into our calculator. If you do 6,930 divided by 0.36, you're going to get 19,250. So this was the amount of the car loan, $19,250. All right, let's look at question 3. Again, we're asked to solve each word problem. So we have that Betty has $40,000 to invest. After meeting with a financial planner, she decides to invest some of the money in a savings account, paying 4% annual simple interest, and the remainder of the money in an annuity, which pays 6% annual simple interest. If she wants to earn a total amount of $2,040 from these two investments each year, how much should be invested at each rate? Okay, so we know the total amount that Betty's going to invest, and I'm just going to use these rates. I know one's a savings account, which is 4%, and the annuity is 6%, but just to keep things more concise, I'm just going to use 4% and 6%. So she has a total of $40,000 to invest. So let's come down here, and let's say that we have 4%, and let's say we have 6%, and then we have the amount of simple interest earned, we have the principal, and we have the rate. Again, the time here is 1 year, so we leave that off. But the main thing is that if you let X be equal to one of these, well, the total amount is $40,000 that she's going to invest. So the other one is just found by $40,000. So $40,000 minus X, minus whatever she puts in the other one. The rate here is 0.04, and the rate here is 0.06. And again, to get your simple interest earned, just multiply across. So this is 0.04 times X, and then this is 0.06 times the quantity 40,000, and then minus X. If we go back up, it says she wants to earn a total amount, and this is the key, of $2,040 from these two investments each year. So all you have to do is come back here and take the amount of simple interest earned from the savings account, which is at 4%, plus the amount of simple interest earned from the annuity, which is at 6%, and you're going to set that sum equal to $2,040. So then 0.04x plus 0.06 times the quantity 40,000, then minus x, this equals 2,040. So once again, we're going to multiply everything by 100 to clear the decimals. And again, this is just completely optional. So this is going to be 4x plus 6. Let me make this x a little bit better. And this is times the quantity 40,000 minus x. And this equals, I'm going to copy these digits, so 2040, and put 2 zeros at the end. Let's put a comma here. So that would be 204,000. So I'm going to use my distributive property here to clean up. Let's go 4x plus 6 times 40,000 would be 240,000. Then minus 6 times x is 6x. And this equals 204,000. Okay, so 4x minus 6x would be negative 2x. So this, let me write this down here a little bit lower. So this is negative 2x. I'm going to subtract 240,000 away from each side of the equation. And so we know that this is going to cancel. So this equals 204,000 minus 240,000 is going to be negative 36,000. Let's divide both sides of the equation by negative 2. And so this is going to cancel right here. We'll have x is equal to negative over negative is positive. 36,000 divided by 2 is 18,000. So this is 18,000. So x is 18,000. And remember, that represented the amount that we put in the savings account, the one at 4%. So then 40,000 minus 18,000 is 22,000. That's the amount that goes into the annuity, which again pays 6%. So this is the answer we want right there. All right, let's take a look at question 4. So again, we're asked to solve each word problem. So Aria arranged a meeting with her local financial planner and decided she needs to earn a total of 5.5% annual simple interest between two investments. She decided to invest $15,000 in a savings account, which pays 6% annual simple interest. Additionally, she decided to invest in a government bond fund, which pays 4% annual simple interest. How much should she invest in the bond fund to achieve her investment goals? Okay, so let's come down here. Again, I'm just going to get this started. So I is equal to P times R. And we had a savings account and a bond fund. But again, you could just identify them with the interest rate if you want. So with the savings account, it's 6%, and with the government bond fund, it's 4%. So let's come down here and let's put 6%, and let's put 4%. And that immediately tells me the rate is 0.06, and this is 0.04. Again, we're working with a time period of 1 year, so that's why it keeps getting cut off. For the principal, we know for the savings account, it's going to be $15,000. So let me put 15,000 in here. And if you multiply across, 0.06 times 15,000 is going to give you 900. So she's going to make $900 each year in simple interest from the savings account that's paying 6%. Okay, so we don't know the principal here, so we're just going to let x be equal to that. So we'll say this is 0.04x. We see that the key to getting an equation is that she needs to earn a total of 5.5%. So we need to figure out how we can get her investment to have a rate of return of 5.5%, again, in terms of annual simple interest. So there's a lot of different ways you could set this up. What I like to do is write it out like this. So your interest is equal to your principal times your rate times your time. In this case, we're thinking about 1 year, so you can just get rid of that. In other words, we want this rate here, this R, at the end of the day to be 0.055 or 5.5%. So what I could do is actually just plug in the amount of simple interest she's going to earn. In this case, that comes from this 900 plus this 0.04x. Let's do that over here. I'll go 900 plus this 0.04x. And again, this is equal to, what is my principal? Again, if we come back up here, that's coming from this guy plus this guy. So 15,000 plus x. So let me actually just rearrange this a little bit so that this is here, and I'll put this as a quantity. So 15,000 and then plus x. Okay, so if you ever get lost on a problem like this, just write out your formula and think about, well, what am I trying to figure out? Then plug in what you know and then just solve for the unknown. Okay, so from here, again, I can multiply by 1,000 and clear all the decimals. So this would be 900. And if I'm multiplying by 1,000, I'm going to put 3 zeros at the end. And then plus, I'm going to move this 3 places to the right. So this would be 40x. And this equals, this would be 55 times the quantity, 15,000, and then plus x. All right, so on the left-hand side, I'm just going to copy things. So we have this 900,000, and then plus this 40x, and this equals, on the right-hand side, 55 times 15,000 is 825,000. Then plus 55 times x is 55x. And then from here, I'm going to subtract 55x away from each side of the equation. And then I'm going to subtract 900,000 away from each side of the equation. So this would cancel, and this would cancel. Then from here, 40x minus 55x is negative 15x. And this equals 825,000 minus 900,000 would be negative 75,000. Let's divide both sides of the equation by negative 15 to finish this up. So this would cancel. You're going to get x is equal to, negative over negative is positive, 75,000 divided by 15. That's going to give me 5,000. So x is 5,000 here. So coming back up, she should put $5,000 into this bond fund to achieve her investment goals. All right, let's take a look at question 5. So again, we're asked to solve each word problem. So last year, Bob earned a total of $1,440 in simple interest from 2 investments. He invested part of his money in bonds, which pay 3.5% annual simple interest, and $5,000 more than 3 times this amount in private equity funds, which pay 4% annual simple interest. How much money did Bob invest in each? The easiest thing here would be to let x be equal to the amount of money he put into the bonds. Let me just write this here so we can remember it. So bonds, we're just going to put x. Then it says, and 5,000 more than 3 times this amount for the private equity funds. So I'm just going to put private, and we'll say that this is going to be 3 times x, so 3 times this amount, and then plus 5,000. So plus 5,000. Okay, so we've modeled this, and we know the interest rates. The first one is 3.5%, and the other one is 4%. So let's put I equals P times R. Again, T is 1 year here, so I'm just leaving it off. Let me paste what we had here. So we have the bonds, and then we have the private for the private equity. We're just using that for a shorthand. Okay, let's get rid of this. We know that this is going to be x, and then this is going to be 3x plus 5,000. So 3x plus 5,000. And hopefully you can remember this, but the interest rate for this one was 3.5%, so 0.035. And the interest rate for this one was 4%, so 0.04. Again, to get these simple interest earned, you just multiply across. So this is 0.035x. This is 0.04. Let me scooch this up just a little bit. And then times the quantity, 3x plus 5,000. It tells us that Bob earned a total of $1,440 in simple interest from the 2 investments. So the simple interest from here plus the simple interest from here should be equal to 1,440. So 0.035x plus 0.04 times the quantity 3x plus 5,000, and this equals, again, 1,440. I will multiply everything by 1,000 to clear all the decimals. So this would be 35x plus, this would be 40 times the quantity 3x plus 5,000, and this equals, I'm going to put 3 zeros at the end of this number. So 1440, and then 1, 2, 3 additional zeros. You put some commas in there. So what I'm going to do here is just clean up on the left side. So we'll have this 35x plus 40 times 3 is 120. So 120 then times x, and then plus 40 times 5,000, Well, 4 times 5 is 20. And then I'm going to put 1, 2, 3, 4 zeros at the end. So 1, 2, 3, 4 zeros at the end. So that would be 200,000. And this equals 1,440,000. So 35x plus 120x is 155x. Let's subtract 200,000 away from each side of the equation. Let me actually move this down a little bit so it's out of the way. So this is the 155x from up here. And let's show that this is going to cancel. And let's say this equals 1,440,000 minus 200,000 is going to be 1,240,000. All right, to finish things up, let's divide both sides of the equation by 155. And so this will cancel. We'll have x is equal to, if I do 1,240,000 divided by 155, I'm going to get 8,000. So remember, 8,000 was the amount that was going to go into the bonds. And then what we would want is, again, 3 times this amount, which is 24,000, and then 5,000 more than that, which is 29,000. So 8,000 for the bonds and then 29,000 for the private equity funds. All right, let's take a look at our quiz. So for the first question, we want to solve each word problem. We have Zach owns a clothing store and is offering a big promotion. Customers can decide on taking a discount of 30% off of the original price, or they can take 25% off of the original price and then an additional 6% off of the discounted price. Which option results in a better price? So for this type of problem, you could use a variable. We did something similar in the practice test, but I think it's faster and more realistic if you just use something like 100 or 1,000, some multiple of 10. So I would start with $100 and I would say, okay, in the first scenario, it says I can just straight up take 30% off of this price. So 30% or 0.3 times 100 is 30. And so if I took $30 away from $100, that would be $70. So this is what I end up paying with the first scenario. So let me just put first scenario. With the second scenario, let me do this over here. I start with $100. The first discount is 25% off. So that's going to give me $25 off. So that means I'm at $75. But this is where it gets tricky. A lot of people, they sit there and they go, okay, well, this is 25% and this is 6%. So they think it's 31% off, but it's not. Your next discount, it says specifically, it's an additional 6% off of the discounted price. So I want 6% off of the $75. Well, 6% or 0.06 times 75 is going to give you 4.5 or $4.50 off. Well, $75 and I take away $4.50, I'm getting up with $70.50. So this ends up giving me $70.50. So this is your second option. So the second option is actually worse. I'm paying 50 cents more than if I took the first option, right? So this discount right here is only 29.5%, whereas this discount was a full 30%. So I want this guy right here, basically where I'm saying the first option results in a better price overall. Customers end up with a discount of 30% off of the original price versus a discount of only 29.5% if they choose the second option. All right, let's look at question 2. So we're asked to solve each word problem. So this year, a local store has $13,524 in inventory. This represents an increase of 61% from the year before. What was the store's inventory last year? So you could let X be equal to the store's inventory last year. So you would have X, then plus, you have a 61% increase. So 0.61, that's the increase of 61% as a decimal, times X, which again is the store's inventory last year. This would be equal to, again, what it's telling you right there, the 13,524, the amount of your inventory right now. So combine like terms on the left. Remember, this is a 1. So this would be 1.61x is equal to this 13,524. Let's divide both sides of the equation by 1.61. And so this is going to give us, this cancels, x is equal to 13,524 divided by 1.61 is 8,400. So I want this answer right here. It's $8,400. All right, let's look at question 3. Again, we want to solve each word problem. So at the end of the week, Aya, a daycare owner, counted $2,318 in receipts. This amount included 13% state and local sales taxes, along with 9% federal taxes. Find the pre-tax amount of the daycare services sold for the week. So the idea here is you could let X be equal to the pre-tax amount of the daycare services sold for the week. Then you could add to that the state taxes, so 0.13 times X, then the federal taxes, so plus 0.09x, and the sum of these would be equal to the total receipts, right? So the 2,318. Combine like terms on the left, let me put a 1 here. So 1 plus 0.13 is 1.13, and then plus 0.09 is going to be 1.22, and then of course times x is equal to 2,318. Let's divide both sides of the equation by 1.22. And let's cancel this right here. We'll say x is equal to 2,318 divided by 1.22 is going to be 1,900 or $1,900. All right, let's take a look at question 4. So again, we want to solve each word problem. So at a local car lot, Nathan begs the manager to sell a car for an all-inclusive price of $20,946.50. This amount would include the 9.9% state and local sales taxes, along with other miscellaneous government document and registration fees of $615. If the dealer agrees to this price, how much is the price of the car before any taxes or fees? So again, you could just let x be equal to exactly what you're trying to find. So you would have x, which is the original price of the car, or you could say the sticker price. And then you're going to have to add to that the state and local sales taxes. So that's 9.9%, so 0.099 times x. Then you also have to add on to that the $615 for the fees. So if you sum these amounts together, you end up with this amount here, which is the $20,946.50. Okay, so on the left-hand side, I can say that this would be 1. Let me make this a little bit better. So 1 plus 0.099. So we'll say this is 1.099x. Then plus 615 is equal to the 20,946.50. What I'll do from here is subtract 615 away from each side of the equation. So this is going to cancel. We'll have 1.099x is equal to, if I do 20,946.5 minus 615, you're going to get 20,331.5. From here, let's divide both sides of the equation by 1.099. This would cancel. You're going to get x is equal to 20,331.5 divided by 1.099 would be 18,500. So coming back up, we want this answer here, which is $18,500. Let's take a look at question 5. So again, we want to solve each word problem. So we have that Jennifer works as a saleswoman for a local clothing store. She earns a salary of $450 per week, plus a 13% commission on all of her sales. She is currently paying an income tax rate of 22%, which includes all state, local, and federal taxes. 1 week, her after-tax check was $472.68. How much merchandise did she sell for that week? Okay, so the idea here, you have some initial amount of merchandise she sells, and let's let x be equal to that. And so to model her salary, she gets $450 no matter what she sells. Then plus, she gets 13% or 0.13 times the amount of merchandise she sells for the week. Again, we're letting x be equal to that. And this right here is her income before we take any taxes away. Now, she pays 22% of her income to taxes, right? It says that right there. So let's subtract away 0.22 times her income, which is this, the quantity 450, then plus 0.13x. And at the end of the day, this should be equal to this after-tax check, which is 472.68. On the left-hand side, I'm just going to leave the 450 plus 0.13x. And then this one, I'm going to take the negative with me each time. So negative 0.22 times 450. This will give me negative 99. So let me put minus 99 like this. And then negative times positive is negative. 0.22 times 0.13 is going to give me 0.0286. And then times x. And then this equals, again, the 472.68. All right, on the left-hand side, 450 minus 99 is 351. Then 0.13x minus 0.0286x is going to be plus 0.1014x. And this equals 472.68. Okay, from here, let's subtract 351 away from each side of the equation. So this is going to cancel. We'll have 0.1014x is equal to 472.68 minus 351 is 121.68. To isolate x, let's divide both sides of the equation by 0.1014. So over here, same thing. And so we know that this would cancel. We have x is equal to, let's punch this into the calculator. So 121.68 divided by 0.1014 is going to give me 1,200, or you could say 1,200. So again, to answer this, how much merchandise she sold for the week, x was equal to that. And so that's going to be $1,200. All right, let's take a look at our section quiz. For the first question, we want to solve each word problem. When -7 is multiplied by the sum of 2 times a number and 1, and then 8 is subtracted away, the result is the same as -5 times the number less 5 multiplied by the sum of 7 times the number and 3. Find the number. So this one has quite a few parts to it. Again, if you're having trouble with this, anytime you see something like a number or the number, just replace it with a variable. Again, you can use x, y, z, whatever you want. So here we have a number. So I would just cross that out and put x. And then you have it again right here where it says the number. So I'm going to cross that out and put x. And then down here you have the number again. So cross that out and put x. The other thing I would do is where you see the result is the same as, that just means equals. So you can cross that out also and put equals. Now, what I would do is just read back through the problem. Again, just take your time and try to interpret things. So you have when -7 is multiplied by. So let me start with -7. And I know it's multiplied by something. So it says the sum of 2 times x. So what is 2 times x? We represent that as 2x. So it would be the sum of 2x and 1. So 2x and then plus 1. And -7 is multiplied by that quantity. So you have to make sure you wrap this in parentheses. Let me just slide this down here like this. You don't need the multiplication symbol, so we can get rid of it at this point. And then we say that 8 is subtracted away. So I'm just going to subtract away 8 like this, so -8. Okay, so the first part's done. Now we have the equals. So we're going to put equals there. And then this part, we have -5 times this x. So let's put -5 times x like that. Then we have again less. So I'm going to put minus. You have 5 that is multiplied by. So let me put 5 times. Let me slide this down so it fits. We have the sum of 7 times x. So that's just 7x and 3. So I'm going to put 7x plus 3. And again, 5 is multiplying this whole quantity. All right, so hopefully you were able to translate this correctly. This is really the hardest part of the problem. Solving the equation is really, really simple. All right, so coming to a new sheet, let's use our distributive property here. -7 times 2x is -14x. And then -7 times 1 would be -7. And then we have -8. If you want, you could just combine like terms now. This would be -15 here. So this is -15 there. And then equals. Over here you have -5x. And then I'll bring this negative with me when I multiply. So -5 times 7x, I'm going to say that's -35x. And then -5 times +3 would be -15. Again, we could just combine like terms now. This would be -40x here. So let's just write that. So we will put that we have -40x and then -15. Let me just slide that down just a little bit. Okay, so we know how to solve an equation. We've been doing this forever. We know that if -15 is on each side of the equation, we can just get rid of it. Because I can add 15 over here and add 15 over here, and this is going to go away from here and here. Now, be careful. Remember, if you're working with 15 minus 15, that is a result of 0. We typically don't write it, but in this case, we're going to get rid of this -40x from the right-hand side. So let me put 0 here as a reminder that we don't want to end up with nothing. We want to end up with an actual value of 0. We don't want to just leave this blank. So over here, I'm going to add 40x to both sides of the equation. And so, of course, this is going to cancel. And what you have now is -14x plus 40x, which is going to give me positive 26x. And of course, this equals 0. Okay, that's why I put that there. So this equals 0. Divide both sides of the equation by 26. And this will cancel. And you get x is equal to 0 over any non-zero number will give you 0. So x here is going to be 0. So coming back up here, the answer we want is 0. Okay, let's look at question 2. Again, we want to solve each word problem. So when the quotient of, instead of a number, again, I'm just going to put x, and 3 is added to 2, the result is the same as. So I'm going to cross that out and put equals. The quotient of 3 and 2, which is multiplied by the number, cross that out and put x, and then subtract it away from the quotient of 35 and 12. Find, again, I'm just going to put x in the place of the number. So when the quotient of x and 3, so that's just x divided by 3, or x over 3 if you want to write it as a fraction as I did, we say is added to 2. So then just plus 2. Then we have equals the quotient of 3 and 2. So that's just 3 over 2 like this, which is multiplied by x. So multiplied by x, and then subtracted away from. So subtracted away from. So let me put a minus out in front. The quotient of 35 and 12. So that's 35 over 12 like this. Okay, so to solve this, your least common denominator is 12. So you could multiply everything by 12. 12 divided by 3 would be 4. So this would be 4x, and then plus 12 times 2 is 24. And this equals 12 divided by 12 is 1, so you just have 35 here. And then minus 12 divided by 2 is 6. 6 times 3 is 18, so this is 18x. What I'm going to do is add 18x to both sides of the equation. And so we know that this is going to cancel. And then let's subtract 24 away from each side of the equation. And so this would cancel. And so on my left-hand side, 4x plus 18x is going to give me 22x. And this equals 35 minus 24 is going to be 11. Let's divide both sides of the equation by 22. This would cancel. You get x is equal to 11 over 22 is going to be 1/2. So coming back up here, we want 1/2 as our answer. All right, let's take a look at question 3. Again, we're asked to solve each word problem. So we have that 3 consecutive multiples of 11 sum to 693. Find the multiples. So hopefully you remember when we talk about multiples, you're generating a list. Let's say for 11, you start with 1 times 11. So this is 11. Then 2 times 11. So this is 22. Then 3 times 11. So this is 33. So on and so forth. So in some definitions, it's a little bit different. They use integers, but mostly you use whole numbers. So let's say you start with 1, then go to 2, then go to 3. You're multiplying by 11 each time. So what we would want is the smallest integer, or you could be more specific and say the smallest whole number. Then you would want the next one up, you just add 1. Then you would want the next one up, you would add 1. Again, you want 3 consecutive multiples. So those numbers are going to be multiplied by 11. So let's go down here, and I've already set things up. So I let x be equal to the smallest integer, or again, to be more specific, you could say the smallest whole number, then x plus 1, just adding 1 to get to the middle, and then x plus 2, just adding 2 to get to the largest. So then this gives us the equation. We have 11 times, again, the smallest integer, plus 11 times, again, the middle guy, plus 11 times, again, the largest guy. If we sum all these together, we get the 693. So let's just solve this equation. The quickest way to do it would be to factor the 11 out first. And inside you would have x plus 1 plus x plus 2. Let me make this plus sign a little bit better. And this equals 693. So x plus x plus x is 3x. So this is 11 times. This would be 3x, and then plus 1 plus 2 is 3. So let's set this equal to 693. So what I would do from here, I would divide both sides of the equation by 11. So let's get rid of that. And we'll have 3x plus 3 is equal to 693 divided by 11 is 63. Let's subtract 3 away from each side of the equation. So this is going to cancel. And what I'll have is 3x is equal to 63 minus 3 is going to be 60. Let's finish things up by dividing both sides of the equation by 3. So this will cancel here. And what I'll have is x is equal to 60 divided by 3 would be 20. So x is 20, but we're not asked to find x. If we come back up here, 20 is not the answer we want. It says find 3 consecutive multiples of 11. So in other words, when we're generating our list, 20 would be the smallest number that's getting multiplied by 11. So you would want 11 times 20, and then 11 times 21, and then 11 times 22. So the results here, these would be the multiples we're looking for. So 11 times 20 is 220, and then 11 times 21 is 231, and then 11 times 22 is 242. So I'm looking for 220, 231, and 242. So this is what I want right there. All right, let's look at question 4. So we want to solve each word problem. So when 6 is multiplied by the smallest of 3 consecutive integers and then added to 4 times the sum of the smallest and middle integer, the result is the same as 118 less than 15 times the largest integer. Find the integers. So what I've done is set things up on the next page just to get through the problem a little bit quicker. So x is going to be the smallest integer. And again, with consecutive integers, they differ by 1. So the next one's going to be x plus 1. That's your guy in the middle. And then x plus 2 is your largest integer. Now this equation, let's dig into where this comes from. So basically we're saying when 6 is multiplied by the smallest of 3 consecutive integers, so that's going to be 6 times x because again, x is the smallest integer. And then it's added to, 4 times the sum of the smallest and middle integer. So the smallest is x and the middle is x plus 1. Now you could write this as 2x plus 1 if you want, and we'll do that in a moment. For right now, we'll just leave it this way. It says the result is the same as, so that's equals. We have 118 less than, so I'm going to put that in the end. We have 15 times the largest integer. So 15 times the largest integer is x plus 2. And again, we want 118 less than that, so minus 118. Again, I'm going to make this a little bit simpler and say this is 2x. X plus x is just 2x. And so we'll go through and just say this is 6x plus 4 times 2x is 8x, and then plus 4 times 1 is 4. This equals 15 times x is 15x, and then plus 15 times 2 is 30, and then minus 118. Okay, very simple equation to solve. 6x plus 8x is going to give me 14x. So this left side is 14x plus 4. And this equals, on the right, I have 15x. And then 30 minus 118 is going to be negative 88. So we are going to subtract 15x away from each side of the equation. This is going to cancel. Subtract 4 away from each side of the equation. This would cancel. So 14x minus 15x is going to give me negative x. And this equals negative 88 minus 4 is going to give me negative 92. So what I'll do from here is just multiply both sides by negative 1. And so this will give me x is equal to positive 92. Now remember, 92 is the smallest integer. So we would have 92, then add 1, 93, then add 1, 94. So coming back up here, I want 92, 93, and 94. All right, let's take a look at question number 5 now. So we want to solve each word problem. We have Lauren, Kate, and Kristen are sisters. 11 years ago, Lauren was 1/3 as old as Kate is today. Additionally, 4 years from now, Kristen will be 1.2 times as old as Kate. If the sum of Kate's age and Lauren's age is the same as Kristen's age 13 years from now, how old is each girl? All right, so I have everything set up on the next page, but just reading through this, I think it probably won't make sense for you if you're completely lost. So let's go back up here and just spend a little bit of time coming up with what's on the next page. So the first thing is, what I like to do, if you have 3 people, generally speaking, you're going to look for the person that's involved in each comparison. So when I look through this, I have Lauren and I have Kate, and then I have Kristen and I have Kate. So what I'm going to do to make it easier, I'm just going to let x be equal to, this will be Kate's age. And to be more specific, it's going to be Kate's current age. But let me just put Kate's age like this. Okay, I think that's good enough for right now. So then how can we figure out how old Lauren is? Well, this is the tricky part. It says 11 years ago, Lauren was 1/3 as old as Kate is today. So we'll start with 1/3 as old as Kate is today. How do we get that? How old is Kate today? She's X years old. So what is 1/3 of that amount? That's going to be 1/3 X. So let's put then 1/3 X. But we're not done because this is 11 years ago. So if this was her age 11 years ago, how do we get it back to today? Well, we just add 11. So I'm just going to go plus 11. And now this is going to be Lauren's age. So this is Lauren's age. All right, lastly, we have to find the age of Kristen. So this one is a bit tricky. And so basically it says 4 years from now, Kristen will be 1.2 times as old as Kate. So let's start with the fact that Kate in 4 years would be X plus 4 years old. She's currently X. In 4 years, she is going to be X plus 4 years old. Now, it says specifically that we want to multiply this by 1.2 because it's 1.2 times as old as Kate. So let's put 1.2. Now, does this represent Kristen's current age? No. It says 4 years from now, Kristen will be 1.2 times as old as Kate. So this represents Kristen's age in 4 years. So to get it back to today, I need to subtract away 4 from this. So this would be Kristen's age. So Kristen's age. And I'm just going to go to the next page and show you that I've written this a little bit more cleanly. So again, X is Kate's current age. And then 1/3 X plus 11 is Lauren's current age. And then 1.2 times the quantity X plus 4 and then minus 4 is Kristen's current age. So that's all set up. So now we have this equation to get if the sum of Kate's age and Lauren's age is the same as Kristen's age 13 years from now, how old is each girl? So I want to sum Kate's age and Lauren's age. So if I look at Kate's age, again, it's X, and then Lauren's age is 1/3 X plus 11. This is equal to, again, Kristen's age in 13 years. So here's Kristen's age, and then this plus 13 is going to move it 13 years into the future, okay? So all we have to do is solve this equation, and then we can go back and figure out how old is Kate, Lauren, and Kristen. So basically what I would do, let me write this as X plus 1/3 X plus 11 is equal to, let's say this is 1.2 times X plus 1.2 times 4 is going to be 4.8, and then minus 4, and then plus 13. Now, we have a denominator here that we're going to clear, and I typically don't like to mix decimals and fractions, but again, if you're using a calculator, it's not that big of a deal. I'm just going to clean this up as much as I can before I deal with that denominator. So over here, 4.8 minus 4 would be 0.8. So let's just erase this in line and just put 0.8 here. And then if I add 13 to that, it's just 13.8. So this is 13.8. Now, I have this 11 over here. I can just subtract this away from each side like this. I'm just going to erase it from over here. So this would be 2.8 over here. Okay, so now I think we're ready to deal with this guy right here. And all I have to do is just multiply everything by 3. So essentially I would have 3x plus x is equal to 1.2 times 3 is going to be 3.6 and then times x, and then plus 2.8 times 3 is going to be 8.4. Okay, so we have decimals. Again, if you wanted to clear the decimals, you could do that. There's a lot of stuff you could do, but again, if you're using a calculator, a lot of that stuff is just a waste of time. So 3x plus x, we know this would just be 4x, and this equals, you have your 3.6x plus 8.4. And then from here, let's subtract 3.6x away from each side of the equation. This would cancel. And so what you're going to have is 4x minus 3.6x. That's going to give me 0.4x is equal to 8.4. To finish this up, let's divide both sides of the equation by this 0.4 here. And so this is going to cancel. And what we'll end up with is that x is equal to 8.4 divided by 0.4 is going to give me 21. So coming back up here, Kate is 21. That means Lauren is 1/3 times 21 is going to be 7, plus 11 is 18, so she's 18. And then Kristen, if you plug 21 in here, 21 plus 4 is 25. 25 times 1.2 is 30, and if you subtract away 4, you get 26. So coming up here, we want this answer here, where Lauren is 18, Kate is 21, and Kristen is 26. Okay, let's look at question 6. So again, we want to solve each word problem. So we have 1 year ago, Nancy was 3 times as old as her son, Bill, is today. If 5 years ago, Bill was 1/5 the age of his mom, Nancy, the year before, and I have a note here because this is tricky. This is really going to be 6 years ago from today. We then say, what is the age of Nancy and her son, Bill? So again, I've modeled everything on the next page, just a little bit neater than what I'm going to be able to write. So I let x be equal to Bill's current age, and then 3x plus 1 is Nancy's current age. So where does this 3x plus 1 come from? Well, if we come up here, again, it says Nancy was 3 times as old as her son Bill is today, so that's the 3x, but this is 1 year ago. So if I have 3x as her age 1 year ago, I have to add 1 to that to get to her current age. So that's why we have the x and then the 3x plus 1. Okay, so that's modeled. In terms of this equation, when we think about it, it says if 5 years ago, Bill was 1/5 the age of his mom, Nancy, the year before. So in other words, we're thinking about Bill 5 years ago, so that is x minus 5, and we're saying that's equal to 1/5 of the age of Nancy the year before. So in other words, her age 6 years ago. Well, we said that her current age was 3x plus 1, so 6 years ago it would be 3x plus 1 then minus 6. So times the quantity 3x plus 1 and then minus 6. Just showing you where this comes from. I'm just going to come down here and work on it in the more clean format. So let's say that we have x minus 5 is equal to, again, this is 1/5 times this quantity 3x, and then 1 minus 6 would just be negative 5. Okay, so what we could do is multiply everything by 5 to clear the denominator. So this is 5x and then minus 25, and this equals, this would go away, so you just have the 3x minus 5. So from here, let's subtract 3x away from each side of the equation. This would cancel. Let's add 25 to both sides of the equation. And let's cancel this out. So 5x minus 3x is 2x, and this equals negative 5 plus 25 is going to be 20. Let's divide both sides of the equation by 2. And so this will cancel, and we get x is equal to 20 over 2 is going to be 10. So this is going to be 10. That's the age of Billy. And then for Nancy, she's 3 times 10, which is 30, plus 1, she's going to be 31 years old. Let's come up here, and we want to say Bill is 10 and Nancy is 31. All right, let's look at question 7. So again, we want to solve each word problem. So Ashley left the hospital driving toward the lake 1 hour before Alberto. Alberto drove in the opposite direction, going 20 miles per hour slower than Ashley for 1 hour, after which time they were 115 miles apart. How fast did Ashley drive? So again, for this type of problem, you're going to need your distance formula. I've already set everything up on the next page. I'm going to let x be equal to Ashley's rate of speed in miles per hour. And so this comes under our column for r, or rate. So this is going to be x for that. And then Alberto, it says specifically he's going 20 miles per hour slower. So we have x minus 20 for that. Now, in terms of the distance formula, remember it's distance, or d, is equal to r for the rate and then times t for the time. So we have the time here. You see 2 for Ashley and 1 for Alberto. And where this comes from, if we go back, it says Ashley left the hospital driving toward the lake 1 hour before Alberto. So that means she's going to drive for an hour more than Alberto. And it says specifically that Alberto is driving for 1 hour. So Alberto is driving for an hour, and then Ashley's driving for 1 plus 1 or 2 hours. So that's where these numbers come from. And essentially to get your distance, you just multiply across. 2 times x is just 2x. And then 1 times x minus 20 is x minus 20. Now, this equation comes from the fact that, again, they're going in opposite directions. So if they're going in opposite directions, and after this certain amount of time, they're 115 miles apart, we just want to set the sum of their distances equal to that 115 and solve. So we have 2x, the distance that Ashley travels, plus x minus 20, the distance that Alberto travels. We're setting this equal to 115. So 2x plus x is just going to be 3x, and then minus 20 is equal to 115. Let's add 20 to both sides of the equation. So this will cancel. We'll have 3x is equal to 115 plus 20 is going to be 135. Let's divide both sides of the equation by 3. And so this would cancel. You'll get x is equal to 135 divided by 3 is 45. So remember, Ashley's speed in miles per hour was represented with x. That's exactly what we want to find. So this answer here is going to be 45 miles per hour. All right, let's look at question 8. Again, we want to solve each word problem. So a freight train left Berlin and traveled toward the outermost station at an average speed of 20 miles per hour. Sometime later, a diesel train left Berlin traveling in the same direction, but at an average speed of 30 miles per hour. After traveling for 12 hours, the diesel train caught up with the freight train. How long did the freight train travel before the diesel train caught up? So another problem with the distance formula, but with this one, again, they start at the same place, and when you hear that word caught up, they end up at the same place. So the two distances will be set equal to each other. So all I really need to do is let x be equal to the time in hours traveled by the freight train, because that's unknown. For the diesel train, it tells us that it's 12 hours. And then the rates are given. The freight train is moving at 20 miles per hour, and the diesel train is moving at 30 miles per hour. And then again, you just multiply across. Distance is equal to rate of speed times time traveled. So the freight train, the distance is 20x. The diesel train, the distance is 30 times 12 or 360. So again, the distances will be equal because you hear that word caught up. So all I have to do is solve this simple equation. 20x equals 360. Divide both sides of the equation by 20. And so let's cancel this out and say that we have x is equal to, you can cancel a 0 here if you want to make this a little bit easier. 36 divided by 2 would be 18. So this is 18 or 18 miles per hour. And you can eyeball that and see it works. 18 times 20 is going to give you 360 as well. So let's come back up and select 18 hours for, again, the amount of time that the freight train traveled for before the diesel train caught up. All right, let's take a look at question 9 now. So we want to solve each word problem. We have premium salad mix, which costs $3.76 per pound, is made by combining arugula, which costs $5.88 per pound, with spinach, which costs $3.23 per pound. Find the number of pounds of arugula and spinach required to make 2.5 pounds of premium salad mix. All right, so let's just let x be equal to the amount in pounds of arugula we're going to use. And then again, because the total mixture is 2.5 pounds, we're going to say 2.5 minus x is the number of pounds of spinach we're going to use. So let's come down here. And so we have x is equal to the number of pounds of arugula. So that's here. And then spinach is 2.5 minus x. And the total mixture is 2.5 pounds. So we know that. We're given the cost per pound in each case. It's $5.88 for the arugula, it's $3.23 for the spinach, and for the final mixture, it's $3.76. So we think about the total price. We multiply the number of pounds times the cost per pound. So here it's 5.88x. Here it's 3.23 times the quantity 2.5 minus x. And then here it's just 2.5 times 3.76, which is 9.4. So these two have to be equal because, again, the total price, this $9.40 that you're going to end up with, comes from the price of the arugula plus the price of the spinach. Let's just solve this equation. So we would have 5.88x plus 3.23 times 2.5 would be 8.075. And then minus, you would just have 3.23x. This equals 9.4. All right, so on the left-hand side, we can combine like terms. 5.88x minus 3.23x is going to be 2.65x. And let's put plus 8.075 equals 9.4. From here, let's subtract 8.075 away from each side of the equation. So this is going to cancel. And you'll have 2.65x is equal to 9.4 minus 8.075 is going to be 1.325. To finish this up, let's divide both sides of the equation by 2.65. And so this will cancel. We'll have x is equal to 1.325 divided by 2.65 is going to be 0.5, or you could say a half a pound. So it's going to be a half a pound of arugula and then 2.5 minus 0.5, which is 2. So 2 pounds of spinach. So we want 0.5 pounds of arugula and 2 pounds of spinach. All right, let's look at question 10. So we want to solve each word problem. And this one is very similar to the last one. So we have Save Mart generic sugar, which costs $2.12 per pound, is made by combining Cool Treat sugar, which costs $3.30 per pound, with Sweetly sugar, which costs $1.40 per pound. Find the number of pounds of Cool Treat sugar and Sweetly sugar required to make 9.5 pounds of generic sugar. So x is equal to the number of pounds of the Cool Treat sugar. And so Sweetly is, again, 9.5 minus x, and then the generic mixture is 9.5. So the cost per pound, again, it's given to us in the problem. It's $3.30 for this one, $1.40 for this one, and $2.12 for this one. And then the total price is just us multiplying across. So 3.3x, 1.4 times the quantity, 9.5 minus x, and then $20.14 here. Again, the number of pounds times the cost per pound. So these have to be equal. In other words, the total price spent on this guy plus the total price spent with this guy has to be equal to this 20.14. Again, the total cost of this final mixture, this generic sugar they're selling. Now let's just clean up. So 3.3x plus 1.4 times 9.5 is going to be 13.3. And then minus 1.4 times x is just 1.4x. Let me make that a little bit cleaner. And this equals 20.14. Okay, so from here, 3.3x minus 1.4x, that would give me 1.9x. Let's subtract 13.3. Let me make this 3 a little bit cleaner. Away from each side of the equation. Let's cancel that away from over here. Let's say this is equal to 20.14 minus 13.3 is going to be 6.84. All right, to finish things up, let's divide both sides of the equation by 1.9. And so this would cancel. And what you're going to have here is x is equal to 6.84 divided by 1.9 is going to give me 3.6. So with x being equal to 3.6, what we can say is 3.6 is the number of pounds for the cool treat sugar. And then the other guy was 9.5 minus 3.6. So that's going to be 5.9 pounds. And that was for the sweetly sugar. So coming back up here, we want 3.6 pounds of the cool treat sugar and then 5.9 pounds of the sweetly sugar. All right, let's take a look at question number 11 now. So we want to solve each word problem. So Joshua has a piggy bank with a total of 39 coins. The piggy bank has a total value of $2.64 and contains only dimes and pennies. How much of each type of coin does Joshua have in his piggy bank? So the idea here is that you know the total coins, it's going to be 39. And you also know the total value is $2.64. So let's come down here and you can let x be equal to one of them. And then the other one's going to be 39 minus x. Now this is the number of coins you have, but it's not the value. Remember, you have to take and set up a little table or something else, whatever's going to organize the information. You have the number of coins. In this case, for dimes, it's x. For pennies, it's 39 minus x. Then you have to think about the value each. So for a dime, it's 0.1. And then for a penny, it's 0.01. So then you have to think about your total value. So what's the total value of all dimes? It's 0.1 times x. What's the total value of all pennies? It's 0.01 times the quantity 39 minus x. So you have the total value here, right? So the total value from dimes plus the total value from pennies, you set that equal to the total value of the piggy bank, which is told to you in the problem, as $2.64. So that's how we got our equation here. So let's go through and just solve this real quick. So you're going to have 0.1x plus 0.01 times 39, that's going to be 0.39, and then minus 0.01x, and this equals 2.64. From here, you have 0.1x minus 0.01x. That's going to give me 0.09x. Then what I want to do is subtract 0.39 away from each side of the equation. This would cancel. We'll set this equal to 2.64 minus 0.39. That's going to give me 2.25. From here, I'm going to divide both sides of the equation by 0.09. And so this would cancel. And I'm going to have x is equal to 2.25 divided by 0.09. That's going to give me 25. So that tells me there's 25 dimes, and then 39, the total number of coins, minus 25 is going to be 14. So there's going to be 14 pennies. So it's not this one, you want this one. You want 25 dimes and 14 pennies. So this one right here. And again, a quick check, 25 dimes would be $2.50, and 14 pennies would be 14 cents. So $2.50 plus another 14 cents would give you that $2.64 that you have right there as the value for all the coins in the piggy bank. All right, let's take a look at question 12. So we want to solve each word problem. So Maritza purchased a sound system using only cash. She paid a total of $168 using $1 bills, $5 bills, and $10 bills only. She used 4 more $5 bills than $1 bills. If she had used 2 fewer $5 bills, the amount of $10 bills used would have been 1/5 the number of $5 bills used. How much of each type of bill did she use to purchase her sound system? So this one is not that bad overall. It's similar to the last problem, you just have more things going on. So once again, I've set everything up on the next page. So I'm just going to let x be equal to the number of $5 bills. And I did that because it's involved in each comparison. So then x minus 4 is the number of $1 bills. If we go back up, it specifically says she used 4 more $5 bills than $1 bills. So the $1 bills would be 4 less than the $5 bills, so it would be x minus 4. Then if we come down here, we have 1/5 times the quantity x minus 2 is the number of $10 bills. So where this comes from, we basically say that if she had used 2 fewer $5 bills, so that's x minus 2, the amount of $10 bills used would have been 1/5 the number of $5 bills used. So I'm just going to multiply 1/5 times that quantity x minus 2, right? If she had used 2 fewer $5 bills. So that's where this 1/5 times the quantity x minus 2 came from. Now, what we can do is set up a little table. So we have for the $1 bills, again, it's x minus 4. For the $5 bills, it's x. And for the $10 bills, it's 1/5 times the quantity x minus 2. We have the value each. A $1 bill, we just put 1. $5 bill, we put 5. $10 bill, we put 10. And then the total value, we just multiply across. So in other words, 1 times x minus 4 is x minus 4. Then 5 times x is 5x. And then 10 times 1/5 would be 2. And so you have 2 times the quantity x minus 2, and that would be 2x minus 4 when you distribute. So now what we would do is sum all the total values. So the total value of the 1s plus the total value of the 5s plus the total value of the 10s, and set that equal to the $168. Again, that's the total that's given to us in the problem, right? A total of $168 is what she paid. So let's come back down and just solve this simple equation. So x plus 5x is 6x plus 2x is 8x. So this is 8x. You get negative 4 minus 4. That's going to be minus 8. And this equals 168. Let's come down here and let's add 8 to both sides of the equation. And so this is going to cancel. We have 8x is equal to 168 plus 8. That's going to be 176. Let's divide both sides of the equation by 8. This would cancel. We got x is equal to 176 divided by 8 is going to give me 22. So coming back up here, there's going to be 22 $5 bills, and then 22 minus 4 is 18, so there's going to be 18 $1 bills, and then 22 minus 2 is 20, and then 20 times a fifth is 4, so there's going to be 4 $10 bills. We want to say that there's going to be 22 $5 bills, 18 $1 bills, and 4 $10 bills. We want this guy right here. All right, let's take a look at question 13. So again, we were asked to solve each word problem. So after meeting with his accountant, Mark decided he needs a total of $6,975 in yearly interest. Mark will invest part of his money in a certificate of deposit, which pays 9% annual simple interest, and 3 times $5,000 more than this amount in state bonds, which pays 2.5% annual simple interest. How much was invested in each? So what I would do here is I would let X be equal to the amount of money he puts in the certificate of deposit. And then you're told specifically here that it's 3 times $5,000 more than this amount. So 3 times, basically X plus 5,000 is the amount he's putting in the state bonds. We have X is the amount of money placed in the CD or the certificate of deposit. And then 3 times, again, X plus 5,000, that's the amount of money placed in the state bonds. Now coming to the table, again, we have simple interest earned, which is I, is equal to the principal, which is P, times R, which is the rate. Again, usually you have time, but in this case, it's 1 year, so we just leave it off. So we know how we got the principal, the X, and then the 3 times the quantity X plus 5,000, but the rate is given to us in the problem as well. It says the CD is paying 9%, so 0.09, and then the state bonds, that's going to pay 2.5%. Now you need this $6,975 in yearly interest to get an equation, so that's where this comes from here. You see our rate 0.09 and then 0.025. Again, you multiply across to get the simple interest. And the idea here is that you take the simple interest from the CD, which is 0.09x. You add that to the simple interest from the bonds. So 0.025 times 3 gives you the 0.075, then times x gives you the x part, then plus, again, if you do 0.025 times 3, then times 5,000, you get 375. So when you add these two guys together, you set it equal to the amount of interest he's going to earn for that year. Again, this is in terms of simple interest. So what we would do here is say 0.09 plus 0.075, that's 0.165, and then times x, and then plus 375. This equals 6,975. All right, let's subtract 375 away from each side of the equation, and let's cancel this away. From here, let's say we have 0.165x is equal to 6,975 minus 375 is going to be 6,600. So what I'll do now is divide both sides of the equation by 0.165. Let's cancel this, and we'll say we have x is equal to 6,600 divided by 0.165 is going to be 40,000. So basically, he's going to put $40,000 into the CD. And then again, what you would want to do, if we come back up here, 3 times 5,000 more than this amount in state bonds. So $5,000 more than $40,000 is $45,000, and then 3 times that amount is $135,000. So we want this answer right here. $40,000 going into the CD or certificate of deposit, and then $135,000 going into the state bonds. All right, let's take a look at question 14. So we want to solve each word problem. So Larry won $2 million in the state lottery. From this amount, state and federal taxes of 50% were deducted. So let's just stop there. If I take 50% of your money away, then instead of having $2 million, I now have $1 million. So I'm just going to write right here that we have $1 million to work with. Okay, forget about the $2 million. It is not relevant anymore. Okay, so we only have $1 million to invest. So it says Larry opened a brokerage account with the remainder of the money. So with the $1 million, he placed half of his balance into a stock fund. So what is half of $1 million? That's going to be $500,000. So I'm just going to put here that this is going into the stock fund. So this is a given for us. And it says, which pays 12% annual simple interest. The remainder of his account balance was split between 2 investments. So you have a bond fund, which pays 5% annual simple interest, and a money market fund, which pays 1.5% annual simple interest. If after 5 years, the account balance was $1,390,000, how much was invested in each? So again, here's where you really have to just pay attention to what's going on. The first thing is he started with $1 million. So if he ends up with $1,390,000, how much interest did he make? Well, you would just do a simple subtraction there, and it's $390,000. So let's just write that down, that he's going to earn $390,000 in simple interest. Now, it's a given how much simple interest he's going to earn from the stock fund, because it tells us it's paying 12%, and it's doing that for 5 years. So $500,000, which is the principal, times 12%, 0.12, that's $60,000. If you do that for 5 years, that's $300,000. So that tells me, again, if you take the $390,000 total and you subtract away $300,000, well, he's earning $90,000 in simple interest from these 2 guys here. So from the bond fund and from the money market fund. So that's really all you have to worry about. If you go down here, I went ahead and let X be equal to the amount of money placed in the bond fund, and then $500,000, which again, that's half of $1 million. That's the other half that was not put into the stock fund. So minus X is the amount of money placed in the money market fund. So setting up a little table here, what you have here is the stock fund. Now this isn't going to be relevant to this equation, but I just listed it. Again, you're putting $500,000 into it. It pays 12% interest. And this is for 5 years. So if you multiply across here, again, simple interest earned is principal times rate times time, where you're going to get this $300,000. And again, the total interest earned was $390,000. So take off the $300,000, and that's how you get this $90,000 here that's coming from this guy and this guy. So these 2 added together. So the principal for the bond fund is X, the rate is 0.05, the time is 5 years. The principal for the money market is going to be $500,000 minus X. The rate is 0.015. The time is 5 years. So again, we just multiply across to get these values here. And then if we add them together, it has to be equal to 90,000. So that's where this is all coming from. All right, so let's go through and solve this. We'll say 0.25X plus, we have 0.075 times 500,000. That's going to be 37,500. And then minus 0.075X. And this equals 90,000. Okay, so 0.25x minus 0.075x is going to be 0.175x. Let's subtract 37,500 away from each side of the equation. So this would cancel. And so let's set this equal to, over here, 90,000 minus 37,500. That's going to be 52,500. Okay, so let's divide both sides of the equation by 0.175. So divide over here. And let's cancel this right here and say X is equal to 52,500 divided by 0.175. That would be equal to 300,000. So what that's telling me is that he put $300,000 into the bond fund and $200,000 into the money market. We know that the stock market fund was $500,000. The bond fund was $300,000. We just figured that out. And then $500,000 minus $300,000 is $200,000. So that's your money market fund. So let's just circle that as our answer. All right, let's look at question 15 now. So we have that Nancy owns a pawn shop and currently has $16,530 in inventory. This represents a decrease of 43% from the year before. What was the store's inventory last year? So again, with these problems, there's a lot of ways to set them up. Typically, what I'll do is I'll just let X be equal to the store's inventory last year. So we have whatever that is, then minus, you have a 43% decrease. So I'm just going to put 0.43 times X like this. And I'll set that equal to the value that I'm given, which is 16,530. So very easy to solve this. Remember, this is a coefficient here that's understood to be 1. So 1 minus 0.43 is going to be 0.57. So you have 0.57x is equal to, this is 16,530. Let's divide both sides of the equation by 0.57. And so let's cancel this, and I'll say x is equal to 16,530 divided by 0.57. That's going to give me 29,000. So her store's inventory last year was $29,000. All right, let's look at question 16. So we want to solve each word problem. So Abby, a furniture saleswoman, earns a monthly salary of $2,400. In addition to this, she earns a 19% commission on all of her sales. Abby pays an income tax rate of 34%, which includes all state, local, and federal taxes. Last month, her after-tax check totaled $3,339.60. How much merchandise did she sell? So a very simple problem overall. We know that she earns a monthly salary of $2,400. I would just start with that. You know that she doesn't have to do anything or sell anything, I would say, to be more specific, to get that money. But it says, in addition to this, she gets a 19% commission on all of her sales. So let's let X be equal to how much she sold. And again, that's what we're trying to find. How much merchandise did she sell? So let's say plus the 19% is 0.19 times X, which again is the amount of merchandise she sold. So this right here would be her gross income, the amount of income we get in our check before they take out all the federal taxes, the state taxes, the health insurance, your 401, all that stuff that they take out. So this is your gross income. So what we're going to do is subtract away. All she really has is income taxes, which we're told it's 34%. She doesn't have any other deductions that we're told about. So I'm going to say 0.34, again, times this income. So this is a quantity 2,400, and then plus 0.19x, like this. And what we can do before we set it equal to this total here, let's just clean it up so it's a little bit easier to work with. I'm going to say that this is going to be 2,400 plus 0.19x. So negative 0.34 times 2,400 is going to be negative 816. And then negative times positive is negative. So 0.34 times 0.19 is going to be 0.0646 and then times x. So cleaning this up, if we do 2,400 minus 816, that's going to be 1,584. And then 0.19x minus 0.0646x is going to be 0.1254x. So this is 0.1254x. Let's get rid of this. So this is pretty simplified now. Let's set this equal to, again, this total, which is $3,339.60. And again, this is the amount she makes after you've taken the taxes out. So let's drag this up here a little bit. All I really have to do is subtract 1,584 away from each side of the equation here. And so this will cancel. You have 0.1254x is equal to 3,339.6 minus 1,584 is going to be 1,755.6. Let's divide both sides of the equation by 0.1254. So 0.1254. So this right here would cancel. And so we'll say x is equal to 1,755.6 divided by 0.1254 is going to be 14,000. So let's just erase all this and say the answer here for how much merchandise she sold is going to be $14,000. All right, let's take a look at our quiz. So for the first question, we're asked to simplify each. And what we're given here is the square root of negative 96. So the idea is that you want to break this up. You have this negative here. So I'm just going to say this is the square root of negative 1 times, for 96, it's 16 times 6. So the square root of 16 times the square root of 6. And again, just replace what you can. We know that the square root of negative 1 is the same thing as I, the imaginary unit. We know the square root of 16 is 4. So basically, this can be rewritten as 4 times I, and then times the square root of 6, which you can't do anything with. So the answer we want here is 4i times the square root of 6. All right, for question 2, again, we're asked to simplify each. What we have here is the square root of negative 392. So we don't need to actually write out the square root of negative 1 each time. If you see the negative here, just pull it out and put an I there and be done with it. Now we can just work with 392. It's kind of a big number, but I would start by dividing it by 4 because the last two digits, 92, that's divisible by 4. So 392 divided by 4 would give you 98. So you have 4 times 98, and 4 is a perfect square. It's 2 times 2. Then 98 is going to be 2 times 49, and then 49 is a perfect square. It's 7 times 7. So I'm going to write this as the square root of 4, and then times the square root of 49, and then times the square root of 2, just to make it completely clear what's going to happen here. And we'll say this is equal to square root of 4 is 2, square root of 49 is 7, 2 times 7 is 14. So then we'll have 14i times the square root of 2 as our answer. So this guy right there. Okay, let's look at question 3. Again, we're asked to simplify each. So we have the square root of -3 times the square root of -6. Okay, so the most common mistake here is to do this. So you say this is equal to, you just say that this is the square root of -3 times the square root of -6. And so you say this is the square root of 18. And then you simplify this and say that it's going to be 3 times the square root of 2. But this answer is wrong. So let me just mark this out and say this is wrong. Why is it wrong? Because the product rule for radicals is only valid in this situation when both the numbers are not negative. So you can't actually do this. What you need to do is take the extra step here and simplify each guy first. So in other words, this is I times the square root of 3, and then times this is I, and I'm going to break this up and say this is the square root of 3 times the square root of 2. So what you end up with is I times I, which is I squared. So this is I squared. And then times square root of 3 times square root of 3 is 3. And then times the square root of 2. So the difference here is the sign. I squared is -1. So this gives me -3 times the square root of 2 as my answer. So I'm looking for -3 times the square root of 2. This guy right there. Okay, let's look at question 4. Again, we're asked to simplify each. So now we have the square root of -300 over the square root of -100. So I'm going to do the same thing. I'm going to simplify each one first. So I'm going to say this is I times, let's write this as the square root of 100 so we can cancel it, times the square root of 3. This is over. We'll say I times the square root of 100. And so essentially the I over the I is going to cancel. That's 1. Square root of 100 over square root of 100 is 1. So I'm just left with the square root of 3 as my answer. So basically I want this guy right here. Again, square root of 3. Okay, let's look at question 5. So again, we're asked to simplify each. So we have the square root of -4 times the square root of -25 over, we have the square root of -9 times the square root of -81. So I'm going to say this is I times, square root of 4 would be 2. So let's just write 2i, make this a little bit quicker. And then times, basically you would have square root of 25 is 5. You have a negative there, so it's 5i. So this is 5i. Then over, square root of 9 is 3. So because of the negative, it would be 3i. And then times, here the square root of 81 is 9. Because of the negative, it's 9i. So between the numerator and denominator, there are no common factors other than the i's that you can cancel, right? So you can cancel basically I squared between the numerator and denominator. So this is going to all cancel away. And you're left with 2 times 5 or 10 over 3 times 9, which is 27. So you end up with 10 over 27. So this is your answer. All right, let's take a look at our quiz. So for the first question, we're asked to simplify each. And let's write this out. We have -3, then minus 5i. Then we're adding to this. We have -7 plus 2i. Then we're subtracting away. We have -6 plus 4i. Okay, so again, the idea for this problem, we want to add the real parts together, and then we want to add the imaginary parts together. And we're going to come up with a complex number in standard form, which is a plus bi. So that's what we want to do. So I'm going to drop all the parentheses here. So I'm going to have -3 minus 5i, and then we'll put -7 plus 2i. Now you have a minus here in front of these parentheses. Again, a lot of people will like to put this as plus -1 and then distribute the -1 to each term. So that reminds you to change the sign. So this would be plus 6 and then minus 4i. So from here, again, you can regroup this if you need to do that. And I think for this first one, let's just do that. So let's put -3. And then we'll put -7 and then plus 6. We'll put those together. And then we'll have -5i. And we'll have plus 2i. And then minus 4i. We'll put those together. Again, sometimes it's helpful to rearrange things because if you don't, you might miss something. So let's come down here a little bit. And let's go through and just combine what we can. So we have -3 minus 7. That's -10. And then -10 plus 6 is going to be -4. Then we have -5i plus 2i. That's going to be -3i. And then minus 4i would be -7i. So this is in the form of a, which is -4 here, plus b, which is -7 here, times I. So -4 minus 7i. So coming back up here, this is what we want. -4 minus 7i. All right, let's look at question 2. Again, we're just asked to simplify each. So we have this quantity 2 minus 3i, then plus the quantity 7 plus 3i, then plus, you have your quantity -2 plus 6i. Okay, so let's just drop the parentheses from here. I'll say 2 minus 3i and drop the parentheses from here. So plus 7 plus 3i. And again, we could just drop the parentheses from here. So minus 2 plus 6i. If you want to pause the video and take the time to rearrange things, that's up to you. I'm just going to do this in line. So I can see here that I have 2 minus 2, which is 0. So really all I'm going to have left is going to be a 7. That's going to be my a. Then I have negative 3i plus 3i. Those are going to cancel. That's 0. And so I just have the 6i, so plus 6i. So again, this is in standard form. A is 7 plus b, which is 6, times your I. So 7 plus 6i. So I'm looking for this answer right here. Okay, let's look at question 3. Again, we're asked to simplify each. So it looks like we have the quantity 3 minus 3i times the quantity 5 minus 5i times the quantity 5 plus 2i. All right, so let's put equals here. And what I'm going to do is I'm going to multiply these first two together, and then I'll take that result and multiply it by the last one. So first terms, 3 times 5 would just be 15. And then my outside, 3 times negative 5i would be minus 15i. My inside, negative 3i times 5 would be minus 15i. And then for the last terms, you have negative times negative, which is positive. You have 3 times 5, which is 15. And you have I times I, which is I squared. Now again, I squared is negative 1, so it's just going to change the sign. Right? So it's just going to change the sign to a minus. Now we have 15 minus 15, which is 0. So this is going to go away. Okay, this is going to go away. Let me actually erase that too. So we have negative 15i minus 15i. That's just going to be negative 30i. So let's write this as negative 30i, then times this 5 plus 2i. And so negative 30i times 5 is negative 150i. And then negative times positive is negative. 30 times 2 is 60. I times I is I squared. Again, whenever you see I squared, it's negative 1, so you're just changing the sign. So you can actually erase this and just put a plus. Now again, we want to write this in standard form, so we want the 60 out in front. 60 is your A, and then we'll have negative 150 for the B, and then times I. So 60 minus 150i, that's your answer in standard form. So coming back up here, we want 60 minus 150i. All right, let's look at question number 4 now. So we're asked to simplify each. So we have 5 over negative 2i. And again, the idea here is that whenever you have I in the denominator, it represents the square root of negative 1. And we're not supposed to have a radical in the denominator when we're talking about simplifying something. What I can do is multiply by I over I. And this is going to give me 5i over negative 2 times I squared. So we know that I squared is negative 1. So really, this is just 5i over negative 2 times negative 1, which is 5i over positive 2. So I'm looking for this guy right here, which is 5i over 2. All right, let's look at question 5 now. So again, we're asked to simplify each. And what we have is negative 3 plus 5i over 2 minus 5i. So with this one, because we have two terms here, we need to multiply the numerator and denominator by the complex conjugate. So I'm just going to take this guy right here, 2, and then change the sign to plus, and then 5i. So I'm going to do that in the numerator and also the denominator so it's legal. Let me wrap this, and also this and this. Okay, so for the numerator, we need to use FOIL. Negative 3 times 2 would be negative 6. And then negative 3 times 5i would be minus 15i. And then 5i times 2 would be plus 10i. Then we're going to have 5i times 5i. That's going to be plus 25i squared. Okay, so let's just simplify this where we are right now. So I know that negative 15i plus 10i would be negative 5i. Let's just erase this and put minus 5i like this. I know that I squared is negative 1, so let's just write this as a minus 25. And so you have negative 6 minus 25, that's just negative 31. So let's get rid of that and write this as negative 31 minus 5i. Let me clean this up a little bit so that it's nicer. Okay, so this is over. Down here, remember, you can just use your formula. Instead of it being a squared minus b squared, it's going to be a squared plus b squared. So 2 is squared, that's 4. And then plus, you would take 5 and you would square that. That's going to be 25. Again, if you need to pause the video, or we can just do it real quick, you know the first term's 2 times 2 is 4. So that's where that came from. The outer is 10i and the inner is negative 10i. So those cancel. And then for the last, you have negative 5 times positive 5, which is negative 25. And then I times I is I squared. I squared is negative 1. So it flips negative 25 to positive 25. So that's how we get positive 25 here. So 4 plus 25 is going to be 29. So this is 29. And we would just break this up to put it in standard form. So this is negative 31. Let me make this better. So negative 31 over 29. That's your A. And then we'll have minus 5 over 29. That's your B. So negative 5 over 29 and then times I. So it looks like I'm looking for this answer right here. So we want, again, negative 31 over 29. And then plus you have negative 5i over 29. All right, let's take a look at our quiz. For the first question, we're asked to simplify each. And we have I, our imaginary unit, raised to the power of 57. So the idea is we want to think about the next number going down that's going to be divisible by 4. We know 57 is not going to be, it's an odd number, but 56 would be, right? 56 divided by 4 is 14. So I could break this up into I raised to the power of 56 times I to the first power. You could just write I if you wanted to. Remember, if this exponent right here is going to be divisible by 4, we can just line this out and put that it's a 1. And then basically 1 times I to the first power is just going to be I. So I want to select this guy right here, I, as my answer. Let's look at question 2. So again, we're asked to simplify each. So we have I raised to the power of 214. So the first thing you would ask yourself, again, is 214 divisible by 4? You can always check the final 2 digits of a number and say, in this case, it's 14. Is 14 divisible by 4? The answer is no. So 214 will not be divisible by 4. So just going down, you would look at 213. That's odd. So then 212. 12 is divisible by 4. So we know 212 would be. So let's write this as I raised to the power of 212, again, because it's divisible by 4, times I squared. So again, if the exponent is divisible by 4, you can just line it out and put a 1 there. And then I squared by definition is negative 1. So the answer here is just going to be negative 1. All right, let's take a look at question 3 now. So we're asked to simplify each. We have I raised to the power of 35. So I raised to the power of 35. And again, just thinking about this number here, 35 is odd, so it's not going to be divisible by 4. Then you have 34, which isn't going to be. 33 is odd. And then you go to 32. So 32 is. So we would say I raised to the power of 32, then times I cubed. And so again, for 32, it's divisible by 4. So I know I can just line this out and put a 1. So what I'm left with here is I cubed. And I cubed is just by definition negative I. So I'm looking for negative I as my answer. All right, let's look at question number 4 now. We're asked to simplify each, and what we have is I raised to the power of negative 217. So like I've talked about before, there's 2 ways to do this. There's a fast way, and that way would be to think about I to the 4th power in such a form that I could multiply it by this and get a least possible positive exponent on I, okay? So I would think about I to the power of 220, because 220 is divisible by 4. So I'd put I to the power of 220 like this. And this is not illegal because, again, I to the power of 220 is 1, and I can multiply anything by 1 and not change its value. So what happens here is I stays the same, and we basically add the exponent. So 220 minus 217 is going to be 3. So this gives me I cubed, which ends up giving me negative I by definition. So this would be negative I. Now, you might want to do this a different way because this might be confusing for you. So let me actually erase this and do this the other way, just in case you're lost right now. So you could also say this is 1 over I to the power of 217. Of course, you would need to break this up and say this is 1 over I to the power of 216, because 216 is divisible by 4, then times I like this. And so this guy right here is going to cancel and become 1. So here's where we get 1 over I, and you might be thinking, well, this does not match this. What happens is you have to rationalize the denominator, okay? Because I is the square root of negative 1. We don't want a radical in the denominator for simplifying. So you're just going to multiply by I over I to do this. So the numerator is I, the denominator is I squared, which again by definition is negative 1. So this is I over negative 1, which is just negative I. So either way you do it, if you use the shortcut, that's fine. If it doesn't make sense for you or it's just something you're not getting, then just go through it, do it the longer way. You'll get the right answer no matter which method you choose. Just remember you need to rationalize the denominator if you end up with I in your denominator. Okay, let's look at another one. So question 5, we want to simplify each. So we have 3 over I raised to the power of 19. Well, again, a lot of ways you could do this. You could use the shortcut. Let's do the shortcut second. So let's go ahead and say this is 3 over 19 is not divisible by 4. Neither is 18, neither is 17. You have to go down to 16. So let's say I to the power of 16 times I. This would be cubed here. And so we'll say that this is 3 over, again, I to the power of 16. This is just going to be 1. So 3 over I cubed. Now, I cubed is negative I. So you would say this is 3 over negative I. And again, you want to rationalize the denominator. So I'm going to say this is times I over I. So this would be 3I over, you have basically negative, let's put that as negative 1, times I, which is I squared. And we know I squared is negative 1. So let's say this is 3I over negative 1 times negative 1, which is just 3I. So the answer I'm looking for here is 3i. Now, let's stop for a moment and do it a different way. If I had this problem on a test, here's how I would attack it. I would first move this into the numerator. So I would say I have 3. Let's put equals. So I would say I have 3 times I raised to the power of negative 19. Remember, you can drag this across the fraction bar. You just have to change the sign of the exponent. So 3 times I raised to the power of negative 19. Now what I would do is multiply, again, by a form of 1. So you would need, in this case, I raised to the power of 20. So I raised to the power of 20. Again, why did I choose this? Well, 20 is divisible by 4, right? So that means that I raised to the power of 20 is 1, and I can multiply by 1 and not change something. And 20 minus 19 is going to give me 1. So doing it this way, I'm just going to get 3i as my answer, and you see how much quicker that was, right? So you can do it this way. Again, if it's confusing for you, you're just not getting it, just take the time to do it the longer way. You'll get the same answer. All right, let's take a look at our quiz. So for the first question, we're asked to solve each equation by factoring. And let's just write this out. We're going to have 25x squared. Then we'll have plus 40x. And this equals negative 24. Then minus 8x. Then we have plus 7x squared. All right, so what I'm going to do here is first put this into standard form. So the ax squared plus bx plus c equals 0. So to do that, I'm just going to subtract 7x squared away from each side of the equation. Let me show this is canceling. I'm going to add 8x to both sides of the equation. And let me show this is canceling. Let me add 24 to both sides of the equation. Let me show this is canceling. Remember, if you don't have anything left over here, you want to put a 0. All these operations result in 0. So negative 24 plus 24, that's 0. Negative 8x plus 8x, that's 0. And 7x squared minus 7x squared, that's 0. So just put a big fat 0 here for the right-hand side. Okay, on the left-hand side, I'm just going to simplify. So 25x squared minus 7x squared, that's going to give me 18x squared. And then you have 40x plus 8x, so that's plus 48x. And then you're going to have plus, you have this 24 here, and this just equals 0. Now at this point, I think most of you can see that there's a common factor of 6 that you can either pull out or you can divide everything by 6 if you want to do that. I think it's probably quicker to just divide everything by 6. Let's just do that. I know in the practice test we were just pulling it out, but this is another approach, so let's just do this for the quiz. All right, so coming down here, 18 divided by 6 would be 3, so this is 3x squared, and then plus 48 divided by 6 is going to be 8, so this would be 8x, and then plus 24 divided by 6 would be 4, and then this equals 0 divided by 6 is 0. So from here, we just want to factor the left-hand side into the product of two binomials. So let's go ahead and set this up like this. And since 3 is a prime number, it's real easy. I'm just going to put 3x here and x here. 4 can only be 1 times 4 or 2 times 2. So you can try it with 4 and 1. Let's just start with that. If I put a 4 here and a 1 here, does that work? Remember, these signs are all plus, so we're going to be adding. So 3 times 4 is 12, plus 1 would be 13, so that's not going to work. If you flip the order around, put a 4 here and a 1 here, this is 3 plus 4, that's going to be 7. So 4 and 1, that's not going to work. So it would have to be 2 and 2, and everything would have to be a plus. So this would be 6x, and this would be 2x. Now let me just show this so no one's lost. This would be 6x, this would be 2x. 6x plus 2x gives you the 8x that you need. Okay, so this is what we want for our factorization. And then coming down here, I'm just going to set each factor with a variable equal to 0. So you've got your 3x plus 2, set that equal to 0. Then or you've got your x plus 2, set that equal to 0. And what we'll do from here is subtract 2 away from each side of the equation. Let's show that as canceling. We'll have 3x is equal to negative 2. Divide both sides of the equation by 3. And so this cancels, and you'll have x is equal to, let me fix this 3 here, make that a little bit better, but x equals negative 2 thirds. Okay, so that's the first answer. Over here, I'm just going to subtract 2 away from each side, so it's a little bit simpler. So that would cancel. You get x equals negative 2. So basically, x can be negative 2 thirds, or x can be equal to negative 2. So coming back up here, I want this answer here. X is negative 2 thirds, or negative 2. All right, let's look at question 2 now. Again, we just want to solve each equation by factoring, and we're looking at 100x squared plus 425x plus 120, and this equals negative 5x. So all I need to do is add 5x to both sides of the equation. So that's pretty simple. This will be 0 over here. So you have 100x squared, and then plus this will be 430x plus 120 equals 0. So everything ends with a 0. So you know that everything is divisible by 10. So again, you could pull the 10 out and leave it outside if you want, or you can divide everything by 10. It makes no difference to your final answer. It's really a matter of personal preference. I'm just going to divide everything by 10 just to change things up a little bit from what we've been doing. So this would be 10x squared plus this would be 43x plus this would be 12, and this equals, of course, 0 divided by 10 is 0. All right, so thinking about factoring this left-hand side now, so with 10, it's not a prime number, so that gives us more possibilities. So generally speaking, you're going to have 10 times 1 or 5 times 2, and 10 times 1 is less likely to work. So if I'm solving this problem on my own, I'm going to start with 5 and 2. So I would start with 5x here, and then 2x here. And this is not going to work, but I just want to take you through it real quick. If you look at 12, it's 1 and 12, or it's 2 and 6, or it's 3 and 4. Now, 2 and 6 are not possible because you'd have a common factor of 2 here. If you put in a 2 here or if you put in a 6 here. So you can cross that out right away. Again, there's no common factor of 2 here, so there can't be a common factor in here. So when I think about 1 and 12, you can't put a 12 here, but you could put it here. You could put a 12 there and a 1 there. So your outer there would be 5. Your inner would be 24. 24 plus 5 is 29. So this is gone. Then you could also have 3 and 4, but again, you can't put a 4 here. You could put the 4 here and the 3 here. This would be 15 plus 8, which is 23, so this is gone. So that's not going to work. So you're going to have to resort to going to 10 and 1. So in this situation, that's what you need. But usually, I would say in most circumstances, something extreme like 10 and 1 or 15 and 1, something like that, it's just not going to work. So for 12, again, it's 1 and 12. It's 2 and 6, but that can't work because, again, you'd have a common factor of 2 here. So we would just go to 4 and 3. Okay, so I can't put the 12 here, but I could put it here. But obviously, that's going to be too big, so just throw that out. This is gone. So it has to be 4 and 3, and the 4 can't go there. It has to go here, and the 3 has to go here, and it has to be all plus signs. So does this work? Yeah, the outer here is going to be 40x. The inner here is going to be 3x. 40x plus 3x is 43x. So this is exactly what we're looking for. Okay, so let's take the 10x plus 3, set it equal to 0. Then let's take the x plus 4, set that equal to 0. And we're just going to solve each one of these individually. Let's subtract 3 away from each side of the equation. This cancels. You'll have 10x is equal to negative 3. Let's divide both sides of the equation by 10. And let's cancel this away and say x is equal to negative 3/10. Over here, let's subtract 4 away from each side of the equation. Let's cancel this away. And so we'll say I'll actually do it up here too. So x equals negative 4. And down here, I'll just say x is equal to negative 4. So x can be negative 3/10 or x can be negative 4. So I'm looking for x equals negative 3/10 or negative 4. This one right there. All right, let's look at question number 3 now. So again, we want to solve each equation by factoring. And here we're going to have 12x squared plus 76x minus 141 equals negative 2x plus 3. All right, so again, I want to put all my terms on the left and have 0 on the right. So let's just add 2x to both sides of the equation, just like that. Let's subtract 3 away from each side of the equation. Let's cancel this away and put 0. On the left, I'm going to have 12x squared. 76x plus 2x is going to be 78x, so let's put plus 78x. Then negative 141 minus 3, that's going to be negative 144, and this equals 0. So looking at these numbers, I know that 12, 78, and 144, those are all even numbers. So at minimum, I can pull out a 2. But you would also notice that everything is divisible by 3, right? 1 plus 2 is 3. 7 plus 8 is 15. 1 plus 4 is 5. 5 plus 4 is 9. So everything's divisible by both 2 and 3. So it's divisible by 6. So let's divide everything by 6 here. Or again, you can pull it out, whatever you want to do. It doesn't matter. This would be 2x squared plus 78 divided by 6. That's going to give me 13. So this would be 13x. And then minus 144 divided by 6. That's going to give me 24. And this equals 0 divided by 6 is 0. Okay, let's slide down here. This one looks like it's pretty easy to factor. So you have a 2 there. Again, that's a prime number. So we will put 2x here and x here. And again, the best thing is when you have a prime number because you don't have all these different possibilities to go through. So for 24, I think about the fact that that would be 1 times 24. You have 2 times 12, but again, that can't work because of the 2 there, so just throw that out. You would have 3 and 8, and then you would have 4 and 6, but 4 and 6 can't work because of the 2 right there. So again, if you have even numbers here that you're trying, well, it can't be that any of those would fit in there because, again, you'd have a common factor of 2, and there's no common factor of 2 here, so you can immediately get rid of those possibilities. So for 1 and 24, you'd have to put the 24 here and you're doing a subtraction here. So 2 times 24 would be 48. That's just too big, right? 48 minus 1 would be 47. So forget about that. That's out. So it has to be 3 and 8. The 8 can't go here, but it can go here. So it would have to be 8 here and 3 here. And again, you would just check this and do a subtraction. So 2 times 8 is 16, and then 3 times 1 is 3. 16 minus 3 is 13. So that's exactly what we want. We want to make sure we get the signs right. So this needs to be a plus. This needs to be a minus. So this right here would be 16x. This would be negative 3x. So 16x minus 3x would be 13x. So this is what we want. Okay, so moving forward now, we have 2x minus 3 equals 0, or we have x plus 8 equals 0. All right, so I would add 3 to both sides of the equation over here. Let me make this 3 a little bit better, more legible. Cancel this. We'll have 2x is equal to 3. Divide both sides of the equation by 2. And let's finish this up by canceling this and saying x is equal to 3 halves. Over here, let's just subtract 8 away from each side of the equation. This cancels. You get x is equal to negative 8. So x equals 3 halves, or x equals negative 8. Okay, coming up here, we have x equals 3 halves, or negative 8. So I want that one right there. All right, let's take a look at question number 4 now. Again, we're asked to solve each equation by factoring. So we will have 29x squared, then minus 106. This will be equal to, we have negative 124x. We have plus this 9x squared, and then we have plus 6. All right, so what I'm going to do is I'm going to add 124x to both sides of the equation, and this will cancel. I'm going to subtract 9x squared away from each side of the equation. This will cancel. And I'm going to subtract 6 away from each side of the equation. I'm already canceling that. And so basically on the right-hand side, we already know that this is 0. On the left-hand side, I'm just going to simplify, and it'll have a lot of stuff everywhere, but basically 29x squared minus 9x squared would just give you 20x squared. Then you have 124x. You don't have anything to combine with that, so let's just write plus 124x. Then you have negative 106, and then you're subtracting away 6, so that's minus 112. And of course, this equals 0. Okay, so on the left-hand side now, again, is there something I can pull out, or is there something I can divide everything by? Well, I know that 20 is going to be 4 times 5. Now, this number right here, 124, and this number right here, 112, that's not going to be divisible by 5, so you can forget about that. But are they divisible by 4? Well, yeah, if you look at 24, the final 2 digits, we know that's divisible by 4, so 124 will be. And also, if you look at 12, the final 2 digits of 112, that's divisible by 4, so 112 will be. So I can divide everything here by 4. So let's go ahead and do that real quick. And so I'll say this is divided by 4, this is divided by 4, this is divided by 4, and so is this. So 20 divided by 4 is 5. So this would be 5x squared. Then plus 124 divided by 4, that's going to give me 31, so this would be 31x. And then minus 112 divided by 4, that's going to give me 28. And again, this equals 0 divided by 4 is 0. Okay, so sliding down here, we have a good situation because 5 is a prime number. So really all we have to do is set up a 5x here and then an x here. And for these parts right here, again, think about 28 and also think about the fact that it's negative. So first off, 28, you have 1 and 28, you have 2 and 14, and then you're going to have 4 and 7. Now, with this subtraction here, that means in terms of absolute value, I'm just going to be working with the absolute values. I'm going to try to subtract what I have and get to 31. So 1 and 28, that's never going to work. If you put a 28 there, it's just way too big. If you put a 28 here and you put a 1 here, that's actually going to be too small because you need to subtract. You would have 28 minus 5, which would be 23. So this does not work at all. So let's get rid of this. And let's think about the next possibility. So you have 2 and 14. If you put a 14 here, it's just way too big, right? So that's not going to work. You could put a 2 here and a 14 here, but that's actually going to be too small. So 5 times 2 is 10, and then you would have 14. 14 minus 10 would be 4. Again, I'm trying to get to 31, so that's out. Okay, so that's not going to work. So really, it's just 4 and 7. So if you put a 7 here and a 4 here, that looks like that would work, right? 5 times 7 is going to be 35, and 35 minus 4 would give you 31. Okay, so let's get rid of that. And let's come through here and get the signs right. I know the larger in terms of absolute value has to be positive, so I want this to be plus and this to be minus. So this gives me plus 35x. This gives me minus 4x. So 35x minus 4x will give you the 31x that you need. All right, now we have the factoring out of the way. So let's turn to solving our equations. So I'm just going to say that I have 5x minus 4 equal to 0, or x plus 7 equal to 0. And again, I just add 4 to both sides of the equation here. Let's go ahead and cancel that. And we'll say that we have 5x is equal to 4. Divide both sides of the equation by 5. Cancel that. And we'll say that x is equal to 4/5. Over here, let's just subtract 7 away from each side of the equation. We'll say x is equal to -7. So we'll say x equals 4/5 or x equals -7. So coming back up here, x equals 4/5 or x equals -7. Okay, let's look at question 5 now. So again, we want to solve each equation by factoring. So let's look at 35x squared minus 189x. We'll set this equal to -100, and then we'll go plus 6x. Okay, so thinking about this, I need to subtract 6x away from each side of the equation. I also want to add 100 to both sides of the equation. Let me just do this off to the side over here. We'll cancel this and put 0. And so on the left-hand side, I have 35x squared. Nothing I can really do with that. -189x minus 6x would be -195x. Then you just have plus 100. And of course, this is equal to 0. Okay, let's slide down here a little bit. And let's think about what we can pull out. We've been dividing everything today. Let's just factor 1 out just for some practice doing that. So we know that everything here is divisible by 5. This ends with a 5, this ends with a 5, this ends with a 0. So it looks like I can just pull that out. And so I'd have 7x squared minus, if you punch up 195 divided by 5 into your calculator, you're going to get 39. So let's put 39x. And then plus 100 divided by 5, we all know that's 20. This equals 0. So this 5 right here, you could divide both sides of the equation by 5 if you want. But again, you can also just leave it out there. It doesn't affect your answer at all. So it's really whatever you want to do. So I'm going to put 5, and then I'm just going to set this up here. And let's think about what's going to go. We know this is 7x and this is x, but what's going to go here and here? So for 20, you have a few possibilities. You have 1 and 20, you have 2 and 10, and then you're going to have 4 and 5, and that's going to be it. Now 1 and 20, I think that's probably not going to work. Remember, this is a plus sign here, so you have to add things, and you're trying to get to, forget about the fact it's negative, you're trying to get to 39. So if you put a 20 here, 7 times 20 is 140, that's way too big. If you put a 20 here, and you put a 1 here, that's too small. So this is out. 2 and 10, if you put a 10 here, that's too big, that's 70. If you put a 10 here and a 2 here, this is going to be 14 plus 10, and that's going to give you 24, so that's too small. So these two are out. It has to be 4 and 5. So it could be that it's 4 here and 5 here. This would be 28 plus 5, which is 33. That doesn't work. You need 39. So let's try a 5 here and a 4 here, and you'll see that works, right? 7 times 5 is 35. 4 times 1 is 4. 35 plus 4 is 39. Okay, so we just need to make the signs work. And for a negative sum and a positive product, you want a negative and a negative, right? Negative plus negative is negative. Negative times negative is positive. So 7x times -5 would be -35x. Negative 4 times x would be -4x. And -35x plus -4x would give you -39x. Okay, so let's look at this guy real quick. And let's set each factor with a variable equal to 0. So you don't have to worry about 5 because there's no variable involved. You just have to set this equal to 0 and this equal to 0. So 7x minus 4 equals 0. Then or x minus 5 equals 0. And let's add 4 to both sides of the equation. And let's cancel this away. I'll say 7x is equal to 4. And let's divide both sides of the equation by 7. Cancel this. We'll get x is equal to 4/7. Let's add 5 to both sides of the equation here. Let's cancel this away. And let's say that x is equal to 5. And so we'll say x equals 4/7 or x is equal to 5. So coming back up here, I want x equals 4/7 or x equals 5. All right, let's take a look at our quiz. For the first question, we're asked to solve each equation. And what we're given is 4x squared. Then we have plus 1, and this is set equal to 5. All right, so the idea here is we're going to solve this using the square root property. So we need to get this into the form of x squared is equal to k so that we can say x is equal to plus or minus the square root of k. So how can we make this match this form? Well, we want to get x squared on one side of the equation by itself. So let's subtract 1 away from each side of the equation, and let's cancel this away. And then from here, let's say that we have 4x squared is equal to 5 minus 1 is going to give me 4. Let's divide both sides of the equation by 4. And let's cancel this with this and say that x squared is equal to 4 divided by 4 is going to be 1. Okay, so now that we have this in the form of x squared equals some number, in this case it's just 1, we can say that x is equal to plus or minus the square root of this number, which is 1, and we know the square root of 1 is 1. So we get a final answer of x is equal to plus or minus 1. So coming back up here, we have x equals 1 or x equals negative 1, so that's what we want. Okay, let's look at question 2 now. So we're asked to solve each equation. So we have 7x squared and then plus 8. This is set equal to negative 82. All right, so once again, we want x squared on one side of the equation by itself. We want a number on the other. So let's subtract 8 away from each side of the equation. Let's cancel this away. We'll have 7x squared is equal to, if I look at negative 82 minus 8, that's going to give me negative 90. So to finish things up, let's divide both sides of the equation by 7. And let's cancel this away. And so we'll slide down here. And we'll have x squared is equal to, 90 is not divisible by 7, and 7 is a prime number, so you really can't simplify this. So we'll just say negative 90 over 7. Okay, so if we want to find our solution here, or in this case, solutions for x, we would just say x is equal to plus or minus the square root of, you have this negative 90 over 7. Now 90 is 9 times 10, so I know I can simplify this a little bit. So let's take a little bit of time here. The first thing is I'm going to write this as x is equal to plus or minus, for this negative, I'll just say the square root of negative 1, then times, I'll go the square root of 9, and then times the square root of 10, and then I'm going to put this over the square root of 7. So we know that we can replace some things now, so we have x is equal to plus or minus, for the square root of negative 1, I'm going to put I, for the square root of 9, I'm going to put 3. So let's put 3i times the square root of 10, and this is over the square root of 7. Now, we don't want a radical in the denominator. We know that at this point. So what we would do is basically multiply by the square root of 7 over the square root of 7 so we can rationalize the denominator. So let's say that x is equal to, we'll have plus or minus 3i times the square root of, if you look at the square root of 10 times the square root of 7, we can write that as the square root of 70. You really can't make that any simpler. Then this would be over, square root of 7 times square root of 7 would be 7. So my answer here would be that x is equal to plus or minus 3i times the square root of 70 over 7. So we want this answer right here, where we say that x equals 3i times the square root of 70 over 7, and then negative 3i times the square root of 70 over 7. All right, let's look at question 3. Again, we're asked to solve each equation. So we have 5x squared minus 2 is equal to 298. So from here, again, if I want x squared by itself, let's add 2 to both sides of the equation, and let's cancel this away. We'll have 5x squared is equal to 298 plus 2 is going to be 300. Let's divide both sides of the equation by 5. Let's slide down here a little bit, and let's cancel this away. We'll have x squared is equal to 300 divided by 5 is going to be 60. So what we'll have here is that x is equal to plus or minus the square root of 60. And for 60, let's think about breaking this down all the way. It would be 6 times 10, so 6 times 10, and 6 is 2 times 3, so let's write this as 2 times 3, and 10 is 5 times 2. So let's put 2 squared times 3 times 5 like this, and we know that 2 squared is going to be 4, but let me actually break this down so that nobody gets lost. Let me slide down here a little bit. I'll say x is equal to plus or minus the square root of 4 times the square root of 3 times 5, or 15. Let's get rid of this right here, the scratch work. And we'll come down here and answer this and say x is equal to plus or minus square root of 4 is 2 times the square root of 15. So we want x equals 2 times square root of 15, and then or x would be equal to negative 2 times square root of 15. So this guy right there. Okay, let's look at question 4 now. Again, we're asked to solve each equation. And so what we're given is x plus 5, this quantity being squared, and it's set equal to negative 22. All right, so what we can do is immediately use our square root property. Although we don't have something like x squared equals k, we have some quantity here with x involved that's being squared, and it's equal to some number. So what I can do is actually say that x plus 5 is equal to plus or minus the square root of negative 22. Okay, now there's more work involved when you have this scenario. What you actually have to do is separate this into 2 different equations. So first, let's write x plus 5 is equal to plus or minus. I'm going to say this is the square root of negative 1 times the square root of 22. 22 is 2 times 11, so you really can't do anything further there. You can replace the square root of negative 1 with I. So let's do that first. And so we have x plus 5 is equal to plus or minus I times the square root of 22. Okay, so that's the first thing. Now what we want to do is split this up into two different scenarios. So we would have x plus 5 is equal to I times the square root of 22. So that's one equation we need to solve. Then we'll have or x plus 5 is equal to the negative of I times the square root of 22. So that's the other equation to solve. And in each case, we just need to subtract 5 away from each side. So in other words, I need to subtract 5 away from here and here. That would cancel. You get x is equal to I times the square root of 22 minus 5. And then or over here, subtract 5 away from each side. This will cancel. You get x is equal to negative I times the square root of 22 and then minus 5. So there's a lot of ways you could write this. I'm going to make it a little bit more compact. So I'm going to put x is equal to, we'll put the negative 5 out in front, and then we'll say plus or minus, because you have plus here and then minus here, you have I times the square root of 22. All right, so coming back up here, we want to select this answer right here. We would have x equals negative 5 plus I times the square root of 22. Then or x could also be negative 5 minus I times the square root of 22. Let's take a look at question number 5 now. So we have solve each equation, and we have 9x squared minus 6x plus 1 is equal to 4. And notice you have a little hint here. Think about how to factor the left side of the equation. So that tells me that I should think about how can I factor this into a binomial squared so I can use the square root property. So let's grab this real quick, and let's think about how we can factor this. So what you would notice right away is that 9 is a perfect square, right? It's 3 squared. Of course, x squared is a perfect square. It's x being squared. And 1 is a perfect square. It's 1 being squared. So let's see if we can match our little form. Let's say this is 3x, this is being squared, minus 2 times, this would be 3 times x, and then plus this guy, which is 1 being squared. So this matches our formula. So what we can do is factor this and just basically say that it's going to be 3x minus 1 quantity squared. Okay, so that's how we would factor the left-hand side. Again, this is just going back to our formulas that we learned way earlier in the course. And so this would be set equal to 4. And again, if I use my square root property, it just tells me that this guy right here, 3x minus 1, the quantity that's being squared, is equal to plus or minus the square root of 4. So I know the square root of 4 is 2, so let's just replace that. So 3x minus 1 is equal to plus or minus 2. And again, all you have to do from this point is just split this up into two different equations. So we're going to say 3x minus 1 equals 2, or 3x minus 1 is equal to negative 2. So you have to solve both of those. Let's come down here. Let's add 1 to both sides of the equation. And let's cancel this away and say that 3x is equal to 2 plus 1 is 3. Divide both sides by 3. X is going to be equal to, let me show this is canceling, 3 over 3 is 1. So that's your first solution. Over here, let's add 1 to both sides of the equation. Cancel that away. We'll say 3x is equal to negative 2 plus 1 is going to be negative 1. Let's divide both sides of the equation by 3. This cancels. Let's put or. We'll say x is equal to negative 1/3. Okay, so x is 1 or x is negative 1/3. So coming back up here, you have x equals 1 or x equals negative 1/3. I want that answer right there. All right, let's take a look at our quiz. For the first question, we want to solve each equation by completing the square. Let's take a look at 10x squared. We'll have minus 20x plus 94, and this is equal to 2. All right, so the first thing I'm going to do is move all the variable terms to one side and all the constants to the other. So I'm just going to subtract 94 away from each side of the equation, cancel this away. So you'll have 10x squared minus 20x is equal to 2 minus 94 is going to give me negative 92. All right, so the next thing I want to do is think about the coefficient on x squared. It needs to be a 1 for me to follow this process. So because it's a 10, I'm going to divide everything here by 10. So let's divide everything here by 10. And so this would cancel. And what I'm going to have here is x squared minus 20 divided by 10 is going to be 2. So this is 2x, and this is equal to negative 92 over 10. Let's put this as negative. 92 divided by 2 is going to be 46, and then 10 divided by 2 is 5. All right, let's slide down here a little bit. And let's say that we're going to now move into the part where we're going to complete the square. So remember, that means we're going to change this left side here into a perfect square trinomial, which can be factored into a binomial squared. So the way we do this is we look at the coefficient on x to the first power. We're going to cut it in half and then square it. So we would have negative 2 times 1/2, and then we're going to square this result. So negative 2 times 1/2 is going to be negative 1. So this would be negative 1 squared, which is positive 1. Okay, so we're going to add 1 to both sides of the equation. So x squared minus 2x, again, plus 1 over here, and this equals negative 46 over 5, and plus 1 over here. So you need a common denominator, so you might as well write it as 5 over 5. Again, so you have a common denominator of 5. Okay, so what I'm going to do from here is basically factor the left side into a binomial squared. So I'm going to say this is x minus 1 quantity squared is equal to, then negative 46 plus 5 would be negative 41 over the common denominator of 5. All right, so from here, I'm just going to use my square root property. So basically, the quantity x minus 1 is being squared, and it's equal to negative 41 over 5. So we can say x minus 1 is equal to plus or minus the square root of negative 41 over 5. So what I'm going to do is clean this up a little bit. So x minus 1 is equal to, we'll go plus or minus, we'll have the square root of negative 1 times the square root of 41 over the square root of 5. Now the square root of negative 1 is I, so let's write x minus 1 is equal to plus or minus. We'll have I, square root of 41, I can't do anything with that, so times the square root of 41, and this is over the square root of 5. Now, remember, you don't want a radical in your denominator, okay? So you want to rationalize the denominator if this comes up. So what I'm going to do is multiply this by the square root of 5 over the square root of 5. And let's slide down here a little bit. We'll say x minus 1 is equal to plus or minus I times the square root of 41, and this would be times 5 here, over square root of 5 times square root of 5 would give me 5. So 41 times 5 would be 205, so let's just write this underneath the square root symbol here. No need to use another step for that. Okay, so from here, we're pretty much done. We're just going to add 1 to both sides of the equation. So let me show that. So let's add 1 over here and add 1 over here. This would cancel. You're going to get x is equal to 1 plus or minus, you'll have I times the square root of 205 over 5. So this would be my answer, but typically you want to get a common denominator going. So since the denominator here is 5, I can multiply this by 5 over 5, and I could say x is equal to 5 plus or minus I times the square root of 205 over the common denominator of 5. So this is the answer I'm going to look for. So it looks like I want this one right here. So x equals 5 plus I times the square root of 205 over 5. And then, or you're also going to have x equaling 5 minus I times the square root of 205 over 5. So this is what we want right here. Let's look at problem number 2. Again, we want to solve each equation by completing the square. So we have x squared plus 12x plus 43 is equal to negative 8. So again, I want to put all my variable terms on the left and I want my constants on the right. So let me subtract 43 away from each side of the equation and cancel that away. I'll have x squared plus this 12x is equal to negative 8 minus 43, which is going to be negative 51. So from here, I noticed that the coefficient on x squared is 1, so I don't need to do any additional work there. So I'm just going to move into completing the square. So I want 1/2 of this coefficient on x to the first power. So we would have 12, cut that in half. That's basically going to be 6, and square it. So 6 squared we know is 36. So I want to add 36 to both sides of this equation. So let's go ahead and say we have x squared plus 12x plus 36 is equal to negative 51 plus 36. Slide down here a little bit. We know the left side is going to factor into x plus 6 quantity squared. So x plus 6 quantity squared. This equals negative 51 plus 36. That's going to give me negative 15. So from here, I can use my square root property. So we'll say x plus 6 is equal to plus or minus the square root of negative 15. So we'll say that x plus 6 is equal to plus or minus. For this negative here, let's just write that as the square root of negative 1, which is I. So I times the square root of 15. And 15 is 5 times 3, so you really can't do anything with that. To finish things up, let's just subtract 6 away from each side of the equation. This will cancel. We'll say x is equal to, we'll say negative 6 plus or minus I times the square root of 15. So this is the answer we want. We want x equals negative 6 plus I times the square root of 15. And then also we would say x is equal to negative 6 minus I times the square root of 15. All right, let's take a look at question number 3 now. So again, we want to solve each equation by completing the square. So we have negative 3x squared, then minus 22x plus 24 is equal to negative 9x squared. All right, so the first thing I'm going to do here is clean up. So I'm going to add 9x squared to both sides of the equation, and I'm going to subtract 24 away from both sides of the equation. What this is going to do, remember, I want all my variable terms on one side and my constant to be on the other. Let's cancel this and cancel this. And so what we can say is negative 3x squared plus 9x squared is 6x squared. And then you'd have minus 22x, and this equals, over here you're going to have negative 24. All right, so coming down here, remember, you want your coefficient on x squared to be a 1. Okay, right now it's a 6, so you have to take the time to divide everything by 6. Okay, divide everything by 6 so that this will cancel away, and now you have something you can work with. You have x squared, then minus 22 over 6. Everything's divisible by 2. 22 divided by 2 is 11, and 6 divided by 2 is going to be 3. So this is negative 11 thirds, then times x, and this equals negative 24 divided by 6 is negative 4. Okay, let's stop for a minute. Let's go real slow here because this is one where people just get lost. The first thing is your coefficient on x is a fraction. And it's not an easy fraction to work with. It's negative 11 thirds. So it's kind of a nastier fraction. So you're going to use the same process. You're going to cut it in half, meaning you're going to take negative 11 thirds. You're going to multiply it by half, and then you're going to square it. Okay, so this is what you want. Now, what this part inside before it's squared is equal to, you need to keep that for factoring. When you're working with integers, it's really easy to factor things without even thinking about it, right? You know your formulas at this point. But when you have these sort of nasty fractions, it's a lot more difficult to factor that using your formula because you're not used to working with fractions. So negative 11 over 3 times a half is going to be negative 11 over 6. So keep this value in mind here for when you're going to factor. This is what you're going to need. Your left-hand side is going to factor into x minus 11 over 6 quantity squared. Okay, and I'll show you that in a moment. So then if we square this, again, squaring a negative, it's inside the parentheses, that's positive. 11 squared is 121. 6 squared is 36. So 121 over 36 is what we need to add to both sides of the equation. And I'm not going to get rid of this value right here. I think it's best to put this in your notes because we're going to need this for factoring. So let me just put that off to the side. And let me use this. So let me come up here. And so we have x squared minus 11 over 3x. Then plus 121 over 36. And this equals negative 4. And let me just slide this up here. So we'll say plus this 121 over 36. Okay, so I added 121 over 36 to both sides. But the tricky part here, again, is factoring this left side. Again, most people just fall apart when they try to do this because your formula is usually working with integers, right? But now we have fractions, so it's harder. So x minus this value, 11 over 6, quantity squared. Again, if you want to check to make sure that works, squaring this gives you x squared. 2 times this, we give you negative 11 over 3 times x. And then squaring this would give you this. Okay, so this equals, over here, I need a common denominator. So negative 4 times, you would need 36 over 36, then plus 121 over 36. And let's write x minus 11 over 6. Quantity squared is equal to, what is negative 4 times 36? That's going to give me negative 144. And then we'll say plus 121 over the common denominator of 36. Negative 144 plus 121 is going to be negative 23. So let's write this as x minus 11 over 6, quantity squared, is equal to negative 23 over 36. From this point, now we can use our square root property. So x minus 11 over 6 is equal to plus or minus the square root of negative 23 over 36. And again, you're just going to break this up. So you'll say x minus 11 over 6 is equal to plus or minus the square root. Let's just say the square root of negative 1 times the square root of 23. 23 is a prime number. You can't do anything with that. Over, let's say, the square root of 36, which we know is 6. So let's come down here. And let's say that we have x minus 11 over 6. Then we'll go is equal to plus or minus square root of negative 1 is I. So let's put I times the square root of 23 over, we're going to have 6, right? Square root of 36 is 6. Now, we could just add 11 over 6 to both sides of the equation. So let's add 11 over 6 over here. Let's add 11 over 6 over here. Cancel that. I'll put x is equal to, we'll put the 11 over 6 out in front. And then we'll say plus or minus I times the square root of 23 over 6. And of course, to finish this up, we could write this as having a common denominator. So x is equal to, you'll have 11 plus or minus I times the square root of 23 over the common denominator of 6. All right, so this is what we want right here. So we have x equals 11 plus I times the square root of 23 over 6. And then we have 11 minus I times the square root of 23 over 6. All right, let's take a look at question number 4 now. So again, we want to solve each equation by completing the square. Let's say we have negative 4x squared plus 7x minus 3 is equal to negative 5x squared. All right, so again, I'm just going to add 5x squared to both sides of the equation. This one cancels. Add 3 to both sides of the equation. So this one would cancel. So negative 4x squared plus 5x squared is going to be x squared. And then we're going to have plus 7x is equal to 3. Okay, so this one looks like it's a lot easier because we don't really need to divide everything by anything because the coefficient on x squared is a 1. So basically we can just move into completing the square. Again, the coefficient on x to the first power is 7. So if I took 7 and I multiplied it by a half, it would be 7 halves. So 7 times a half, that's 7 halves. And squaring that, let's just put this as 7 halves being squared. This would equal 49 over 4. Now again, when you work with fractions like this, remember 7 halves, that's what you're going to need when you factor this. So keep that in mind. It's whatever this is multiplied by a half, you're using that when you're factoring. So let's add 49 over 4 to both sides. Let's say we have x squared plus 7x, then plus 49 over 4. This will be equal to 3 plus 49 over 4. So again, keep this 7 halves in mind because we're going to need that for factoring. And I can factor the left side. Again, it's going to be x plus that 7 halves, quantity squared. You can always check this. The first guy squared is x squared. 2 times x times 7 halves would be 7x. And then 7 halves squared would be 49 over 4. So we're good to go there. This equals, I need a common denominator. So let's multiply 3 by 4 over 4. So times 4 over 4. So this would be 12 plus 49 over the common denominator of 4. So 12 plus 49 is going to be 61. We will say this is the quantity x plus 7 halves squared. Let me make this 2 a little bit better. Is equal to 12 plus 49, again, is 61. So this is 61 over 4. And from here, we can just use our square root property. So let's go ahead and say that we have x plus 7 halves is equal to plus or minus the square root of 61 over 4. And so let's break this up. X plus 7 halves is equal to, we'll have plus or minus the square root of 61. Nothing I can do with that. Over, you have the square root of 4. Now the square root of 4 is just 2, so we can replace that. And let's say we have x plus 7 halves is equal to plus or minus the square root of 61 over 2. Okay, so to finish things up, let's just add negative 7 halves to both sides of the equation. Let's go minus 7 halves over here and minus 7 halves over here. Let's cancel this. And let's say x is equal to, you have negative 7 halves plus or minus the square root of 61 over 2. And of course, if you want to, you can just write this with a common denominator. That's typical. So we'll say x is equal to, let me make this x a little bit better. We'll say this is negative 7 plus or minus the square root of 61 over the common denominator of 2. Okay, so coming up here, I want x is equal to negative 7 plus the square root of 61 over 2. And then, or x could be negative 7 minus the square root of 61 over 2. So this guy right there. Okay, let's look at question number 5 now. Again, we want to solve each equation by completing the square. So we have x squared plus 5x minus 7 is equal to negative 9 plus 8x. Okay, so let me subtract 8x away from each side of the equation, and let's add 7 to both sides of the equation. So let's cancel this away, and let's cancel this away. And let's say that x squared, we have 5x minus 8x, that's going to be negative 3x. And this equals negative 9 plus 7 would be negative 2. Okay, so we have all the variable terms on the left and we have our constant on the right. So now we would check the coefficient on x squared. In this case, it's a 1. So we're good to go there. So now we'll take the coefficient on x to the first power. So here it's negative 3. We're going to cut that in half. So multiply it by half. And then we're going to square the result. So this would be negative 3 halves. And this would be squared. And so the negative, again, it's inside of parentheses. If it gets squared, it's going to be a positive. 3 squared is 9 and 2 squared is 4. So we're going to want to add 9/4 to both sides of the equation. Let me slide this down a little bit. Let me keep this in frame here. So I'm going to say this is x squared minus 3x. I'm going to say plus 9/4 is equal to negative 2, and then plus 9/4. Let's multiply this by 4 over 4 right now so we can have a common denominator. So we've added 9/4 to both sides. But again, if you're working with fractions, you want to keep this value in mind. This is what you got from taking this coefficient negative 3 and multiplying it by a half. So that negative 3 over 2 is what you need when you're factoring. Okay, so just keep that in mind. So to factor the left side, again, what I'm going to have is x minus 3 over 2 quantity squared. And you can always check it using your formula. Square this guy, you get this. Then basically you have minus 2 times this guy to get this. And then if you square this guy, you get this. Okay, so from here, negative 2 times 4 would be negative 8. So you basically have negative 8 plus 9. I think we could do that in our head. That's going to be 1. So this would be 1 over the common denominator of 4, or just 1/4. All right, so from here, I can just use my square root property. I can say x minus 3 halves is equal to plus or minus the square root of 1/4. And of course, when you think about the square root of a fourth, it's just going to be 1/2, right? So let's break this up so nobody's lost. This is x minus 3 halves is equal to plus or minus the square root of 1 over the square root of 4. We know the square root of 1 is 1. We know the square root of 4 is 2. So let's say that this is x minus 3 halves is equal to, you're going to have plus or minus 1/2. So in this situation, we need to set up two different equations. So x minus 3 halves is equal to 1/2, then or x minus 3 halves is equal to negative 1/2. Okay, so coming through here, let's add 3 halves to both sides of the equation. And let's cancel this away. We'll say x is equal to, we'll have 1/2 plus 3 halves. So 1 plus 3 is 4. 4 divided by 2 is 2. So x equals 2. Then or, over here, let's add 3 halves to both sides of the equation. So this cancels. You'll have x is equal to negative 1/2 plus 3 halves. Well, negative 1 plus 3 is going to be positive 2. 2 divided by 2 is 1. So x equals 2 or x equals 1. So coming back up here, we have x equals 2 or x equals 1. We want that answer right there. All right, let's take a look at our quiz. For the first question, we're asked to solve each equation using the quadratic formula. So we are given 2x squared minus x minus 6 is equal to 0. So in this case, we're fortunate we don't have to do a lot of work because this is already put in standard form for us. So it matches the ax squared plus bx plus c is equal to 0. When you first start working with the quadratic formula, you might get confused about signs. Remember, you can always change it up a little bit to make it crystal clear. You could put plus negative 1x there and plus negative 6 there to make it crystal clear. So a is going to be 2. Remember, that's the coefficient for x squared. So a is equal to 2. Then b is the coefficient for x. It's negative 1. So let's put negative 1. And then c is your constant. That's going to be negative 6. So we're going to grab these values here, and we're just going to plug into the quadratic formula. So we'll say x is equal to the negative of b. So remember, I'm just going to wrap b in parentheses so I don't make a sign mistake. Then plus or minus the square root of, for b squared, again, I'm going to wrap this in parentheses, so negative 1, that's going to be squared. And then minus 4 times a is 2. Then times c is negative 6. So what I do is I look at the signs here. I know negative times negative is positive. So let me just put plus negative there just to make that crystal clear. And let's put this all over 2a. A is 2, so that's going to be 2 times 2 or 4. Okay, so to simplify, x is equal to, the negative of negative 1 is positive 1. Then plus or minus the square root of, negative 1 squared is 1. Then if I do negative times negative, that's positive. So I know this is positive. So let me put plus here. 4 times 2 is 8, and 8 times 6 is going to be 48. So let's put 48 there. We know that 1 plus 48 is 49, so let's just replace this now. And let's put this over 4. Okay, so from here we have x is equal to 1 plus or minus, the square root of 49 is 7, and this is over 4. So the idea here now is you want to split this up and say that you have x is equal to 1 plus 7 over 4, then or x is equal to 1 minus 7 over 4. So for this one on the left, we would have x is equal to 1 plus 7 is 8. 8 divided by 4 is 2. Then or, over here on the right, we'll say x is equal to 1 minus 7 is going to be negative 6, and that would be over 4. So negative 6 over 4. 6 divided by 2 is 3. And then 4 divided by 2 is going to give us 2. So we could really say this is x is equal to negative 3 halves. So for my solutions, I'm going to have x equals 2 or x equals negative 3 halves. So coming back up here, we want this one. So we have x equals 2 or x equals negative 3 halves. Okay, let's look at question number 2 now. Again, we're asked to solve each equation using the quadratic formula. So we have 8x squared, and this is equal to 16 plus x. So again, what we would do is subtract x away from each side of the equation, and let's subtract 16 away from each side of the equation. And so this on the right is just going to cancel and be 0. On the left, I've kind of stacked these things up on top of each other just because we don't have room. But let's just write this as 8x squared, and then minus x, and then minus 16 equals 0. We can just get rid of this, just some scratch work. And again, we're just going to grab the values for a, b, and c, I think we know what they are at this point. Again, you can put this as plus negative 1x to make that clear. You can put this as plus negative 16 to make that clear. So let's just write ax squared plus bx plus c equals 0. And again, a is going to be 8. So a is 8. B is going to be negative 1. And then c is going to be negative 16. All right, so let's just plug into our quadratic formula. So x is equal to, we'll have the negative of b. B is negative 1. Then plus or minus the square root of b squared. So you're going to have negative 1 being squared. Make sure to wrap it in parentheses. Then minus 4 times a is 8. Then times c is negative 16. Let's scooch this over a little bit. And let's put this over. 2a, a is 8. So 2 times 8 is 16. Let's say x is equal to, the negative of negative 1 is positive 1. Then plus or minus the square root of negative 1 being squared is 1. So we have negative times negative here. Again, you can put plus negative here to make this crystal clear, but negative times negative is positive. So let me put a plus here. So now we can just say 4 times 8 is 32, and 32 times 16 is going to give me 512. So this would be 1 plus 512, which is 513. Okay, then this is over 16. Now, for 513, this is what you would want to try to simplify. You probably don't work with that number very often. It's a pretty big number. It's an odd number, so it's not divisible by something like 2 or 4 or 6 or 8 or something like that. So you would think about 3. 5 plus 1 is 6. 6 plus 3 is 9. So I know it's going to be divisible by 3, and it's also going to be divisible by 9. So let me start with my calculator, 513 divided by 9, and that's going to give me 57. So I can write this as 57 times 9, and I know 9 is a perfect square, so I can pull this out. So what I'll say is x is equal to 1 plus or minus, square root of 9 is going to be 3. So we'll say 3 times the square root of 57 and then over 16. And there's really nothing else I can do with this. This is pretty much as simple as I can make it. So let's go back up and we're going to be looking for this answer right here. So x equals 1 plus 3 times square root of 57 over 16 and then or 1 minus 3 times square root of 57 over 16. All right, let's take a look at question number 3 now. So again, we're asked to solve each equation using the quadratic formula. So we're going to have 4x squared plus 9 is equal to negative 10x. Let's add 10x to both sides of the equation. Let's get rid of it from over there and put a 0. We'll have 4x squared plus 10x plus 9 is equal to 0. All right, let me just get rid of this. And again, we just want our ax squared plus bx plus c equals 0. So let's eyeball this and say a is 4. B is 10, and C is 9, right? So A is 4, B is 10, and C is 9. Let's grab this, and let's just plug in. So x is equal to negative B. So negative, B is 10. So you wrap this in parentheses just so you don't make a sign mistake. Then we have plus or minus the square root of B squared. So B is 10. So let me wrap 10 in parentheses and square it. Then minus 4 times A is 4. Then times C is 9. Okay, let me put this over 2A is 4, so 2 times 4 is 8. Okay, so x is equal to negative 10. So negative 10 plus or minus the square root of, we know 10 squared is 100. So let's write 100. Then basically this is minus 4 times 4 is 16. 16 times 9 is going to be 144. So 100 minus 144 is negative 44. So this is negative 44 here. And let's put this over 8. All right, so let's see if we can simplify this a little bit. We know that this negative here, remember, if you have the square root of negative 1, that's I, the imaginary unit. So let's put x is equal to negative 10 plus or minus, again, I'm going to put an I here, and then times the square root of, I could also say this is 4 times 11, and the square root of 4 is 2, so let me bring that out and say this is 2i times the square root of 11, and this is going to be over 8. Now I can make this simpler by canceling a common factor of 2 between the numerator and denominator. So x is equal to, let's say this is 2 times the quantity negative 5 plus or minus, we'll say I times the square root of 11, and this is over 8 is 2 times 4. Okay, so let's cancel this 2 with this 2. Let's slide down here, and let's say we have x is equal to negative 5 plus or minus I times the square root of 11, and this is over 4. So this is as simple as we can make this guy. So let's go look for our answer. So this is what I want right here. We have the x equals negative 5 plus I times square root of 11 over 4, and then negative 5 minus I times square root of 11 over 4. All right, let's look at question number 4 now. So this one says find the discriminant of each quadratic equation, state the number and type of solutions. So we have negative 12x squared minus 11, and then this equals negative 9x squared minus 14x. So to find the discriminant, you first need to put this in standard form, just like if you were using the quadratic formula. So let's add 9x squared to both sides of the equation. And let's add 14x to both sides of the equation. Let's cancel this away and put 0. Okay. On the left-hand side, negative 12x squared plus 9x squared is negative 3x squared. Then plus 14x minus 11 is equal to 0. Okay, so the discriminant is found as the part under the square root symbol. So that b squared minus 4ac. So let's just grab all the values. Let's say this is ax squared plus bx plus c equals 0. So a is negative 3, b is 14, and c is negative 11. So a is equal to negative 3. We have b is equal to 14, and c is equal to negative 11. Let me actually grab this. And although we don't need to do this, it's helpful to come back to the quadratic formula. This is your discriminant, this part underneath the square root symbol. So you just need to figure out what this is. So let's take a look at b squared. So what is b? It's 14. So 14 squared minus 4 times a is negative 3, times c is negative 11. So let's figure out what this is. Let's get rid of this. We're just going to do this calculation. And so 14 squared is 196. So this is 196. And then you have negative, negative, and negative. So let's put minus. And then we're just going to multiply the absolute values. So 4 times 3 is 12. 12 times 11 is 132. So this equals 64. So what do we know about this? Again, if this was the square root of 64 here, forget about the rest of it. We know that the square root of 64 is 8, right? So what we're going to end up with, we would have two rational solutions, right? So if we come back up here, see how it says 64, that's the discriminant, that's the value we found, and then two rational solutions. In other words, our two solutions would be rational numbers. So we would come up here and select this one. All right, let's take a look at question 5. We're asked to find the discriminant of each quadratic equation and then state the number and type of solutions. So we're going to look at 3x squared, then minus 5x, then plus 8 is equal to 4. So first and foremost, when you talk about, again, the discriminant, that's the part underneath the square root symbol. So when you look at the quadratic formula, again, it's x is equal to the negative of b plus or minus the square root of your b squared minus 4ac. This whole thing is over 2a. Okay, this part right here, this b squared minus 4ac, that again is your discriminant, just like we saw in the last problem. So what I want to do is first write this in standard form. And to do that, I would subtract 4 away from each side. So subtract 4 away from here and here. So this is going to cancel and give me a 0. And then 8 minus 4 is going to be 4. So I could then label this guy right here, this 3 as a. That's the coefficient for x squared. Let's go plus negative here. So this b here is negative 5. And then c, that's my constant. That's going to be 4. Okay. So all you actually have to do is figure out this guy right here. So what is b squared minus 4ac? Well, b is negative 5, so negative 5 squared. Then minus 4 times a is 3. Then times c is 4. Well, negative 5 squared is 25. So let me erase this and just put 25. And then 4 times 3 is 12. 12 times 4 is 48. So essentially you have 25 minus 48, which is negative 23. Now, let's stop for a minute and think about this. If I had, let's say I erase this real quick, and I just put negative 23 here, and you can fill in the rest if you want to. So this would be the negative of negative 5, which is positive 5. So you can put plus 5 or just put 5 if you want. And then 2 times 3, this would be 6. But this isn't really what I'm thinking about here. What I'm thinking about is, what is the effect of having this guy as a negative 23? Well, at the end of the day, I can write this as I times the square root of 23 like this. So this is going to give me 5 plus I times square root of 23 over 6, and 5 minus I times square root of 23 over 6. So I'm going to get two non-real complex solutions. So coming back up here, I want to answer this guy right here. So negative 23, that's the discriminant, right? The b squared minus 4ac part. And then it's going to give me two non-real complex solutions. So this guy right here. All right, let's take a look at the quiz. So for the first question, we're asked to solve each equation. Let's write this out. We have 3x to the 4th power minus, we're going to have 20x squared plus, we have 32, and this is set equal to 0. Again, the idea here is we can solve this type of problem using a simple substitution technique. It is what we call quadratic in form. You look at this exponent here, it's a 4, and it's double that of the smaller exponent, which is a 2. So what you can do is rewrite this as 3x squared, and then being squared, minus 20x squared plus 32 equals 0. And then you could let something like u or w or whatever you want to use be equal to x raised to that smaller power. So here it's x squared. And then we're just going to substitute. So where there's an x squared, so here and also here, you'll just plug in a u. So you have 3u squared minus 20u plus 32 is equal to 0. Now, you will be able to solve this using factoring. So let's think about how we can factor the left-hand side here. So let's set this up as 3u, and let's put a u here, and let's set this equal to 0 over here. So notice that you have a negative sum and a positive product. So when I try to work things out, I'm going to be thinking about adding together to try to get to 20. Forget about the fact that it's negative. So for 32, I have quite a few possibilities. So I have 1 and 32. Let's start with that. That's obviously going to be too big. If you put 32 here, it's way too big. And if you put 32 here, it's still too big. So get rid of that. Then you have 2 and 16. Would that work? Well, if you put a 16 here, it's already going to be too big. If you put the 16 here, like this, and you put the 2 here, well, that's going to be 6 plus 16, and that's going to be too big, right? 6 plus 16 is going to be 22, so that's out. So next you would have 4 and you would have 8. So basically I could put a 4 here and an 8 here, and that would give me 12 plus 8, which is 20. So this is what I'm looking for here. Let's get rid of that. And we just need to make the signs right. So we're going to put a minus here and a minus here so that this ends up being negative 12u. And this ends up being negative 8u. And so negative 12u plus negative 8u would give you that negative 20u that you're looking for. Okay, so I'm just going to use my zero product property now. So 3u minus 8 is equal to 0, or u minus 4 is equal to 0. Let's add 8 to both sides of the equation here. Let's cancel this away. We'll say that 3u is equal to 8. Let's divide both sides of the equation by 3. Cancel this away. And we'll say u is equal to 8/3. Over here, let's add 4 to both sides of the equation. Cancel that away. I'll say or u equals 4. So let's put this down here. So u equals 4. Okay, so we're not done. We can't answer that u is equal to 8/3 or u equals 4 because our original equation dealt with x. Remember, we made a substitution to say that u is equal to x squared. So everywhere there's a u, at this point, you could just replace it with x squared. So I'm going to say x squared is equal to 8/3. Then or I'm going to say x squared is equal to 4. Now, how do we solve these types of equations? Remember, you can just use your square root property. So if x squared equals some real number k, then x equals plus or minus the square root of k. So here x squared equals 8/3, so we can just say that x is equal to plus or minus the square root of 8/3, then or x is equal to plus or minus the square root of 4. So let's break this first one up. So x equals plus or minus the square root of 8 over the square root of 3. Now we know we don't want a radical in the denominator, so let's multiply this by the square root of 3 over the square root of 3. Let me make this 3 a little bit better. We know square root of 3 times square root of 3 would be 3. So let's write this denominator here as 3. And the square root of 8 times the square root of 3 would be the square root of 24. But you need to simplify that because the square root of 24 is really the square root of 4 times the square root of 6, and the square root of 4 is 2. So let's write this as plus or minus 2 times the square root of 6, and then we'll put or over here. We have x is equal to plus or minus the square root of 4, which is going to be 2, right? So x could be 2 times square root of 6 over 3, negative 2 times square root of 6 over 3. It could be 2 or negative 2. So coming back up here, you see we want this first answer here. So x could be 2 or negative 2, then 2 times square root of 6 over 3, and then negative 2 times square root of 6 over 3. All right, let's take a look at question number 2. Again, we want to solve each equation. So we're given x to the 4th power minus 11x squared minus 26, and this equals 0. So the first thing I would do here is, again, just write this as x squared minus 11x squared minus 26 is equal to 0. And again, thinking about this, I can let u be equal to, again, x squared. So everywhere there's an x squared, so here and here, I can just plug in a u. And so what we'll do here is say that it's u squared minus 11u minus 26 is equal to 0. And we'll just solve this using factoring. So let's put our parentheses here, put a u here and a u here. So give me two integers whose sum is negative 11 and whose product is negative 26. Where you're going to want to do negative 13 and then positive 2. Now let's solve this using the zero product property. So I'm going to say u minus 13 is equal to 0, or we'll say u plus 2 is equal to 0. What we'll do is add 13 to both sides of the equation. Let me make these 3's a little bit better. Let's cancel this and say u is equal to 13. Then or, over here, let's subtract 2 away from each side of the equation. Cancel this. We'll say u is equal to negative 2. Again, you cannot stop here, right? This is not the solution we're looking for. We need this in terms of x. Let me make this 3 better. Remember, u is equal to x squared. So everywhere there's a u, plug an x squared back in. So x squared is equal to 13, or x squared is equal to negative 2. Again, for my square root property, if x squared equals k, then x equals plus or minus the square root of k. So for this one, x squared equals 13, we'll say that x is equal to plus or minus the square root of 13. Then or, if x squared equals negative 2, then x is equal to plus or minus the square root of negative 2, which is I times the square root of 2. So let's go back up, and I'm looking for this first answer here. So x equals the square root of 13, the negative square root of 13, I times square root of 2, and negative I times square root of 2. Okay, let's look at question number 3. So again, we're asked to solve each equation, and we have 2x to the 4th power minus 27x squared, then plus 55, and this equals 0. Again, I'm just going to use my substitution technique. So let's first write this as 2x squared being squared, then minus 27x squared, then plus 55 equals 0. And again, I'm just going to let u be equal to x squared. So we'll say that we're going to let u be equal to x squared. So this would be 2u squared minus 27u plus 55 is equal to 0. Let's make this 5 a little bit cleaner. And then again, from here, I'm just going to factor this. So we'll say that this is 2u, and we'll say that this is u. And if I think about this, I need to get this guy right here. This is a plus. So when I try to work this out, I'm going to be adding things, and I want a middle of 27. Forget about the fact that's negative. So 55 is 1 times 55, which is not going to work, or it's 11 times 5. So if I put an 11 here, and I put a 5 here, that would be 22 plus 5, which would get me 27. Again, I want a negative 27. So what I would do is put a negative here and a negative here, right? So the outer here would be negative 22u. The inner here would be negative 5u. So negative 22u plus negative 5u would be negative 27u. Okay, so now that we have that set up, we're just going to use our zero product property. So let's say we have 2u minus 5 is equal to 0. Then or we have u minus 11 is equal to 0. Let's add 5 to both sides of the equation. Cancel that. We'll have 2u is equal to 5. Let's divide both sides of the equation by 2 and say u is equal to 5 halves. Over here, let's add 11 to both sides of the equation. Cancel that. And we'll say that u is equal to 11. So let's put or u equals 11 like that. Again, let's remember that u was equal to x squared. So we'll say x squared is equal to 5 halves. Then or x squared is equal to 11. Again, from the square root property, we know if x squared equals k, then x equals plus or minus the square root of k. So what I'll say here is that x is equal to plus or minus the square root of 5 halves. I'm going to need to rationalize the denominator. I'll do that in a second. Then or we'll say x is equal to plus or minus the square root of 11. So for this one, what I would do, let me actually just break this up into the square root of 5. Let me make that better. So the square root of 5 over the square root of 2. Let me make this cleaner. So square root of 5 over square root of 2. I'll multiply this by the square root of 2 over the square root of 2. So this would be the square root of 10 up here. And square root of 2 times square root of 2 would be 2. So let's put this over here as over 2. So what I'm looking for here is x equals plus or minus the square root of 10 over 2, or x equals plus or minus the square root of 11. So coming back here for this one, I want x equals square root of 11, or the negative square root of 11, and then you have square root of 10 over 2, and then negative square root of 10 over 2. All right, let's look at question number 4 now. So again, we're asked to solve each equation. So what we have is the quantity x plus 1 being raised to the 2/3 power. So let's write that out. So x plus 1 being raised to the 2/3 power. Then minus, we're going to have x plus 1 being raised to the 1/3 power. Then minus 2, and this equals 0. So again, we have the same pattern. You have that this exponent here, this 2/3, is double that of this one here. So to make this more clear, that we can use our little substitution, you can actually write this as x plus 1 being raised to the smaller power, so the 1/3 power. And again, because it's double that, you can use your power to power rule. So you can raise this to the second power. Again, power to power rule, x plus 1 stays the same. That's the base. You multiply 1/3 times 2, you get 2/3. So you're right back to where you started. Let's scooch this down a little bit. We'll put minus. We have this x plus 1 raised to the 1/3 power. Minus 2 equals 0. Okay, so from here, let's let u be equal to, it's always the guy raised to the smaller power. So in this case, it's going to be x plus 1, this quantity raised to the 1/3 power. So you're going to plug in a u there and also there. Okay, so those are the two places. So let's say that we have u squared minus u minus 2 is equal to 0. And let's solve this by factoring. So I'm going to put u here and put u here. And I need two integers that sum to -1 and give me a product of -2. That's going to be -2 and +1. All right, so solving this using the zero products property, we're going to have u minus 2 is equal to 0, then or u plus 1 is equal to 0. Let's add 2 to both sides of the equation, cancel this away. We're going to have u is equal to 2, then or let's subtract 1 away from each side of the equation. Let's cancel this away. We're going to have u is equal to -1. So let's recall that we let u be equal to x plus 1 raised to the 1/3 power. Okay, so we're going to need to plug that in here and here. So what we'll do is x plus 1 to the 1/3 power is equal to 2. Again, all I'm doing is replacing u with x plus 1, this quantity raised to the 1/3 power. That's all I'm doing. So I'm taking this right here and plugging it in right there. That's all I'm doing. So it's equal to 2. Then or, same thing. So the quantity x plus 1 raised to the 1/3 power is equal to -1. So you can think about this as raised to the 1/3 power, or you can think about it as being the cube root. But either way, if you want to get this guy right here, this part isolated, what you have to do is actually undo this exponent. And you can do that by basically cubing things, right? If you cube a cube root, it undoes the cube root, right? So basically what I would do here is say that I'm going to raise this side right here to the 3rd power and this side to the 3rd power. And so power to power rule, x plus 1 stays the same. 1/3 times 3 is going to be 1. So this gives me x plus 1 is equal to 2 cubed is 8. Then or over here, I'm going to do the same thing. Raise both sides to the 3rd power. So you would have, again, power to power rule, 1/3 times 3 is 1. So you have x plus 1 is equal to -1 being cubed is -1. So now we have two very simple equations to solve. Let's subtract 1 away from each side of the equation. You get x is equal to 7. Let's subtract 1 away from each side of the equation. You get or x is equal to -2. So coming back up here, we want x equals 7 or x equals -2. Okay, let's look at question number 5. Again, we're asked to solve each equation. So we have this 6x to the power of -2 plus we have x to the power of -1, and this equals 2. So once again, if you look at this exponent here, it's -2 and it is double that of -1. So again, we can use this pattern. You can say that this is 6 times x raised to the smaller guy, which is -1, and then square it. Again, haven't done anything illegal. X is the same. -1 times 2 is -2. Right back to what I have. Then plus x raised to the power of -1, and this equals 2. And so again, you can let something like u be equal to x raised to that smaller power. So x raised to the power of -1. You slide down here a little bit. Let's see what we have. So we would have 6u squared plus we would have u, and this equals 2. Let me subtract 2 away from both sides, so -2 equals 0. So I'm going to solve this using factoring. Now, again, if you don't like factoring for this because there's a degree of difficulty to it, you can always use the quadratic formula and just come back and do the steps after I'm done factoring. It's really up to you what you want to use. So for 6, it's not only 6 times 1, it's also 2 times 3. Again, when I think about these things, 6 and 1, the extreme case, usually doesn't work. It might, but it usually doesn't. So let's start by just trying 2u and 3u. See if we can get that to work. If it can't, then we'll go to 6u and u. So for this -2 here, remember, because this is negative, I want to use subtraction with absolute values. And essentially, I also want to think about the fact that 2 is a prime number, right? It's 1 times 2 only. So if you put a 2 here and a 1 here, does that work? Well, the outer is 4 and the inner is 3. 4 minus 3 is 1, so I can make that work. Remember, you can't put the 2 here because you'd have a common factor of 2 here and not here. So that's why I immediately went to that configuration. So let's make this a plus and this a minus so that this is positive 4u. And this is going to be negative 3u. And if you do 4u minus 3u, that gives you plus 1u or plus u, however you want to say that. And now let's solve this using our zero products property. So 2u minus 1 equals 0. Then or 3u plus 2 is equal to 0. And so let's add 1 to both sides of the equation. This cancels. You get 2u is equal to 1. Then you can say or Let's subtract 2 away from each side of the equation. This cancels. You get 3u is equal to negative 2. Let me divide both sides of the equation by 2. We'll cancel that. We get u is equal to 1/2. Then or, over here, let me divide both sides of the equation by 3. We'll cancel that. We'll get u is equal to negative 2/3. So I want you to remember that we let u be equal to x raised to the power of negative 1. So what we'll do here is replace u with x to the power of negative 1. So x to the power of negative 1 is equal to 1/2. Then or x to the power of negative 1 is equal to negative 2/3. Now, how are we going to solve this? Well, there's a lot of strategies you could use. First off, x to the power of negative 1 is what? It's 1 over x. So 1 over x is equal to 1/2. So what you could do here is you could cross multiply because you do have a proportion. So x times 1 is x, and that's equal to 2 times 1, which is 2. So that's one way to find the solution. Another way to find the solution, if you wanted to do it this way, you have x to the power of negative 1. Well, again, what I could do, if I want to undo this negative 1 here that's being done to x, I could raise this to the power of negative 1, and then raise this to the power of negative 1. Power to power rule, x stays the same. Negative 1 times negative 1 is positive 1. And this equals, if I raise this to the power of negative 1, again, it's like taking the reciprocal of it. So it's basically 2 over 1, which is 2. Okay, so x equals 2. Whichever way you want to do it, it really doesn't matter. You get the same answer. So whichever method you're more comfortable with, let's put that up here. Put or. For this one, we have x to the power of negative 1 is equal to negative 2/3 like this. Again, I'm just going to raise both sides to the power of negative 1. So this would give me x is equal to, again, just take the reciprocal of this. It's going to be negative, and the reciprocal of 2/3 is going to be 3/2. So that would be my other solution here. We would say that x equals 2, or, let me drag this up here, x equals negative 3/2. So coming back up, we want x equals 2, or x equals negative 3/2. All right, let's take a look at our quiz. For question 1, we're asked to solve each word problem. We have that Mary owns a small sailboat that is currently being pulled into a dock. To accomplish this task, she has attached a rope from the top of the dock to the boat at water level. When she pulls the boat to a distance of 12 feet away from the dock, the length of the rope from the boat to the dock is 3 feet longer than twice the height of the dock. Find the height of Mary's dock. So this is just a simple problem that relies on your knowledge of the Pythagorean theorem. What you want to do here for all these problems is just draw a picture. Some of you can do it without that, but most of you will need a picture just to visualize what's going on. So I have a picture here. It's not the greatest picture in the world, but basically you have your sailboat here, and you can see you have a dock here. And basically from right here to right here, that represents the length of the rope. This is the hypotenuse of the right triangle that's being formed. Now, if we go back, it tells us specifically when she pulls the boat to a distance of 12 feet away from the dock. So going back here, I'm going to label this right here. Let me just color this in. This guy is going to be 12. Now, I want to think about the height here and the hypotenuse here, and then I can use my Pythagorean theorem. Let's let x, we're going to let x be equal to the height here. And this will be in feet. So I'm just going to put an x right here. And then what does it tell me about this hypotenuse or the rope from right here to right here? Let's come up here. And what it says is that the length of the rope from the boat to the dock is 3 feet longer than twice the height of the dock. Well, the height of the dock is represented with x. So it's 3 feet longer than twice x. So 3 plus 2x. So let's come back here. And let's label this as 3 plus 2x. So I think you can come up with your equation at this point. Basically, it's just a Pythagorean theorem. So we're going to have that 12 squared, that's one of the legs, plus you're going to have x squared, that's another leg, is equal to the hypotenuse, which is 3 plus 2x, that's going to be squared. So 3 plus 2x quantity squared. Okay, so let's just go through and crank this out. We know 12 squared is 144. Then plus we have x squared, and this equals, I'm going to use my formula here. And actually, let me write this as 2x plus 3 quantity squared. So 2x plus 3 quantity squared is just going to keep me from having to move things around. So 2x, if I square that, is going to be 4x squared. 2 gets squared, x gets squared. Then plus 2 times this guy times this guy. So 2 times 2 is 4, and then 4 times 3 is 12. So we'd have 12, and then don't forget the x. And then plus, you want to square this last guy, which is 3, so that's going to be 9. So we just want to get this into standard form, and then you can use factoring, or you can use the quadratic formula, whatever you want to do, it's up to you. So what I'll say here is just I'm going to subtract x squared away from each side of the equation, cancel that away. Let's subtract 144 away from each side of the equation. I forgot my 1 there. Cancel that away. So this will be 0 over here. And I'm going to end up flipping this. But for right now, let's say 0 is equal to, this will be 3x squared plus 12x. And then 9 minus 144, that's going to be negative 135. Okay, so I'm just going to flip this around. So I'm going to say this is 3x squared plus 12x minus 135 is equal to 0. So let's just use the quadratic formula. We'll say that x is equal to, we'll say the negative of b, in this case b is 12, so negative 12, plus or minus the square root of, you have b squared, so we'd have 12 squared, so that's 144. Then minus 4 times a is 3, then times c is going to be negative 135. Okay, so this is all over 2 times a, and a is 3. All right, so let's just punch this into the calculator and see what we get. So we'll have x is equal to negative 12. Let me put the 12 there. And then plus or minus the square root of. So let me do this part first. We know the answer is going to be positive, right? So let me put plus negative here so that's clear. So then 4 times 3 is 12. 12 times 135, that's 1,620. So you would have 144 plus 1,620. Let's just punch that into the calculator real quick. That's going to give us 1,764. Let's just put that there. And let's just hit the square root key now. So let's erase this and put 42 here. And this is over 2 times 3, which is 6. Okay, so basically you only need one of these because we're looking for a length, and we can't have a negative length, right? So the one where we do negative 12 minus 42, just forget about that. That's not going to work. So you really just need to do x is equal to negative 12 plus 42 over 6. And if I do 42 minus 12, that's 30. And 30 over 6 is going to be 5. So 5 is what I'm looking for. If we came back up, this would be 5 here. And then basically 2 times 5 is 10. 10 plus 3 is 13. And most of you now can see that this is a 5, 12, 13 right triangle. So it's a Pythagorean triple, right? So coming back up, again, it says find the height of Mary's dock. We just want to say that it's 5 feet. All right, let's look at question number 2. So we want to solve each word problem. So 2 cars left an intersection at the same time. One of the cars traveled directly north, while the other car traveled directly west. 4 hours later, they ended up being exactly 200 miles apart from each other. If the car that traveled north had gone 40 miles farther than the car headed west, how far did each car travel? Okay, so another Pythagorean theorem problem. And this one, I think you've seen this before in the lesson and the practice test. You just want to make yourself a little drawing of what's going on. So here's the intersection where they start. And basically one car goes north and the other car in this case goes west. So at the end of the 4-hour period, these cars are 200 miles apart. So this guy is going to be right here. This guy is going to be right here. So basically we have a right triangle. So what we want to do is let x be equal to the distance that one of these guys is going to travel. So let's let x be equal to, if we come back up here, it says the car that traveled north had gone 40 miles farther than the car headed west. So we could let x be equal to the distance traveled by the car that headed west. And to make this really short, I'm just going to put west, and you know what that means. And then I'm going to put then x plus 40, because the car going north travels 40 more miles. I'm just going to put is equal to north. Okay, and we know what this means. So then I'll label this as x, and I'll label this right here as x plus 40. And again, we're just using our Pythagorean theorem. So we would have x squared, that's one leg, plus you'd have the quantity x plus 40 squared, that's the other leg, is equal to the hypotenuse, which in this case is 200, being squared. Okay, so we're going to have x squared plus, use your formula here, this is x squared plus 2 times 1 times 40, which is going to be 80, then times x, then plus 40 being squared, which is going to be 1600. And this equals, let me slide this down so we can fit it, 200 squared, which is going to be 40,000. Okay, so some pretty big numbers here. Let's go ahead and see what we can do to simplify. So x squared plus x squared is 2x squared. Then plus we have 80x. Then let's subtract away 40,000 from each side of the equation. So 1600 minus 40,000, that's going to give me negative 38,400. And of course, this equals 0. So at this point, you could divide everything by 2 to work with smaller numbers, or you can just, because we're using calculators, just throw this into the quadratic formula. That's what I'm going to do. I'm not going to waste any time. I'll just say x is equal to the negative of b. B here is 80, so negative 80. Then plus or minus the square root of b squared. So you're going to have 80 squared. Punch that into your calculator. You're going to get 6,400. And then you're going to have minus 4 times a. A is 2. and then times c. So c is negative 38,400. Let's extend that. I'm just going to slide this over just a little bit, and it didn't catch that, so let me drag this over here. We'll put this over. We're going to have 2a, a is 2, so 4. Okay, so again, just put plus negative here, and then you're just working with the absolute values. So 4 times 2 is 8. 8 times 38,400, that's going to be 307,200. And I'm just going to add that to 6,400 in my calculator, and that's going to give me a result here of 313,600. Now I'm going to hit the square root key, and my calculator gives me 560. Okay, so this is going to be 560 here. And again, when you solve this, you don't want the negative here. Remember, x is going to represent a distance. You can't have a negative distance. So negative 80 plus 560, we want to do that one. Let me get rid of this plus or minus and just slide this down here. So negative 80 plus 560 over 4. Let's punch that into the calculator. Well, negative 80 plus 560 is 480, and then divide that by 4, and you're going to get 120. Remember, x, which is the distance traveled by the car going west, this right here is going to be 120, right? So this is 120. And then the other guy went 40 miles further, right? So 120 plus 40 is 160. So this right here is 160. So answering our problem, you basically want this one right here, 120 miles and 160 miles. So basically the westbound car went 120 miles and the northbound car went 160 miles. Okay, let's look at question 3. Again, we're asked to solve each word problem, and we have note the formula used to find the area of a rectangle, in case you're not familiar with it. So the area is length times width. So A is the area, L is the length, and W is the width. So here we have the length of a rectangular garden is 10 feet more than the width. If the area of the garden is 600 square feet, what are the dimensions of the garden? So this is one where I don't think you need a picture for. You can put one in if you want. I drew a little basic picture of a garden. And what you could do is say, we're going to let x be equal to the width of the garden. And then it tells us specifically that the length is going to be 10 feet more. So then coming back here, I could just say that the length is x plus 10. And again, the area is found by multiplying these two together. So x times the quantity x plus 10. Let's come up here and do that. So x times the quantity x plus 10 would give me this area. And it says specifically here, it's 600 square feet. So let me put 600 here. Let me just copy this real quick. And let's go through and just say this is x squared plus 10x. I'm just going to subtract 600 away from each side. And this equals 0. Again, this is a pretty big number to work with. You could factor this. But again, because this is big, let's just use the quadratic formula. We'll say x is equal to negative b. Again, b is 10, so negative 10. Plus or minus the square root of b squared. So 10 squared is 100. Then minus 4 times a. A is going to be 1. Then times c. C is negative 600. So again, this guy is going to be a positive. I'm going to put plus negative here to make that clear. So 4 times 1 is 4, and then times 600 is 2,400. So you basically have 100 plus 2,400, which is 2,500. And then if I hit the square root key in my calculator, I'm going to get 50. Okay, so this right here is going to be 50. Let's put that like that. And let's put this over. We have 2a. Again, a is 1, so let's just put 2. You can get rid of the negative there. You're not going to need that solution. So we'll put this as negative 10 plus 50, that's 40. And then 40 over 2 is going to be 20. So you have to remember that x was the width, okay, and then the length was 20 plus 10, or 30. So coming back up here, we want this one where it says the length is 30 feet and the width is 20 feet. So this is what we want. Remember, the length is 10 feet more than the width. So don't answer this one. That one's a trick one. All right, let's look at question number 4 now. So we have solve each word problem. And we have a note here. For this problem, we will disregard air resistance. I think most of you, if you're following along with a textbook, you've seen this type of problem before, or even if you've taken a general algebra class before. So it says, note we will use the formula. We have h, which stands for height, is equal to negative 16t squared. T is the number of seconds. Then plus v sub 0, which is the initial velocity in feet per second. Then times your t again. Then plus s sub 0, which is the initial height in feet the projectile is launched from. So we have that a toy rocket is launched vertically upward from an initial height of 33 feet. The initial velocity is 82 feet per second. Find out how long before the rocket will hit the ground. So this is not one where you need a picture. I mean, you can just visualize that. Let's say this is the ground and this is 33 feet above, where you're launching a rocket up and then gravity is going to take its toll on it and it's basically going to bring it back down to the ground. Okay, so we want to know the ground is basically a height of 0. We want to know how long in terms of seconds before the rocket will hit the ground. So let's just plug into the formula. Your h, your height, again, because we're trying to figure out when it's going to hit the ground, that's going to be 0. this equals negative 16t squared, and then plus your v sub 0, which again is the initial velocity in feet per second, that is going to be 82. So 82, and then times your t, and then plus for your s sub 0, again, the initial height in feet the projectile is launched from, that's 33 feet. Let's put 33. Okay, let me grab this. And this is something where these plus signs kind of look like they're t's. So let me maybe make this a little bit different here so I don't get confused myself. I'm even going to circle it so it's crystal clear. And let me put this 0 over on the other side. Again, this is probably one where you want to use your quadratic formula. So normally the variable is x, but now it's going to be t. So t is equal to, you have negative b. So b here is 82, right? It's the coefficient for t raised to the first power. So negative 82 plus or minus the square root of, if you square 82, you're going to get 6,724. All right, let me slide this down. I don't know if this is all going to fit. So let me put this down here. Then you have minus 4 times a is negative 16, times c is 33. So let's do this part in the calculator. Again, you could put plus negative here if you want. We want 4 times 16, which is 64, then times 33, which is 2,112. So 2,112. Let's punch this into our calculator and see what we get. So 6,724 plus 2,112, and I get 8,836. So 8,836. We'll hit the square root key, and we're going to get 94. So let's put 94 here, and let's put this over 2 times your a. In this case, a is negative 16. Okay, so this would be negative 32. And you need to pay close attention here because you don't want the negative solution. So which one's going to give you a negative solution? Well, if you go with the plus here, notice that you'd have a positive over a negative. So you don't want that, right? You want the negative over negative, which gives you positive. So I'm actually going to get rid of the plus here. So I can go with this one. Negative 82 minus 94. That's going to give you negative 176. This is divided by negative 32. So this equals, if you want to do it as a decimal, which I think that's how it's given, it's going to be 5.5. And this is in terms of your seconds. That's what we're solving for. If you wanted to list your answer as a fraction just because you were doing self-study, you could always put it as 11 over 2. So coming back up here, again, we solved for t. T was 5.5. So we want 5.5 seconds. That's how long before the rocket will hit the ground. All right, let's take a look at question 5. So we want to solve each word problem. So Joan wants to buy a rug for her office, which measures 15 feet wide by 20 feet long. She doesn't want the rug to cover the entire room. She wants to leave an even strip of flooring, which is uncovered around the edges of the room. If she purchases a rug with an area of 234 square feet, what is the width of the even strip of uncovered floor? So typically we're asked to find the dimensions of the rug, but in this case, we're asked to find what is the width of the even strip of uncovered floor. And really, that's not that hard. Again, you could just draw yourself a little picture. And I'm just going to use the same picture from the lesson and the practice test. Again, you have the room, and then you have the rug, and then you have this uncovered floor, this strip of that. And again, it's the same width all the way around. So typically, we'll just say that we'll let this width right here be equal to x. And that's, again, exactly what we're trying to find in this problem. So I'm just going to do this all the way around, just so this is crystal clear. Okay, so how can we get a solution? The first thing is you're given the area of the rug. So you know it's 234 square feet. Okay, that comes from the length of the rug times the width of the rug. So let me put the rug here, and let me put length, and let me put width. Okay, and we know that the area is 234. I don't think I'm going to fit this on the screen. So 234, and it's square feet, but we're just going to leave it off for right now. Okay, so for the length of the room and the width of the room, we're given that. We're told that the length of the room, so from here to here, is going to be 20 feet. So it's 20 feet. And we're told that the width of the room, so from here to here, we are told that that's 15 feet. So how do I get the length and the width of the rug just modeled based on all this that we have here? Well, basically, you would take the length of the room and subtract away x and subtract away another x. So you've seen this before, right? So basically 20 minus x, that's 20 minus 2x. Let me slide this down a little bit. So the length would be 20 minus 2x. Then for the width, it's a similar thought process. You have 15 feet here, minus x, and then minus x again. So that's going to be 15 minus 2x. Okay, so I think you can see how to get an equation going. Again, the area is going to be length times width. So the length is 20 minus 2x, and the width is 15 minus 2x. So if I multiply those two together, I can set it equal to the area we're given, which is 234 square feet. We just need the 234 part. So let me actually just copy this, and we'll paste this in here. Let me do this as 20 minus 2x, then times 15 minus 2x like this. This equals 234. You can get rid of this at this point. You don't need it right now. Let's put this up here. And we're just going to go through and do FOIL real quick. So 20 times 15 is going to be 300. So that's 300. And then I have 20 times negative 2x. That's minus 40x. And then negative 2x times 15 would be minus 30x. Let's just combine that now and say that's negative 70x. And then from here, negative 2x times negative 2x would be plus 4x squared. And this equals 234. So let me just rearrange this and say that this is 4x squared minus 70x. And then I'll have plus 300 equals 234. And I'll subtract 234 away from each side of the equation just to put this in standard form. So we have 4x squared minus 70x, and then plus 300 minus 234 would be 66. And then this equals 0. So this is a bit big to factor. You could divide everything by 2 if you wanted to, but in my opinion, if you're using a calculator, it's a complete waste of time. So I would just plug right into the quadratic formula, use your calculator, and see what you get. So we're going to have x is equal to, we'll have negative, and then you want b. Here b is negative 70, and then plus or minus the square root of, you have b squared, so negative 70 squared, and then minus 4 times a is 4, times c is 66, and then this is all over 2a, in this case, a is 4, so this is going to be 8. All right, so negative 70 squared is 4,900. So this is 4,900. Let me put my square root symbol back in. And then basically 4 times 4 times 66, this is going to be 1,056. And then 4,900, and this should look like a 9. So 4,900 minus 1,056 is 3,844. Let's put that in there. And if you hit your square root key, you're going to get 62. So this part is 62. Negative of a negative is positive. So basically what you have is 70 plus 62 over 8. And then you have 70 minus 62 over 8. So we're going to need both of those. And we're going to need to figure out which one's going to work and which one we can throw away. So x is equal to, let's go 70 plus 62 over 8. So this would be 132 over 8. And basically if you punch that into your calculator, you're going to get 16.5 as a decimal. Or also, you could do 33 over 2 as a fraction. Whatever you want to do. This is the one that's not going to work. I'm just going to tell you in advance, but I'll show you how to determine that. So then the other one, it's going to be x is equal to 70 minus 62, which is 8, over 8, which is 1. So this is the answer we actually want. And I'll show you how you can figure that out. Coming back up here, again, when you think about the dimensions of the rug, we have 20 minus 2x for the length and 15 minus 2x for the width. If you plug a 1 in, you're going to see that things work. Right? So basically 20 minus 2 is 18. So your length of the rug is 18 feet. And then for the width, you'd have 15 minus 2, which is 13. So if you multiply 13 by 18, you do get the 234. So your area works out. So this is what you want. You want to say that x, or this width here, that's uniform all the way around, is going to be 1. If you try to plug in 16.5, you're going to end up with some negative values, and that doesn't make any sense. Okay, so you want to throw that solution out. So coming back up here, we just want to grab this answer right here and say, what is the width of the even strip of uncovered floor? Well, it's going to be 1 foot. All right, let's take a look at our quiz. For the first question, we're asked to solve each inequality. And we're going to have 10x squared plus 11x plus 8. This is greater than 7x squared. What I'll do is subtract 7x squared away from each side of this inequality. I'll put the right-hand side as 0. So let's put this as minus 7x squared over here. This would give me 3x squared, then plus 11x, then plus 8. This is greater than 0. Okay, so what I'm going to do here is just replace this inequality symbol with an equals. So I'm going to have 3x squared plus 11x, then plus 8 is equal to 0. I'm just going to solve this using factoring. So I know with 3 it's a prime number. So I'm just going to put this as a 3x here and an x here. And then basically I just need to work this out. So 8 is either 1 times 8 or 2 times 4. If I put an 8 here, this is going to be too big, right? So this would be 24. And so that's just way too big because all of these are going to be plus signs because all of these are plus signs. If I switch this around and put an 8 here and a 1 here, that would work. The outer here would be 3x. The inner here would be 8x. 3x plus 8x is 11x. So we're good to go with this one. So from here, let's go 3x plus 8 is equal to 0. Then or x plus 1 is equal to 0. What I'll do is subtract 8 away from each side of the equation. Cancel this. We'll have 3x is equal to negative 8. Divide both sides of the equation by 3. And we'll get x is equal to negative 8/3. Over here, let's subtract 1 away from each side of the equation. And we'll just say or x is equal to negative 1. Okay, so these are our two critical values. So we'll come down to the number line. I'll say this is negative 8/3. I'll say this is negative 1. And essentially, I'll say this is region A, this is region B, and this is region C. And basically here, x is less than negative 8/3. Here, x is greater than negative 8/3 and less than negative 1. And here, x is greater than negative 1. Now, coming back up here, what I'm going to do is write this original inequality in factored form. You don't have to do this if you want. You could just plug in your test value and see if it's greater than 0. But if it's in factored form, it's a little bit easier to do because you can just think about the signs. So let's come up here and actually just drag this like this, up here like that. And so coming back over here, you just want to pick a test value in region A, B, and C. Just plug it in and see if it works. So basically for region A, you can just pick something like negative 3. So if you plug in a negative 3 there and a negative 3 there, again, you can go through and do the calculation, but really all you have to do is figure out the sign, right? So in other words, 3 times negative 3 is going to be negative 9, and then negative 9 plus 8 is going to give you negative 1. So I know this is negative here. Then for this one, negative 3 plus 1 is going to give you negative 2, so I know this is negative here. So without actually getting the value, I know that I would have a negative times a negative, which would give me a positive, and a positive is always greater than 0, so I know anything in region A would work, right? This would be true. Now you can only do this with an easier problem where you're able to solve it with factoring. If you get something where your solution requires you to use the quadratic formula, well then you're actually going to have to plug in to your inequality and see if it makes it true or false, okay? But with this situation, it's a little bit faster. All right, let's get rid of this and get rid of this. And then over here, I want to pick something that's in between negative 8/3 and negative 1. So let's just pick negative 2. That would work. So negative 2 and negative 2. So 3 times negative 2 is negative 6. And negative 6 plus 8 is positive 2. So this is positive. And then negative 2 plus 1 is going to be negative 1. So this is negative. Positive times negative is negative. And a negative is not greater than 0. So this is false. And then for the next one, we want something greater than negative 1. Let's just pick 0. It's easy to work with. So this would be 8 times 1, which is 8. So again, positive times positive is going to give me a positive. So that's going to always be greater than 0. So this is true. So writing our solution here, again, because this is a strict inequality, these critical values are excluded. So we're really just going to say that x is less than negative 8/3 or x is strictly greater than negative 1. So coming back up here, this is what I want. X is less than negative 8/3 or x is greater than negative 1. Okay, let's look at question 2 here. So again, we're asked to solve each inequality. And here we have negative x squared minus 123 and then minus 10x. This is greater than negative 2 minus 10x, then minus, let me slide this down so it fits. So then we have this 2x squared. All right, so I want 0 on the right-hand side, so I'm just going to add 2x squared to both sides of the inequality. Let's get rid of that. I'm going to add 10x to both sides of the inequality. And you'll notice that that's going to drop out on both sides. And then I'm going to add 2 to both sides of the inequality. And so this right-hand side is going to be 0. So on the left-hand side, what I have is negative x squared plus 2x squared is going to be x squared. And then negative 123 plus 2 is going to be negative 121. So let me put this as greater than 0. Let me get rid of this. So you can do x squared minus 121 is equal to 0. This is something you can solve using factoring. It's probably faster just to use the square root property though. You can just say x squared is equal to, if you add 121 to both sides of the equation, you would have this guy over here. And then x is equal to plus or minus the square root of 121, which means x equals plus or minus 11. Okay, let's put this like this. You could have also factored that into the quantity x plus 11 times the quantity x minus 11. Again, it's really up to you what you want to do. So up here, let me actually just factor this. So x plus 11, then x minus 11. We'll take that with us. So for the critical values, you've got negative 11 and positive 11. Again, I'll say this is A, this is B, this is C. So here x is strictly less than negative 11. Here x is greater than negative 11. and less than positive 11, and here x is greater than 11. And again, we're just going to pick a test point in each region. So here, let's just pick negative 12. So negative 12, and then negative 12. And then negative 12 plus 11 is going to give me negative 1. So this would be negative. Negative 12 minus 11 would be negative 23. So this would be negative as well. So negative times negative is positive, and a positive is always greater than 0. So this is true. So over here, I would just pick 0. So if you plug in a 0 there and there, you would basically have 11 times negative 11, which is negative 121, where again, you could just say this is positive and this is negative. So I know it's going to be a negative, and a negative is never going to be greater than 0. So this is going to be false. All right, for the next one, you would look at something greater than 11. So let's just use 12. So you have 12 plus 11, which is 23. So this is positive. And then you're going to have 12 minus 11, which is positive 1. So this is positive. Positive times positive is positive, and it's always going to be greater than 0. So this is true. So for your solution here, we'll just say, again, because this is a strict inequality, the critical values are excluded, that x can be less than negative 11, or x can be greater than 11. So coming back up here, we want x is less than negative 11, or x is greater than 11. All right, let's take a look at question 3 now. So again, we're asked to solve each inequality. So we're going to have 5x squared minus 16x. Let's leave a little space, and we'll put this as less than negative 6x, and then minus 5. And so what I'm going to do here is I'm just going to add 6x to both sides of the inequality, cancel this away. I'm going to add 5 to both sides of the inequality, cancel this away, and I'm going to put 0 there. So we'll have 5x squared. Negative 16x plus 6x is going to be negative 10x, so minus 10x. Then we have plus 5, and this is going to be less than 0. Okay, so to make my life a little bit easier, I'm just going to divide everything here by 5. So divide by 5, divide by 5, divide by 5, and divide by 5. Remember, you can always divide an inequality by the same positive number, and your solution set will remain the same. So 5 over 5 is 1, so this is x squared. Then minus 10 over 5 is 2. Then times x. Then plus 5 over 5 is 1. And this is going to be less than 0 over 5 is 0. Now, before you get deeper into this problem, I want you to think about something. The left-hand side here is what we call a perfect square trinomial. So it factors into a binomial squared. So most of you know that this will factor into x minus 1, quantity squared, and then this is less than 0. Now, because this guy right here, this x minus 1, this quantity is being squared, it is impossible for it to be less than 0. Why? Because if I square something, it's never going to be negative. It's either going to be 0 or it's going to be positive. So there is no value that I can plug in for x, then subtract away 1 and square it and get something that's less than 0. It's impossible. So for this one, we would want to say that there is no solution. All right, for question 4, again, we want to solve each inequality. So we'll have 4x squared plus 8x. And then what I'm going to do is just add 3 to both sides of the inequality now. So 1 plus 3 would be 4, so plus 4. And this is less than or equal to 0. So I'm just going to divide everything here by 4. Again, just to make my life a little bit easier. And so this would be x squared plus 2x plus 1 is less than or equal to 0. Now I want to pause again and think about the fact that we have a special case scenario because the left side is a perfect square trinomial, just like we had in the last example. The only difference here is the sign in front of this 2x. Before it was negative 2x, now it's positive 2x. So this is going to factor into x plus 1 quantity squared. And so we're saying that this is less than or equal to 0. Now in the last example, we had a strict inequality, right? Strictly less than 0. Here we don't have that. The part where it says less than 0, that's never going to be true because again, we're squaring this guy. But could it be equal to 0? Well, yeah, it could be. We would just say that we want to take x plus 1 quantity squared and set that equal to 0. How would we solve that? Well, you could use your square root property and take the square root of each side. And so you would say that x plus 1 is equal to, there is no plus or minus 0, there's only 0. So here x would just be equal to negative 1. So if x is negative 1, that's going to be our solution. What happens is negative 1 plus 1 is 0. 0 squared gives you 0. So 0 is less than or equal to 0, right? Because of the or equal to part. If this had been a strict inequality, again, you'd have no solution. But in this case, because it's a non-strict inequality, we do have a solution, but only one solution, and that's where x is equal to negative 1. For any other value, this inequality will not be true. All right, let's take a look at question 5 now. So we're asked to solve each inequality, and we're going to have 6x squared minus 5x minus 42. and this is less than negative x. So what I'm going to do here is add x to both sides of the inequality. Let's get rid of this and put a 0 over here. We'll have 6x squared, and then negative 5x plus x is going to be negative 4x. Then we'll have minus 42, and this is less than 0. So what I'll do now, just to make it a little bit simpler, I'll divide everything by 2, and this will give me 3x squared minus 2x minus 21 is less than 0. Okay, let me drag this up here, and let's actually just factor the left side, and then I'll set up an equation. So we'll just factor this like this. I'll put 3x here. Let me make this better. So 3x here and x here. And then for 21, it's either 1 times 21 or 7 times 3. 1 times 21 is probably not going to work, so let's go with 7 times 3. If you put a 7 here, it's too big, so you need to put the 7 here and the 3 here. That gives you 9 minus 7, which would be 2. I need a negative 2, so let's make this negative and this positive. So this would be negative 9x. This would be plus 7x. Negative 9x plus 7x would be negative 2x. This is what we want. Okay, so let's come down here and just convert this into an equation. So 3x plus 7, this quantity, that was a quantity x minus 3. Let's set this equal to 0. So we'll say 3x plus 7 equals 0. Subtract 7 away from each side of the equation. Cancel that. You'll have 3x is equal to negative 7. Divide both sides of the equation by 3. And we'll say that this cancels, and you have x is equal to negative 7/3. Over here, you would have x minus 3 is equal to 0. Let me put or in there. Let's add 3 to both sides of the equation. So let me just put or x is equal to 3. Okay, so the critical values here, you have x equals negative 7/3, and then you also have x equals 3. So coming back here, let's put negative 7/3 here, and let's put 3 here. Let's get rid of this. And let's just call this region A. Let's call this region B. Let's call this region C. All right, so in region A, we have x is less than negative 7/3. For region B, x is going to be greater than negative 7/3, and it's going to be less than 3. And for region C, it's going to be x is greater than 3. So thinking about this, if I pick something in region A, let's say I just choose something like x equals negative 3, for example. If I plug in a negative 3 there and a negative 3 there, well, 3 times negative 3 is negative 9. Negative 9 plus 7 is going to be negative 2. So I know this is negative. Negative 3 minus 3 is negative 6, so this is negative. Negative times negative will give me a positive, and a positive is never going to be less than 0. So this right here in region A is going to be false. So from region B, I can pick something like, let's say 0. So plug that in there, plug that in there. So this would basically be 7, and that's positive. This would be negative 3, so that's negative. Positive times negative is negative. A negative is always less than 0, so this one is true. So let's go to the next one in region C, where x is greater than 3. Well, we could pick something like 4. Let's say you plug in 4 there. 3 times 4 is 12. 12 plus 7 is 19, so this is positive. And then 4 minus 3 would be 1, so this is positive. Positive times positive is positive, and a positive is never less than 0, so this is going to be false. So because we had a strict inequality, we'll just say x is greater than negative 7/3. Let me make this 3 a little bit better. And we'll say and x is less than 3. So coming back up here, we're going to say that x is greater than negative 7/3, and it's going to be less than 3. All right, let's take a look at our section quiz. For the first question, we're asked to simplify each. We have the square root of negative 204. And again, the idea here is if you have the square root of a negative number, you can use your imaginary unit I to simplify. So I'm just going to break this up and say this is the square root of negative 1 times the square root of 4, then times the square root of 51. Now 51 is 17 times 3, so you really can't do anything further here. I'm going to replace the square root of 4 with 2. So let's start with that. I'm going to replace the square root of negative 1 with I, the imaginary unit, and then we'll put times the square root of 51 like this. And this is as simple as we can make it. So we're going to select this answer right here, which is 2i times the square root of 51. All right, let's take a look at question 2 now. So again, we're asked to simplify each. What we have is the square root of negative 18 times the square root of negative 5. So as we talked about in the lesson and then also in the practice test, if you get a problem like this, you want to simplify first before you multiply. So what I'll say here is that this is I, right? I'm just taking this out and writing it as I, times the square root of, for 18, it's 9 times 2. So let's say the square root of 9 times the square root of 2. And I'll just replace this right now. We know the square root of 9 is 3. So I'll say this is 3i times the square root of 2, just to make it a little bit quicker. And then over here we have times, again, I'm going to write this as I, and then times the square root of 5. Can't do anything with the square root of 5. So from here, now you would multiply, right? So 3i times I would be 3i squared. So this is 3i squared. And then square root of 2 times square root of 5 we could write as the square root of 10. Now, I squared by definition is -1. So to finish this up, I'm just going to replace this I squared with -1. So we just say this is -3 times the square root of 10. So I'm looking for this one right here, -3 times the square root of 10. Okay, let's look at question 3. Again, we're asked to simplify each. So we're going to have 6 plus 2i, then minus, we're going to have -7 minus 7i, then plus, we're going to have -6 minus 5i. So you have to be very careful when you have a minus sign in front of parentheses. Remember, you have to change the sign of each term inside when you're dropping the parentheses here. A lot of times we put this plus -1 here, and then we show this using the distributive property, just so nobody's lost. So from the first set of parentheses, I'm just going to drop them. So I'm just going to say I have 6 plus 2i. And then here I'm going to distribute the -1 to each term. So this is plus 7, and then plus 7i. And then we're going to have plus. Here I can just drop the parentheses because it's a plus sign out in front. So -6, or you can put -6 if you want. It doesn't matter. So -6, and then minus 5i. Let me make this I a little bit better. I think it's not that legible. So let's come back over here. Now you're just going to combine what you can. So if you notice you have 6 minus 6, that's going to be 0. So let's just mark this out to show that it's canceled away. So really for the real part of this complex number, you're just going to have 7. And then for the imaginary part, you have 2i plus 7i minus 5i. So 2 plus 7 is going to give me 9. And then 9 minus 5 is going to give me 4. So this would be plus 4i. Okay, so 7 plus 4i is the answer we're looking for. So we want this guy right here. Okay, let's look at question 4. Again, we're asked to simplify each. So now we're going to have this 5 minus 8i, this quantity, multiplied by the quantity 1 plus 3i, then multiplied by the quantity -1 minus 8i. So really, this is just something where you would FOIL the first two, and then take that result and multiply it by the last one. So let's set this up as 5 minus 8i, and then times 1 plus 3i, and then times -1 minus 8i. I don't think we can fit this on the screen here. So let's start with the first two. So 5 times 1 would be 5. Then I would go 5 times 3i, that's going to be plus 15i. Then -8i times 1 would be minus 8i. And then -8i times 3i would be minus 24i squared. And so looking at this, I know that I squared is -1. So what I'm going to actually do is erase this and change this to the opposite sign, because multiplying by -1 would change a negative, like -24, into a positive, such as positive 24. So from here, I can really just say 5 plus 24 would be 29. So let's write this out in front and say this is 29. And then 15i minus 8i would be 7i. So we have 29 plus 7i. So that is the result of multiplying these two together. So now we'll just multiply this by the other guy, so -1 minus 8i. And again, you can just use your FOIL. So we'd have 29 times -1, which is -29. And then I'd have 29 times -8i. That's going to be -232i. And then 7i times -1 is minus 7i. And then 7 times -8 would be -56. So this would be -56. And then I times I is I squared. So remember, when you get I squared, it's basically -1, and you would just change the sign of this guy. So I'm going to erase this, and I'm going to change this from negative to positive. And then I can just say -29 plus 56, that's going to give me 27. So let's just erase this and put a positive 27 out in front. Then -232i minus 7i would be -239i. Let's get rid of that and put that in there. So this is my answer that I want. So coming back, I want this 27 minus 239i. Okay, let's look at question 5 now. So we're asked to simplify each. So we have -1 minus 2i. This is over -5 minus 5i. So again, what you want to do here is basically just multiply by the complex conjugate, so you can get rid of this I from the denominator, because remember, I is technically the square root of -1, and when we simplify, we do not want a radical in the denominator. So I'm going to multiply this by -5 plus 5i over -5 plus 5i. I'm going to wrap this so this is crystal clear what we're going to do. So let's actually take this to the next page. Okay, so in the numerator, I'm going to use my FOIL. -1 times -5 is positive 5. The -1 times 5i would be -5i. and then negative 2i times negative 5 would be plus 10i. And then negative 2i times 5i would be negative 10i squared. Might as well just put a plus here and get rid of this I squared. Again, you're just changing the sign because I squared is negative 1. And then, of course, 5 plus 10 would be 15. So let's write this as 15 here. Negative 5i plus 10i would be 5i. So it's 15 plus 5i. So that is my numerator for now. In the denominator, remember, you can use your formula. It's going to be a squared plus b squared. Remember, you get the plus because of the I. I squared gives you negative 1, and it flips that normal negative from that formula to a positive. So I'm going to square negative 5. That's going to give me 25. And then I'm going to square 5, and that's going to give me 25 as well. So let's put plus 25 here. So let's go ahead and just write this as 50. And of course, you can simplify this because what I can do is factor out a 5 from the numerator. This would be 3 plus I over, let's go 5 times 10 like this. Let's cancel a common factor of 5, and I'll report my answer as 3 plus I over 10. And of course, if you want to write this in standard form, you need to split this up. A lot of teachers want you to do this. So I'll say this is 3 over 10. This is your A or your real part. Then plus, I'm going to say that there's 1 over 10 times I. So this is your A plus BI, right? So the B in some textbooks is 1 over 10. That's the imaginary part. Some textbooks will say 1 over 10 times I is the imaginary part. Just depends on where you're following. But this is basically the answer we're looking for. So I want this one over here, 3 over 10 plus I over 10, or you could put 1 over 10 times I, whatever you want to do. So this is the answer. All right, let's take a look at question 6 now. We're asked to simplify each. We have I raised to the power of 349. So again, as we talked about in the lesson, I to the 4th power is 1. So what you want to do, if you have something that's an exponent that's greater than 4, try to find the next number going down that's divisible by 4. In this case, it would be 348. So you would have I to the power of 348 times I. And we know if the exponent here is divisible by 4, then this guy is going to end up being 1, right? Because you could say this is I raised to the 4th power, and then raise this to the 87th power. Again, this is 1, so this is 1 to the 87th power, which is just 1. So this right here is just going to be 1, and then times I, which just gives me I. So for my simplified answer, it's just going to be I. Okay, let's look at question 7. Again, we're asked to simplify each. So we have 12I raised to the power of negative 15. So forget about the 12 for a second. Just focus on the I to the power of negative 15. I told you in the lesson that you could do this the long way if you wanted to. You end up having to rationalize, and it kind of takes a while. The shortcut here is to think about multiplying by a form of I to the 4th power, which again is 1. It's like multiplying by 1, where it's going to create the least possible positive exponent on this I guy. So what I would do is use 16. Right, so I'm going to multiply by I to the power of 16. Again, this can be written as I to the 4th power raised to the 4th power. I to the 4th power is 1, so this is 1 basically raised to the 4th power, right? If we multiply by 1, we're not changing anything. So what we have here is basically I raised to the power of negative 15 plus 16 from your rules of exponents. So this is I to the 1st power, or just I. So putting this together as a full solution, I know I can replace I to the power of negative 15 with basically I. So I can say this is equal to 12I, right? So this is the answer that I want. All right, let's take a look at question 8 now. So we're changing things up and going into solving equations. And we want to solve each equation by factoring. So we have 27x squared minus 153x is equal to 7x minus 256 plus 3x squared. So if you're taking a test and you get a problem like this and they say solve it by factoring, the first thing you want to do is try to write it in standard form, and you want to simplify it as much as possible. So is there a common factor, some way to make this a simpler problem? So first, I'm just going to subtract 3x squared away from each side of the equation, cancel that away. I'm going to subtract 7x away from each side of the equation, cancel that away. And I'm going to add 256 to both sides of the equation, cancel that away, so the right side is 0. 27x squared minus 3x squared is going to be 24x squared. If I have negative 153x minus 7x, that's negative 160x. Then I'll have plus 256 is equal to 0. So these are some pretty big numbers. What I would think about is there something that I can divide everything by to make this simpler? And the answer to that is yes. you'll notice that everything is going to be even here. Everything is also going to be divisible by 4. You can just check the last 2 digits of each number. And it turns out that everything is also going to be divisible by 8. So 24 divided by 8 is going to give me 3. So this is 3x squared. And then minus, if we do 160 divided by 8, that is going to give me 20. So this is 20x. And then plus, if we do 256 divided by 8, that's going to give me 32. If we do 0 divided by 8, that's going to give me 0. Okay, so this is a lot more manageable. So let me just factor the left-hand side here. 3 is a prime number, so I know this is going to be 3x and this is going to be x. Unfortunately for 32, you do have quite a lot of possibilities. I'm trying to get a middle here of negative 20x. And again, if this is a plus here, I know that I need to add things, and forget about the fact that it's negative 20, trying to get to 20. So if you want to start with 1 and 32, you can. It's very unlikely to work. A 32 here is very big. That's not going to work. A 32 here is still too big. So let's get rid of 1 and 32. So next you would try 2 and then 16. So if you put a 16 here, it's too big. If you put a 16 here and a 2 here, that's going to be 6 plus 16. That's too big. So get rid of that. So next you would have 4 and 8. So if you put an 8 here, that's going to be too big. That's already 24. If you put the 8 here and the 4 here, that's going to be 12 plus 8, which gives me 20. That's what I'm looking for. Just have to get the signs right. And in this case, you're going to want a minus here and a minus here. So the outer here is going to be negative 12x, and the inner here is going to be negative 8x. So negative 12x plus negative 8x is going to give you that negative 20x that you're looking for. Okay, so from here, I'm just going to set each factor with a variable equal to 0 and solve the resulting equation. So 3x minus 8 is equal to 0. Then or x minus 4 is equal to 0. So over here, let's add 8 to both sides of the equation. Cancel that away. I'll say that 3x is equal to 8. Divide both sides of the equation by 3. Let's cancel this away and say x is equal to 8/3. Over here, let's just add 4 to both sides of the equation. Cancel that away. We'll say x is equal to 4. So I'll just put a comma here and put a 4. So x equals 8/3 or 4. So coming back up here, I want this answer. X equals 8/3 or 4. Okay, let's look at question number 9 now. So again, we're asked to solve each equation by factoring. So we have 22x squared plus 140 is equal to negative 4 minus 210x minus 2x squared. So again, I'm just going to write this in standard form. So it's probably quicker to subtract 22x squared away from each side, like this. Get rid of that. Subtract 140 away from each side. Get rid of that. Put this as a 0. So I'll have 0 is equal to, let's start over here. So negative 2x squared minus 22x squared is negative 24x squared. Then it looks like minus 210x. Negative 4 minus 140 would be minus 144. Okay, so I can legally flip this around and put this as equal to 0. Now, I have a leading coefficient that's negative. I think that's a little bit harder to work with. So you can always divide everything by negative 1. But also you would notice here that everything is divisible by 2. And then also everything is going to be divisible by 3. So that means everything is divisible by 6. So let me divide everything here by negative 6. So negative over negative is positive. 24 over 6 is 4. So this is 4x squared. Negative over negative is positive. 210 divided by 6 is 35. So plus 35x. Negative over negative is positive. And then 144 divided by 6 would be 24. So plus 24. And this equals 0 divided by negative 6 is 0. All right, so let's factor the left-hand side here now. So we have 4 as our leading coefficient. So that can come from 2 times 2 or 4 times 1. Now, because this guy right here, if you think about 24, it's 1 times 24, it's 2 times 12, it's 3 times 8, or it's 4 times 6. Now, in each case, if I did, let's say 2x here and 2x here, it's not going to work because you can't have a common factor of 2 in the binomial that you're setting up if you don't already have it in the trinomial. So in each case, when you go through, all of these are going to be eliminated right away. So this right here is not possible. So you would immediately go to 4x and x. Now notice that everything here is plus, right? So I know this is a plus and this is a plus without even thinking about it. Now 1 and 24 is impossible. You cannot put the 24 here, right? Because you have a common factor of 4. And if you put the 24 here, it's just too big. So let's get rid of this right away. Get rid of that. 2 and 12 is impossible, right? You'd have a common factor of 2 no matter how you put it in. So that's gone. 4 and 6 is impossible for the same reason. You'd always have a common factor of 2. So it has to be 3 and 8, and you can't put the 8 here, so the 8 would have to be here, and the 3 would have to be here. So in this case, we eliminated quite a few possibilities just because of our little shortcut. And so let's check to see if this works. The outer here would be 32x. Let me make this a little bit better. And then the inner here would be 3x. 32x plus 3x would give me 35x. So we are good to go there. Did not mean to erase that. Okay, so let's go ahead and say that we have 4x plus 3 is equal to 0. Or we'll have x plus 8 is equal to 0. Let's subtract 3 away from each side of the equation. Cancel this away. We have 4x is equal to negative 3. Let's divide both sides of the equation by 4. Cancel this away and say x is equal to negative 3/4. Over here, let's subtract 8 away from each side of the equation. Cancel this away. We'll say or x is going to be negative 8. So coming back up, we want x equals negative 3/4 or negative 8. Okay, let's look at question 10 now. So we want to solve each equation. 5x squared plus 6 is equal to 326. So 5x squared plus 6 is equal to 326. What I would do here is subtract 6 away from each side of the equation. Cancel that away. We'll have 5x squared is equal to 326 minus 6 would be 320. I would then divide both sides of the equation by 5. So divide both sides of the equation by 5. This is going to cancel. You're going to have x squared is equal to 320 divided by 5. That's going to give me 64. Now remember from the lesson, if we have x squared is equal to k, then x is equal to plus or minus the square root of k. So here we would have x is equal to plus or minus the square root of 64. Square root of 64 is 8, so this is x equals plus or minus 8. So we want this guy right here, x equals 8, or also x could be negative 8. All right, let's look at question 11 now. So we're going to have 3x squared plus 8 is equal to negative 31. All right, so what I'm going to do is subtract 8 away from each side of the equation, cancel this away. We'll have 3x squared is equal to negative 31 minus 8 is going to be negative 39. Forgot to put the 3 there, so negative 39. And let's divide both sides of the equation by 3. Cancel this away. We'll have x squared is equal to negative 39 divided by 3 is going to be negative 13. So the idea here is now we can once again say that x is equal to plus or minus the square root of negative 13. Now let me just drag this up here. We can say that x is equal to plus or minus. Where this negative is, like we talked about earlier, this can be represented with the imaginary unit I, right? It's basically just the square root of negative 1. So I'm going to say I times the square root of 13. So remember, two solutions. You have I times square root of 13, and then the negative of I times square root of 13. So coming back up here, I want this one. So x equals I times square root of 13, and then negative I times square root of 13. Okay, let's look at question 12 now. So we're asked to solve each equation. We have the quantity 4x minus 3 being squared, and this is equal to 19. For this one, I would basically just take the square root of each side. Remember, with your square root property, you're going to have 4x minus 3, if I take the square root of this side, is equal to, you've got to have the plus or minus the square root of this side. So from here, I'm trying to solve for x. So what do I need to do? I need to add 3 to both sides here, and let's cancel this away. So we'll have 4x is equal to plus or minus the square root of 19 and then plus 3. Well, really, to get my solution, I'm just going to divide both sides of the equation by 4 so that I can isolate x. Let's just do this like this. This will cancel. So you get x is equal to, let's just put the 3 in front. You could say 3 plus or minus the square root of 19 over 4. Again, you could break that up and say it's 3 over 4 plus or minus the square root of 19 over 4. Up to you what you want to do. But we're going to want this answer right here, where you have x equals 3 plus square root of 19 over 4, and then also 3 minus square root of 19 over 4. All right, let's take a look at question 13 now. So now we want to solve each equation by completing the square. And we're going to have x squared minus 6x minus 32, and this equals negative 11x, then plus 4. All right, for this one, we want all the variable terms on one side, and then we want the constants on the other. So I'm going to add 11x to both sides of the equation. Cancel that away. And then I'm going to add 32 to both sides of the equation. So remember, you don't want this one in standard form, okay? So we want to cancel this and say this is x squared. And then negative 6x plus 11x is going to give me plus 5x. And this will be equal to 4 plus 32 is going to be 36. So remember what you're trying to do. The first thing is to make sure that this guy right here, this coefficient on x squared is a 1. It is a 1 here, so we're good to go. You are trying to create a perfect square trinomial on the left-hand side. So this is something that can be factored into a binomial squared. Once we have that, we can use our square root property to get our solution. So to complete the square, you're going to look at this coefficient for x to the first power. You're going to cut it in half, and then you're going to square it. So let's say we have x squared plus 5x plus, you would have 5 halves. Again, that's just multiplying by a half. And then you would square that, so that would be 25 over 4. And this is added to both sides of the equation. So you would have 36 plus 25 over 4. Now this left-hand side is going to factor into x plus, what was 5 times a half? That's 5 halves, so that's what you want there. And this is quantity squared. And this equals, for this side to simplify, you've got to get a common denominator. So you'd multiply 36 by 4 over 4. Let me move this down a little bit so I can show this up here. So times 4 over 4. 36 times 4 is 144. And then plus 25, that's going to give me 169. So this is 169 over 4. So from here, what I'm going to do is use my square root property. So basically, you would have x plus 5 halves is equal to plus or minus the square root of 169 over 4. So we would have x plus 5 halves is equal to, the square root of 169 is 13, and the square root of 4 is 2. So you basically have plus or minus 13 halves like this. And so what I'll do is I'll subtract 5 halves away from each side of the equation, cancel this away, and we'll basically say that we have x is equal to plus or minus 13 halves minus 5 halves. So we have to actually split this up into two different solutions. So for the first one, we'll say x is equal to, you're going to have 13 minus 5, which is going to be 8 over 2, which would be 4. The other one would be negative 13 minus 5, which is going to be negative 18, and then over 2, which is going to be negative 9. So my solutions here would be x is equal to 4 or negative 9. So coming back up here, I want x equals 4 or negative 9. Okay, let's look at question 14 now. So we want to solve each equation using the quadratic formula. So we have 5x squared minus 8 is equal to 8x. Let's just put this in standard form before we go to the next page. So we'll say this is 5x squared. I'm going to subtract 8x away from each side. So then minus 8, and this equals, because I subtracted 8x away from the right, I'll just put 0. Okay, so this is going to be my a, the coefficient for x squared. This is going to be my b. Again, you can put plus negative there to make that clear. And this is going to be my c. You can put plus negative there to make that clear. So x is equal to the negative of b. So let me just write this in. So negative of negative 8. Then plus or minus the square root of b squared. B is negative 8, so negative 8 squared. Minus 4 times a. A is going to be 5 times c. C is negative 8. You could put plus negative there to make that a little bit better. And then this is over 2 times a. A is 5, so 2 times 5 is 10. Okay, so just basically simplifying here with a calculator, x is equal to negative of a negative is positive. So 8 plus or minus the square root of negative 8 squared is 64. Negative times negative is positive, so I'm going to put a plus here. 4 times 5 is 20, then times 8, that's going to be 160. So 64 plus 160 is 224. Now 224 is not a perfect square. So what I'm going to do is write this as 16 times 14. And so we know the square root of 16 is going to be 4. So let me write this as 4 times the square root of 14 like that. Okay, then this will be over 10. Now before I do anything else, notice that you could cancel a common factor of 2 between the numerator and denominator. But you want to be careful, and you want to factor so you don't make a mistake. So let's go x is equal to, I'm going to pull out a 2. So this would be 4 plus or minus 2 times the square root of 14. And then over, let's go 2 times 5. Let's just cancel this. And actually, I'm just going to delete it to save some space. So that's going to be gone. So this, and just get rid of the parentheses at this point. So this is going to be my simplified form. I really can't do anything else with this because of this square root of 14 here, which is basically 14 is 2 times 7. You can't make that any simpler. So basically, you could say you have 4 plus or minus 2 times square root of 14 over 5. So you want this one right here. So you want 4 plus 2 times square root of 14 over 5, and then 4 minus 2 times square root of 14 over 5. Let's take a look at question 15 now. So we want to solve each equation using the quadratic formula. We're going to have negative 16x squared. This equals negative 6x squared plus 7 minus 2x. Okay, so let's get this into standard form. I'm going to add 16x squared to both sides. And let's get rid of that and put 0. So negative 6 plus 16 is going to be positive 10. So let's say this is 0 is equal to 10x squared. And then I'm going to rearrange this and put minus 2x and then plus 7. Of course, you can put this on the right-hand side. That's how I like it. If it's on the left, it's fine. It's really up to you what you want to do. But this is going to be your A. Let's put plus negative here. This is going to be your B, and this is going to be your C. So I'm just going to plug in. So x is equal to, you have the negative of B. Your B is negative 2. Then plus or minus the square root of B squared. So negative 2 is being squared. And then let me scooch this down. We have minus 4. So let me put plus negative 4 times A, which is 10, times C, which is 7. And then we'll put this over. We have 2 times A. A is 10, so that would be 20. Okay, so let me do a lot of this in line. The negative of negative 2 is positive 2. Let's get rid of this and just put 2. Negative 2 squared is going to be 4. And then what you'll have here is negative 4 times 10, which is negative 40. And negative 40 times 7 is going to be negative 280. So let me put minus 280. This is going to end up being negative 276. So negative 276. Okay, so we know because of this negative, we can basically pull that part out and put I. And then for the square root of 276, let's start by saying this is 69 times 4. So 69 times 4. And 69 is 23 times 3. So you really can't do anything else with that. But the square root of 4 would be 2. So let's say that this is 2i times the square root of 69. You'll notice you have a common factor of 2. But again, always take the extra time to factor this so you don't make a mistake. So x is equal to, pull the 2 out. This is a 1 plus or minus. You could put a 1 here if you want. I'm just going to put I times the square root of 69. And then this is over. Let's write this as 2 times 10. Let's cancel this 2 with this 2. And let's say, again, you could just erase this at this point. We're just doing this for scratch work. That your answer is 1 plus or minus I times the square root of 69 over 10. So we want this answer right here. So 1 minus I times square root of 69 over 10. And then 1 plus I times square root of 69 over 10. Okay, let's look at question 16. We want to find the discriminant of each quadratic equation and state the number and type of solutions. So let's look at 2x squared plus 5 is equal to negative 7 minus 11x. Okay, to find the discriminant, remember it's the b squared minus 4ac. It's the part under the square root symbol when you're working with your quadratic formula. So all I really need to do is put this in standard form. So let me add 7 to both sides. So this is just going to be 12. Let's get rid of this. And let me add 11x to both sides. So I'll have plus 11x and then plus 12, and this equals 0. So again, the discriminant is b squared minus 4ac. So this is a, this is b, and this is c. So b squared, it would be 11 squared, and then minus 4 times a is 2, and then times c is 12. So 11 squared is 121, then minus 4 times 2 is 8, 8 times 12, that's going to be 96. 121 minus 96, that's going to be 25. So if your discriminant is 25, that tells me when I take the square root there, I'm going to get 5, right? So I'm going to have 2 rational solutions. So coming back up here, I want to say 25 and then 2 rational solutions. Okay, let's look at question 17. So again, we want to solve each equation by completing the square. So here we have negative 7x squared plus 9x plus 118 is equal to negative 8x squared. Let's just add this over here now. So if I add 8x squared to both sides, this is going to be positive x squared. So let's just get rid of that. And then you have minus 6x. So again, if I add 6x to both sides, this is going to be 15 over here. So plus 15x. And then you have plus 11. I want to keep this over here because, again, if I'm completing the square, I want these 2 guys over here, and I want my constant on the other side. You don't want to write it in standard form. That's a very common mistake. So I want to subtract 118 away from each side. Let's get rid of this from over here. And 11 minus 118, it's going to be negative 107. So this equals negative 107. So from here, again, the coefficient on x squared is a 1. So we're good to go there. You want to cut this guy, this 15 in half, the coefficient for x to the first power, and then square it. So basically 15 over 2, and then square that. That's going to give you 225 over 4. This is what you're adding to both sides of the equation. Now this one's going to get nasty. I can just tell you in advance. This is going to be x squared plus 15x plus 225 over 4. You're going to need this 15 over 2, so when you cut it in half, when you factor it, that's what you're going to want. Let me move this over here real quick. Let me get rid of this and put this 4 like this. This is just off to the side. I'm going to factor this as x plus, again, this 15 over 2, this quantity being squared, and And this equals, let me get rid of this and get rid of this. So we'll say this is equal to your negative 107 plus this 225 over 4. Now you've got to get a common denominator going, so I've got to multiply this by 4 over 4. Negative 107 times 4, that's going to be negative 428, then plus 225 over 4. So punch this into the calculator, and you're going to get negative 203. So negative 203 over 4. So this is a pretty nasty fraction. Now, all we have to do from here is use our square root property. So we would get x plus 15 over 2 is equal to plus or minus the square root of negative 203 over 4. And there's a few things we can do here. So I'll say x plus 15 over 2 is equal to plus or minus, the negative can come out, right? So this is I, then times the square root of 203 over the square root of 4. So we know the square root of 4 is 2, so you can just write this as being over 2 like this. And then for the square root of 203, 203 is 7 times 29. So you really can't do anything else with that. So to report your answer here, what you can do is just subtract 15 over 2 away from each side of the equation. Let's cancel that away. I'll say x is equal to, I'm going to write this out in front, so negative 15 over 2, then plus or minus I times the square root of 203 over 2. So you can write your answer this way. A lot of teachers like for you to combine this and write it as x is equal to negative 15 plus or minus I times the square root of 203 over your common denominator of 2. So coming back here, we want this answer right here. So x equals, you have your negative 15 plus I times square root of 203 over 2, and then negative 15 minus I times square root of 203 over 2. All right, let's take a look at question 18 now. So we're asked to solve each equation. We're going to have x to the 8th power minus 97x to the 4th power plus 1,296, and this is equal to 0. All right, so hopefully you know at this point that this guy is going to be quadratic in form. So basically you have this 8 here, this highest exponent on x, that's going to be double that of this 4, which is the lowest exponent on x. So what we can do is say this is x to the 4th power, again, the smallest or the lowest one, and then we're going to square that, and then minus 97x to the 4th power plus 1,296, and this equals 0. So this is the pattern you're looking for when you have something that's quadratic in form. So in other words, I want to make a substitution for x to the 4th power. So I'll just say something like let u, or you could use w or whatever you want, be equal to x again to that smaller power, so to the 4th power. So we'll say this is u squared minus 97u plus 1,296, and this equals 0. All right, so obviously this is not something you want to use factoring for. The numbers are just too big. So I'm just going to label this as A, this, let's go plus negative here. This is B, and this will be C. So u instead of x, normally we have x, but now we have u. U is equal to the negative of b, so the negative of negative 97, and then plus or minus the square root of, you have b squared, so negative 97 squared. Let me slide this down, I don't think it's going to fit. And then we have minus your 4 times a, in this case a is 1, so just leave it. Then times c, which is 1,296. This is all over 2a, a is 1, so just over 2. Okay, this is something you could just punch into your calculator. Negative 97 squared, that's going to be 9,409. So 9,409. And then 4 times 1,296, that's going to be 5,184. If we do this subtraction, 9,409 minus 5,184, I'm going to get 4,225. Okay, let's hit the square root key on our calculator. You're going to get 65. Okay, so basically what we would do, the negative of negative 97 is 97. Let's just simplify that. You would have to set up two equations here. So we would say that u is equal to 97 plus 65, which is 162 over 2, which is basically going to be 81. Then or u is equal to 97 minus 65, which is 32 over 2, which is going to be 16. So let's just write here that u is equal to 81 or u is equal to 16. Now remember, we let u be equal to x to the 4th power. So I'm just going to replace this with x to the 4th power, and I'm going to replace this with x to the 4th power. Now, a lot of people at this point will basically use something like this. They'll say that x is equal to plus or minus the 4th root of 81, then or x is equal to plus or minus the 4th root of 16. Again, all I did was take the fourth root of each side because this was raised to the fourth power. You have the plus or minus there because when you're working with something raised to an even power, you have to think about the negative and then also the positive. So the problem with using this strategy here is that if you're not used to working with something like this, you're going to miss some solutions, right? The fourth root of 81 is 3, okay? So you might say that x is equal to plus or minus 3, then or x is equal to, the fourth root of 16 is 2, so plus or minus 2. That's only half the solutions though. You might want to think about the fact that if you go back here, let's say, for example, I just plugged in 3i. So let's say we have 3i, and I raise that to the fourth power. Does that equal 81? Yes. 3 to the fourth power is 81. I to the fourth power is 1. So this becomes, let's just do this the long way. 3 to the fourth power times I to the fourth power equals 81. Again, 3 to the fourth power is 81, so you get 81 times 1 equals 81, and you get 81 equals 81, so this is a true statement. So we are missing 3i. We're also missing negative 3i, we're missing 2i, and we're missing negative 2i. So how can we get those solutions? Well, what I would do, rather than going through this long tutorial about the proper way to solve something like this, for this level of algebra, I would just use a substitution, okay, and just call it a day. So I'm going to erase this method right here. I don't think you should use that because we haven't talked about something like that yet. And what I would do is write this as x squared being squared is equal to 81, or we'll go x squared is being squared is equal to 16. And then from here, I'm just going to let w, you could use u again, it doesn't matter. So I'm going to let w equal x squared. So now you have w squared is equal to 81, or w squared is equal to 16. Now, by the square root property, w is equal to plus or minus the square root of 81, which is 9. Then or w is equal to plus or minus the square root of 16, which is 4. Okay, so now w is x squared. So now you can come back and you can substitute and say this is x squared and this is x squared. So now using this additional substitution, you're going to get all the solutions. If x squared equals 9, then x equals plus or minus the square root of 9. So x equals plus or minus 3. So x is equal to plus or minus 3. Then if x squared equals negative 9, then now x equals plus or minus 3i. So plus or minus 3i. So you see we get those additional solutions that we were missing by doing this substitution. Again, coming down here, if x squared equals 4, then x equals 2 and then negative 2, so plus or minus 2. And then if x squared equals negative 4, well now x is going to be what? It's going to be plus or minus 2i. So plus or minus 2i. So this gives us our 8 solutions that we need. So you've got 3, negative 3, 3i, negative 3i, 2, negative 2, 2i, and then negative 2i. We want this guy right here. So x is 3, negative 3, 2, negative 2, 2i, negative 2i, 3i, and then negative 3i. Okay, let's look at question 19. So again, we're asked to solve each equation, and we have the quantity x plus 5 raised to the 4/3 power, and then plus you have the quantity x plus 5 raised to the 2/3 power. Let me slide this down just a little bit. Then minus 20, and this equals 0. Okay, so again, we have something that's quadratic in form. To make this clear, let's write this as x plus 5, and then I'm going to raise this to the 2/3 power. So again, this is smaller. And then I'm just going to raise this to the second power or square it. Again, if you multiply here, 2/3 times 2 gets you right back to 4/3. Then plus, you're going to go x plus 5 to the 2/3 power and then minus 20. Let me slide this down so it all fits. And then this equals 0. Okay, so my substitution here, we're going to let u be equal to this x plus 5 raised to the 2/3 power. So I'm going to replace this whole thing and this whole thing with u. So we'll say u squared plus u minus 20 is equal to 0. All right, let's factor this guy. Say that u is here and u is here. I need two integers that sum to positive 1 and have a product of negative 20. So that's going to be positive 5 and negative 4. So solving this with my zero product property, we know that u plus 5 equals 0, or u minus 4 equals 0. So here, just add negative 5 to both sides. So u equals negative 5. Here, add 4 to both sides. So we'll say u is equal to positive 4. Okay, so let me actually copy all this. And what I'm going to do is say that the quantity x plus 5 to the 2/3 power is equal to negative 5. Let me slide this down. Then or, we have the quantity x plus 5 to the 2/3 power is equal to positive 4. So this right here on the left has no solution. How do we know that? Well, think about it. You have something here that's going to end up being squared, and it's a result of negative 5. You can't have that, right? So in other words, if I wrote this as, let's say, the cube root of x plus 5, Let me put my 3 here as the index, and then I squared this whole thing. Remember, this is legal. Well, basically, no matter what I get as a result here, when I square it, the result is either 0 or some positive number. So this part right here has no solution. So you can just throw it away. Just get rid of it. You don't have to worry about it. In fact, I'm just going to erase it. All right, for this part right here, we can go ahead and get a solution. So we'll say x plus 5 is raised to the 2/3 power. We'll say this is equal to 4. All right, so what can we do here? First, I'm going to write this in a radical form. So I'm going to say that this is the cube root of the quantity x plus 5 being squared. And we'll say this is equal to 4. So by the square root property, we know that, again, if x squared equals k, then x equals plus or minus the square root of k. So in this case, this guy right here is being squared. So I'm going to say that we have the cube root of x plus 5 is equal to plus or minus the square root of 4. All right, so from here, let's say that we have the cube root of x plus 5 is equal to, square root of 4 is 2, so plus or minus 2. So what I would do is just keep this plus or minus. To get rid of this guy right here, we need to cube both sides of the equation. So I'm going to cube this side right here, and I'm going to cube this side right here. So essentially, the cubing will undo the cube root. So you're left with this radicand. So I'm going to have x plus 5 is equal to plus or minus 2 cubed is going to be 8. So from here, I just want to go through and get my two solutions. So you'd have x is equal to 8 minus 5, or x is equal to negative 8 minus 5. So in this case, if you subtract 5 away from 8, you get 3. So x equals 3. And then here, negative 8 minus 5 is negative 13. So x equals negative 13. So x could be 3 or x could be negative 13. So this is what we want right there. And for these, you can plug them in and see that they work. I know this one's a bit tricky to work with, but if you plug in a 3 for x and go through and evaluate, you'll get a true statement. Also, if you do a negative 13, plug that in for x, go through and evaluate, you'll get a true statement as well. All right, let's take a look at question 20 now. So we're asked to solve each word problem. So after attending a conference, Becky and Jane left from the same point on the runway at the airport. Becky's plane left first and flew north at 70 miles per hour. Due to a delay, Jane's flight didn't leave until 7 hours after Becky's. When Jane's flight left, it flew west at 80 miles per hour. How long after Becky's flight took off does it take for the two planes to be 740 miles apart? Okay, so hopefully you realize that this is just another Pythagorean formula problem, and essentially you can just draw yourself a little picture of what's going on. So let's say that this is your runway where they both take off from, and this is Becky. She's flying north, and this is the other girl, which is Jane, and Jane is the one that flies west, and she got delayed. So at some point in time, Becky's going to be here, and Jane's going to be here, and the distance between them is going to be 740 miles. So we just need to figure out this distance and this distance. So you could do something like this. You could let x be equal to the number of hours. Let's just say for Becky to keep it simple. So for Becky, okay? So for Becky. So I know that she's traveling at 70 miles per hour. So basically the distance for her, again, distance is rate times time. Well, my rate is 70 miles per hour. My time is x hours. So 70x, if I go back to my little diagram, this is 70x right here. Now, what about this one right here? It's a little bit more complex because what happens is her flight for Jane didn't leave until 7 hours after Becky. So however many hours Becky travels for, which is x, this one for Jane needs to be 7 hours less, or x minus 7. So you could say something like, then x minus 7 is equal to, let's just say number of hours for, in this case, it's going to be Jane. Okay, so let's come down here. And I want to note that she's traveling at 80 miles per hour. So this right here would be 80 times the quantity x minus 7. So basically we have our distance for each, right? So we have this guy's going to be 70x, this guy's going to be 80 times the quantity x minus 7, and we know the hypotenuse is 740. So basically just go 70x, this whole thing is squared, then plus, you can distribute this to make it a little bit easier. So this would be 80x minus 560, and this would be quantity squared, and this would be equal to 740 squared. All right, so let's start with 70 squared, which is going to be 4,900. Then we would have x squared, and then plus, you can use your formula for this. Square the first guy. 80 squared is 6,400, and then you would have x squared. You can go ahead and combine this now so it fits. 4,900 plus 6,400 is going to be 11,300. Let me get rid of this and put this as 11,300 x squared. And then you're going to have minus 2 times this guy times this guy. So 2 times 80 is 160. Then times 560 would be 89,600. And then don't forget times x. And then lastly, you have plus this guy right here, this 560 squared, which is a big number. It's 313,600. And then this will be equal to your 740 being squared, which is 547,600. What I'm going to do is actually just subtract this away from each side. So 313,600 minus 547,600, that's going to give me negative 234,000. And let's just put this as equal to 0. Now, what I can do here, you'll notice that everything is divisible by 100. So that's one step that we can take. So basically, I'm going to delete 2 zeros from the end of each number. So get rid of this, get rid of this, get rid of this, and basically 0 divided by 100 is still 0. Okay, get rid of these commas. They don't make any sense anymore. So can I go any further? So you have 113 here. So 113 is going to be a prime number. So let me just rewrite this. So 113 x squared minus 896x minus 2,340 is equal to 0. Let's get rid of this. And actually, we don't need this anymore. Okay. From here, I would just use the quadratic formula. The numbers are still big, so you still need a calculator. So this is A, this is B, let me put plus negative here, and this is C, let me put plus negative here. So x is equal to, you have the negative of negative 896, which is just 896, and then you're basically going to have plus or minus the square root of b squared. So negative 896 squared is going to be 802,816, so definitely need a calculator. Then let's say minus 4 times A is 113, then times C, which is negative 2,340. Let me make that a little bit better. I'm actually slide this stuff down here, and that got cut off. So let me extend this and wrap this. So let's do 4 times 113, which is 452, then times 2,340, and that's going to be 1,057,680. We know it's positive because you have a negative and a negative. So let's go plus. So plus 1,057,680. Okay, let's punch this into the calculator. So the total here is going to be 1,860,496. Let's hit the square root key, and I get 1,364. Okay, so 1,364. So then this would be over 2 times 113 would be 226. All right, so let's go. X is equal to 896 plus 1,364 is 2,260. Divide that by 226 and you get 10. Now the other one's going to give you a negative, and remember we're talking about x being a time or the number of hours, so this is the only solution we want. The other one would be nonsense. If we come back here, this is 10, meaning from here to here, this is going to be 700 miles. And then if you plugged in a 10 here, 10 minus 7 is 3, so this is 3, meaning this is going to be 240 miles. And you could just check this with the Pythagorean theorem. 240 squared plus 700 squared, does that equal 740 squared? The answer is yes, right? So you can do that on your own. But basically that checks out. So coming back up here, basically it would be 10 hours for Becky flying before the two planes are 740 miles apart. So we want this right here, 10 hours. Okay, let's look at question 21 now. So we have that Jacob's backyard is 20 feet wide and 30 feet long. He decides he wants to put a pool in the middle of the backyard, leaving a strip of grass of uniform width around the pool. After meeting with the contractor, Jacob decides on 184 square feet of grass. Under these conditions, what are the dimensions of the pool? Okay, so I have a few things here already set up for us. So you see the backyard is 30 feet in length and 20 feet in width. So for the area, it's 600, which is 30 times 20 square feet. So let me just put here that the total area of the backyard is 600 square feet. And let me move this over here somewhere. We'll just keep that there. We're told that he wants 184 square feet of grass. So coming back here, I would take 600, the total backyard square footage, minus 184, the amount for the grass. That's going to give me the square footage for the pool. So 600 minus 184, that's going to give me 416. So when I think about the pool, for the pool, it's going to be 416 square feet. Okay, so we know this and we're going to need this. In terms of getting the dimensions of the pool, remember, we can just let this uniform width all the way around. This color is bad on this, so let me change this color up. Maybe let's use orange and see if that works. Yeah, that looks good. So let's say this is X, and this is X here, and this is X here, and this is X here. Okay, so basically if we know from right here to right here is 30 feet. Well, for the pool, it's 30 feet minus x feet and then minus x feet again, right? So in other words, for the length of the pool, it's 30 minus 2x, right? So 30 minus x, then minus x again. For the width, now you have from here to here, again, that's 20 feet. So it's 20 minus, again, you have to take out this x and you have to take out this x. So 20 minus 2x. So the idea here is that the 30 minus 2x, the length, times the 20 minus 2x, the width, would give you this 416. That's going to be your area for the pool. So let's set this up. We have 30 minus 2x times the quantity 20 minus 2x is equal to 416. So 30 times 20 is going to be 600. Then 30 times negative 2x would be minus 60x. Negative 2x times 20 would be minus 40x. Negative 2x times negative 2x is plus 4x squared. This equals 416. So negative 60x minus 40x would be negative 100x. Let's just erase that and put that in there. And so I'm actually just going to rearrange this and say this is 4x squared minus 100x. And then let me subtract 416 away from each side. And that's going to give me plus 184. And this equals 0. Okay, so everything here is divisible by 4. You could divide this by 4, this by 4, this by 4, and this by 4. You'll get x squared minus 25x plus 46 is equal to 0. Now this is pretty easy to solve with factoring. So let's put an x here and an x here. We need two integers whose sum is negative 25 and whose product is positive 46. We know that's going to be a negative 23 and a negative 2. Okay, so for these guys, you would solve x minus 23 is equal to 0, or x minus 2 is equal to 0, and I'll add 23 to both sides of the equation. This will cancel. You get x is equal to 23. Let's add 2 to both sides of the equation. This will cancel. You'll get x is equal to 2. Okay, this one right here, this 23 is not going to work. I'm just going to tell you that in advance. Essentially, you just want to plug them both in. When you come back up here and make sure they work, if you plug in a 23, it's just going to give you a negative result. You can't have a negative length or negative width. So we know it's going to be 2, right? So you plug in a 2 there and a 2 there. And essentially the dimensions for this pool, the length, it's going to be 30 minus 2 times 2 is 4. So 30 minus 4 would be 26. So your length is 26 feet. Your width is going to be what? 20 minus 4 is going to be 16. So 16 feet. And again, if you calculate the area, 26 times 16, that's going to give me 416, right? We have 416 square feet for the pool. So that checks out. And then for the grass, it's going to be 184 square feet. If I add that back in, I'm back to 600 square feet, which again, that was the area for this entire backyard, right? It's 20 feet in width by 30 feet in length. So coming back up here, I want this, right? 16 feet for the width and 26 feet for the length. All right, let's take a look at question 22 now. So again, we want to solve each word problem. So we have here, note for this problem, we will disregard air resistance. And we're going to use this formula. H, which is the height, is equal to negative 16t squared, where t is the number of seconds, plus v sub 0 times t, where v sub 0 is the initial velocity in feet per second. And again, t is the number of seconds, plus s sub 0, where s sub 0 is the initial height in feet the projectile is launched from. So we have that a projectile is launched vertically upward from an initial height of 25 feet. The initial velocity is 198 feet per second. Find out how long before the rocket will hit the ground. So a real easy problem. You're going to plug a 0 in for h, because hitting the ground is essentially a height of 0. And then this is equal to negative 16t squared, then plus, for v sub 0, again, the initial velocity is given to us right here. It's 198 feet per second. So then times t, and then plus your s sub 0. Let me slide this down just a little bit. Your s sub 0, which is the initial height in feet the projectile is launched from, and that's going to be 25 feet, so plus 25. Now these plus signs look like t's, so I'm just going to circle them real quick so it's crystal clear they're not. And I'm just going to use my quadratic formula here. So I'm going to say that t is equal to the negative of b. In this case, b is the coefficient for t to the first power, so it's 198. So negative 198 plus or minus the square root of b squared. So 198 squared, let's just do that in the calculator. That is going to give me 39,204. Then minus 4 times a is negative 16, times c is 25. Okay, so what's this going to be? 4 times 16 is 64, then times 25, that's going to be 1,600. This is a negative and this is a negative. Negative times negative is positive. So this will be plus 1,600. Let's do this on the calculator. I get 40,804. So 40,804. Let's hit the square root key and you're going to get 202. So this is going to be 202 and this is all over 2a. So a is negative 16 and 2 times negative 16 is going to be negative 32. Okay, so what are we going to have here? So t, which is a time in seconds, is equal to, you're not going to want the negative plus the positive, because in this case, that would give you a positive over a negative, which is negative. You don't want a negative amount of seconds. You want negative plus negative over negative, right? Because you're going to have negative over negative, which is positive. So basically, just look at this solution right here. So negative 198 minus 202, which is negative 400. Let me write negative 400 over negative 32. And if I punch that into the calculator, I get positive 12.5. So going back up, we want to say 12.5 seconds. All right, let's take a look at question 23 now. So we're asked to solve each inequality. And what we have is 6x squared minus 24x minus 100. This is greater than negative 10 minus 12x. Okay, so before I even go to the next page, let's just add 10 to both sides of the inequality. Let's cancel this away. Let's say negative 100 plus 10 is negative 90. And then let's add 12x to both sides of the inequality. Let's cancel that away. Let's put this as a 0 right here. So 6x squared, then negative 24x plus 12x is going to be minus 12x, and then minus 90 is greater than 0. So essentially, you want to figure out where your critical values are. So I'm just going to replace this with equals. So your 6x squared minus 12x minus 90. Okay. Now, you can divide everything here by 6. So divide everything by 6 here. And you're going to get x squared minus 2x minus 15 is equal to 0. So let me actually replace both of these. I'll just do this in factored form. So I'm going to factor this right here, and then I'll replace it above. So x goes here and x goes here. Two integers that sum to negative 2 and have a product of negative 15. That's going to be negative 5 and positive 3. So negative 5 and positive 3. So let me write this up here. So x minus 5, this quantity, that was a quantity x plus 3. Okay, so I'm leaving it in factored form because it makes it a little bit easier to figure out if a test value is going to work or not, just based on the sign that you get. So in this particular case, we know that we would solve x minus 5 equals 0 or x plus 3 equals 0. And here I would add 5 to both sides, so x is equal to 5, so that's one critical value. And here I would subtract 3 away from each side, so x equals negative 3, that's my other critical value. So get rid of all this, you don't need this anymore. So you can call this A, B, and C for reference. You don't need to do that, but I always do. And you'll say this is where x is strictly less than negative 3. This is where x is greater than negative 3 and less than 5. And here x is greater than 5. So if I look at something that's less than negative 3, you could pick negative 4. And again, you just want to think about the sign here. You can go through and get the value too. It's really up to you. Negative 4 minus 5 is negative 9. So I know this is going to be a negative. Then negative 4 plus 3 is going to be negative 1. So this is a negative. Negative times negative is going to give me a positive, and any positive is always greater than 0. So we could say for this region A that it's going to be true, right? It's going to work. In region B, you have 0. So plug that in. You would have a 0 here. You'd have a 0 here. So negative 5 times positive 3 is negative 15. Or more importantly, you could just say it's a negative, and a negative is never going to be greater than 0. So here it's going to be false. Then for region C, anything greater than 5, let's just use 6. Plug in a 6 there and a 6 there. 6 minus 5 is 1. 6 plus 3 is 9. So you have a positive times a positive that gives you a positive. Any positive is always greater than 0. So this is true. Now remember, we had a strict inequality here. So these critical values here are not part of the solution. So we would say that x is less than negative 3 or x is greater than 5. So I want x is less than negative 3 or x is greater than 5. Okay, let's look at question 24 now. So we're asked to solve each inequality. We have 7x squared minus 2x minus 15 is less than negative 4 plus 3x squared minus 9x. Okay, so let me add 9x to both sides like this. Cancel this away. Let me subtract 3x squared away from each side. Let's cancel this away, and let's add 4 to both sides. Cancel this away. So the right side is 0 now. Okay, on the left side, 7x squared minus 3x squared is 4x squared. Negative 2x plus 9x is going to be plus 7x. Negative 15 plus 4 is going to be minus 11. And of course, this is less than 0. So coming down here, let's work on 4x squared plus 7x minus 11 is equal to 0. And I'm just going to factor this. So let's factor this guy. So for 4, it's either 4 times 1 or 2 times 2. Now, we get lucky here because you have 11. Forget about the fact that it's negative. 11 is only 1 times 11. So you can quickly go 4x and x. and see if 11 and 1 would work. Obviously, you can't put an 11 here. That's way too big. If you try a 1 here and an 11 here, this is 11 minus 4, which would give you 7, right? So you got to work out the sign. Basically, you want this right here to be plus and this to be negative. This would give you negative 4x. This would give you plus 11x. 11x minus 4x would give you 7x. So this is what we're looking for. And I did not mean to erase that. Okay, so let me factor this up here as 4x plus 11. Then that quantity times the quantity x minus 1. We'll say this is less than 0. And let's say that we have 4x plus 11 is equal to 0. Then or x minus 1 is equal to 0. Let's subtract 11 away from each side of the equation. Cancel this. We have 4x is equal to negative 11. Divide both sides of the equation by 4. Cancel this. We get x is equal to negative 11 fourths. Over here, I'm just going to add 1 to both sides of the equation. Cancel this. And then basically x is also 1. So let's go negative 11 fourths and then 1. Again, you can call this A, B, and C. Here, x is less than negative 11 fourths. Here, x is greater than negative 11 fourths. And less than 1. Here, x is greater than 1. Okay, so just picking something in region A, I would just say something like maybe negative 3. So plug in a negative 3 there and there. 4 times negative 3 is negative 12. Negative 12 plus 11 is negative 1. So this is going to be negative. Negative 3 minus 1 is going to be negative 4. So this is negative. Negative times negative is positive, and a positive is never less than 0. So this is false. For the next region, you have 0 involved. That's usually the easiest to work with. So let's plug in a 0 there and a 0 there. So this is going to be 11, which is positive. This is going to be negative 1, which is negative. Negative times positive is negative, and a negative is always less than 0. So this is going to be true. And then in the next region, we're basically going to have things that are greater than 1. So let's pick 2. Let me get rid of this. 4 times 2 is 8. 8 plus 11 is 19. So this is positive. And then 2 minus 1 here would be 1. So this would be positive. So positive times positive is positive. And a positive is never going to be less than 0. So this is false. Now this is a strict inequality. So again, the critical values are not included. So we'll just say that x is strictly greater than negative 11 fourths and less than 1. So this is what we want right here. We have x is greater than negative 11 fourths and less than 1. Okay, let's look at question 25. So we have 25x squared minus 30x plus 9 is less than or equal to 0. Now we talked about these special case scenarios a lot. When you see something here and you have, let's just look at 25 for example. 25 is a perfect square. It's 5 being squared. 9 is a perfect square. It's 3 being squared. So I'm going to rewrite this as 5x being squared. And I'm going to write this as 3 being squared. Just think about, can I factor this as a binomial squared? This would be 5x minus 3 quantity squared. Does that work out? First guy squared would give you the 25x squared. So that works. Then minus 2 times the first guy times the second guy. 2 times 5 is 10. 10 times 3 is 30. Times x is negative 30x. That gives you that right there. Then square the last guy. 3 being squared is 9, so plus 9. So this is how you can factor this, and we're saying this is less than or equal to 0. Is this possible? It's not possible for it to be less than 0. Remember, if you square something, it's either going to be 0 or some positive value. It cannot be less than 0. It's impossible. So you can only think about the fact that this guy being squared could be equal to 0. So you could satisfy that part only. So if you had the problem where it was like this, there'd be no solution. But in this case, you can just solve 5x minus 3 quantity squared is equal to 0. From the square root property, you just say 5x minus 3 is equal to, there is no plus or minus the square root of 0. The square root of 0 is just 0, okay? There's no plus or minus, so just 0 here. Then you would add 3 to both sides. Let's just put a 3 over here. Let's just get rid of it from over here. Divide both sides by 5, and you're going to get x is equal to 3/5. So this is the solution we want right there. If you plug a 3/5 in for x, you get a true statement. But for any other value for x, it's going to be a false statement, and the inequality will not be satisfied. So this guy is only true when x equals 3/5. All right, let's take a look at our quiz. For the first question, we're asked to solve each equation, and we are going to have the square root of negative 5x plus 36. This is set equal to x minus 8. Okay, so because this square root operation is isolated on the left-hand side, I can immediately just square both sides of the equation. And so I want you to remember that squaring the quantity x minus 8 requires our formula. So we need to make sure we expand this, right? Don't just say it's x squared minus 8 squared. That's not going to work. So here, this would just be negative 5x plus 36. And this equals, again, over here, use your formula. So it's x squared, then minus 2 times this guy times this guy. So 2 times 8 is 16, so minus 16, then times x, then plus square 8, and you get 64. Okay, so this is going to be a quadratic, so I just want to put this in standard form. For most of these, you're going to be able to solve them using factoring, or if not, you can just solve it with the quadratic formula. So what I'll do here is just add 5x to both sides of the equation. We'll cancel this away. Let's subtract 36 away from each side of the equation. Cancel this away and put 0. We'll put x squared, and then negative 16x plus 5x is negative 11x. And then 64 minus 36, that's going to be 28. So let's put plus 28. And this equals 0. So from here, I'm just going to factor the left-hand side. So I'm going to put an x here and an x here. Two integers that sum to negative 11 and have a product of positive 28. That's going to be negative 7 and then negative 4. So we can see that the solutions here would be x equals 7 or x equals 4. Well, let's just go through for completeness and say x minus 7 equals 0 or x minus 4 equals 0. So add 7 to both sides here. Cancel this. We'll say x is equal to 7. Add 4 to both sides over here. Cancel this. We'll say x could also be 4. Now, again, these are proposed solutions, so they don't necessarily work in the original equation. So coming back up here, let's check x equals 7. And then also we're going to check x equals 4. So let me write this out. So we have the square root of negative 5x plus 36. This should be equal to x minus 8. So let's check 7 first. So if we plugged in a 7 there, you'd have negative 5 times 7, that's negative 35. Then plus 36, that would be positive 1. So this would be the square root of 1, which is 1. Then over here, if you plugged in a 7, 7 minus 8 is negative 1. So essentially you get 1 equals negative 1, which is false. So what that tells me is that this guy, this 7 here, needs to be rejected, right? That's not a valid solution. The other guy is 4. So let's rewrite this. We'll have the square root of negative 5. Let me just plug in a 4 now, plus 36. This equals 4 minus 8. So this should be negative 4 here. Negative 5 times 4 is negative 20. Plus 36 would be 16. So you have the square root of 16. That's going to be 4. Again, you get a false statement. 4 equals negative 4. That is false. Okay, so this one's going to get rejected also. So when this happens, you basically don't have a solution, right? So we just select here the answer that says no solution. Okay, let's look at question 2. Again, we want to solve each equation. So we're going to have 9 plus the square root of 31 minus 3x, and this equals x. So what I'm going to do is subtract 9 away from each side of the equation, and that's going to isolate this square root over here, and then I'll square both sides. And so this will be 31 minus 3x is equal to, if I square this guy, I'm going to use my formula, so x squared. Then you have minus 2 times 9 times x, so this is basically minus 18x. Then plus 9 squared is 81. Okay, let's put this into standard form. I'm going to add 3x to both sides of the equation. This will cancel. And then I'm going to subtract 31 away from each side of the equation. Let me make this 3 a little bit better. That'll cancel. So this is 0 over here. Again, I like to flip things around. So I'm just going to say this is x squared. And then negative 18x plus 3x is going to be negative 15x. And then basically 81 minus 31 is going to be 50. So plus 50. And this equals 0. So very easy to solve this guy using factoring. Let's put an x here and an x here. And basically you want two integers whose sum is negative 15 and whose product is positive 50. Well, that's going to be negative 10 and negative 5. So negative 10 and negative 5. So let's say x minus 10 equals 0 or x minus 5 equals 0. Let's add 10 to both sides of the equation over here. This will cancel. We get x is equal to 10. Over here, let's add 5 to both sides of the equation. This will cancel. So x could also be 5. Now, again, these are proposed solutions. So coming back up here, we need to check each one. So you have 9 plus the square root of 31 minus, for x, I'm going to plug in a 10. So this would be 3 times 10 or 30. And this equals, you're going to put 10 there. Okay, so 31 minus 30 is going to be 1. The principal square root of 1 is 1. And 9 plus 1 is 10. So this would give you basically that 10 equals 10. So that's a true statement. So we know this one works. Now, in terms of 5 working, you have 9 plus the square root of 31 minus 3 times 5 is 15. And this should be equal to 5. Okay, so 31 minus 15, that's going to be 16. And the principal square root of 16 is 4. So basically, you get 9 plus 4, which is 13, is equal to 5. So that is a false statement, right? So we can write over here that this is false. And so I'm going to reject this guy. And so basically, the only valid solution here is that x is going to be 10. Okay, let's take a look at question 3 now. So again, we want to solve each equation. So we have negative 2 is equal to the square root of negative 6 minus x, and then minus, we're going to have the square root of negative 2 minus x. Okay, so at this point, we need to move one of these guys to the other side so that we can isolate one of the radicals. I'm just going to add the square root of negative 2 minus x to both sides. That's a little sloppy, so let me slide that over just a little bit more. So basically, I'm going to say this is the square root of negative 2 minus x, then minus 2, and this equals, this cancels, so the square root of negative 6 minus x. So at this point, I can square both sides and get rid of this square root here. Now, unfortunately, I'm going to have to do this again because you're going to have a square root over here on the left, so there's just more work involved. So just use your formula here. Squaring the first guy is negative 2 minus x. Then basically minus 2 times this guy times this guy. So 4 times the square root of negative 2 minus x. Then plus this 2 being squared, which is 4. And this equals, square this guy, you get negative 6 minus x. Okay, so at this point, our goal is to isolate this guy right here, so we can square both sides again. And so let's see what we can do here. Looks like I can add x to both sides of the equation, get rid of this and this. Looks like I can add 2 to both sides of the equation, get rid of that from here. And then I can subtract 4 away from each side of the equation, get rid of that. So you'll have negative 4 times the square root of negative 2 minus x. This equals negative 6 plus 2 is going to be negative 4. And then negative 4 minus 4 is negative 8. Now, what you could do, again, this is optional, but I think you would want to do it here. You could divide both sides by negative 4. Cancel this. You'd have the square root of negative 2 minus x is equal to, here, negative 8 divided by negative 4 is 2. So from here, what I'll do is just square both sides. This will give me negative 2 minus x is equal to, 2 squared would be 4. And then to solve this, what you could do to make it quicker is add x to both sides and subtract 4 away from each side. This would cancel and this would cancel. And you would have x is equal to negative 2 minus 4 is going to be negative 6. And again, you could just flip that around and say x is equal to negative 6. Let's go back up. And again, I want to check this before I select it. Right? I don't want to just say x equals negative 6 because it could be no solution. I just want to check it. So negative 2 is equal to the square root of negative 6 minus your x. Here x is negative 6, so minus the negative 6 is plus 6. So this would end up being 0. So let's put 0 here. And then basically you have minus the square root of negative 2 minus a negative 6. Minus the negative is plus a positive, so this is plus 6. Let me get rid of this 0 here. Now negative 2 plus 6 would be 4. So here we have this negative out in front. So essentially you have the negative square root of 4, which is negative 2. So this is negative 2 equals negative 2. So this is a valid solution. So we would want to select x equals negative 6 as our answer. All right, let's take a look at question number 4 now. So again, we're asked to solve each equation. So we have the square root of negative 3 minus 4x. Then minus, we have our square root of 2x plus 7. And this equals 2. All right, so the first thing we're going to have to do here is pick one of these guys, one of these square root operations to isolate. I think it's easier if I just add the square root of 2x plus 7 to both sides of this equation. And what will happen here is that this guy would cancel. And so you're going to have this guy, this square root of negative 3 minus 4x. That is now isolated. So this is equal to, we can put this one in front, so we'll put the square root of 2x plus 7 and then plus 2. So now when we square both sides, we'll get rid of this guy, but we're still going to have a square root on the right-hand side, so we'll have to isolate and then square again. So what we'll do here is just square both sides. And so this will just give me the radicand, so negative 3 minus 4x. This is equal to, over here I need to use my formula. So the first guy being squared would be 2x plus 7, then plus, I'm going to have 2 times this guy times this guy. Now 2 times 2 is 4, so let's put 4, then times the square root of 2x plus 7, and then lastly you want to square 2, so that's going to give you 4. All right, let me slide this down just a little bit so it all fits on the screen. What I want to do from here is just make things as simple as possible. My goal is to isolate this guy on one side so I can square both sides again. So what I'll do is say that 7 plus 4 would give me 11. So I can actually just erase this from here and just put this as 11 here. And then what I'll do is I'll subtract 11 away from each side of the equation. And I'll also subtract 2x away from each side of the equation. So I'll cancel this away from here. And then basically my right-hand side would be 4 times the square root of 2x plus 7. Now over here, I'm going to write this in a different order. So I'm going to go negative 4x minus 2x. That'll be negative 6x. I'm going to put that out in front. And then negative 3 minus 11, that's going to be negative 14. So just minus 14 here. Now what I want to do here is square both sides. But what I would do first is actually make this a little bit simpler. Now you could divide everything by 4, or you could divide everything by negative 4, depending on what you want to do. But that's going to give you fractions over here. And that's going to make your formula a little bit harder. So what I would do is actually divide everything by negative 2. That's going to make your formula really easy on the left-hand side. So negative 6 divided by negative 2 is 3. So this would be 3x. And then basically negative over negative is positive. And then 14 divided by 2 is 7. This equals 4 divided by negative 2 is negative 2, and then times the square root of 2x plus 7. Now, the right-hand side will be more work, but the left-hand side would be less work. So again, it's all personal preference. All right, so what I'm going to do now is square both sides. And so over here, I'm going to use my formula. So 3 squared is going to be 9, and then you'd have x squared, then plus 2 times 3x times 7. 2 times 3 is 6, 6 times 7 is 42, so this is 42x. Then plus 7 squared is 49. And this equals, over here, when I think about this, I have to be real careful. So negative 2 is being squared. Negative 2 squared is positive 4. And then I'm multiplying this by the result of squaring the square root of 2x plus 7. I have to put this in parentheses. This is just going to be the radicand of 2x plus 7. So to remove the parentheses, 4 times 2x would be 8x. And then plus 4 times 7 would be 28. So let's write that there. Let's erase this and just slide this up. No need to make another line. So basically, let's just put this in standard form. I'm going to subtract 8x away from each side. And I'm going to subtract 28 away from each side. So we'll cancel this away and put 0. We'll have 9x squared. And then plus 42 minus 8 is 34. So this would be 34x. And then plus 49 minus 28. That's going to be 21. And this equals 0. All right, now this one's a little bit challenging to factor, so you can always just use your quadratic formula if you get stuck on that. I'm just going to factor it. It's not that bad, but it does take a little bit of thought. So first and foremost, you can't go with 3x here and 3x here. The reason is, if you think about it, with 21, it's either a 1 and 21. So let's say I put a 21 here and a 1 here. Well, notice you'd have a common factor here of 3, right? So you have a 3 here, and 21 is 3 times 7. There's no common factor here, so that's not possible. So if you flip this around and did 7 and 3, it's the same thing. You'd always have a common factor of 3. So 3x and 3x, that is not possible. So if this guy's factorable, it has to be 9x and it has to be x. When you think about, again, 1 and 21, well, that's just not going to work, right? The 21 would have to go here because it couldn't go here because you'd have a common factor of 3. And 9 times 21, that's 189. That's way too big. So we'd have to turn to 7 and 3 next. And we can't put the 3 here because it'd be a common factor of 3. So the 3 would have to go here and the 7 would have to go here. So that's our last possibility. So does this work? This right here, 9 times 3 is 27. So this would be 27x. Then this right here, 7 times 1 is 7. So this would be 7x. 27x plus 7x is 34x. So we're good to go. Okay, so let's say that 9x plus 7 is equal to 0. Then or x plus 3 is equal to 0. Let's subtract 7 away from each side. Cancel this. We'll have 9x is equal to negative 7. Divide both sides of the equation by 9. We'll cancel this and say x is equal to negative 7/9. The other guy here, we just subtract 3 away from each side. Let me make this a little bit cleaner here and cancel this away. And we'll say that x could also be negative 3. So again, these are proposed solutions. We have to check them. So we're going to have the square root of, we have negative 3 minus 4 times, in this case, it's negative 7/9. Let me make that a little bit better. Then minus, we have the square root of, we have 2 times this negative 7/9, then plus 7, and this equals 2. All right, so does this work itself out? Let's see. So this guy right here, negative 4 times negative 7 is 28. So this would be 28/9. So this right here would be plus 28/9. You need a common denominator, so you would multiply this by 9/9. So this would be negative 27. So negative 27/9. And essentially what you'd have here is 28 minus 27, which is 1, over the common denominator of 9. So this is basically the square root of 1 over the square root of 9. So that's going to give me 1/3. So this guy over here is 1/3. third. Now for this guy, basically 2 times negative 7 is negative 14. So this is negative 14 over 9. And again, I need to get a common denominator. Let me slide this down. So essentially, I would multiply this guy by 9 over 9. So this would be 63. So 63 over 9. And 63 minus 14, that's going to be 49. So this is 49 over 9. So this is the square root of 49 over the square root of 9. So this would be 7 over 3. So this is 7 over 3. Now, what is 1 minus 7? That's going to be negative 6. So this would be negative 6 over 3, which is negative 2. So you get negative 2 is equal to 2, which is obviously a false statement. So we're going to reject this first guy. That does not work. For the second guy, we have the square root of negative 3 minus 4 times negative 3, and then minus the square root of 2 times negative 3, and then plus 7, and this should be equal to 2. So negative 4 times negative 3 is 12, and then 12 minus 3 would be 9. So this would be the square root of 9, which would be 3. So this is 3. Then over here, 2 times negative 3 is going to be negative 6. Negative 6 plus 7 is going to be 1. So this is the square root of 1, which is 1. So essentially, you get 3 minus 1 equals 2. So this is going to be a true statement, right? You're going to end up with 2 is equal to 2. So this one works itself out. So we can say that x equals negative 3 is the solution we want. So this guy right there. Okay, let's look at question 5 now. So we want to solve each equation. So we have the square root of 2x plus 10. Then we're going to have minus our square root of 4 minus 7x. Then we'll say this is equal to negative 3. All right, so I'm going to add the square root of 4 minus 7x to both sides of our equation. Again, that's going to isolate this guy on the left. So we'll say this is the square root of 2x plus 10. This is equal to, you'll have the square root of 4 minus 7x, then minus 3. What I'll do from here is square both sides. So let's do that real quick. So this is going to give me my radicand. So 2x plus 10. This equals, I'm going to square this guy. So this is 4 minus 7x. Then I'm going to say that we have minus 2 times this guy times this guy. So 2 times 3 is 6. So this would be 6, then times the square root of 4 minus 7x. Then plus 3 being squared is 9. Okay, so cleaning up, 4 plus 9 would be 13. So let's just get rid of this and put a 13 here. And then what I would do is actually subtract 13 away from each side of the equation and add 7x to both sides of the equation. Let's get rid of these and see where this gets us. So 2x plus 7x would be 9x. Let me make this x a little bit cleaner here. And then 10 minus 13 would be negative 3, so minus 3. This equals your negative 6 times the square root of 4 minus 7x. All right, now here's where you need to make a decision. Now you could divide everything by 6 or negative 6, again, depending on what you're trying to do, but that's going to give you some fractions over here, and I think most people don't want to deal with that. So I think that it's probably better for this tutorial to just divide everything by positive 3. So divide by 3, divide by 3, and divide by 3. That'll just make things a little bit simpler. So this is going to be 3x, and then minus 1 is equal to negative 6 divided by 3 is negative 2, then times your square root of 4 minus 7x. Okay, what I'm going to do at this point is square both sides. So I'm going to square this side and then square this side. So use my formula. 3x being squared is 9x squared. Then we're going to have minus 2 times this guy times this guy. So 2 times 1 is 2. Then times 3x would be 6x. Then plus 1 being squared, which is 1. This would be equal to, again, you've got a square negative 2, that's 4. And then I'm going to wrap this in parentheses. Squaring this guy gives me the radicand, so this is 4 minus 7x. So this ends up giving me 16 minus 28x. Let me just erase this and drag this up here. And so from here, I'm just going to put this in standard form. Again, we'll try to factor it. In the case that we can't, we'll just use the quadratic formula. So I'm going to subtract 16 away from each side. Cancel this. I'm going to add 28x to both sides. And so let's cancel this, put this as a 0. On my left-hand side, I'll say this is 9x squared. And then 28x minus 6x would be 22x, so plus 22x. And then lastly, you have 1 minus 16. That's going to be negative 15. And this equals 0. Okay, so again, you're dealing with something that's a little bit hard to factor. So if you struggle with factoring, maybe you want to use the quadratic formula. But I think we can probably get it. So if you start with 9x and x, when you think about 15, forget about the fact that it's negative. You've got 1 and 15, or you've got 5 and 3. Now, because this is a minus here, you want to subtract in terms of absolute value and try to get to 22. Okay, again, forget about the signs for right now. So when I think about 1 and 15, you can't put the 15 here because it's going to have a common factor of 3. But you could put the 15 here and the 1 here. Now, 9 times 15 is 135, so that's way too big. So what you want to move to is 5 and 3. Now, you can't put the 3 here, but you could put it here and put the 5 here. Now, 9 times 3 is 27, and then 27 minus 5 is going to give me 22. So this is what I want. So I want a plus here and then a minus here so that this works out. So this right here is going to be 27x. This right here is going to be minus 5x. Again, 27x minus 5x is 22x. So this is what we want. Okay, so let's solve this guy. We have 9x minus 5 is equal to 0, or we have x plus 3 is equal to 0. Let's add 5 to both sides of the equation. Cancel this. We'll get 9x is equal to 5. Divide both sides of the equation by 9. We'll cancel this. We get x is equal to 5/9. Okay, let me erase that and make that better. Over here, let's subtract 3 away from each side. Cancel this. And we'll say that x could also be negative 3. Again, these are proposed solutions, so let's check them. So coming back here, again, you have your square root of 2x. So let's try 5/9 first. So 2 times 5/9, then plus 10, then minus your square root of 4 minus 7 times 5/9. And then basically this equals negative 3. So again, these are quite a lot of work when you get fractions involved. So if I think about this, this would be 10 over 9. So this would be 10 over 9. And if you want a common denominator, you'd multiply this by 9 over 9. So this would be 90. So 90 over 9. So I think we can see this would be 100 over 9. So let me write the square root of 100 over the square root of 9. Let me make the square root symbol a little bit better. And we can see that's going to be 10 over 3. So this is going to be 10/3. So 10/3. Over here, we're going to deal with negative 7 times 5. That's going to be negative 35. And that would be over 9. So let's just write minus 35 over 9. So I'm going to multiply 4 by 9 over 9. So that's going to be 36 over 9. So 36 over 9. And we can see that would be 1 over 9. So this is the square root of 1. So the square root of 1 over the square root of 9, which is basically 1/3. Okay, so this is 1/3. And what do we have here? 10 minus 1 is 9. 9 divided by the common denominator of 3 would be 3. So you're going to end up with 3 equals negative 3. So 3 equals negative 3, which is false. Okay, so that one doesn't work. So coming back up here, we're going to reject that solution. So the other one, we have the square root of 2x. So x is negative 3 in this case. So 2 times negative 3 would be negative 6. And then plus 10 would be 4. So this is the square root of 4. Then minus the square root of, you have 4 minus 7 times negative 3. Let me write that out. So 4 minus 7 times negative 3. So negative 7 times negative 3 is 21. So 4 plus 21 is 25. So basically the square root of 4 is 2. And then if you have minus, or you could say the negative square root of 25, that's negative 5. So you have 2 minus 5 equals negative 3. So yeah, that's true. You get negative 3 equals negative 3. So this is a true statement, so we would check that one off. That is a valid answer. So we want to select that x is equal to negative 3. Let's take a look at our quiz. For the first question, we're asked to solve each equation, and we will see the cube root of 3x plus 7. Let's make this 3 a little bit cleaner here. This is minus the cube root of, we're going to have 4x plus 2. This is set equal to 0. Okay, so what I want to do is isolate each radical on one side. So I'm going to add the cube root of 4x plus 2 to both sides of this equation. And so this is going to cancel over here. What I'm going to have is the cube root. So the cube root of 3x plus 7. Let me slide this down just a little bit. This will be equal to, we'll have the cube root of 4x plus 2. So now that I have each radical isolated on a given side, I'm going to cube both sides, and that's going to get rid of both radicals. So basically, you'd have the radicand in each case. So I'm going to have 3x plus 7 is equal to, over here would just be the 4x plus 2. So to solve this, I'm going to subtract 7 away from each side. We'll cancel that away. We'll subtract 4x away from each side. Let's cancel that away. So 3x minus 4x would be negative x, and this equals 2 minus 7 is negative 5. You can multiply both sides by negative 1. So let's multiply both sides by negative 1, or you could divide both sides by negative 1, whatever you want to do. this would be x is equal to 5. So coming back up here, again, if you cube both sides of an equation and you're confident in your steps, you can just select the answer and say x equals 5. You will not get extraneous solutions from cubing both sides of an equation. But you might want to check it just for completeness. So we would have the cube root of 3 times 5 plus 7. Then minus, you'd have your cube root of 4 times 5 plus 2. This should equal 0. 3 times 5 is 15. 15 plus 7, that's going to be 22. So this is the cube root of 22. And then over here, 4 times 5 is 20. 20 plus 2 is 22. So if you had the cube root of 22 minus the cube root of 22, that would be 0. So x equals 5 is our correct solution. Okay, let's look at problem number 2 now. So we want to solve each equation. So we have 4 times the cube root of, we have x minus 9, and then plus 13, and this equals 5. Okay, so let's isolate this cube root guy here. So I'm going to subtract 13 away from each side. Let's cancel that away. You'll have 4 times the cube root of x minus 9. This would be equal to 5 minus 13. That's going to give me negative 8. Okay, so from here, you could cube both sides now, but I think it would be better to divide both sides of the equation by 4 just to save yourself some work. So this is going to cancel away. And what we're going to have is the cube root of x minus 9. This is equal to negative 8 divided by 4 is negative 2. And now let's cube both sides of this equation so we can get rid of this cube root here. So on the left side, I'm just going to have that radicand. So this is x minus 9 is equal to, on the right side, negative 2 being cubed is negative 8. To solve this equation, let's add 9 to both sides. This would cancel. You're going to get x is equal to 1. So coming back up, you can select x equals 1. Again, if you cube both sides of an equation, you're not going to get extraneous solutions. Now, you might want to check this again just to see if you made a mistake. So 4 times the cube root of, here it's x minus 9. Well, it would be 1 minus 9, which is negative 8. And then plus 13 is equal to 5. Well, the cube root of negative 8 is negative 2. So this would be 4 times negative 2, which is basically negative 8. So negative 8 plus 13 is 5, right? You would get 5 equals 5. So this x equals 1 is a valid solution. Okay, let's take a look at question 3 now. So again, we're asked to solve each equation. And we have the 4th root of 3x squared minus 12, and this is equal to 3. Okay, so with this one, I can immediately just raise both sides to the 4th power. And so this right here on the left, I'm just going to have this radicand. So I'm going to have this 3x squared minus 12. This would be equal to, on the right, 3 to the 4th power is 81. So let's just solve this equation. It's going to be quadratic, but it's going to be a really simple one. So let's add 12 to both sides and see what that gets us. This would cancel. You're going to have 3x squared is equal to 81 plus 12 is 93. So 93 is divisible by 3, right? 93 is 9 plus 3, which is 12. 12 is divisible by 3, so is 93. So what I'm going to do is divide both sides of the equation by 3. And so this would cancel. You get x squared is equal to 31. Now, this is something we can solve really easily using our square root property. So you get x is equal to plus or minus the square root of 31. Now, you really can't do anything with the square root of 31. That's not going to break down. 31 is a prime number. All right, so coming back up, we do need a check because we raised both sides to an even power, right, the 4th power. So we could get extraneous solutions here. So we're going to have the 4th root of, you have 3 times. Now, for x, think about this right here. So you have the principal square root of 31 and the negative square root of 31. Does it matter if I put a plus or a minus in here? No, because I'm going to square it, right? So you can check them both at once. You could put plus or minus in there, but I'm just going to put the square root of 31. And we know that we're just checking both. And this is going to be squared, and then minus 12, and then this should be equal to 3. So if I square the square root of 31, I get 31. And then 3 times 31 would be 93. And then 93 minus 12 would be 81. And the 4th root of 81 is 3, right? So these are both going to work. So basically, you would want to select this guy right here, where we say x is equal to the square root of 31, and then also x could be the negative square root of 31. All right, let's take a look at question number 4 now. So again, we're asked to solve each equation, and we have the square root of 3 times the square root of 2x plus 3. Let's extend that a little bit. This equals, we have the square root of 5x minus 6. So let's go through and square this guy and see what we get. So for this guy, you're going to get this radicand here. So 3 times square root of 2x plus 3. This would be equal to this radicand here, which is 5x minus 6. But then again, you haven't cleared all the radicals, so you have to square both sides again. So we're going to square both sides again. So you have 3 that's going to be squared, so that's 9. And then times this square root of 2x plus 3 is being squared. Now, you have to wrap this in parentheses so you don't make a mistake. So this would be 2x plus 3 here. And this equals, over on this side, let's use our formula. So 5x being squared is 25x squared. Then minus 2 times this guy times this guy. So 2 times 6 is 12 times 5 is 60. So this is minus 60x here. Let's make this 0 a little bit better. Then lastly, plus you have 6 squared, which is 36. Okay, let's distribute this. So this would be 18x and then plus 27. Let's get rid of this and slide this up here. All right, I'm just going to put this in standard form and we'll look at it. I think it's probably a little bit too big to factor, so we'll probably just use the quadratic formula. So let's subtract 27 away from each side of the equation. Let's cancel this. Let's subtract 18x away from each side of the equation. Let's cancel this. So this is 0 over here. And I'm just going to flip the sides. So I'm going to say this is 25x squared. Negative 60 minus 18 is negative 78, so then minus 78x. And then 36 minus 27, that's going to be 9. So let's go plus 9, and this equals 0. All right, so could we factor this? It's quicker to solve things if you can factor it. 25 is 5 times 5, or it's 25 times 1. And then 9 is 9 times 1, or it's 3 times 3. Now this is a minus and this is a plus, so I know it's going to be 2 negatives. Let's just try to factor it. I think we could do this more quickly than the quadratic formula. So let's start with 5x and 5x and see if that works. If I put a 9 here and a 1 here, this is 45 and 5. Again, if this is a plus, you're going to be adding in terms of absolute value, trying to get to 78. You're going to end up with negatives in each case, okay, but we're going to get rid of that for right now. This is not going to work. It's not big enough, right? This is 45 plus 5. That's only 50, so that's not going to work. If you went to 3 and 3, so 3 and 3, then essentially what you're going to have is 15 plus 15, which is 30. So that's not going to work. So this is not the right factorization. All right, so let's go to 25x and x. Now with 9 and 1, 9 is too big to go here because that would be 9 times 25, that's 225. If you put a 9 here and a 1 here, that's too small, right? That's going to be 25 plus 9, that's 34, so that's not going to work. So it would have to be 3 and 3, and that will work, right? So this guy right here, if you put a negative here and a negative here, this would be negative 75x, and this would be negative 3x. And maybe it's the same amount of time as the quadratic formula. I don't know, but I like factoring a little bit better. So let's solve these guys. You have 25x minus 3 is equal to 0. Then or you have x minus 3 is equal to 0. Let's add 3 to both sides of the equation. This cancels. You get x is equal to 3. Over here, let's add 3 to both sides. This cancels. You get 25x is equal to 3. Divide both sides of the equation by 25. So you'd have x is equal to 3 over 25. Or x could be 3. All right, so let's come back up here and check these guys. So the first one, this 3 over 25, I'm going to tell you in advance it's not going to work. So you could plug it in as a fraction, or if you want to save yourself some time, you can convert it to a decimal. It's 0.12. And then you can plug it in and see if they're close. A lot of times you have to do an approximation, but it's a lot faster if you do it that way. But let's just do it the long way in case anybody wants to see it. We'll just say this is the square root of 3 times the square root of 2, and then for x, I'm going to plug in a 3 over a 25. And then basically you would have plus 3 there. Let me extend these two. Let's say this should be equal to, let me slide this down. You've got your square root of 5 times this 3 over 25, and then basically minus 6. Okay, so a lot of work here because we have to get some common denominators. So 2 times 3 would be 6. So this is 6 over 25. Let's start with that. And then 3, I need to multiply this by 25 over 25. So this would be 75 over 25. And then essentially you would have 6 plus 75, which is 81, over the common denominator of 25. So this is 81 over 25. Now, if I take the square root of that, it's the square root of 81, which is 9, over the square root of 25, which is 5. So this is going to be 9/5. Now, before I go any further, you notice that the square root of 9 would be 3. So just pull that out. You would say this is 3, then times the square root of 3 over the square root of 5. Now, of course, if you were reporting this as your answer or showing your work for your teacher, you would want to simplify this guy completely. And so you'd want to rationalize the denominator. Of course, if you're just doing self-study and you're trying to check on your own, that's completely unnecessary. But I'm going to go through and say this is times the square root of 5 over the square root of 5. So this would be 3. Let me make this a little bit cleaner up here. Times the square root of 15. And this would be over 5. So we're trying to get a match over here. So let's see what we would get. Let me drag this over here a little bit. And we'll say that this would cancel and give me a 5. So I have 3/5. And then basically I'm subtracting away 6. So you already know that this is going to not work because the inside of here is going to be negative. So you could stop at this point again if you're doing self-study. But if your teacher requires you to go all the way and show all these steps, well, you would keep going. So let's say this is times 5 over 5. So we can get a common denominator. So this is basically minus 30 over 5. And so 3 minus 30 is negative 27. So this is negative 27 over 5. So negative 27 over 5. Just to complete this, I'm going to pull out the negative and put it as I. And then 27 is 9 times 3. The square root of 9 is 3. So I'm going to put 3i times the square root of 3. And then over the square root of 5. And again, just like we did over there, I'm going to rationalize the denominator. So we'll multiply by the square root of 5 over the square root of 5. So this up here would be the square root of 15, and this down here would be 5. So we end up with this false statement here. These two are not equal, so we can reject this. Okay, for the next one, it's a little bit easier. So we have this square root of 3 times the square root of 2 times 3 is 6. 6 plus 3 is 9. So we know the square root of 9 is 3. And so basically, you would have the square root of 9, and that's 3. So let's put 3 here, and this equals the square root of 5 times 3 is 15. 15 minus 6 is 9. So this is the square root of 9, which is 3. So you get 3 equals 3, which is a true statement. So this works. So we would say x equals 3 is a valid solution. All right, let's take a look at question number 5 now. So we want to solve each equation. So what we have is the square root of 1 plus the square root of 24 minus 10x. Let me extend those a little bit. This equals the square root of 3x plus 5. Now, in a lot of the problems we look at, you have multiplication here, but in this particular case, you have addition here. So if you had multiplication there, you could, again, convert this to exponential form. You could raise both sides to the 4th power and basically knock it out in one go. But in this particular case, you can't do that, so you could still use exponential form, but I think I'm not going to do that here because it might lose a lot of people. So I'm just going to square both sides just to get things started. And so essentially, you're going to have this radicand here, right, when I do that. So you have 1 plus the square root of 24 minus 10x. And this equals, over here, you're going to have this radicand, which is 3x plus 5. So looking at this now, what I want to do is isolate this radical. So I would subtract 1 away from each side. I would cancel this away. I would have the square root of 24 minus 10x. This is equal to, you're going to have 3x. 5 minus 1 is 4, so plus 4. So now I would square both sides. So I would square this side, and then I would square this side. So this over here is going to give me 24 minus 10x. And this equals, over here, 3x being squared is 9x squared. Then plus 2 times 3x times 4. 2 times 3 is 6. 6 times 4 is 24, so this is 24x. Then plus 4 squared is 16. Okay, let's add 10x to both sides of this equation and see where that gets us. We'll get rid of that. Let's subtract 24 away from each side of the equation. Let's get rid of that. Let's make this 0. Okay, so I'm going to have 9x squared. Then 24x plus 10x would be 34x, so plus 34x. And then basically 16 minus 24 is negative 8, so minus 8. And this equals 0. Now again, these numbers are a little bit large, so you could factor this if you wanted to. Again, you can also use the quadratic formula if you don't like this. I prefer to factor. I think it's always faster, but again, it's really up to you. So if you think about 8, forget about the fact that's negative. It's either 1 times 8 or 2 times 4. So that's not that many possibilities. And 9 is 1 times 9 or 3 times 3. Let me just start off with 9 and 1. So let's go 9x and x. And if I put an 8 here, that's too big. And if I put the 8 here and I put the 1 here, that's going to be 9 minus 8. That's 1. That's too small. I'm trying to subtract because this is a minus here. And I'm trying to get to 34 in terms of absolute value. Okay, so let's move on now and go to 2 and 4. So if I put a 4 here, that's 36. And if I put a 2 here, that's 2. So 36 minus 2, that can get me to 34. I need to put a plus here and a minus here, and I'll be good to go, right? This is 36x. This is negative 2x. So 36x minus 2x is 34x. So this is what I want. Okay, so 9x minus 2 is equal to 0, or x plus 4 is equal to 0. So let's add 2 to both sides of the equation. We'll cancel this. We have 9x is equal to 2. Divide both sides of the equation by 9. Cancel this. And so you get x is equal to 2/9. Over here, we'll subtract 4 away from each side. Cancel this. So we also have x equaling negative 4. All right, let's come back up here and check these two. So let's start with this 2/9. So I'm going to go the square root of 1 plus, then you have this square root of 24 minus 10 times this 2/9. Let me extend this and extend this. This should be equal to the square root of 3 times this 2/9, and then plus 5. Okay, so obviously a lot of work if you have fractions, but over here, I would start on the inside. So let's say this is negative 10 times 2. That's going to be negative 20. So we'll say this is negative 20 over 9. Now I need a common denominator, so I'm going to multiply 24 by 9 over 9, and that will give me 216 over 9. So now what I would do is say 216 minus 20. That would give me 196. So this would be 196 over 9. Now if I take the square root of this, remember you can split that up and say it's the square root of 196, which is 14, over the square root of 9, which is 3. So this is basically going to be 14 over 3. Now I got to get another common denominator here. I'm just going to write 1 as 3 over 3. And so what we would have is basically 3 plus 14, which is 17, over the common denominator of 3. So let me write this as the square root of 17 over the square root of 3. Again, if you're required to show all these steps, you want to make sure you rationalize the denominator here, just so that everything is simplified. So this would be the square root of 51 over 3. So let me get rid of this, put this over 3. Okay, let's slide this down. This side should be easier. So here we can see immediately that this is going to cancel with this and give me a 3. So you've got 2/3 plus 5. So 2/3, let me get rid of this multiplication symbol, plus 5. I'll multiply this by 3 over 3. So this would be 15 over 3. And essentially this is 17 over 3. And we saw that we just had that. If I rationalize the denominator again, I'm going to get the square root of 51 over 3. So this one does work out. So x equals 2/9. That's a valid solution. Now the other one is actually easier to check because you don't have a fraction involved. So you have the square root of 1 plus the square root of 24 minus. You have 10 times this negative 4. Let me make this negative 4 better. Close that down. Let me extend that and extend that. This should be equal to the square root of 3 times negative 4, then plus 5. So just eyeballing this, I think you can see it's not going to work. So here, if you do negative 10 times negative 4, that's 40. So let's put plus 40. 24 plus 40 is 64. And if you take the principal square root of 64, you get 8. And then 1 plus 8 is 9. And the principal square root of 9 is 3. Now, over here, you're not going to get 3. I think you can all see that. But essentially, you have 3 times negative 4, that's negative 12. And then if you did negative 12 plus 5, that's going to be negative 7. So this you could really write as I times the square root of 7. So these are not equal, right? You could say this is a false statement. So you would reject that guy right there. And essentially, you come through here and just say, well, I want x equals 2/9. That's my valid solution. All right, let's take a look at our quiz. For the first question, we're asked to solve each inequality. We have 2 times our square root of 4 minus 7x, then plus 14, and this is greater than 24. All right, now before I do anything, you would notice that you could actually divide each part of this inequality by 2 and just get a simpler form. And that's something I suggest you do just so that you're working with smaller numbers. It's not necessary, but it just makes the problem easier. So here, this would cancel. So you have the square root of 4 minus 7x, then plus 14 divided by 2 is 7, and this is greater than 24 divided by 2 is 12. So this will have the same solution set. So you could just work with this now, and it'll be a little bit easier in terms of the numbers. So the first thing we do for this type of problem is we figure out the domain. So the set of allowable x values. In the real number system, we can't have the square root of a negative value. So what I would want to do is take my radicand, which is 4 minus 7x, and say that has to be greater than or equal to 0. So I would just solve this, subtract 4 away from each side of the inequality, and then this would cancel. You'd have negative 7x is greater than or equal to negative 4. Then from here, let's divide both sides of the inequality by negative 7. We'll flip this because we divided by a negative. this would cancel. You'd have x is less than or equal to basically 4 over 7, right? Negative over negative is positive, and you just have 4 over 7. No common factor there other than 1. Okay, so let's write our domain. And what we'll say, let me just slide this down, is that for the domain, it's going to be the set of all x such that we have x needs to be less than or equal to 4/7. Let's close this down here. And now what we want to do is solve the resulting equation. And remember, I'm not working directly with the inequality because weird things can happen when you square both sides of an inequality. And I feel like although this method takes a little bit longer, it's always going to get you the right answer, so it's better to show you that method. And we'll say this is the square root of 4 minus 7x then plus 7 is equal to 12. And then basically from here, you would want to isolate this radical. So let's subtract 7 away from each side. This will cancel. You'll have the square root of 4 minus 7x is equal to 5. You would square both sides of the equation. So that would give you the radicand here. So 4 minus 7x, and that equals 5 squared is 25. So then I'll subtract 4 away from each side and cancel this. You'll have negative 7x is equal to 25 minus 4 is 21. Then I'll divide both sides of the equation by negative 7. We'll cancel this away and say x is equal to 21 divided by negative 7 is negative 3. So we do need to check this. Let me make this negative 3 a little bit more legible. So coming back to the original equation we set up, you're going to plug in a negative 3 for x and see if it makes sense. So we have the square root of 4, basically minus 7, and then times this negative 3. Or you could really say that this is negative 7 times negative 3, which is positive 21. And so we'll say 4 plus 21, well, that would be 25. And if you take the principal square root of 25, you get 5. So this would be 5 plus 7, which is 12. So you get 12 equals 12. So this is a valid solution. Okay, so now that we know what we have here for the solution for the related equation, and we also have our domain, we're ready to go to the number line and test on each side. So let's write this as a greater than. And what I'm going to do is subtract 12 away from each side. So 7 minus 12 would be negative 5. So I'm going to put minus 5 here. And I'm going to put this as 0 here. And I'm just doing this because it's a little bit easier to check things. It's not necessary, but again, it's just personal preference. Okay, so coming down here, you think about your critical values. So the first one would be negative 3. So that, again, solves the related equation. So let's go ahead and put a vertical bar there. And then also you want to think about 4/7. So that is involved with your domain restriction. So anything that's 4/7 or less than 4/7, you're okay. But if it's greater than 4/7, it violates the domain. So 4/7 is a little bit more than a half. If you punch that into your calculator, you get about 0.57. So let's just say it's about right here. And I know that's not exact, but it's close enough for what we're doing. So let's just say this is 4/7. And so we're going to split this up into 3 intervals. So interval A, that's anything that's less than negative 3. And then you're going to have interval B, that's going to be between negative 3 and 4/7. And then interval C, that's greater than 4/7. So we know that for us to be in the domain, that x has to be less than or equal to 4/7. So anything in interval C will not work. Okay, so that violates the domain. So if you set up your A, your B, and your C, you can immediately say that C, that's just going to be false. We know nothing in C is going to work. So for A and B, we just need a test, right? So for A, you could pick something like maybe, let's say negative 4. So we would have the square root of 4, and then you'd have minus 7 times negative 4, and then minus 5 is this greater than 0. So you'd basically have negative 7 times negative 4, that's 28, and basically you'd have 4 plus 28, which is 32. Now 32 is not a perfect square, but it is 16 times 2, right? So the square root of 16 is 4, so you could say that this is 4 times the square root of 2. Now, this is probably something you need to punch into your calculator. Is 4 times the square root of 2 larger than 5? Well, yeah, it's going to be about 5.66 if you round that guy. So this would be larger than 5. So if I'm subtracting away 5, it will be greater than 0. So let's just say in interval A, things are going to work. So this is true. All right, for interval B, let's see what's going to happen there. Obviously, it's going to be false, but let's just prove that. Let's just pick something like 0. That's easy to work with. So if you plugged in a 0 for x, that negative 7 is going to go away, right? Negative 7 times 0 will be 0. So you'd have the square root of 4, which is 2. So then you'd have 2 minus 5 is greater than 0, and that is a false statement, right? This would be negative 3 is greater than 0. So this is false. So we know at this point that things in region A work. So if I'm writing out my solution, let's go ahead and say that x is less than negative 3. Now, would negative 3 be included? Well, remember, negative 3 solves the related equation. So if I think about this, this is a strict inequality, right? It's strictly greater than here. So if I plugged in a -3, you'd have 0 over here, and then it's greater than 0. That's a false statement. So -3 itself will not be included. So our solution is just x is less than -3. So coming back up here, I want this one. So x is less than -3. All right, let's take a look at question number 2 now. So again, we want to solve each inequality. So we have 2 plus the square root of 4x minus 4. This is less than or equal to 6. All right, so one thing I can do before I start is simplify a little bit. So let's say 2 plus, we have the square root of, so I can actually factor out a 4 here. So let's say this is 4 times the quantity x minus 1, and this is less than or equal to 6. Now, I can legally break this up and say this is 2 plus the square root of 4 times the square root of this quantity x minus 1. Remember, this is legal because of our product rule for radicals. Then this would be less than or equal to 6. Now, the square root of 4 is going to be 2. So I can replace this with a 2 here. And let me put my square root back in there. And the reason I'm doing this is because you'll notice that I can just divide everything by 2 now and just get a simpler form. Right? I'm always trying to work with smaller numbers if I can. It's not necessary, but it just makes your life a lot easier. So 2 over 2 is 1. Then plus 2 over 2 is 1. So this is just the square root of x minus 1. You can wrap it in parentheses or not. It's not going to make a difference. Then this is less than or equal to 6 over 2 would be 3. So again, this is a much simpler form and it has the same solution set. Now, another thing you could do to make this even easier, you could immediately subtract 1 away from each side of the inequality and just say this is the square root of x minus 1 is less than or equal to 2. Now from here, let's think about our domain. And so for the domain, let me set that up. So the set of all x such that, in this case, again, we're in the real number system, so this can't be negative. So we would say that x minus 1 needs to be greater than or equal to 0. We add 1 to both sides of the inequality. This cancels. You get x is greater than or equal to 1. Okay, so let me erase this. So that's our domain. And then solving the related equation is pretty easy. We would say the square root of x minus 1 is equal to 2. Let's go ahead and square both sides. And we'll see that we have x minus 1 is equal to 4. If you add 1 to both sides, you're going to get x is equal to 5. So let's check x equals 5 in this original equation. I'm just going to get rid of that. So basically, you'd plug in a 5 there. 5 minus 1 is 4. The square root of 4 is 2. So you get 2 equals 2. So this is a valid solution. So the last thing I'm going to do here is just subtract 2 away from each side of this inequality. So we have the square root of x minus 1, then minus 2. That's less than or equal to 0. Again, this is personal preference. It's something that you can do just to make it a little bit easier to check. So I'm just going to grab this. Let's come to the number line. So we really only need to look for 1, which is going to be right here. And then we need to look for 5, which is going to be right here. Okay, so let's set up the intervals. So this is A. That's going to be anything less than 1. This is B. That's going to be between 1 and 5. And then this is C. That's going to be greater than 5. So let's set this up as A, B, and C. Now, we know for the domain, x needs to be greater than or equal to 1. So anything in A is not going to work. So we're automatically going to reject those. So I'm going to say this is false. Now we need to test in B and we need to test in C. So for B, let me actually move this up here out of the way. For B, let me pick something like 2. So 2 minus 1 would be 1. You'd have the square root of 1, which is 1. So 1 minus 2 would be negative 1. Is that less than or equal to 0? Yes, that is a true statement. So this is true. So in C, we know this is going to be false. Let me actually erase this A and put that there. Get rid of this. And let's test something in C just to prove that. So you could pick something like 6. So 6 minus 1 is 5. So this is the square root of 5 minus 2 is less than or equal to 0. Now you know that the square root of 4 would be 2, right? So the square root of 5 is larger than that. And so basically you have a value here that is larger than 2, and 2 is being subtracted away. So you know this is positive, and a positive is never going to be less than 0, and it's not going to be equal to 0. So this is obviously going to be a false statement. But just in case you were a little bit lost by what I just said, you can punch up square root of 5 into your calculator, and you're going to get about 2.24. And clearly that's larger than 2, right? So you get a positive result there. Okay, so now what we would do is think about our solution. So things in region B will work. So that's between 1 and 5. So we could say x is greater than 1 and less than 5. But what about 1 and what about 5? Well, remember, 5 solves the associated equation. And we see that on the left side of 5, so in other words, values that are less than 5, those are going to work in our inequality. So that's going down to and now including this 1, right? 1 is included in the domain. We just can't have anything less. So we would put a less than or equal to there because 1 is included. And then in terms of 5, because this is a non-strict inequality here, this is going to be included as well because, again, it solves a related equation, right? This side would be 0 and this side would be 0. So we want a less than or equal to over here as well. So our solution is that x is greater than or equal to 1 and less than or equal to 5. So we would want this guy right here. Again, x is greater than or equal to 1 and less than or equal to 5. All right, let's look at question 3 now. So we want to solve each inequality. We have the square root of x plus 9 minus the square root of x. This is greater than the square root of 3. So for the previous 2 problems, we were able to make our inequality simpler. In this case, we really can't do anything. So I would immediately move in to figure out what is the domain. So you would take each radicand with a variable and set it as greater than or equal to 0. So this one and this one. Don't worry about this because 3 is greater than or equal to 0. It's good to go. You would say x plus 9 is greater than or equal to 0. And then you're going to say and. We're going to say x is greater than or equal to 0. Well, this one, if I subtract 9 away from each side, we're going to get x is greater than or equal to negative 9. And then I'll say and x is greater than or equal to 0. So with and, it has to work in both. This guy is more restrictive, right? So in other words, when you think about this, if you're lost, you can always draw a number line. And you can say, let's just put negative 9 here. And let's say 0 is here. So let's say the solution for this, x is greater than or equal to negative 9, looks like this. And let's say the solution for x is greater than or equal to 0 looks like this, where you can clearly see which guy includes more numbers, right? X is greater than or equal to negative 9. You have all these numbers from here going all the way to about right there where you're less than 0. Those numbers work in this guy, but don't work in this guy. But anything starting with 0 and going on will work in both. Okay, so we want x is greater than or equal to 0 as our domain, right? So anything less than 0 won't work. Okay, so let's just write this out formally so nobody is lost. So we'll say that the set of all x such that x is greater than or equal to 0. So now what I'm going to do is solve the related equation. So the square root of x plus 9, then minus the square root of x is equal to the square root of 3. So what you'd want to do here is isolate one of these, and I'm just going to isolate the more complicated one first. I think that's a better strategy. So we'll have the square root of x plus 9 is equal to, let's go the square root of x plus the square root of 3. And from here, I can square both sides. Unfortunately, I will still have a radical on the right. So this would give me the radicand here, so x plus 9, and this equals. Over here, you have to use your formula. So this first guy squared is x, then plus 2 times this guy times this guy. So that's 2 times the square root of x times the square root of 3. Now, the square root of x times the square root of 3 is the square root of 3x. Then plus, let me make this x a little bit cleaner here. We have the square root of 3 being squared, which is 3. Okay. We see that we have x over here and we have x over here. So you can legally get rid of that because I could subtract x away from each side. We can also subtract 3 away from each side. So this would cancel. So you have 6 is equal to 2 times the square root of 3x. From here, we can divide both sides of the equation by 2. And essentially we would have 6 over 2, which is 3, is equal to 2 over 2 is 1. So this is the square root of 3x. So now we would just square both sides again. And so that's going to give me, and I'm just going to flip the side because I like my variable on the left, but you can keep yours on the right. It's whatever you want to do. This would be 3x is equal to 9. We would divide both sides of the equation by 3. Let's cancel this and say that x is equal to 9 divided by 3 is 3. Okay, let's make sure that x is equal to 3 is going to work. So you'd plug in a 3 there and a 3 there. Let me slide this down here. So 3 plus 9 is 12. So you'd have the square root of 12. And 12 is 4 times 3. So this is the square root of 4 times 3. Well, the square root of 4 is 2, so this is 2 times the square root of 3. So 2 times square root of 3. And then basically you have minus the square root of 3. And of course, you have the same radicand here and the same index. So these are like radicals. So 2 times square root of 3 minus the square root of 3 is just the square root of 3. Does that equal the square root of 3? Yes, it does. So x equals 3 is valid. Okay, let me erase this. And let me just rewrite this in a more neat fashion. So the square root of x plus 9 minus the square root of x is greater than the square root of 3. If you want to move this over, you can. I don't think it would actually help you in this case, but it's all personal preference anyway. So let's grab this and let's think about 0. So that's going to be right here. And let's think about 3. So that's going to be right here. So you have interval A, or you could say region A, you have B, and then you have C. So you have your A, your B, and your C. So anything that is less than 0, where we're in region A, that's going to be rejected because it's a domain violation. So this is automatically false. For B, you could pick something like, let's say 1 and test it. So you'd have the square root of 1 plus 9, that's the square root of 10, and then minus the square root of 1, which is 1. And we're saying, is this greater than the square root of 3? Well, this is something I'd probably use a calculator for. The square root of 10 minus 1, if you punch that into your calculator, is about 2.16. Let's just cut it off there. So let's say this is about 2.16. Is this greater than, for the square root of 3, I think a lot of people know that approximation, it's about 1.73. So this is clearly going to be a true statement. So we'll say this is true. And we'll also just say this is false, and then I'll prove that to you. Let me make this a little bit cleaner here. So true. And then let's plug something in region C. Let's just pick 4. So 4 plus 9 is 13. So the square root of 13 minus the square root of 4, is that greater than the square root of 3? Well, the square root of 13 minus the square root of 4, and I can actually replace this with 2 just to make that cleaner. If you punch this into your calculator, you're going to get about 1 point, let's just say 61. Is this greater than, we know the square root of 3, that's about 1.73. So this is a false statement, right? We already said that, but we're proving it here. So thinking about my solution, I'm going to think about region B. So we basically have between 0 and 3. So x is greater than 0 and less than 3. Now, 3 itself is going to be excluded. This is a strict inequality. But on the left side of 3, meaning less than 3, things are going to work, right? So that's going down to and including this 0 because 0 is in the domain. So you can include that here with a less than or equal to. But anything to the left of 0 is not going to work because it violates the domain. So x is greater than or equal to 0 and strictly less than 3. So come back up and we want this one where x is greater than or equal to 0 and less than 3. All right, let's take a look at question 4. So we want to solve each inequality. So we're going to have the square root of x minus 2 is greater than the square root of 2x minus 1. Okay, for this one, basically you would think about your domain right away. So we would say x minus 2 is greater than or equal to 0. And then we're going to say and 2x minus 1 is greater than or equal to 0. So let's add 2 to both sides of the inequality. We'll cancel that away. We'll say x is greater than or equal to 2. And then we'll say and. Here we'll add 1 to both sides of the inequality. Cancel that. We'll say 2x is greater than or equal to 1. Divide both sides by 2. And we'll basically say that x is greater than or equal to a half. Now this one right here is more restrictive. I know this confuses a lot of people. So let me draw this out on a number line. Let's just say this is 0, this is 1, and this is 2. So 1/2 would maybe be right here. And so if I'm thinking about this guy right here, if x is greater than or equal to a half, that looks something like this. Now, if I'm thinking about x is greater than or equal to 2, that would look something like this. So again, which one includes fewer numbers or is more restrictive? Well, x is greater than or equal to 2. You've got all these numbers over here that work in this one that will not work in this one, and they have to work in both, okay? So we're going to go with x is greater than or equal to 2. So let's write out that the domain is the set of all x such that x is greater than or equal to 2. Now, let's solve the resulting equation. You're going to see that there's a problem. So we'll say that there's the square root of x minus 2 is equal to the square root of 2x minus 1. For this one, I could square both sides immediately. And so essentially you would have x minus 2 is equal to 2x minus 1. Let's add 2 to both sides of the equation, cancel this, and then we'll subtract 2x away from each side of the equation. Let's cancel this. X minus 2x is negative x, and this equals negative 1 plus 2 is going to be 1. You could multiply both sides by negative 1 if you want to, and so this would cancel with this and give me x is equal to negative 1. Now, the problem with this x equals negative 1 is that it violates the domain. Let me actually erase all this. And I know that some people are going to be confused here, so let me try to explain this the best way that I can. So we obtained a solution where x is equal to negative 1. Now, we can see in the domain that x needs to be greater than or equal to 2. Again, we're working with real numbers. So if I plug in a negative 1, well, basically right here, I'm going to have the square root of negative 1 minus 2, which is negative 3. Now, you could write that as basically I times square root of 3 if you wanted to. So you could say this is I times square root of 3. but we are no longer working with real numbers. And again, when you solve these type of problems, if somebody doesn't tell you anything, then you would assume that your domain is a set of real numbers. So this solution here is not going to be valid, okay? Now you can see that if you plug this in, it's going to give you the same value over here. 2 times -1 is -2. -2 minus 1 is -3. So this is I times square root of 3 as well. So this would be a solution if you were working with complex numbers. But again, because we're in the real number system, we have to reject this solution and say it's not valid. So how can we solve this type of problem? Well, essentially what you would do is test something in the domain, and it's either going to be true or it's going to be false. So if it's true, then it's going to be true anywhere in that domain, right? So where x is greater than or equal to 2, it'll be true everywhere. If it's going to be false, then there's basically no solution, okay? So we would say that the square root of x minus 2 is greater than the square root of 2x minus 1. Let's maybe pick 6. So we would say 6 minus 2 is 4. So this is the square root of 4, which is 2. Is that greater than? Again, we pick 6. So 2 times 6 is 12. And then you would have 12 minus 1, which is 11. And so this is the square root of 11. Now, is 2 greater than the square root of 11? You could punch this into your calculator. You get about 3.32. But the way I would think about this is the square root of 11 is bigger than the square root of 9. And the square root of 9 is 3. And 3 is obviously bigger than 2. So this is a false statement, right? 2 is not greater than the square root of 11. So because this is false, that means it's never going to be true, right? So there's no solution. So we can come through here and say that there's no solution for this problem. And if you had actually flipped this and said this was a less than, then basically your solution would be x is greater than or equal to 2, right? Because it would be true anywhere in the domain of this guy, okay? But in this case, we don't have that symbol, so we say no solution. All right, so coming to an online calculator like Desmos or another one is a good option if you're lost about this. You can see that I've already plotted this square root of x minus 2. So that's this guy in red. Again, that is going to be defined from 2 and on. So any x value that is 2 or larger. And then for the other guy, we plotted this in blue. So this is the square root of 2x minus 1. That is going to be defined where x is 1/2 or anything larger. Now let's look at where they're both defined. So that's going to be starting at 2. And you can see that this guy in red, which is the square root of x minus 2, is always going to be less than this guy in blue, which is the square root of 2x minus 1, right? It's always going to be less than for any value of x that they're both defined. So for this one, when x is 2, y is 0. For this one, when x is 2, y is going to be square root of 3, or you could say 1.73, and that continues forever and ever and ever. So this is a good option if you're trying to figure out why there's no solution. It's basically the fact that this square root of x minus 2 is never going to be larger than this square root of 2x minus 1. Again, if you flip that around, then it would be true anywhere where they're both defined, so basically from 2 on. We would want to select no solution because, again, the square root of x minus 2 is never going to be greater than the square root of 2x minus 1. Let's take a look at question 5. So we want to solve each inequality. And we're going to have the cube root of x minus 1, and this is less than -2. So for this one, when you think about the domain, it's the set of real numbers. This is an odd index, and we can take something like the cube root of a negative number, or you can take the fifth root of a negative number. Again, if you have an odd index, you don't have that same problem like we had with square roots. So for this guy, I don't have to consider my domain. Now, you could go through and solve the related equation. We did that in the lesson, and then you could test on each side. That's up to you. But if you cube both sides of an inequality, something like this, you're not going to run into any issues like you would with squaring both sides. So for this one, I think it's a lot quicker just to do it this way, but you're welcome to do it the other way. Both methods would work here. So I would say that this is x minus 1 is less than -8. I would just add 1 to both sides of the inequality and cancel that, and just say that x is less than -7. So that's a lot quicker. Let's just grab that one. Although doing it the other way in this case would also be pretty quick. So it's really up to you. Here, x would just be less than -7. All right, let's take a look at our quiz. For the first question, we're asked to solve each inequality. And we're going to have x minus 4 is greater than the square root of 8 minus 2x. All right, the first thing we do with this type of problem, because it's a square root and we are working with the real number system, we want to figure out what is the domain. And so to do that, we're going to first set this 8 minus 2x, or the radicand, as greater than or equal to 0. And we're just going to solve this. I think the quickest way to do this is just to add 2x to both sides. So let me actually erase this and just put a 2x over here. And then I would just divide both sides by 2 like this. And basically you would have 4 is greater than or equal to x. Let me cancel this visibly so nobody's lost. And of course you could just flip this around and say x is less than or equal to 4. So let's grab this and just bring it up here. You could just leave it like this, or you can just say officially that your domain is going to be the set of all x such that this condition, so x is less than or equal to 4. Okay, so now that we have the domain, you basically want to solve the related equation. And so we would say that we have x minus 4 is equal to the square root of 8 minus 2x. Let's make this 8 a little bit better there. And then I would just immediately square both sides because this square root here is isolated on the right. And so to use my formula here on the left, remember you square the first guy, so x squared. You have the minus, and then 2 times this guy times this guy, so 2 times 4 is 8. So then times x, and then plus this last guy 4 being squared, so that's 16. This equals, in this case, you just get your radicand, so 8 minus 2x. Now what I'll do from here, because this is a quadratic, I'm just going to put it in standard form. And then in most of these problems, I think in this problem, we can factor it to solve. But in some cases, you'll need to use the quadratic formula, just depending on the situation. So I'm going to subtract 8 away from each side and add 2x to both sides. And so this over here is 0. So you'll have x squared, and then basically negative 8 plus 2 is negative 6, so minus 6x. And then 16 minus 8 is going to be 8, so plus 8, and this equals 0. So again, you can solve this one using factoring. So let's put an x here and an x here. So it looks like we need two integers that sum to negative 6 and have a product of positive 8. So that's going to be negative 4 and then negative 2, right? Negative 4 plus negative 2 is negative 6. Negative 4 times negative 2 is positive 8. We know that we would say x minus 4 is equal to 0, or x minus 2 is equal to 0. I think most of us know that the solutions here would be x equals 4 by adding 4 to both sides here. Then or you have x equals 2 from adding 2 to both sides here. Now we have to check these solutions in the original equation because, again, if we square both sides, we can get extraneous solutions. So coming back up here, if I plug in a 4 for x, you'd have 4 minus 4, which is 0. Is that equal to? You would have basically 2 times 4 here, which is 8. 8 minus 8 is 0. Square root of 0 is 0. This one works. What about 2? I think you can eyeball and see that's not going to work. 2 minus 4 is negative 2. Does this equal? 2 times 2 is 4. Well, 8 minus 4 is 4. Square root of 4 is 2. So this one's going to be rejected, right? That's extraneous. So thinking about this now, I'm just going to keep that one solution of x equals 4. Let me drag that up here. And basically, I'm just going to go to the number line. And I'm just going to look for this one critical value that we have. We basically have only 4, right? That's all we have to think about because that's involved in the domain here, and then that's the solution for the related equation. So basically, you just have interval A, which is anything less than 4, and then interval B, which is anything greater than 4. And essentially, let's just write out that we have A, and then we have B. Now, from the domain, we know that x needs to be less than or equal to 4. So that means anything in B where we're greater than 4 is an automatic reject. So I'm just going to write that this is false. And so we really just need to test, do things work in A? So for this one, let's just pick 0, and we would have 0 minus 4, which is negative 4. Is that greater than the square root of, you have 8 minus, basically 2 times 0, which would be 0. So this is the square root of 8, or you could say, since 8 is 4 times 2, that it's 2 times square root of 2. So 2 times square root of 2. Really, you don't even need to do that because this is positive and this is negative. Is a negative ever going to be greater than a positive? No. So this is false here as well. Now, additionally, you would also want to check 4 itself to see if it works. If this was a greater than or equal to here, it would actually work because it would solve the related equation, so it would satisfy because it's a non-strict inequality. But in this case, because we have a strict inequality, nothing works, right? Nothing in A works, nothing in B works, and this value of 4 here that solves the related equation doesn't work as well. So for this one, you can just go ahead and say that it's no solution, right? So there is no solution for this problem. So coming back up here, you want to circle no solution. Okay, let's look at question 2. So we want to solve each inequality, and here we have the square root of 4x squared, then minus 28x, then plus 49. And then this is greater than or equal to, you're going to have this 1/2 x, then plus 2. When we have a square root involved, again, you have to take your radicand, in this case it's a quadratic, set it as greater than or equal to 0, and solve that resulting inequality. Now, for the quadratics I gave you in this one, basically they're perfect square trinomials, so it's going to make it a little bit easier to work with. I already gave you one in the practice test, which was really difficult and very time consuming. So for this guy, you're going to notice that you can factor it as 2x minus 7 quantity squared, right? If you use your formula, 2x being squared is the 4x squared, then minus this guy times 2, right? So 2 times 2 is 4, 4 times 7 is 28, and then 28 times x is 28x. So that's why you have the minus 28x, and then plus this last guy 7 being squared, so that's where you get your 49. So we would say that this guy right here is greater than or equal to 0. So this is how we get our domain. Now, if this guy right here, again, is squared, then the result is going to be 0 or some positive number. So it doesn't matter what I plug in for x here, because in the end, if it's negative, if it's 0, if it's positive, it's always going to be true, right? Because this is always going to be 0 or some positive value. So we would say for the domain, it's the set of real numbers. So I can plug in anything I want for x. You could write that out officially. You could say the domain is going to be the set of all x such that x, a lot of people will say it's an element of the real numbers. So most books will give you this fancy looking R, which I can never write. It looks something like this, something like that. And I don't think I should probably try to draw that because I'm terrible at it. So let me just put an R. This just means x is an element of the real numbers. So basically that would be our domain. The next thing we would do is solve the related equation. So we would say the square root of 4x squared minus 28x plus 49, this would be equal to 1/2 x plus 2. Now, if you don't want to deal with this fraction over here, before you square both sides, you could multiply everything by 2. It's going to make this side more complex, but this side easier. Again, this is all just personal preference. I'm not going to do it. I don't mind working with fractions, but you may need to. So I'm just going to square this side, and I'm going to square this side. And that's going to give me the radicand here. So we're going to have 4x squared minus 28x plus 49. And this equals. Now this one you have to use your formula. Again, you would square this guy. So 1/2. So 1/2 squared. Let's think about that because it's a fraction. Basically, you'd have 1 squared, which is 1, over 2 squared, which is 4. So this is 1/4. And then don't forget about your x being squared there. Then plus, you're going to have 2 times this guy times this guy. Now, 2 times 1/2 is 1, and then 1 times 2 is 2. So this is 2, and then don't forget about the x. And then plus this 2 being squared is going to be 4. So let's subtract 2x away from each side. And then let's subtract 4 away from each side. So this will cancel. We also have to subtract 1/4 x squared away from each side. So this would cancel. So this is 0 over here. So for 4, let's get a common denominator with this 1/4 here. Forget about the fact that it's negative right now. So basically, I would say that this is 16 over 4. Then basically minus 1/4. Let's wrap this in parentheses and say that's multiplied by x squared. And we know that's going to be 15/4. So let me just write that now. So this is 15/4 times x squared. And then basically negative 28 minus 2 is negative 30. So this is minus 30x. And then 49 minus 4 is going to be 45. So this is plus 45. And then this equals 0. Now, when we look at this equation, everything here, forget about this 4 for a second. Everything here, the 15, the negative 30, the 45, they're all divisible by 15. Okay, so I could divide everything by 15, but I also want to get rid of this 4 here. Okay, so what can I do? I can multiply everything by 4, which is going to clear this denominator, over 15, which is basically going to reduce all of these. Okay, if this is too complicated for you, you could multiply everything by 4 first, and then you could divide everything by 15. I think that's a little bit of overkill, but if you need to do that, that's up to you. So I'll just go ahead and start with 4 over 15 times 15 over 4 times x squared. Then minus, we're going to do this 4 over 15 times 30 times x. Then plus, let me slide this down so it fits. We'll have 45 times 4 over 15, and then basically equals 0 times 4 over 15. Okay, so coming through here, this is going to cancel completely, so you just have x squared. And then basically 30 divided by 15 is 2, so minus 8x. And then 45 divided by 15 is 3, so 3 times 4 would be 12, so plus 12. And this equals 0 times anything is 0. Okay, so the last thing here, I'm just going to solve this using factoring. So I'm going to put an x here and an x here. I need 2 integers that sum to negative 8 and give me a product of positive 12. So that's going to be negative 6 and then negative 2. So I think we know that x minus 6, if we set that equal to 0, we would have x is equal to 6. And then if x minus 2 was set equal to 0, we would get x is equal to 2. So x equals 6 or x equals 2, those are our proposed solutions. So let's check this in this original equation. I think using the factored form is a little bit easier in this case. So let's go ahead and say that this is going to be 2 times your x, whatever that is, and then minus 7, and this quantity is squared. So if I plugged in a 6 here, you'd have 2 times 6, which is 12. 12 minus 7 is 5. So the square root of 5 squared is 5. So this left side would be 5. On the right, you'd have a half times 6, which is 3. 3 plus 2 is 5, so that works out. Then for 2, if I plug in a 2 there and a 2 there, 2 times 2 is 4. 4 minus 7 is negative 3. But the negative 3 is squared first before we take the square root, so it's okay. So negative 3 squared is 9. The square root of 9 is 3. So this would be 3 is equal to. A half times 2 is 1. 1 plus 2 is 3. So this one works as well. So both 6 and 2 are valid solutions here. And so let me just change this to a greater than or equal to now. And we'll copy this. And so coming down here, we're looking for basically just 6 and 2. For the domain, remember, it's the set of real numbers, so we're not going to automatically reject anything. So I'm looking for 6, which is right here, and I'm looking for 2, which is right here. So basically, I'm going to test in region A, which is less than 2, region B, which is between 2 and 6, and region C, which is greater than 6. So let me write over here that we have A, we have B, and then let me put C over here. So for A, you could use 0. And again, you could put this in factored form. So I would say this is 2x minus 7, quantity squared, underneath this square root symbol. So if you test 0, you'd basically have the square root of negative 7 being squared would be 49, so the square root of 49 would be 7. Is that greater than or equal to? If you have a half times 0, that's 0, so basically this is 2. So this is true. 7 is obviously greater than 2, so this is true. Then for B, you could pick something like, let's say, 3. So 2 times 3 is 6. 6 minus 7 is negative 1, and negative 1 squared is 1, right? So the square root of 1 is 1. Is this greater than or equal to? If you had 1 half times 3, that's 3 halves. And then plus 2, I think everyone knows that 1 is not greater than this, so we'll just go ahead and say this is false. For completeness, you could say 3 halves is 1.5, and if you add that to 2, you get 3.5, or you could say 7 halves. So for C, let's test something like 7. So 2 times 7 is going to be 14, and then 14 minus 7 is going to be 7, and 7 squared is 49, the square root of 49 is 7. Is this greater than or equal to? You have a half times 7, which is 7 halves, and then plus 2, let's just write that as 4 over 2. So this would be 11 halves here, which is basically 5.5, and 7 is greater than 5.5, so this is true. Okay, so thinking about our solution here, things in A work and things in C work. This is also non-strict. So remember, your 6 and your 2, that solves the related equation, right? So because this is non-strict, those are going to be included. So we could say here that x is going to be less than or equal to 2, or we would say x is greater than or equal to 6. So that would be our solution. So coming back up, we want this one. So again, x is less than or equal to 2, or x is greater than or equal to 6. All right, let's take a look at question 3 now. So again, we're asked to solve each inequality, and we have x minus 6 is less than the square root of 30 minus 5x. All right, so once again, we have a square root, so I'm going to figure out what is my domain. So we'll say the domain is the set of all x such that, so let's say that 30 minus 5x is greater than or equal to 0. So let's subtract 30 away from each side of our inequality. So let's do it this way. We'll cancel that. We'll have negative 5x is greater than or equal to negative 30. Let's divide both sides of the inequality by negative 5. And let's remember to flip the direction of the inequality symbol. Let's cancel this. We'll say x is less than or equal to negative 30 divided by negative 5 is 6. So here we'll fill this in and say x needs to be less than or equal to 6. We'll basically close that down. So our domain, the set of all x such that x is less than or equal to 6. Okay, let's solve the related equation. So x minus 6 is equal to the square root of 30 minus 5x. Let's make this a little bit better here. So I'm going to square both sides immediately. And so what that's going to give me over here, again, use your formula. So x squared minus 2 times this times this. So 2 times 6 is 12, then times x is just 12x. Then plus your 6 squared is 36. And on the right-hand side, you just get the radicand, so you're 30 minus 5x. All right, so a quadratic has emerged. And again, I want to put this in standard form, so let's subtract 30 away from each side. We'll cancel that. Let's add 5x to both sides. Let's cancel that. So the right-hand side is now 0. And so on my left-hand side, you have x squared, and then negative 12x plus 5x is negative 7x. And then 36 minus 30 is going to be 6, so plus 6, and this equals 0. So give me two integers. whose sum is going to be -7 and whose product is +6. So you can think about -6 and -1, right? So -6 and then -1. So we know at this point that x minus 6 would be set equal to 0. So x would be 6. And then x minus 1 would be set equal to 0. So x would also be 1. Again, these are proposed solutions. So let's start with 6. So 6 minus 6 would be 0 over here. So this would be 0. Over here, basically 5 times 6 is 30. So you'd have 30 minus 30, which is 0. Square root of 0 is 0. So this one works. In terms of 1, you're going to see that it's not going to work. You can reject that. Basically, 1 minus 6 is -5. And then over here, you basically have 5 times 1, which is 5. So 30 minus 5 would be 25. The square root of 25 is 5. So this doesn't work, right? You get -5 equals 5. So let's just get rid of this. We don't need it. Let's get rid of this. And I'm just going to actually take all of these together. So fortunately for us, we only have one critical value, so just 6. So we really only have to think about values that are in, we would say, region A, which is anything that's less than 6. Again, in region B, where things are greater than 6, that violates the domain, so you can automatically reject. So I'm just going to say B. This is going to be false. So if things in A work, then basically your solution would be that x is strictly less than 6. 6 wouldn't be included because this is a non-strict inequality, and 6 solves a related equation. If A doesn't work, then there's no solution, right? Just like we saw in the first example. So let's go ahead and pick 0. So you'd have 0 minus 6, which is -6. Is that less than? Now, if you plug in a 0 for x there, then basically you just have the square root of 30. And the square root of 30, you really can't make that any more simple. 30 is 3 times 5 times 2. So it doesn't really matter here. You don't even need a calculator because you know that a -6 here is going to be less than this positive square root of 30. So this is going to be true. Now, as I mentioned, things in A work, right? So anything where x is strictly less than 6. 6 itself will not work because, again, it solves a related equation, and this is a strict inequality, right? So you would get the left side equaling the right side here. And that's not going to work for a strict inequality. So our answer here would just be x is less than 6. So coming back up here, we want this one. So x is less than 6. Okay, let's look at question 4. Again, we're asked to solve each inequality. We have x minus 4 is greater than or equal to the square root of 4x minus 20. So again, I'm going to start with our domain. So we know that it's the set of all x such that, in this case, you have 4x minus 20 is greater than or equal to 0. Let's add 20 to both sides. You'd have 4x is greater than or equal to 20. And then let me divide both sides by 4. And so basically this would cancel, and you would say that x is greater than or equal to 5, right? 20 over 4 is 5. Okay, let's close this down, and let's solve the related equation. So we say x minus 4 is equal to the square root of 4x minus 20. I'm going to immediately square both sides. So we're going to have our formula over here. So x squared minus 2 times 4 is 8 times x is 8x. Then plus 4 squared is 16. And this equals, over here you just get the radicand, so 4x minus 20. Let me subtract 4x away from each side of the equation. This would cancel. Let me add 20 to both sides of the equation. This would cancel. So this over here is 0. And what we'll have is x squared. And then negative 8x minus 4x would be negative 12x. And then 16 plus 20 is going to be 36. So plus 36, and this equals 0. Now, I think most of you will notice that this is actually a perfect square trinomial. This is x minus 6 quantity squared, right? Because if you do the formula in reverse, this guy squared is x squared, then minus 2 times x times 6 would be minus 12x. And then basically plus 6 being squared is 36. So let's set this equal to 0. Obviously, you're only going to have one solution here. It's going to be where x is 6, right? So you could say x is just equal to 6 here. So let's go back up and let's check this real quick just to make sure it works. 6 minus 4 is going to be 2. And then over here, 4 times 6 is 24. 24 minus 20 is 4. The square root of 4 is 2, so this does work as a solution. Okay, let's grab everything. Let's come back here. And so basically you have a critical value of 5. Let's do that. And then you have a critical value of 6. So we have a tight window here. So let's say this is A. That's where we're less than 5. This is B. So that's between 5 and 6. And this is C. So that's greater than 6. So we know that x has to be greater than or equal to 5. So in A, which is less than 5, that's an automatic reject. So I'm just going to put false there. Then we got to test in B, and we have to test in C. Okay. For B, you'd pick something like 5.5. So 5.5 minus 4 would be 1.5. So let's just put this as decimal form. So 1.5 like that. Is this greater than or equal to? We'll go the square root of 4 times 5.5. That's going to be 22. And then 22 minus 20 is going to be 2. So is 1.5 greater than the square root of 2? Yes. Some of you would know that the square root of 2.25 is 1.5. But if you don't know that, again, it's not that big of a deal. You can basically just use your calculator and say the square root of 2 is approximately 1.41. So obviously that is smaller than this 1.5. So we're going to say that this is going to be a true statement. And then for C, let's pick something, let's say 7, for example. So you'd have 7 minus 4, which is 3. Is that greater than or equal to? 4 times 7 is 28. 28 minus 20 is going to be 8. So this is the square root of 8, which again, 8 is 4 times 2. The square root of 4 is 2. So this is 2 times square root of 2. And if you punch this into your calculator, it's about 2.83. So we can see that this is also true. So basically, when we think about this guy, it's going to be true wherever it's valid in the domain. Okay, so in other words, anywhere where it's going to be 5 or larger. Okay, so we would say that x here is greater than or equal to 5. That's going to be our solution because basically it's always true across this entire domain. That's what you see when you see something like this. If you're a little bit confused by this, you can always pull it up on Desmos and look at the graph. And remember, we're trying to figure out where is x minus 4 greater than or equal to the square root of 4x minus 20. So x minus 4 is in red. Okay, so basically we're graphing y equals x minus 4. And then if you graphed y equals the square root of 4x minus 20, that's this guy in blue. So what you can see is that the guy in blue is always going to be less than or equal to the guy in red. So the only point where they're equal is where x is 6. Remember, that's solve the related equation. So at that point, they're going to be equal. But everywhere else, the square root of 4x minus 20 is going to be less than this x minus 4. Now, this guy is only defined from an x value of 5 going on. So that's why we would say where x is 5, it's okay. And then anything larger is okay because it's always going to be true wherever this square root of 4x minus 20 is defined. So that's why we get this weird answer here. Again, if you're ever confused by something like this, you can always go to Desmos or some online graphing calculator. Just graph each piece and then think about what's going on. So coming back up here, we want this one, which is x is greater than or equal to 5. All right, let's take a look at question 5. So we want to solve each inequality. So we have the square root of 4x squared, then minus 12x, then plus 9. And this is less than x minus 1. So again, we have the square root involved, so we need to figure out our domain. So that radicand has to be non-negative. Now again, I gave you an example with a perfect square trinomial, so this is going to be 2x minus 3 quantity squared. Again, square 2x, you get 4x squared. And then you got minus 2 times this guy times this guy. So 2 times 2 is 4, 4 times 3 is 12, so you have basically minus 12x there. Then essentially you have plus this last guy 3 being squared. Okay, so this is a perfect square trinomial. So we can say that this guy right here has to be greater than or equal to 0. And as we talked about before, this is always going to be true for any x. So your domain is just the set of real numbers. So the domain is going to be the set of all x such that, again, x is an element of the real numbers. I'm just going to put a regular r. I know the books would use the fancy r, but I just simply can't draw it. Okay, so from this point on, we're going to solve the resulting equation. So we would basically say the square root of 4x squared minus 12x plus 9 is equal to x minus 1. And so I would square both sides immediately. And let's say this is 4x squared minus 12x plus 9. Again, this side would just give me the radicand. This equals, over here I have to use my formula. So x squared minus 2 times this guy times this guy. So 2 times 1 is just 2, and then times x, that's just minus 2x. Then plus 1 being squared is 1. Okay, so let's put this in standard form. Let's subtract 1 away from each side. Let's cancel this. Let's add 2x to both sides. And let's cancel this. And then let's subtract x squared away from each side. Let's cancel this. Let's put this as 0. So 4x squared minus x squared is 3x squared. And then negative 12x plus 2x is going to be negative 10x. And then 9 minus 1 is going to be 8. And this equals 0. Okay, so this one is a little bit harder to factor, although I think it's not that bad because 3 is a prime number. So I'm going to use reverse FOIL here if you want to use the AC method, or if you want to do the quadratic formula. Again, you can pause the video and do those. It's really up to you. So 8 is either 1 times 8 or 4 times 2. So if I put an 8 here, that's going to be too big. This is a plus. We have to add things. Okay, we're going to end up with a negative and a negative, but I want to think about in terms of absolute value, how can I get to 10? If I put an 8 here, that's 24, so forget about it. That's too big. If I put the 8 here and the 1 here, that is going to be 3 plus 8, that's 11, so that's out. So it's going to have to be 4 and 2. So basically, if I put the 4 here, it's too big, so I have to put the 4 here and the 2 here. So basically, it's 3 times 2, which is 6, plus 4, which is 10. So I want a minus here and a minus here, so that I get a negative 6x and I get a negative 4x. Negative 6x minus 4x is going to be negative 10x. So this is what we want. Now, let's say that 3x minus 4 is equal to 0, or x minus 2 is equal to 0. So x is equal to, let's add 4 to both sides, cancel this. So basically, you would have that 3x is equal to 4, divide both sides by 3. So x is going to be 4/3 there. That's the first guy. Let me actually get rid of this. And then here we would just add 2 to both sides. I think we can see that. So this is 2. Okay, I think for checking this, it's better to put this in factored form. So let's say that this is the square root of the quantity 2x minus 3 being squared. So let's start with 4/3. So you'd have 2 times 4/3, which is 8/3. And then minus 3, which you could write as 9/3. So this is negative 1/3. So negative 1/3. And then this is squared, but then we're taking the square root of that. So essentially, this is the absolute value of negative 1/3, which is 1/3. Again, the fact that you're squaring this and it's a negative changes it into a positive. And then when you take the principal square root, you get a positive. Okay, that's why you can say that you just want the absolute value of this number. So this would be 1/3 over here. Now, on this side, you would have 4/3 minus 1. So 4/3 minus 3/3, I think you can see that that's 1/3. So the left side does equal the right side. And then for 2, that's a lot quicker. So 2 times 2 is 4. 4 minus 3 is 1. 1 squared is 1. Square root of 1 is 1. So this is 1. Over here, 2 minus 1 is 1. So this works as well. Now, what I'm going to do, I'm going to keep this in factored form. And I'm just going to put this as a less than. And let's grab this. So coming to the number line, again, we don't have to worry about the domain here because it's the set of real numbers. So we need to grab 4/3, which is basically 1 1/3. Let's just say that's about right there. So I'll say that's 4/3. And then you also need to grab 2, so that's a very tight window. So we're going to say this is A, so that's anything less than 4/3. This is B, if I can fit it in there, so that's going to be between 4/3 and 2. And then this is C, that's greater than 2. So we're just going to test. So in A, you can just pick 0, very easy to work with. So 2 times 0 is 0. So basically you have negative 3 being squared, which is 9. Square root of that is 3. So you have 3 is less than. Basically, this would be 0 minus 1, which is negative 1. That is false. So in interval A, we'll say this is false. Let me write out B and C. I forgot to do that. So basically what I would do now for B, this is a very tight window. So you needed something between 4/3, which is 1 1/3, and 2. So I would basically pick 3/2 or 1.5. So if you do this, you'll have 2 times, let's just say 1.5 to keep it simple, then minus 3. And so 2 times 1.5, that's going to be 3. And 3 minus 3 is 0. And 0 squared is 0. And then the square root of 0 is 0. So this would be 0 over here. Then over here, if you do 1.5 minus 1, you're going to get 0.5. And 0 is less than 0.5. So this is true. So this is true. Now for C, you could pick something like, let's say 3. So 2 times 3 is 6. Then 6 minus 3 is 3. Now we have the square root of 3 squared. That's obviously just 3. Or you could say it's 3 squared, which is 9. Take the square root, you're back to 3. Whatever you want to do. Then this is less than. Again, you're picking 3 here. So 3 minus 1 is 2. So is 3 less than 2? No. So this is a false statement. So basically, when we think about this, it's a strict inequality. Okay, so 4/3 and 2, they're not going to be included because those solve the related equation. And so you would have the left and the right sides being equal. And again, this is strictly less than. So we're just going to say that x is greater than 4/3 and less than 2. So this is what we want. So we'll select this answer here, where x is greater than 4/3 and less than 2. All right, so one thing I wanted to do to wrap this video up is just give you another demonstration of using Desmos, or again, you can do this with any online calculator. If you are lost at any point and the step-by-step solutions didn't quite get it for you, then you want to come to one of these calculators and just visualize what's going on. So I have already graphed the square root of 4x squared minus 12x plus 9. You see that's in red here, okay? Now, there are some alternative forms to this. So I could graph it like this. I'm just going to click this button here. And you see that it's in black now because it just did an overlay, okay? So that's another way that you can graph it. All it did was factor this guy right here, the perfect square trinomial, into a binomial squared. Now, we talked about earlier in the course that basically the result of this would be the absolute value of this 2x minus 3. So I could click this here, and basically, let me get rid of this black here real quick and get rid of this red right quick, and now you see that it comes up in purple. Okay, so these are all different ways to basically graph that guy, and a lot of you will remember what the absolute value function looks like when you graph it from something like Algebra 2 or Algebra 1. If you haven't taken that course yet or those courses, then you'll see that later on in the course when we talk about functions. Let me get rid of these. I'm actually just going to X them away, and then I'm going to color this one back in. And then we also have this X minus 1, which is in blue. Okay, so if you're lost, just think about the problem that we had. So the problem was, where is this guy right here, this square root of 4x squared minus 12x plus 9, where is it less than this x minus 1? Well, again, remember the domain for this guy was the set of real numbers, so it's basically defined everywhere in the real number system. So then we just found our critical values. So we found that basically these two guys are equal at 4/3, and here you'll see that they cross at one point in the 3 repeats forever, that's basically 4/3, and then also at 2. Right? So you have those two guys. You see they cross there, so they're equal there, and then they're also equal there. Well, basically, if you look between those two critical values or crossing points or boundaries or whatever you want to say, you'll see that this blue line here is above this red graph here. Okay? So that is the part where we have a solution. That is where this x minus 1 is greater than this square root of 4x squared minus 12x plus 9, or you could flip that around and say the square root of 4x squared minus 12x plus 9 is less than this x minus 1. But everywhere else, excluding these boundaries, it's basically not going to be true, right? So if you think about the boundaries, that's where they're equal. But everywhere outside of that, so basically to the left of 4/3, this x minus 1 is always going to be less than this square root of 4x squared minus 12x plus 9. And then anywhere to the right of 2, this x minus 1 is going to be less than this square root of 4x squared minus 12x plus 9. So again, I highly recommend this calculator if you are struggling with some of these practice problems. A lot of them take a little time to digest and figure out what's going on, but graphing them is always a good way to figure out what's going on. All right, let's take a look at our quiz. For the first question, we're asked to solve each equation, and we have 4 over x, then minus x minus 4. This is over x squared plus x, and this equals 1. Okay, the first thing I'm going to do here is figure out what is the LCD. So I'm just going to change this into x times the quantity x plus 1, like this. I'll get rid of that and scooch this up here. So the LCD would be x times the quantity x plus 1. So I would multiply everything by that LCD. So let's say this is 4 over x, and then times this x times the quantity x plus 1, then minus x minus 4, over this x times the quantity x plus 1, and then times x times the quantity x plus 1. And this equals, let me slide this down so it fits, we'll have 1 times this x times the quantity x plus 1. Okay, so this x we cancel with this x. You'll have 4 times the quantity x plus 1, which is 4x plus 4. Then you have this minus here, so you have to be very, very careful. You are subtracting this whole thing away, so put brackets or parentheses or whatever you have to do. This is going to cancel completely, so you have this x minus 4 here. Okay, so basically you want to change the sign of x to negative x and change the sign of negative 4 to positive 4. That's what those brackets are going to do. Then over here, you would have 1 times x times the quantity x plus 1. Let's just write that as x squared plus x. All right, let's put this into standard form. So 4x minus x is 3x. And then 4 plus 4 would be 8. This is equal to x squared plus x. So I think the easiest thing to do here would just be to subtract 3x away from each side. Cancel this, subtract 8 away from each side. Cancel this and put this as a 0. So we'll say it's x squared. And then basically 1 minus 3 is negative 2, so minus 2x. And then you'll have minus 8, and this equals 0. So I'm going to solve this with factoring. Again, you can use the quadratic formula if you're not comfortable. So put an x here and put an x here. And then I want two integers whose sum is negative 2 and whose product is negative 8. So that would be negative 4 and positive 2. So I think we can see that x here would be 4, or x here would be negative 2. So coming back up, you want to first make sure that you're not violating the domain. If you think about the domain here, again, it's the set of allowable values for x. And when you work with a rational expression, you want to make sure that your x that you have does not result in a denominator of 0. So in other words, if I plugged in a 4 or if I plugged in a negative 2, would I get a denominator of 0? And the way you figure that out is when you factor the denominators, you set each factor with a variable equal to 0, and you solve the resulting equation. So you would say x is basically just equal to 0. So you can't plug a 0 in for x, so the set of all x such that x is not equal to 0. And then you would set x plus 1 equal to 0. You solve that, you get x equals negative 1. So basically, we know that for the domain, it's the set of all x such that x is not 0 or negative 1. Now we have 4 and negative 2, so that doesn't violate the domain, so we're good to go there. Now you might want to check this to make sure the left and the right sides are equal. So for that, you would just plug in. So you would say that 4 over 4 is 1, then minus 4 minus 4 is 0. So it doesn't matter what you're going to plug in down here. As long as it's not 0, this is 0. So I'm just going to put a 0 here. And does that equal 1? Yes, it does. So then for the other one, it's negative 2. So 4 divided by negative 2 is negative 2. Then minus negative 2 minus 4 is negative 6. And this is over. You'd have negative 2 times the quantity negative 2 plus 1. So negative 2 plus 1 is negative 1. Let me just say this is positive 2 to make it simpler. And then negative 6 divided by 2 would be negative 3. Minus the negative 3 is plus 3. So this right here would be 1. And we're saying it should be equal to 1, and it is. So this is a valid solution here. So we have x equals 4, and then x equals negative 2. So this is what we want, x equals 4 or x equals negative 2. All right, let's take a look at problem number 2 now. So we want to solve each equation. We have 1/2 is equal to x minus 6. This will be over 2x minus 14. Then minus, we have 1 over our 2x squared, and then minus 14x. So the first thing I'm going to do here is find the LCD. And again, I would just factor these denominators. This one would be 2 times the quantity x minus 7. And you can erase this and just throw this up there, or you can keep it and rewrite it. It's up to you. Then for this one, I can actually pull out a 2x. So inside the parentheses, I'd have x minus 7 as well. If you look for the LCD here, it's just going to be this guy right here. So this 2x times the quantity x minus 7. When you think about it, you have a 2 here, a 2 here, and a 2 here. So that's common everything. Then you have this x minus 7 here and here, right? It's common to those two. You only have one each time. And then you have this x that's only going to be for this one, but again, you've got to put it in there. It only occurs once and only right there. So that's my LCD, this 2x times the quantity x minus 7. So let's multiply everything by that. I'm going to try to squeeze this in here. Let's just say this is 2x times the quantity x minus 7. I'll just say this is over 2. You can go ahead and cancel this now, get it out of the way. We'll say this is equal to x minus 6 over this 2 times the quantity x minus 7, and then times this 2x times the quantity x minus 7. This one you have to be really careful on because the 2 is going to cancel, and then the x minus 7, that quantity is going to cancel here, but you have this x left. It's really easy to miss that, okay, and to think the whole thing's canceling, but basically you have that x left. So you're going to have this x multiplied by the quantity x minus 6. So let me actually just do that now. So x times the quantity x minus 6, which you could say is x squared minus 6x. So let's drag that up there, get that out of the way. Then minus. We know if we multiply the LCD by this guy, the denominator is going to cancel, so you just have 1. Now over here, let me clean this up and just erase the 2. And then I'm basically good to go here. What you could do is just say this is x squared and then minus 7x. Okay, so looking at this equation here, it's pretty simple. You can get rid of the x squared on each side. Again, you could just subtract it away from each side. It would go away. You could add 6x to both sides of the equation, and this would cancel. Negative 7x plus 6x is negative x, and this equals negative 1. Let's divide both sides by negative 1. Let's cancel this with this and say x is equal to 1. All right, so thinking about this, if we want the domain, or the set of allowable x values, it's a set of all x such that x is not equal to, again, you have this 2 here, but here you have the 2x. So again, you got to take that 2x, set it equal to 0, and solve, and you're going to get 0, right? So x can't be 0 here, because if you plugged in a 0 for x there, well, then you'd have division by 0, right? That's not allowed. Additionally, you have to take this x minus 7 and set it equal to 0. The solution there is x equals 7. So here the domain is the set of all x such that x is not 0 or 7. We got a solution of x equals 1, so we're okay on that part right there. So now if you want to check, we could just plug in and see if the left and the right sides are equal. So you have 1/2 is equal to 1 minus 6 is negative 5. This is over. You have 2 times the quantity. 1 minus 7 is negative 6. So this would be a negative over a negative, which is a positive. Let's just get rid of these. And then we'll say 2 times 6 is 12. So this is 5/12 over here. And then minus, you have 1 over. Now 2 times 1 would just be 2. And then times, if you look at this, you have your 1 minus your 7, which is negative 6. Now, I can just say that this is going to be 2 times negative 6, which is negative 12. And essentially, this fraction here is negative. So you have minus a negative, which is plus a positive. And so basically, you do 5 plus 1, which is 6, over the common denominator of 12, and 6 over 12 is 1/2. So you get 1/2 equals 1/2. So this is a valid solution. So coming back up, I just want x equals 1. Okay, let's look at question 3. So again, we want to solve each equation. So we have x plus 6 plus we have 1 over this x minus 1. And then this is going to be equal to x over x minus 1. All right, so the LCD is x minus 1. So you're going to have to multiply everything by x minus 1. So you'd have x times the quantity x minus 1, then plus 6 times the quantity x minus 1, then plus, basically it would cancel here and cancel here. So they just put a 1 there, and this equals x. Okay, so x times x is x squared, then minus x times 1 is x, then plus 6 times x is 6x, then minus 6 times 1 is 6, then plus 1 is equal to x. So what I'll do is basically subtract x away from each side here. Let's cancel that away and put 0. So this right here, you'd have negative x minus x, that's negative 2x, then plus 6x, that's going to be 4x. So I'm actually just going to write this down here. So x squared, and then basically plus 4x, and then negative 6 plus 1, that's going to be negative 5, and this equals 0. So let's say here that we have x and we have x. So I want two integers whose sum is 4 and whose product is negative 5. So that's going to be positive 5 and then negative 1. All right, so I think we can see that if we set x plus 5 equal to 0 and solved it, x would be negative 5. If we set x minus 1 equal to 0 and solved it, we'd have x is equal to 1. Okay, so again, thinking about our domain here, it's the set of all x such that x is not equal to, well, here you have x minus 1. If you set it equal to 0 and you solve it, you get x equals 1. So x can't be 1, and that's basically it, right? So the set of all x such that x is not 1. Well, if you look at the solutions you got, one of them is 1. So you have to reject that, because again, if you plug in a 1 there, 1 minus 1 is 0, right? You can't divide by 0, that's undefined. So you have to reject that solution. Now, negative 5, you just have to plug in and check and see if it works. So negative 5 plus 6, that's going to be 1. Then plus, you'd have 1 over negative 5 minus 1 is going to be negative 6. So this is 1 over negative 6. And this equals over here, you'd have negative 5 over negative 5 minus 1 is negative 6. So this is 5 over 6 like this. And let's make this a minus here. And then basically I'll just say that this is going to be 6 over 6. And you'll see that 6 minus 1 is 5 over the common denominator of 6. So this is 5 over 6 is equal to 5 over 6. So this one does work as a solution. So x equals negative 5 is what you're looking for. So coming back up here, again, we want x equals negative 5 only. You do not want this solution because you have to reject that 1 because it violates the domain, right? You cannot plug in a 1 for x because you'd have division by 0. So x equals negative 5 is our solution. Let's take a look at question 4. So we want to solve each equation. We're going to have x squared plus x minus 42. This would be over. We're going to have x squared minus 7x, then minus. We're going to have 1 over x, and this equals x minus 1 over x minus 7. What I'm going to do is factor this top guy here. So let's go ahead and set this up. This would be x, and this would be x. I need two integers that sum to 1 and give me a product of negative 42. Well, what you could do here is go plus 7 and then minus 6. Then down here, we would factor out an x, and you'd have x minus 7. Then we have minus 1 over x. Then this equals x minus 1 over x minus 7. Now, this is not going to cancel with this. You have x plus 7, and you have x minus 7. That's not going to cancel, okay? I'm just factoring things so you can see that nothing will cancel. It's also easier to check when things are in factored form. So I'm just going to say that the LCD would be this guy. So x times the quantity x minus 7. You have an x here and an x here. And then you have an x minus 7 here and an x minus 7 here. So if I multiply this guy by the LCD, I would just have the quantity x plus 7 times the quantity x minus 6. We know this is the x squared plus x and then minus 42. And then minus, I'm going to basically have this x times the quantity x minus 7, then over x. Now let me just do this now so we can save some room. This is going to cancel. So basically what you'd want to do is make sure that this negative here is applied to each guy. So you can keep this just wrapped in these parentheses here. That would be fine. So let's just say this is negative x plus 7. Get that out of the way. And then we'll slide this up here. And we'll say this is equal to. So you have this x minus 1 over x minus 7. And this is multiplied by, let me slide this down so it fits, x times the quantity x minus 7. So let me wrap this here. This would cancel. And so you're going to have x times the quantity x minus 1, which is x squared minus x. So this will be x squared and then minus x. Okay. Same thing on each side of an equation. You can get rid of it, right? So you could subtract x squared away from each side. It's gone. Then additionally, you have negative x and negative x. Get rid of that. So let's put this as a 0. So I have x and then negative 42 plus 7. That's going to be negative 35 or minus 35, and this equals 0. So here x is just equal to 35. So what's my domain here? What is my domain? So it's the set of all x such that x is not equal to, well here, x can't be 0. Or x can't be 7, right? X minus 7, if you set that equal to 0 and solve, you get x is equal to 7. So those are our two values that x can't be equal to. Now x here, our solution for the equation is 35. That does not violate the domain, so we're good to go there. Now again, you could plug it in and check and make sure you got the right answer and you didn't make a silly mistake. That's what I would do, but if you're pressed for time, then just move on. So 35 plus 7 is 42. And then basically you'd have 42 times 35 minus 6 is going to be 29. That's going to be pretty big. We're going to have to use a calculator for that. Then this is over. You're going to have 35, and then times 35 minus 7 is 28. Now, it looks like I can cancel some stuff before I move forward. 29 is a prime number, so forget about that. But 42 is 7 times 6. So let's write this as 7 times 6, and let's write 35 as 7 times 5. And let's cancel this 7 with this 7. And then with 28, let me write that as 2 times 14. Let's put a multiplication symbol there. So 6 divided by 2 is 3. So I'm going to cancel that out completely. So we're going to say this is 3 times 29, which is 87. And this would be over 5 times 14, which is 70. So 87 over 70. Then minus. You can have 1 over 35. And of course, you can multiply this by 2 over 2. So this is minus 2 over 70. So you could just say this is 85 over 70. Now, you could cancel a common factor of 5. So that's going to be 17 over 14. Okay, over here, 35 minus 1 is 34. And then this is over. 35 minus 7 is 28. Now, you could cancel a common factor of 2. 34 divided by 2 is 17, and 28 divided by 2 is 14. So you get 17 over 14 is equal to 17 over 14. So x equals 35 is a valid solution. So we want this, x equals 35. Okay, let's look at question 5. So we want to solve each equation. So we have 1 over x plus 3. Then plus, we have x squared over x plus 3. And this equals 1. Okay, so obviously the LCD here is going to be x plus 3. So if you multiply both sides by x plus 3, this denominator is going to cancel and you're going to have 1. Then plus this denominator is going to cancel, you're going to have x squared. And this equals, over here you would have x plus 3, right? X plus 3 times 1 is just x plus 3. So this is a simple quadratic that we're going to solve. So basically, let me just subtract x away from each side. Let me just write that over here and cancel this. And let me put plus here. Let me subtract 3 away from each side. Cancel this and put 0. So I'm just going to rearrange this in the proper order. So we'll say x squared, then minus x. And then 1 minus 3 is negative 2. So minus 2, and this equals 0. So let's come through here and set this up. So we'll say x here and x here. I need two integers whose sum is negative 1 and whose product is negative 2. So that's negative 2 and positive 1. So x here would be 2, right? If we said x minus 2 equals 0, the solution is x equals 2. Or x here would be negative 1. Again, if you said x plus 1 is equal to 0 and you solve that, you get x is equal to negative 1. Okay, so coming back up here, for the domain, again, the set of allowable x values is the set of all x such that x is not equal to. In this case, you would just set x plus 3 equal to 0 and solve that, and you get x equals negative 3. So here, x can't be negative 3, right? So the set of all x such that x is not negative 3. For your solutions, you got 2 and negative 1, so it does not violate the domain, so you're good there. But I'm just going to plug in and check. So 1 over 2 plus 3 is 1 over 5. Let me slide this down just a little bit. So this would be 1/5, and then plus 2 squared is 4, and this would be over. Basically, 2 plus 3 would be 5. Now, 1 plus 4 is 5 over the common denominator of 5 would be 1. So you get 1 equals 1, so this one checks. The other one is negative 1. So 1 over, you have negative 1 plus 3, that's 2. So this is a half, and then plus negative 1, both the negative and the 1. If you plug in for something, you have to wrap it in parentheses. So this is negative 1 squared like this. So this is 1, and this is over. Negative 1 plus 3 is going to be 2. So a half plus a half, we know that's 1. So you're going to get that 1 is equal to 1. So this one checks as well. So the solutions we're looking for, we have x equals 2 and then also x equals -1. So we want x equals 2 or x equals -1. All right, let's take a look at our quiz. For the first question, we're asked to solve each inequality. So we have 3 over x minus 4. This is greater than 2. All right, so for a rational inequality, you want to get one side as a rational expression. You want to have your inequality symbol, and then the other side is 0. So I'm just going to subtract 2 away from each side. That's going to give me 3 over x minus 4. Then minus 2 is greater than 0. I'm going to get a common denominator, and so I'll have 3 over x minus 4. And then basically minus 2 times this quantity x minus 4. Then this would be over this x minus 4. Then this is greater than 0. So then you'd have 3 and then minus. Here's where you have to be careful. You have to subtract this whole thing away. So let me use some brackets here. Use parentheses as well. It's up to you. So 2 times x is 2x, and then minus 2 times 4 is 8. So to remove the brackets, you need to change the sign of each inside. So let me get rid of this and this. This will be a minus, and this will be a plus. Then this is over your common denominator of x minus 4. Let's just go ahead and say that 3 plus 8 would be 11. So this is going to be negative 2x plus 11. That's going to be your numerator. And then your denominator is just your x minus 4. Then this is greater than 0. Okay, so once you have it set up like this, you're going to set your numerator equal to 0. So negative 2x plus 11 is equal to 0. You're going to solve that. So basically this is negative 2x is equal to negative 11, just subtracting 11 away from each side. We divide both sides by negative 2. And so this solution here is that x is equal to 11 halves or 5.5. Let me show that as canceling. Okay. The other guy is going to be us setting the denominator equal to 0. So x minus 4 equals 0. And that would be x is equal to 4. Now we should note here that 4 is going to be excluded from the domain, right? Because if you plug in a 4 for x, 4 minus 4 is 0. You're dividing by 0, and that's undefined. So you could write a little comma here and say that x is not equal to 4. Or I'm just going to write out the domain and say that the domain is going to be the set of all x such that x is not 4. And you just want to come to a number line, and you want to take this value of 4. Let me set up a little vertical line there. That's going to be a critical value for us. And then 11 halves is 5.5. So let's just say that's about right there. It doesn't have to be perfect. So let's say this is 11 halves. Okay. You can actually get rid of both of these. You don't need them because this is a strict inequality. So first off, the critical value of 4 makes the denominator of 0, so that has to be excluded. And then if you use 11 halves or 5.5, that's going to make this 0. And so you'd have 0 is greater than 0, which is false. So you're going to exclude both of those. You can also get rid of this. We don't need this anymore. Just something you can put down for your notes. But essentially, you would just say that we want to create these regions. So A is less than 4. B is between 4 and 11 halves, and C is greater than 11 halves. So you have this A, this B, and this C, and we just need a test in each. So for A, I'm going to pick 0. You're going to have 11 over negative 4. So it's basically a negative, and a negative is not greater than 0, so this is false. So for B, let's pick 5. Negative 2 times 5 is negative 10. Negative 10 plus 11 is 1. This would be over. 5 minus 4 is 1. So basically you get 1 is greater than 0, which is true, or you could say a positive is greater than 0. That's true. However you want to do it. Now the other guy is going to be C, so let's just pick 6. So negative 2 times 6 is negative 12. Negative 12 plus 11 is negative 1. This would be over. You would have 6 minus 4, which is 2. So you get negative 1/2 is greater than 0. Again, a negative is not going to be greater than 0. So this is false. So thinking about our solution, remember those critical values of 4 and 11 halves, those are both going to be excluded. We talked about that earlier. So the solution here is x is going to be greater than 4 and less than 11 halves. So this is what we want. So coming back up here, we want this one. Again, x is greater than 4 and less than 11 halves. Okay, let's look at question 2 now. We're asked to solve each inequality. So we have 7 over x minus 1. This is less than or equal to. We have 3 over x plus 2. So what I'm going to do is subtract this away from each side. So you'll have 7 over x minus 1, then minus this 3 over x plus 2. This will be less than or equal to 0. You want to combine this into one single rational expression. So I'm going to say this is 7 over x minus 1, then times this quantity x plus 2 over this quantity x plus 2. Let me wrap this as well. Then minus, you have 3 over this x plus 2. Let me just wrap this now. Then times this quantity x minus 1 over this quantity x minus 1. So again, the LCD would just be the product of the two denominators. There's nothing in common. So that's why I just multiplied them together to get a common denominator. So then this is less than or equal to 0. Okay. Coming down here, you would just say this is 7x plus 14, just using your distributive property. This is a minus, so you have to be extremely careful. I'm going to put this inside of brackets. 3 times x is 3x, and then minus 3 times 1 is 3. If you want to remove the brackets, then basically you change the sign of each. So this is a minus, and now this is a plus. This is over your common denominator of x minus 1 times x plus 2. So then this is less than or equal to 0. Now here, 7x minus 3x would be 4x. So let's just say this is 4x. And then 14 plus 3 is 17. So this would be 17 here. Okay, let me move this down over here. What you want to do at this point is set the numerator equal to 0. So 4x plus 17 is equal to 0. Subtract 17 away from each side. Let's cancel this. You get 4x is equal to negative 17. Divide both sides by 4. And we'll say that x is equal to negative 17 over 4. Now notice that this guy right here would satisfy this inequality because you have a non-strict inequality. Okay, we'll talk more about that later, but you might want to note that in your scratch work, depending on how organized you are so you don't forget later on. Then the other two that we get from solving the equation where the denominator is set equal to 0, remember those two solutions are not going to work, right? Because they make the denominator 0 and we can't divide by 0 that's undefined. So you have x minus 1 is equal to 0 or x plus 2 is equal to 0. And so here x is equal to 1, and then here x is equal to negative 2. Okay, so these are going to be our critical values. And again, I just want to note here so that we don't get lost that the domain is the set of all x such that x is not 1, and then also it's not going to be negative 2. Because again, those values give us a denominator of 0. Let's say that this is negative 17 over 4. Let's say that this is negative 2, and let's say that this is 1. So I'm going to get rid of all of these. Remember that negative 17 over 4 is going to be included in the solution. I'm going to get rid of this domain as well. We don't need it. You can just keep it for your scratch work if you want. And let's just say that this is a, so anything less than negative 17 over 4, which is basically negative 4 and a fourth, if you're thinking that way. Then b is anything between negative 17 fourths and negative 2. C is between negative 2 and 1, and d is anything greater than 1. Okay, so let's write out A, B, C, and D. So for A, I'm just going to pick a negative 5. So 4 times negative 5 is negative 20. Negative 20 plus 17 is going to be negative 3. Now, if you want, you could just do a sign analysis and say it's negative. I think that's probably a little bit easier. Then negative 5 minus 1 is going to be negative 6, so that's negative. And then negative 5 plus 2 is going to be negative 3, so that's negative. This would basically be a negative over a positive, which is a negative. And so is a negative less than 0? Yes, that's always true. So this is true. So for B, I could pick something like negative 3, right? So 4 times negative 3 is negative 12. Negative 12 plus 17 is positive 5, so this is positive. Then for negative 3 minus 1, that's negative 4, so that's a negative. And then negative 3 plus 2 is negative 1, so that's a negative. So now you get a positive over a positive, and that's a positive, and that's not less than 0. So this is going to be false. Okay, so for C, we have 0 involved. So we can say 4 times 0 is 0. So this is 17. This is positive. Then over here, this would be negative 1 times positive 2. So negative times positive, that's negative. Positive over negative is negative. And so negative is always going to be less than 0. So this is back to being true. And then for D, we could pick 2. 4 times 2 is 8. 8 plus 17, that's 25. So this is positive. Then down here, 2 minus 1 is 1. So that's positive. And then 2 plus 2 is 4. So that's positive. So basically, it's going to be a positive over a positive, which is not going to be less than 0. So this is false. Okay, let's get rid of everything. Remember, this negative 17 fourths, that makes the numerator 0. So you're going to get 0 over something that's not 0. So that's 0. And that is less than or equal to 0, right? The or equal to part works there because this is non-strict. Let me get rid of this, and we'll write our solution. So basically, x is going to be less than or equal to negative 17 fourths. And then we'll say or. Over here, we'll say x is greater than negative 2 and less than 1. And again, negative 2 and 1, those made the denominator 0, so those are excluded. So coming back up here, we want this answer. So x is less than or equal to negative 17 over 4, or x is greater than negative 2 and less than 1. Okay, let's move on and look at question 3 now. So we want to solve each inequality. So we have 4x minus 1. This is over x squared plus 4x plus 4, and this is greater than 0. All right, so what I'm going to do is actually factor this denominator here. So let me write 4x minus 1 over. This is going to be x plus 2 quantity squared, right? Or you could write x plus 2 times x plus 2 if you want to do that. But basically, this is a perfect square trinomial, so it factors into this binomial squared. So this right here is going to be greater than 0. So we have a single rational expression on the left, and then we have our inequality, which in this case is a greater than, and then we have 0 on the right. So that's what we want. Now I'm just going to set the numerator equal to 0. So 4x minus 1 is equal to 0. Add 1 to both sides. This cancels. We'll say 4x is equal to 1. Divide both sides by 4. We'll say x is 1/4. Okay, so that's one critical value. So x, let's put this over here, x is equal to 1/4. And again, this would not solve the inequality because you'd have 0 is greater than 0, which is false. Then for the other one, I think we can see that it's going to be -2, right? So you take x plus 2 and basically set that equal to 0, subtract 2 away from each side, and you get x is equal to -2. So that's another critical value. And let me just list here for clarity that the domain is the set of all x such that x is not equal to -2. So let's write that this is the domain. And let's grab this. For the critical values, you have -2, so that's going to be right there. And then for 4th, let's just say that's about right there. It doesn't have to be perfect, just so we have a visual representation of what's going on. So we'll say this is a, so that's less than -2. This is b, between -2 and 1/4. And this is c, which is greater than 1/4. So you have a, b, and c. Now, when you think about this, you can get rid of this domain here. You don't need it anymore, just for scratch work. When you think about this, your denominator, because you have this guy being squared, it's either going to be 0 if x is -2, and we can't actually test that because it's a critical value, or it's going to be some positive value. So no matter what we plug in from A, B, or C, this is going to be positive. So that's actually going to speed up the process because I only need to think about, is this positive or is this negative? In A, let's just pick something like -3. 4 times -3 is -12, and -12 minus 1 is -13, so this is negative, right? Negative over positive is negative, and that's not greater than 0. So this is going to be false. Now, if we move on to B, you could pick 0. So 4 times 0 is 0, so you have -1. Basically, a negative over a positive is negative, and that's not greater than 0, so this is false. Now, let's think about C. So in C, you could pick 1. So 4 times 1 is 4. And then 4 minus 1 would be 3, so this would be positive. And a positive over a positive is a positive, and that's going to be greater than 0, so this is true. Okay, so in this particular case, again, 1/4 is going to be excluded because 4 times a fourth is 1. 1 minus 1 is 0, so this would be 0. This guy down here would not be 0, so you'd have 0 is greater than 0, which is false. So for my solution, I'll just say that x is greater than 1/4. And that's all I need here. So coming back, I'll just select that x is greater than 1/4. Okay, let's look at question 4. Again, we want to solve each inequality. So we have 2x squared plus, we're going to have 5x minus 12. This will be over 3x minus 1, and this is greater than 0. We have our rational expression on the left. We have our greater than, or our inequality symbol, and then we have 0 on the right. So we're basically ready to go. I just need to factor the numerator. So let me see what that's going to be. I'm going to put a 2x here and an x here. Now this is a minus. So I'm going to subtract in terms of absolute value and try to get to 5. Okay, so thinking about 12, it's 1 times 12. Now you could put the 12 here, but you can't put it here. That's just too big, right? So then you have 2 and 6. So you can't put a 2 here and you can't put a 6 here, so that's out, right? You'd have a common factor of 2. And then you have 3 and 4. Now you can't put the 4 here, but you could put it here and you could put the 3 here. Now that's going to give me 8 minus 3, which is 5. Let's make this a plus and this a minus. So this would be 8x here, and this would be minus 3x here. 8x minus 3x is 5x. Okay, so that's good to go. Then this would be over your 3x minus 1. We're saying this is greater than 0. We will say that the numerator is equal to 0. So that means 2x minus 3 is equal to 0, or x plus 4 is equal to 0. So in this case, you would add 3 to both sides. And we would say 2x is equal to 3. Divide both sides by 2. And we'll say that x is equal to 3 halves, or you could say 1.5. All right, let me get rid of this over here. Make this more cleanly. We'll say that x is equal to 3 halves. Over here, just subtract 4 away from each side. So x could also be -4. Now these two guys here are going to give you a numerator of 0, a denominator that's not 0. So this would be 0 is greater than 0, which is false. So none of the critical values are going to work here. And then you have 3x minus 1. Set that equal to 0. Add 1 to both sides. Cancel this. We'll have 3x is equal to 1. Divide both sides by 3. Cancel this. You get x is equal to 1/3. Okay, so we know that x cannot be 1/3. Let me move this down here, and I'll just note that the domain is the set of all x such that x is not going to be 1/3. Okay, so coming to the number line, we have -4. Let's say that's there. Then we have 1/3. Let's say that's there. And then we have 3/2. So this is A, that's anything less than -4. This is B, between -4 and 1/3. This is C, between 1/3 and 3/2. And this is D, which is greater than 3/2. All right, none of these critical values are going to work. I'm just going to get rid of this. I'm going to get rid of that. You could just keep it for your scratch work if you want. You really don't need it anymore. So I'm just going to test something in A. Let's just pick -5. And so -5 times 2 would be -10. And -10 minus 3 would be -13. So let me just put negative here. I think if you want to use a calculator, that's fine, but we'll just do a sign analysis. Then -5 plus 4 is -1, so that's negative. This is over. 3 times -5 is -15, and -15 minus 1 is -16, so that's negative. Negative times negative is positive, so this is a positive over a negative, which is a negative. Now, a negative is not greater than 0, so for A, let me write this over here. So for A, this is going to be false. It's not going to work. Let's go B and C and D, put those in there. So for B, let's pick 0. So this would be -3, which is negative. This would be 4, which is positive. This would be -1, which is negative. So negative times positive is negative, and negative over negative is positive. A positive is greater than 0, so this is true. Okay, so for C, let's pick 1. So 2 times 1 is 2, then -3 is -1, so this is negative. Then 1 plus 4 is 5, that's positive. So negative times positive is negative, of course. Then down here, 3 times 1 is 3, minus 1 is 2, so this is positive. Negative over positive is negative. A negative is not greater than 0, so this is false. And then for D, let's just pick 2. 2 times 2 is 4. 4 minus 3 is 1. So this is positive. 2 plus 4 is 6. That's positive. And then 3 times 2 is 6. Minus 1 is 5. So that's positive. So we know that we would have a positive over a positive. And that's going to give me a positive. And so a positive is greater than 0. So this is true. And we already know that the critical values are all excluded. We talked about that earlier. So for my solution here, I'm just going to say that we have B, so x is greater than -4 and less than 1/3. Then or I'm going to have D, where x is greater than 3/2. Okay, so I want this one right here. So x is greater than -4 and less than 1/3, or x is greater than 3/2. Okay, let's look at question 5. So we have 7 over x plus 1. This is less than or equal to. We have 3 over x plus 5. All right, so we're going to have 7 over x plus 1, then minus 3 over x plus 5, and this will be less than or equal to 0. Okay, we need a common denominator. So you have a denominator of x plus 1, a denominator of x plus 5. So the LCD here would be the product of the two. So I'm going to say this is 7 over x plus 1. I'll just wrap this times the quantity x plus 5 over the quantity x plus 5. Then minus, we have 3 over x plus 5. Let's just wrap this. Then times the quantity x plus 1 over the quantity x plus 1. Let's slide this down here. We'll say this is less than or equal to 0. So this would be 7x plus 35. And then minus, make sure you use brackets or parentheses. You need to subtract this whole thing away. So this is 3x plus 3. And then if I remove the brackets, I'll say this is negative and this is negative. So basically negative 3x minus 3. 7x minus 3x would be 4x. So let's say this is 4x, and 35 minus 3 is 32. So this is 32. You can just factor this now and say it's 4 times the quantity x plus 8. I think that's easier to just do it now and get it out of the way. Then this is over. You'll have x plus 1, that quantity times the quantity x plus 5, and this will be less than or equal to 0. Let's take the numerator, set that equal to 0. You can forget about the 4, you don't need it. Just take x plus 8, set that equal to 0 and solve, and you get x equals -8. So let's say over here that x is equal to -8. And you can see that that would work as a solution because, again, this is a non-strict inequality. So you'd have 0 is less than or equal to 0. So this would work. So then for the other guys, you have x plus 1 equals 0 or x plus 5 equals 0. So we know that this would give us a solution where x is -1, right? Subtract 1 away from each side. or x could be -5 if you subtract 5 away from each side. But again, you would note that your domain here excludes these two values. That just helps you when you're going back to figure out which endpoints are excluded. Let me just say that the domain is the set of all x such that x is not equal to -1 or -5. Okay, so coming down here, let's say this is -8. Let's say that this is -5, and let's say this is -1. Now we know that -8 is going to work. I think we can remember that -1 and -5 will not. So let's just erase this so we have some room. And we'll say this is A, so anything less than -8. This is B between -8 and -5. This is C between -5 and -1. And this is D where it's greater than -1. So let's say we have A, B, C, and D. Let's go ahead and do this like this. So for A, let's just pick -9. And again, you can just think about the sign, or you can punch it into your calculator, whatever you want to do. I'm going to say this is 4 times. You're going to have -9 plus 8, which is -1. So this right here would be a negative, right? It would be -4, but let's just put negative. Now, down here, you'd have -9 plus 1, which is -8, so that's negative. And then -9 plus 5 is going to be -4, so that's a negative. Well, negative times negative is positive, so this is negative over positive, which is negative, and that will be less than 0, so this is true. In B, you could pick -7. So -7 plus 8 is going to be 1. 1 times 4 is 4, so this is positive. And then down here, -7 plus 1 is -6, so that's negative. And -7 plus 5 is -2, so that's negative. So this will basically be a positive here. Positive over positive is positive, and that's not going to be less than 0, so this is false. And then for C, you could pick -4. So -4 plus 8 is 4. 4 times 4 is 16, so this is positive. And then over here, -4 plus 1 is -3, so that's negative. And then -4 plus 5 is going to be 1, so that's positive. So this right here would be a negative. Negative times positive is negative. And then positive over negative is negative. So negative is less than 0, so this is true. Okay, then for D, you could pick 0. So this would be 4 times 8, which is 32, so that's positive. Here you'd have a positive 1 times a positive 5, so that would be a positive. And a positive over a positive is a positive, and so this will not be less than 0, so this is false. Okay, so thinking about the solution, remember the -8 is included, and the -5 and the -1, those are excluded. Okay, so it's important. So we would say that going into A, we'd say x is less than or equal to -8. Then or for C, we'll say x is greater than -5 and less than -1. So we have x is less than or equal to -8, or x is greater than -5 and less than -1. So this guy right there. All right, let's take a look at our quiz. For the first question, we're asked to solve each word problem. We have that Amy travels the country as a singer. For her first trip, she drove from St. Charles to Port Smith, a distance of 2,400 miles. Her second trip from Port Smith to Amasland was 3,600 miles and took the same amount of time as the first trip. If Amy's speed was 30 miles per hour slower on the first trip versus the second trip, what was her average rate of speed on the second trip? Okay, so for this type of problem, we're going to use our distance formula. So distance is equal to rate of speed times time traveled. And we're trying to figure out what was her average rate of speed on the second trip. Okay, coming to the table, I've already set some things up for us. So you see that you have a distance here. And for the first trip, it's 2,400. That's just from the problem. For the second trip, it's 3,600. That's from the problem. Now, I chose to let x be equal to her rate of speed on the first trip. So that means on the second trip, it's x plus 30. Now, you could have done this differently. You could have let the second trip be x, and then the first trip would have been x minus 30. Again, this is coming from the fact that it says that if Amy's speed was 30 miles per hour slower on the first trip versus the second trip. So if you let the second trip be x, then the first trip has to be x minus 30. But I didn't do that. I let the first trip be x, so that means the second trip has to be x plus 30. Okay, so just keep that in mind. Now, when we talk about the time, remember, you can solve the distance formula for time. So distance is equal to rate times time, divide both sides of the equation by r, and you get time is equal to distance over rate. So that's where this stuff is coming from. So essentially, you're getting your 2,400, which is your distance, divided by x, which is your rate, and then over here, your 3,600, which is your distance, divided by your quantity x plus 30, which is your rate, okay? Now, coming back up, again, it says specifically that it took the same amount of time, okay? So that means to get an equation, we can set this time right here equal to this time right here and just solve for x. So we'll say that this is 2400 over x is equal to, this is 3600 over x plus 30. Now, I just want to note that when we solve for x, we don't actually have our answer, because if we go back, again, it's what was her average rate of speed on the second trip. So we have to add 30 to that to get our answer. So that's very important. So coming down here, I'm just going to cross multiply. I'm going to say x times 3600 would be 3600x. And then this guy we would basically have is equal to your 2400 times your quantity x plus 30. I think we all know at this point that x can't be 0 and x can't be negative 30. It's not going to come up, but you just want to note that in case you're solving something in the future where one or more solutions needs to be rejected because it violates the domain. What I'm going to do here is think about the greatest common factor of 3600 and 2400. It's going to be 1200. So I'm going to divide this side by 1200 and this side by 1200. This isn't necessary, especially if you're working with a calculator, but it makes it a little bit easier to work with the numbers. So this divided by this is going to be 3. So this is 3x is equal to, this divided by this is 2. So this is 2 times the quantity x plus 30. Okay, what I'm going to do at this point is just use my distributive property. So this is 3x is equal to, this would be 2x plus 60. Subtract 2x away from each side. This cancels, and 3x minus 2x is x, so x equals 60. Again, we modeled this such that x was the rate of speed on the first trip. But again, we want the rate of speed on the second trip, so it's 60 plus 30 or 90. So coming back up here, we want to say that it's 90 miles per hour. Okay, so don't select 60, that's the wrong answer. Now, thinking about checking this, again, you could just think about, are the times going to be equal? Well, on the first trip, we know that she's driving at 60 miles per hour, and she's going 2,400 miles, right? So you could just divide 2,400 by 60, and that's going to give you 40, right? So on the first trip, you can say that she travels for 40 hours. Now, the times should be equal, okay? On the second trip, we're saying that it's 90 miles per hour, and she's going 3,600 miles. So 3,600 divided by 90 is also 40, right? So for the second trip, you can just line to that and say it's also 40 hours. So the two times are equal, so we know we have the correct answer, right? So her average rate of speed on the second trip was 90 miles per hour. All right, let's take a look at question 2. So we want to solve each word problem. So we have Abby can travel 48 miles downstream in the same time it takes her to go 24 miles upstream. Her boat goes 6 miles per hour in still water. So what is the speed of the current? So this actually sets up in a very similar way to the last one. So again, you're going to use the distance formula. So distance equals rate of speed times time traveled. And I have everything filled out in the table already. So the distance for downstream, we're told that's 48. The distance for upstream, we're told that's 24. Now, in terms of this rate, if we go back, it tells us that her boat goes 6 miles per hour in still water. So that's no current. So I'm just going to let x be equal to the speed of the current. And then basically, if I'm going downstream, I'm going with the current. So it's 6, the speed of the boat in still water, plus x, the speed of the current. If I'm going upstream, then it's 6, the speed of the boat in still water, minus x, which is the speed of the current. Okay. Then again, for time, you just solve the distance formula for time. Divide both sides by rate. We saw this already. So time is equal to distance over rate. Okay, so that's where that's coming from. So here you get distance of 48 over the rate of 6 plus x. Or you can flip that around and say it's x plus 6, whatever you want to do. Then here for the time, it's 24, which is your distance, divided by your rate, which is 6 minus x. Either way, we're told that it's in the same time. Okay, so that means the two times will be equal. So this time will be equal to this time, and these circlings here are just going out of control. So let me see if I can do that more neatly. So this time will be equal to this time. So you'll have 48 over 6 plus x is equal to 24 over 6 minus x. Here, x can't be negative 6, and here, x can't be 6. So just keep that in mind when you solve these types of equations. So I would cross multiply. So this times this is equal to this times this. So 48 times the quantity 6 minus x is equal to 24 times the quantity 6 plus x. Now, you can work with this as is, or you can make your life a lot easier and divide both sides by 24. I think that's going to greatly simplify this. But again, it's up to you if you're using a calculator. It doesn't matter. This divided by this would be 2. So 2 times the quantity 6 minus x is equal to 24 over 24 is 1. So this is just 6 plus x or x plus 6, whatever you want to write. I'm going to distribute this. So this is 12 minus 2x is equal to 6 plus x. Then I'm going to subtract x away from each side. And I'm going to subtract 12 away from each side. And so let's cancel this and let's cancel this. And we'll say negative 2x minus x is negative 3x. And this equals 6 minus 12 is going to be negative 6. Let's divide both sides of the equation by negative 3. and then I'll cancel this with this and say x is equal to negative 6 divided by negative 3 would be 2. So x is 2. So again, that's the speed of the current. So coming back up, we want to say it's 2 miles per hour. And again, you can check this. If we know that she's traveling 6 miles per hour in still water, if she's going downstream, she's going 6 plus 2 or 8 miles per hour. So 8 miles per hour. Now, for 48 miles, how long is that going to take her? Well, 48 divided by 8 is 6. So that would be 6 hours. And again, we're looking for the same time. So to go 24 miles upstream, how long is that going to take? Well, again, now I'm going 6 minus 2 or 4 miles per hour. And 24 divided by 4 would also be 6. So either way, it's 6 hours of time. But because I'm going downstream here, I go 48 miles, and upstream here, I go 24 miles. So the speed of the current is 2 miles per hour. All right, let's look at question 3 now. So we want to solve each word problem. When Jason works alone, he can paint the fence in 12 hours. When Sandy paints the same fence, it takes her 36 hours. How long would it take to paint the fence if they work together? So this type of problem is very, very simple. Think about 1 unit of time. We're told if Jason works alone, he can paint the fence in 12 hours. So in 1 unit of time, or 1 hour, he does 1/12 of that fence. I'm going to add this to, what's the contribution of Sandy? So in 1 hour, it's going to be 1 over 36, right? Because in 36 hours, she completes the job or paints the fence. So add these two amounts together, and you're going to figure out how much they complete in 1 hour. Over here, I'm just going to multiply this by 3 over 3 to get a common denominator. So this would be equal to 3 over 36 plus 1 over 36, which is 4 over 36, or basically, you would have 1/9. Now, if I told you that after an hour, you would complete 1/9 of a certain job, how many hours would it take for you to complete the job? 9 hours, right? But the way you model that is you say 1/9 is the amount they complete in 1 hour. So times X hours, that equals 1 job. And to solve this, you multiply both sides by 9. And so this would cancel. You'll have X is equal to 9. So 9 hours is what we want. All right, it's really easy to check this. You can think about in an hour, Jason does, again, 1 over 12 of the job. He's going to do this for 9 hours. And plus, what does Sandy do in an hour? 1 over 36. And then she does this for 9 hours, and this should equal 1 job. So for this one, I'm actually just going to multiply everything by 3. So I'm going to say that this is 27 over 36, like this. And then we would say that this is 9 over 36, like this. And 27 plus 9, that's going to be 36. So this would be 36 over 36, which is 1, right? So this is verifying our answer. Again, it's going to be 9 hours if they work together to paint the fence. All right, let's take a look at question 4 now. So again, we want to solve each word problem. So we have that working together, Al and Steve can clean the interior of a plane in 1 hour and 15 minutes. When Al works alone, it takes him 1 hour and 40 minutes. How long does it take Steve to clean the interior of the plane if he works alone? So this is what we want to know. How long does it take Steve to clean the interior of the plane if he works alone? So you could let X be equal to that. You could say that we're going to let X be equal to the time, we'll say in minutes, and I'll explain why in a moment. We'll say for Steve to, we'll just say complete the job, or you could just say clean the plane. How about that? We'll make it simple. So clean the plane. I know it's the interior, but let's just make it shorter. Okay. So from this, let me make this N a little bit better here so we can read it. For this, you have to first convert things over to minutes or hours. It's not good to work with a mixture. So we know that 60 minutes is 1 hour. So if you see something like an hour and 15 minutes, you can convert that over to 75 minutes. And then for something like an hour and 40 minutes, you can convert that to 100 minutes. And now it's pretty straightforward. We know that in 1 minute, this guy, Al, is going to complete 1 over 100 of that job. Again, this is in terms of minutes. So this is 1 over 100 for him. Then plus, what does Steve do? Well, again, it takes him X minutes to clean the plane. So in 1 minute, he's done 1 over X. So this right here, this is their combined amount that they do in 1 minute. Now, if I multiply this by the number of minutes it takes to complete the job, which is 75, I should get 1 completed job. Okay, so let me actually erase all this. I'm just going to stay on this page and we'll move this up here. It won't be too bad overall. So we'll do 75 times 1 over 100. Each of these is going to be divisible by 25. So this will end up being 3/4. So this is 3/4. And then plus this would be 75 over X, and this equals 1. Now I would note with this equation that X can't be 0. You're not going to get that as a solution, but just for reference. Now you could multiply everything here by 4x. That's going to be your LCD. let's go ahead and do that real quick. So this 4 we cancel with this 4. This x we cancel with this x. So you're going to have x times 3 or 3x. And then basically plus 75 times 4 is going to be 300. And this will be equal to 1 times 4x is 4x. I'm just going to subtract 3x away from each side of the equation. Let's cancel this. You're going to have 300 is equal to 4x minus 3x is x. You could also flip that around and say x equals 300. But we know that these answers here are not given in terms of minutes. Remember, this was minutes. So you have to convert this back into hours, and 300 divided by 60 would be 5. So 5 hours is the answer that we're looking for. All right, now checking this, again, you can go back and say, well, they're going to work on this for 75 minutes together. Okay, so for the first guy, when we think about Al, he's completing 1 over 100 of that job every minute he works. So 1 over 100, and then times, he's going to do this for 75 minutes. So basically between these two, we know there's a common factor of 25. So this would be 3, and this would be 4. Okay, so we know this is 3/4. Let me actually just erase this and put 3/4. So that's how much Al is going to do of that job. Then plus, how much is Steve going to do? Well, again, he's going to do every minute 1 over 300 of that job. Again, that's just converting this back into minutes. It's 300 minutes, so 1 over 300 per minute. Then times, he's going to do this for 75 minutes. So there's a common factor here of 75. And so this would be 1/4. And you could see that if this guy Al does 3/4 of the job, and we add that to what Steve does, which is 1/4 of the job, we do get one completed job. Okay, so this is the correct answer here. It's 5 hours or 300 minutes. All right, let's take a look at question 5 now. So again, we want to solve each word problem. So we have that a local assembly shop uses water tanks for cooling purposes. The inlet pipe can fill an empty water tank in 1 hour, while the outlet pipe takes 3 hours to empty a full water tank. If both pipes are turned on at the same time, how long would it take to fill an empty tank? Okay, for this problem, like we've seen in the past, it's two competing forces. So if I think about this inlet pipe, in 1 unit of time or 1 hour, it's actually completed the whole job. So it's taken an empty water tank and it's completely filled it. So I'm just going to write a 1 there. Now, I also have to think about what's being done to compete. So we have this outlet pipe, which takes 3 hours to empty a full water tank. So in 1 hour, it's basically emptied 1/3 of this full water tank. So I'm going to just subtract away 1/3. So let's think about what's going on here. In an hour, I've filled an empty water tank. And in an hour, I've also taken 1/3 of that full water tank away. So in 1 hour, 1 minus 1/3, or you could say 2/3, or you could do this the long way and say this is 3 over 3, and 3 minus 1 is 2 over the common denominator of 3. Either way, this is 2/3. That's how much of that water tank is full, okay? So I would just multiply this by x. This is the number of hours it's going to take to complete the job or fill this empty water tank. And let's set this equal to 1 for one completed job, and then just cross multiply, so times 3 over 2, then times 3 over 2. This cancels, and you get x is equal to 3/2. Now, in terms of hours, if I say it's 3/2 hours or 1.5 hours, well, that's going to be 1 hour and 30 minutes. So that's the answer we want. All right, now checking this is simple. Essentially, you're thinking about 1 hour and 30 minutes. What's going to happen? Well, for the inlet pipe, remember, it completes the job in 1 hour. So in an hour and 30 minutes, it's completed 1.5 jobs. So let's just write down that it's 1.5. That's how much of that is done. So basically it's filled a full water tank and then a half of one. Then I have to subtract away what the outlet pipe's done in an hour and 30 minutes. Well, I know that it takes 3 hours to empty a full water tank. So in an hour and a half or half that amount of time, it's done half the job, right? So I can just take away 0.5 or half, and this does get me to 1, right? So 1 completed job, or we could say 1 completely full water tank. All right, let's take a look at the section quiz. For question 1, we're asked to solve each equation. And we're going to have x minus 1 is equal to the square root of 2x plus 13. All right, so because this square root is isolated here, I'm just going to immediately square both sides. That's going to give me x minus 1 quantity squared, which is x squared, minus, you have 2 times x times 1, which is just minus 2x, then plus 1 squared is 1. And this equals, here you're going to get the radicand, so 2x plus 13. What we'll do from here is subtract 2x away from each side. Let me subtract 13 away from each side. We're going to cancel this and say it's 0. So you'll have x squared minus 4x, and then basically minus 12, and this equals 0. So this is something we can solve using factoring. Again, you can always use the quadratic formula if that's what you prefer. I'm going to put an x here and an x here. I need two integers that sum to -4 and have a product of -12. So that's going to be -6 and +2. So we would say that x minus 6 is equal to 0, or x plus 2 is equal to 0. So the solutions here, you get x is equal to 6 or -2. So let's check these and make sure they work. So to check 6 minus 1 is 5, and this equals 2 times 6 is 12. 12 plus 13 is 25. The square root of 25 is 5. So this one works. For -2 minus 1 is -3. And this equals, over here, 2 times -2 is -4. -4 plus 13 is going to be 9. The principal square root of 9 is 3. So you get -3 equals 3. So this guy right here is going to be extraneous. So we only want x equals 6. So coming back up here, I want x equals 6. Okay, let's look at question 2. Again, we're asked to solve each equation. So we have the square root of 4x plus 1. This equals -2 minus the square root of 3 minus x. All right, so what I'm actually going to do here is multiply everything by -1. So I'm going to put a negative here. I'm going to make this positive and make this a plus. I'm just going to do that because when you use your formula and this leading guy is negative, it leads to problems for a lot of students. So I'm just going to do that just to make it easier. Maybe you don't need to do that. It's really up to you. It's personal preference. So I'm going to square both sides. This negative getting squared, it's just going to go away, right? A -1 squared is just +1, so it's gone. So now we just have 4x plus 1 here. And this equals, now I can use my formula and it's a lot easier. 2 squared is going to be 4. Then plus 2 times this guy times this guy. So that's 4 times square root of 3 minus x. Then plus this guy being squared is just 3 minus x. You just get the radicand. Okay, let me clean up as much as I can. So on this side, 4 plus 3 would be 7. And then plus your 4 times square root of 3 minus x, and then minus x. Let's put our equals, and then over here we have 4x plus 1. So let's say we're going to add x to both sides. Let's cancel this. Let's subtract 7 away from each side. Let's cancel this. And so we'll have 4x plus x, that's 5x. And then 1 minus 7 is going to be -6. And so this is equal to, you have 4 times the square root of 3 minus x. All right, now here comes a personal decision. It's more work if you leave the 4 here on this side, but if you divide both sides by 4, it's going to be more work on this side. So it's up to you. I'm just going to square both sides as it is and just deal with it like that. But again, if you want to do it another way, whatever you want to do. So for this guy, I'm going to square this. This is going to be 25x squared. Then minus 2 times this guy times this guy. 2 times 5 is 10. 10 times 6 is 60. So this is 60x. And then plus 6 squared is 36. And this equals, you have to square 4, that's 16. And then times squaring this guy would give you 3 minus x. Make sure to wrap that in parentheses. From here, 16 times 3 is 48. And then minus 16 times x is 16x. So 48 minus 16x. So let's drag that up here. And let's subtract 48 away from each side of the equation. This will cancel. Let's add 16x to both sides of the equation. This will cancel. So this will be 0. And so you're going to have 25x squared, -60 plus 16. That's going to be -44. Then times x. 36 minus 48 would be -12. And this equals 0. You could use the quadratic formula here if you want. It is a little bit tedious to factor this, but I think it's not that bad overall. So 25 is 1 times 25, or it's 5 times 5. 1 times 25 is probably not going to work. I actually don't know. I haven't factored this yet. I'm going to start with 5x and 5x, and maybe that's wrong. We'll just see. So for this guy, it's a negative. So I know I'm going to subtract, and I'm trying to get to 44. Forget about the fact it's negative. Just working with absolute values. So for 12, it's 1 times 12. So you put a 12 here, it's going to be too big. Then you also have 2 times 6. If you put a 6 here and a 2 here, this would be 30. And this would be 10, so that's not going to work. Then you have 3 and 4. So if you put a 4 here and a 3 here, this would be 20 and 15. That's not going to work. So it's not 5x and 5x. So I was wrong on that. So it's going to have to be 25x and x. And again, for 12, it's not going to be 1 and 12. So if you put a 12 here, 25 times 12, that's 300. So that's way too big. And if you put the 12 here and the 1 here, that's 25 minus 12, which is 13. So that's not going to work either. So let's go to 2 and 6. So if you put the 6 here and the 2 here, 25 times 6 is 150. That's just too big. So if you put the 2 here and the 6 here, looks like we found something that would work, right? Because this is 50x and this is 6x, and 50x minus 6x would give me 44x. Again, forget about the fact that it's negative. You just play with the signs and make this a negative so that this is negative 50x. Put this as a plus so that this is plus 6x. Negative 50x plus 6x is negative 44x. So we are good to go now. Okay, so we want to say that we have 25x plus 6 is equal to 0, or x minus 2 is equal to 0. Let's subtract 6 away from each side and say 25x is equal to negative 6. Divide both sides by 25. And so this would cancel and say x is equal to negative 6 over 25. Here I would add 2 to both sides. This would cancel, and I would get a 2. All right, so let's check these. So negative 6 over 25, that's a little bit hard to check. Well, 4 times negative 6 over 25 is going to be negative 24 over 25. And then you're adding that to 1. So that's, let's say, 25 over 25. So this would be 1 over 25. Now, if I took the square root of 1 over 25, I would get 1 over 5. So this is 1/5 over here. Now, over here, you have negative 2 minus the square root of 3. Now, minus a negative is plus a positive. So plus 6 over 25. So let's say that this is 75 over 25. And 75 plus 6 is going to be 81. So this is the square root of 81 over 25. So that's going to be 9/5. So this is 9/5. I think you can see this is not going to work because this is going to be negative and this is going to be positive. But just for completeness, let's say this is negative 10/5. Well, what's going to happen is you're going to have negative 19/5 over here, right? So this does not work. This is extraneous. For the other one, you have 2. 4 times 2 is 8. 8 plus 1 is 9. The principal square root of 9 is 3. Does this equal? Over here, 3 minus 2 is 1. So the square root of 1 is 1. So you have negative 2 minus 1. That's negative 3. So this doesn't work either, right? You get 3 equals negative 3. So that's out also. So both of these guys are extraneous. So we don't have a solution, right? So we're going to go back up and say there's no solution. All right, let's take a look at question 3 now. So again, we want to solve each equation. So we'll have 1 plus the square root of 2x plus 3. This equals the square root of 4x plus 4. The first thing I'm going to do is just square both sides. So I'm going to square this side and square this side. So on this side, you do have to use your formula. So 1 squared is 1. Then plus 2 times this guy times this guy. So that's just 2 times square root of 2x plus 3. Let me extend that. And then plus this guy being squared, you just get the radicand. So that's 2x plus 3. Okay, let me slide this down just a little bit. So this will be equal to, if I square this guy, I just get the radicand. So this is 4x plus 4. All right, let me clean up as much as I can here. So on the left-hand side, you have this 1 plus 3. Let's go ahead and just say that that's going to be 4. All right, now the next thing, you'll notice that you have a 4 here and a 4 here. So you can just get rid of it from both sides. Again, it's just like you're subtracting 4 away from both sides of the equation. We can also subtract 2x away from each side of the equation. Let's get rid of that. So what I'm going to have here is 2 times the square root of 2x plus 3. This is equal to 4x minus 2x would be 2x. And now what I would do is divide both sides of the equation by 2. So this is going to cancel. So I have the square root of 2x plus 3. This equals, this cancels, you just have x. So now I have this square root isolated. That's what I want. So I'm going to square both sides again. And so this is going to give me the radicand over here. So 2x plus 3. And this will be equal to x squared. Okay, let me write this in standard form. So I'm going to subtract 2x away from each side. Let's cancel that. Let's subtract 3 away from each side. Let's cancel that. Let's put this as 0. I'm just going to flip it around and say this is x squared, then minus 2x, then minus 3, and this equals 0. So I can factor this. So this is going to be an x here and an x here. I need two integers whose sum is negative 2 and whose product is negative 3. So that's going to be negative 3 and positive 1. So negative 3 and positive 1. All right, so I'm just going to say that x minus 3 is equal to 0, then or x plus 1 is equal to 0. So I think we know at this point that x would be 3, right? Add 3 to both sides. Or x would be negative 1 if you subtract 1 away from each side. So 3 and negative 1, we need to check those guys. We have 1 plus the square root of 2 times, I'm going to start with 3, so 2 times 3 is 6, 6 plus 3 is 9. So square root of 9 is 3. And then 1 plus 3, this is a terrible 3, so let me remake that. So 1 plus 3 would be 4. So the left side would be 4. Now on the right side, you have the square root of 4 times 3 is 12, and 12 plus 4 is 16, so you'd have the square root of 16, which is 4. So you get 4 equals 4, so this is a valid solution. So thinking about negative 1, you'd have 1 plus the square root of 2 times negative 1 is going to be negative 2. Then if I add that to 3, I'm going to get positive 1. So the square root of 1 is going to be 1. So this would be 1 plus 1 or 2. Over here, you have 4 times negative 1, which is negative 4. And then negative 4 plus 4 is going to be 0. Square root of 0 is 0. So this one is extraneous. It's not going to work. So we only want x equals 3 as our solution. So coming back up, I just want x equals 3. All right, let's take a look at question 4. We want to solve each equation. So we're going to have the cube root of x squared plus 5x plus 1. And this equals the cube root of x squared plus 4x. Okay, so the idea here is that I can cube both sides immediately because you have the cube root isolated here and the cube root isolated here. So I can just immediately cube both sides. Now, when you raise both sides of an equation to an odd power, you're not going to get extraneous solutions like when you square both sides or raise both sides to the 4th power or something like that. You're not losing information. When you square both sides, you lose the fact that you could have had a negative or it could have been a positive. You're going to lose information in that process. When you cube a negative, you keep a negative. So that's why it's different. So in this case, I just get the radicand, so it's x squared plus 5x plus 1. And this equals here, I just get the radicand, so x squared plus 4x. Let me actually get rid of this. And I will check this with you, although it's not necessary. So we will say that x squared and x squared, you can get rid of those on each side. You could just subtract x squared away from each side. I would subtract 4x away from each side and subtract 1 away from each side. Let's cancel that. 5x minus 4x is x, and this equals, let me cancel this. This is going to be negative 1. So again, this solution is not going to be extraneous. We know that already because cubing both sides will not produce extraneous solutions. But we could have made a mistake when we were solving, so it's always good to check. So we can say this is the cube root of negative 1 squared plus 5 times negative 1 plus 1 is equal to the cube root of negative 1 squared plus 4 times negative 1. Okay. So over here, negative 1 squared is 1. And then essentially 5 times negative 1 is negative 5. So this is basically minus 5. And what is this? This is 1 plus 1, which is 2 minus 5. That's negative 3. So this is the cube root of negative 3, or you can say the negative of the cube root of 3. Over here, you're going to see that it's going to be the same, right? Negative 1 squared is 1. So basically, you're going to have 1, and then 4 times negative 1 is negative 4. So you'd have 1 minus 4, which is negative 3. So again, you could pull the negative out and say it's the negative of the cube root of 3. So these two sides are equal, so x equals negative 1 is valid. So coming back up, this is what I want. My x equals negative 1. Okay, let's look at question 5. Again, we want to solve each equation. So here we have the 4th root of 8x minus 3, and then plus 5, and this equals 0. Okay, so what I'm going to do is subtract 5 away from each side to start, because I want to isolate this guy. So we have the 4th root of 8x minus 3 is equal to negative 5. Now, when we work with radicals, we know that we have a specific notation for a principal square root or a principal 4th root in this case, and then a negative square root or a negative 4th root, right? Because if I said something like the square root of 4, well, this is 2. But a lot of us also know that the square root of 4 could technically be negative 2 as well, but we notate that by saying this is the negative of the square root of 4, and this is negative 2, okay? So this right here is not possible based on the notation. I'm just going to solve it with you real quick and show you that you're going to get a solution that's not valid. So let's just come through here, and I'm going to raise both sides to the 4th power, and that's going to clear this radical here. So you just get the 8x minus 3 is equal to negative 5 to the 4th power is 625. Let's actually just erase this real quick. And let's see what this does. So we're going to add 3 to both sides, cancel this. You get 8x is equal to 628. If you divide both sides by 8, you're going to get that x, let me cancel this, is equal to, if you cancel a common factor of 4, it would be 157 over 2, or you could say 78.5. Either way. So that's what x is equal to. So let me show you that this is not going to work. Let's put this down here. So you'd have the 4th root of 8 times this guy. So let me write this out. So 8 times 157 over 2. 8 divided by 2 would be 4. So this is basically 4 times 157. And what is that going to give me? It's going to be 628. So 628. And then again, minus 3. And if you subtract 3 away, you get 625. So this is the 4th root of 625. That's not equal to negative 5. It's equal to 5, right? Because this is a principal root here. So this would not work, right? You can move this out of the way here and say that this becomes 5 is equal to negative 5, which is obviously false. And so we're going to reject this as extraneous. Now, if you had something with a negative out there, then that would work, right? The negative 4th root of 625, that is by definition negative 5. All right, let's take a look at question 6. So we want to solve each equation. We have x squared minus 16x, then plus 64. This is over. We have x squared minus x minus 6. Then we have plus 1 over x minus 3. Then this equals, let me slide this down just a little bit. We have this 3x plus 21. Then this is over. X squared minus x and then minus 6. Okay, so the first thing I would do is try to factor everything and see if something's going to cancel. And then if nothing cancels, which in most cases it won't, then you're going to move on and find your LCD. So in the numerator, this is a perfect square trinomial. It's going to factor into the quantity x minus 8 squared. Now, we don't need that right now. We're going to use it when we check. So I'm just going to not factor that because it's not going to cancel with anything. But just for reference, it's x minus 8 quantity squared. Then here for x squared minus x minus 6, you need two integers whose sum is -1 and whose product is -6. So that is going to be x minus 3 and then times this quantity x plus 2. Okay, so that's going to be for here, and then also here it's the same denominator. So let me put this up here. So this x squared minus 16x plus 64. Again, if you had factored that into x minus 8 quantity squared, you'd see nothing would cancel, so then you'd have to write it again in its unfactored form. So then plus we have 1 over x minus 3. Nothing to really do there. And this equals up here, you could factor this as 3 times the quantity x plus 7. But again, it's not really going to do anything because this is not going to cancel with anything in the denominator. So we'll just leave it in its unfactored form of 3x plus 21. We'll factor it when we go to check. So here I'll put this as x minus 3, then times this quantity x plus 2. Our LCD, I think, is pretty obvious. It's going to be this guy right here. So this x minus 3, this quantity times the quantity x plus 2, and it's also over here. I think we've worked with these long enough to understand what's going to happen here. We're going to multiply everything by the LCD. So we know that the denominator here is going to cancel because it is the LCD. And the denominator here is also going to cancel. So let's write that we have x squared minus 16x plus 64. Again, if I multiply everything by the LCD, this denominator is gone. Then plus. If I multiply 1 over x minus 3 times the LCD, which is x minus 3, times x plus 2, well then this guy right here, this x minus 3 is going to cancel with this x minus 3, and I'm left with 1 times x plus 2, which is just x plus 2. So this is just x plus 2 here. And then again, when I move on over here on the right side of the equal sign, well, the denominator is going to cancel, right? So I'm just going to have the 3x plus 21. X squared, I can't really do anything with that. Let's see, you have negative 16x. Let's just go ahead and say that you have plus x. I'm going to get rid of it from right there. And then I'm going to subtract 3x away from each side. So this is going to cancel. And this is on the same side. So that's why this is a plus here and still a plus here. Okay, so just in case anybody's confused by that. Then I'm going to actually add 2. Again, it's from the same side. I'm just moving it over. Add 2 there, and then subtract 21 away from here. And I'm just stacking it up so I can just do it in one shot. So this is 0 over here on the right. So now we're going to have x squared, and then basically you have negative 16 plus 1, and then minus 3. So negative 16 minus 3 is negative 19, and then plus 1 is going to be negative 18. So this is x squared minus 18x. And then 64 plus 2 is 66, and then minus 21, that's going to be 45. And then we'll set this equal to 0. Okay, this is one you can solve using factoring. So let's go ahead and set that up. We'll put an x here and an x here. We need two integers whose sum is negative 18 and whose product is positive 45. So I would be thinking about 15 and 3, right? So you want a negative 15 and then a negative 3. Right, so negative 15 plus negative 3 is negative 18. Negative 15 times negative 3 is positive 45. So we're good to go there. All right, so now what I want to do is say that x minus 15 is equal to 0, or x minus 3 is equal to 0. Let's add 15 to both sides of the equation. This cancels. You get x is equal to 15. Over here, let's add 3 to both sides of the equation. Let's put this over there. We'll cancel this. So x could also be 3. Now, again, these are proposed solutions. We do need to check to make sure that we're not violating the domain. Okay, coming back up here, I'm going to check this in its factored form. I'm going to erase this and then put this as x minus 8 quantity squared. Just easier to check things if they're factored. This one would be 3 times the quantity x plus 7. Okay, we can immediately see that 3 is going to be a problem. Why? If you were determining your domain, let me just put this over here. So the domain, what would happen is it's the set of all x such that x is going to not be equal to, well, you'd set x minus 3 equal to 0 and you solve that and you would get 3. And you can see that you got a 3 here, right? So you have to reject that. If you plug in a 3 there, 3 minus 3 is 0, and 0 times anything is 0. So division by 0 is undefined, so that has to be rejected. The other guy is we would set x plus 2 equal to 0. We'd solve that. That's going to be negative 2. But that's not going to matter here because we don't have a negative 2 over here, right? We have a 15, and that should be valid as long as we didn't make a mistake. So let's just check the 15, make sure that we're okay. Again, at this point, if you were on a timed exam, I would probably just move on to the next question and then check it if I had time. So 15 minus 8 is 7. 7 squared is 49. This is over. Down here, 15 minus 3 is 12. And then if you look at 15 plus 2, that's 17. So 12 times 17, that's going to be 204. So this is 204. Then plus, you have 1 over 15 minus 3 is 12. Now for this one, you would multiply by 17 over 17. 17 times 12 is going to be 204. So let's erase this and just put this as 204 down here. And then up here, this is going to be 17. So now I have a common denominator, and we just want to do 17 plus 49. That's going to be 66. And this would be over the common denominator of 204. Now you can simplify this. Each guy here is divisible by 6. You divide 66 by 6, you get 11. If you divide 204, and I'm just going to write that over here because we're going to need it in a moment. If you divide 204 by 6, you're going to get 34. Okay, so we get 11 over 34 on this side. That's what I'm looking for over here. I went ahead and just wrote the 204 because we already did this one. We don't need to do it again. Up here, you would have 15 plus 7. That's 22. And 22 times 3 is 66. So 66 over 204, again, that's going to simplify to 11 over 34. So this one is a valid solution. X equals 15. Again, you have to reject 3. So coming back up, you only want this one, x equals 15. You do not want this x equals 15 or 3 because, again, 3 is an extraneous solution. It violates your domain, so you have to go with just x equals 15. Okay, let's look at question 7. So again, we want to solve each equation. So we're going to have 2x squared plus 26x plus 80. This would be over 3x squared minus 9x plus 6. Then plus, you have 1 over x minus 1. And this equals, you're going to have 2x minus 14. And this is over 3x squared minus 9x plus 6. Okay, you could, again, factor everything to start. So this up here, this 2x squared plus 26x plus 80. Let's put this in factored form now. I think we'll need it later. So basically, you could pull out a 2. That would give you x squared plus 13x plus 40 inside. Now, can we factor this? Can we find two integers whose sum is 13 and whose product is 40? Well, yeah, it's going to be 8 and 5. So this is 2 times the quantity x plus 8 times the quantity x plus 5. Down here, we can pull out a 3 immediately. That gives me x squared minus 3x plus 2. And this one, we have 3 times the quantity. This would be x. And then basically, if you think about two integers that sum to negative 3 and have a product of 2, that's going to be negative 2 and negative 1. So this is minus 1, and then x minus 2 like this. Okay, let's bring this up here like this. Now, you're going to want the unfactored form. So I'm actually going to pull a switcheroo here, and I'm going to write 2x squared plus 26x plus 80. I'm going to get rid of this from right here, and I'm just going to drag this up here. It's just easier to check when things are factored. At least it is for me. If you're using a calculator, then I guess it doesn't matter. So over here, I'm going to go plus 1 over x minus 1. Nothing I can really do with that. And then this guy over here has the same denominator, right? So I can just copy that and say it's 3 times the quantity x minus 1 times the quantity x minus 2. So basically, you could pull out a 2. So this is 2 times the quantity x minus 7. But again, it doesn't do you any good. So I'm just going to pull a switcheroo again. Let's move this up here. And let's move this down here. Let me put this in position there for later on when we come back up. Okay. I should also write these as factored. So 3 times the quantity x minus 1 times the quantity x minus 2. And let me just do that over here real quick. So 3 times the quantity x minus 1 times the quantity x minus 2. What I'm going to do from here is find my LCD. And I think we know that it's going to be this guy right here. Right? So 3 times the quantity x minus 1 times the quantity x minus 2. So it's there and there. So if you multiply both sides by the LCD, this denominator is going to cancel, and so is this one. So I can just copy this. So 2x squared plus 26x plus 80. Then plus. For this one, you have to consider you have 1 over x minus 1. It's multiplied by the LCD. So it's multiplied by 3 times the quantity x minus 1 times the quantity x minus 2. And this x minus 1 is going to cancel. So what you'll have is 3 times the quantity x minus 2. So that's 3x and then minus 6. So 3x minus 6 is what I want to put up here. Let me put the 3x minus 6. And then again, this denominator is going to cancel. So you have equals 2x minus 14. Okay, so let's simplify this. You have 26x plus 3x. That's 29x. Let me do this in one shot. So let me just put plus 3x here. And I'm just going to cancel it away from here. And again, it's a plus here because it's on the same side. Okay, so it's very important. Then here, this is on minus 6. It's going to be on the same side. So I'm just going to put minus 6 here. So I'm not changing the sign because, again, it's on the same side. So it's very important. Then over here, this is on a different side. So I'm going to move it over. So I'm going to subtract 2x away from each side. So this will cancel. And then I'm going to add 14 to both sides. So this will cancel and this will be 0. Okay, so we'll have 2x squared. And then 26x plus 3x is 29x. And then 29x minus 2x would be 27x. Then we have 80. Basically, I will go plus 14 first. That's 94. And then 94 minus 6 is going to be 88. So plus 88. And this equals 0. All right, so I'm going to solve this by factoring. If you're uncomfortable with this, again, you can always use the quadratic formula. So I'm going to think about, these are all going to be plus signs here because this is all plus. Now, the thing that makes this fast is that 2 is going to be involved in a lot of the factors of 88. Okay, and if you put a 2 here, it's got a common factor of 2, and you don't have a common factor of 2 there, so that's not possible. So in other words, 1 and 88, you could throw that away immediately because it's just too big. Okay, you could put an 88 here, but you couldn't put it here. But that's just too big. Then you have 2 and 44, which you can get rid of immediately because no matter what you put there, you'd have a common factor of 2. There's no common factor of 2 here, so that's out. So then you'd have 4 and 22, but again, it's out because both of those are even. It's not divisible by 5 or 6 or 7. You'd have to go to 8 and 11. So 8 and 11, could you make that work? The 8 cannot go here, so it'd have to be an 11 here and an 8 here. So this would be 16 plus 11, which is 27. So that one's not that bad. Okay, so I'm going to say that we have 2x plus 11 is equal to 0, then or x plus 8 is equal to 0. Let's subtract 11 away from each side. This cancels. We get 2x is equal to negative 11. Divide both sides by 2. This cancels. So you get x is equal to negative 11 halves. Over here, let's subtract 8 away from each side. Let's cancel this. So also x could be negative 8. So let's check these. So coming back up, we would first see, are we going to violate the domain? So the domain here is what? The set of all x such that x is not equal to, we'll think about x minus 1, you set that equal to 0, you solve, you get x equals 1. X minus 2, you set that equal to 0, and you solve, you get x equals 2. So the set of all x such that x is not equal to 1 or 2, well, we have negative 11 halves and negative 8. So as long as we didn't make a mistake, we're going to be good to go. Now, if I think about negative 8, that's going to make this 0 up here, right? So 0 times anything is always 0. So this would be 0 in the numerator, and then over, this would be non-zero. So this is 0 over here. I'm just working with negative 8 because I saw that right away and it's quick. So then plus, you have 1 over, you'd have negative 8 minus 1, which would be negative 9. So this is basically negative 1/9. And this equals, so over here you have negative 8 minus 7. That's negative 15. And negative 15 times 2 is negative 30. This is over. You're going to have 3 times, you have negative 8 minus 1. That's going to be negative 9. And then times, you have negative 8 minus 2. That's going to be negative 10. So what can we cancel? Well, 3 times negative 10 is negative 30, right? So essentially what I can do is say this is going to cancel with this and this. And so you're going to have 1 over negative 9, which again is going to be this negative 1/9. So this guy is valid. Okay, that's the easier one. The harder one here, because it's a fraction, is this negative 11 over 2. You could use your calculator and you could punch in negative 5.5. You could do that if you want. I'm just going to get some common denominators. I know it'll take a little bit of time, but some people will do it this way. So we'll say 2 times, we'll have negative 11 over 2, then plus, for 8, I'll write that as 16 over 2. So this is basically 5 halves. So 5 halves, and we know that 2 times 5 halves would be 5. So this is 5, and then this is multiplied by, we have a negative 11 over 2, plus 5, which I'll write as 10 over 2. So basically, this would be negative 1/2. So this I'll write as negative 5 halves, like this. Okay, in the denominator, I'm just going to do this off to the side. So we'll have 3 times, you're going to have negative 11 over 2, minus 2 over 2. I'm doing that for 1. So this would be negative 13 over 2. So negative 13 over 2. multiply that by 3, you're going to get negative 39 over 2. So negative 39 over 2. And this would be multiplied by, over here you're going to have negative 11 over 2 minus, I'll say 4 over 2. And so negative 11 minus 4 is negative 15. So this is negative 15 over 2. So negative 15 over 2. Negative times negative is positive. And so this is going to be a 4 down here. Now 39 times 15, that's 585. Okay, let me note this right here that this is going to be 585 over 4. And then I'm just going to erase this. And then essentially you have this divided by this. So I'm just going to divide it like this so it's more clean. And this equals negative 5 halves times the reciprocal of this, which is 4 over 585. And so this 4 would cancel with this 2 and give me a 2. And then basically 585 divided by 5, that's 117. So let's cancel this and put 117 here. So this is negative 2 over 117. So let's get rid of this and say this is negative 2 over 117. So then plus, over here, you have 1 over your x, which is negative 11 over 2. Then minus, we'll say 2 over 2 for 1. So this is negative 13 over 2. So negative 13 over 2. So what I'm going to do is just flip this. This will be negative 2 over 13. To get a common denominator, I'll multiply this by 9 over 9. So this will be negative 18. So negative 18 over 117. And so we'd end up with negative 20 over 117. Okay, so that's the left side. Now, is this equal to, over here, you have your 2 multiplied by your negative 11 over 2 minus, and this is a 7 here. Kind of looks like a 1, but it's a 7. So let's just say that's going to be 14 over 2. And so what is this going to give me? Negative 11 minus 14, that's negative 25. So this would be negative 25 over 2. And the 2's would cancel, so this is just negative 25. Okay, so we have negative 25. And then basically, I'm going to put this over 1. We're dividing it by this guy right here, the 585 over 4. We figured that out earlier. So this ends up being multiplication by the reciprocal. So 4 over 585. And basically what we can do at this point is cancel. We know that 585 divided by 5 is 117. So let's say this is 117. And let's say that this is 5. So we multiply and we get negative 20 over 117. So what we have here is the same value on the left as on the right. So it took a little time, but we did verify our solution here. So x could be negative 11 halves or negative 8. So coming back up, x could be negative 8 or negative 11 halves. All right, let's take a look at question 8 now. So we want to solve each inequality. So we have the square root of x minus 5. Then plus, we have our square root of x plus 7. We'll say this is less than or equal to 4. Okay, so for this type of problem, again, I recommend first figuring out what is the domain. So let me write out the domain here. And recall that in the real number system, we can't take the square root of a negative number. So you're going to take each radicand here and set it as greater than or equal to 0. So you're going to say x minus 5 is greater than or equal to 0. And then you're going to use the keyword and. We're going to say x plus 7 is greater than or equal to 0. And so for this one, you would add 5 to both sides, and you say x is greater than or equal to 5, then and. For this one, you would subtract 7 away from each side, so x is greater than or equal to negative 7. Now, because this is and, it has to work in both. So you're going to go with this one, right? If you were to draw out a little number line on this, in case you're confused, let's just say this is 0, let's say this is 5, and let's say this is negative 7. Well, what happens is the solution for this, or we say x is greater than or equal to negative 7, that looks like this. So that's all those numbers. But if I think about the x is greater than or equal to 5, well, that looks like this. So which one is more restrictive, right? It's the x is greater than or equal to 5, right? If I chose x is greater than or equal to negative 7, there's all these numbers going up to, but not including that 5, that are going to work in this one, but not this one, right? It's got to work in both. So we will say that our domain is going to be the set of all x such that x is greater than or equal to 5. Okay, so now that we have that out of the way, let me just scooch this up here. And what we're going to do is solve the related equation. So we'll have the square root of x minus 5, then plus the square root of x plus 7, and this is going to be equal to 4. Now this one's a little bit tricky because you have to move something before you can square both sides. So what I'm going to do is leave this one alone. So I'll have the square root of x minus 5 on the left. That's isolated. And this equals, I'll keep my 4 there. I'm going to subtract this away from each side. So minus the square root of x plus 7. Okay, so from here, I'm just going to square both sides now. So that's going to get rid of this radical. Unfortunately, I'll still have a radical over here. So here you just get the radicand. So it's x minus 5, and this equals, here you're going to use your formula. So 4 squared is 16. Then minus 2 times 4 is 8. Then times the square root of x plus 7. Then plus, if I square this guy, I get the radicand. So that's x plus 7. Okay, so to clean this up, you notice that you have an x here and an x here. You could subtract it away from each side. I'm just going to cancel it away. That's going to be gone. And then essentially what you have here is 16 plus 7, which is 23. So you could erase this and just put this as a 23 and then subtract it away from each side like this. And then let's say this is going to cancel over here. So negative 5 minus 23 is negative 28. And this equals negative 8 times the square root of x plus 7. Okay, now negative 28 is not divisible by 8, but it is divisible by 4. And I would get rid of the negative 2. So let's just say we're going to divide both sides by negative 4 just to make our life a little bit easier. This will cancel and give me a 7. So 7 is equal to, this will cancel and give me a 2. So this is 2 times the square root of x plus 7. So now we can just square both sides. So we'll square this side and we will square this side. That's going to give me 49 is equal to, you have to square 2, that's 4, and then times, this guy you get the radicand, but you have to wrap it in parentheses, so x plus 7, because 4 needs to multiply by that quantity. So here we'll have 49 is equal to, 4 times x is 4x, and then plus 4 times 7 is 28. I will subtract 28 away from each side of the equation, cancel this away. 49 minus 28, that's going to give me 21. So I'm going to say that this is 4x is equal to 21. Divide both sides by 4. Let's cancel this and say that x is equal to 21 over 4. So coming back, we get x is equal to 21 over 4. And let me put a little border here so we can check. So 21 over 4 minus 5, that is going to be, let's get a common denominator. So 21 over 4 minus, you'll say this is basically 20 over 4. So that's going to be 1/4. And then we're taking the square root of that. So the square root of 1/4, that's going to be 1/2. So this would be 1/2. Okay. Then we have plus. Over here, you have 21 over 4. And then plus 7. Let's write that as 28 over 4. So 21 plus 28 is 49. So this is 49 over 4. And we are taking the square root of this, and that's going to give me 7/2. So if we added these two guys together, we would get 4, right? In decimal form, it's 0.5 plus 3.5. That's obviously 4. Or with fractions, basically you already have a common denominator. So you can just say 1 plus 7 is 8 over the common denominator of 2. And so this would be that 4 is equal to 4. Okay, so this is a valid solution. I'll just check that off. Okay, so coming up here, we need to look at 5, and we need to look at 21 over 4, which is basically 5 1/4. So those are very, very close together. So I'm going to put 5 here, and I'm going to put 5 1/4, or you could say 21/4 here. But let me actually write this as 5 1/4. Because I'm going to do something a little bit different when we get to testing in these intervals. So let me call this A. That's anything less than 5. We know we're going to reject there. This is B, between 5 and 5 1/4. And this is C, which is greater than 5 1/4. Okay, let's write out A. Let's write out B. Let's write out C. Okay, let's do this like this. And we're going to go through and say that in A, it's an automatic reject. So this is going to be false because, again, x needs to be greater than or equal to 5. Right? So if it's less than 5, that doesn't work. For B, this is where it gets really tricky, right? So you need something between 5 and 5 1/4, and essentially I'm going to pick 5 1/8, okay? So that's going to be my test value. This is something where I would basically use a calculator. Let me actually get rid of this and this. We don't need this information anymore. So you're going to plug in 5.125, which is 5 1/8, there and then also there. So 5.125. Okay. So 5.125 minus 5, that's going to give you 0.125. And if I hit the square root key, I'm going to get something that's about 0.35. Now, this doesn't have to be exact. I'm just going to get something that's close. Then for this one, 5.125 plus 7, that's going to be 12.125. And if I hit the square root key, let's say that's about 3.49. So this is 3.49. So if I add these two together, are they going to be less than 4? Well, 0.35 plus 3.49, yeah, that's going to be 3.84. Now, this is an approximation, but it's far enough away from 4 that I'm confident in my answer. So I would go ahead and say that this is true. Sometimes this is just how it's going to work. Now, you could work with a fraction if you wanted to in this case to be more precise, but I think this is good enough. So I'm going to say that this is true. Now, for C, I can pick something like 6. That's a lot easier to work with. 6 minus 5 would be 1. So this is square root of 1, which is 1. Then plus, if you go 6 plus 7, that's 13. So the square root of 13, that's about 3.61. So 3.61, let's say. We can see clearly this is not going to be less than 4, right? Certainly not going to be equal to 4. It's about 4.61, and so that's not less than 4. So let's say this is false. Let's write this out. So we have x is greater than 5 and less than 5 1/4, or you could put 21 over 4. Now, would 5 be included? Would 5 1/4 or 21 fourths be included? Well, we know 21 fourths would be included. It solves a related equation, so we're going to get 4 is less than or equal to 4. That's a true statement. So we'll make that a less than or equal to. But let's think about 5. Is that going to work or is it not going to work? Well, in this case, we know that things on the left side of 5 1/4 are going to work, going down to and including this 5 because 5 is in the domain. We have to reject things that are to the left of 5 because, again, it's not going to work. We would end up taking the square root of a negative number. So this one would be included as well. And you can always plug in if you're a little bit doubtful there. 5 minus 5 is 0, so this would be 0 over here. Then 5 plus 7 is 12, and the square root of 12 is about 3.46, so that's definitely less than 4. So this would be our solution that we're looking for. So coming back, we're going to want this guy right here to say x is greater than or equal to 5 and less than or equal to 21 fourths. Again, if you're struggling with these, you can always graph them on Desmos like I showed you in the quiz and the practice test. All right, let's take a look at question 9 now. So we want to solve each equation. So we'll have the square root of negative 6 minus 2x. This is greater than the square root of 2x plus 18. Okay, so in this case, you can simplify a little bit before you start. This isn't required, but I recommend it because you'd be working with smaller numbers. So if you notice inside of the square root here, you could actually factor a 2 out. So I pull out a 2, and inside I would have negative 3 minus x. So far, everything's pretty much the same. I just factor out a 2. Then I'll put is greater than. Over here, I'll have my square root. Again, inside I'm going to factor out a 2. So we'll have this x plus 9. Now, the reason I'm doing that is because I can legally change this into the square root of 2 times the square root of negative 3 minus x. This is greater than the square root of 2 times the square root of x plus 9. So I'm going to divide both sides by the square root of 2. So let's go ahead and do that. And so I'll cancel this with this, and I'll cancel this with this, right? You can always divide both sides of an inequality by the same positive number. You're not going to change your solution set. So now, what am I going to work with? Let me get rid of this. And you can actually get rid of this original one. You don't need it anymore. You're going to say that you have the square root of negative 3 minus x, and this is greater than the square root of x plus 9. Okay, so once I have that done, I'm going to figure out what is my domain. So again, we can't have the square root of a negative number in the real number system. So I'm going to say that negative 3 minus x must be greater than or equal to 0. And then we'll say x plus 9 is greater than or equal to 0. So on this side here, I would just add x to both sides. So this is negative 3 is greater than or equal to x, or you could flip that around and say x is less than or equal to negative 3. Let me actually get rid of this from over here, and I'll just drag this up here like this. Over here, we'll subtract a 9 away from each side. So let's say that x is greater than or equal to this negative 9. Now, what we have here, you would want to actually rearrange this and say that x is going to be greater than or equal to negative 9, and then you'll say and x is less than or equal to negative 3. So you could write this as a 3-part inequality and basically say that x is greater than or equal to negative 9 like this, and then and x is less than or equal to negative 3. Okay, so we know that's our domain. Now you could write it out if you want. You could say the domain is the set of all x such that you have this x again is greater than or equal to negative 9 and less than or equal to negative 3. You don't have to do all this. I'm just doing it for the sake of the video for completeness. But again, if you're just doing this at your house, then obviously you can just do whatever you need to keep track of your domain. Okay, so the next thing I'm going to do is just replace this inequality symbol with equals, solve the related equation. So the square root of negative 3 minus x is equal to the square root of x plus 9. I'm going to square both sides of the equation. And so that gives me negative 3 minus x is equal to, over here, x plus 9. I'm going to add 3 to both sides of the equation, cancel this away. I'm going to subtract x away from each side of the equation, cancel that away. Negative x minus x is going to be negative 2x. And this equals 9 plus 3 is going to be 12. Let's divide both sides of the equation by negative 2. And so this would cancel, and we're going to say that x is equal to negative 6. Okay, so coming back up here, I'm just going to plug in a negative 6 for x. And I don't need this equation, so I can just plug it in like this and see where that gets me. So minus a negative is plus a positive. So this is negative 3 plus 6, which is 3. So this would be the square root of 3 over here. And over here, negative 6 plus 9 is 3. So you get the square root of 3 is equal to the square root of 3. So this is a valid solution. So I'm going to have negative 9, and then I'm going to have negative 6, and then I'm going to have negative 3. So let's call this A. Let's call this B, C, and D. So A is less than negative 9. And we know automatically that x must be greater than or equal to negative 9 and less than or equal to negative 3. So A is a reject. We'll say that this is false. And then similarly for D, we'll say this is false as well. So we need to test inside of B, and we need to test inside of C. So for B, you could use something like, let's say, negative 7. So you have negative 3 minus a negative 7. So minus a negative 7 is plus 7. So negative 3 plus 7 is 4. The square root of 4 is 2. So this is 2 is greater than, over here, if you had the square root of negative 7 plus 9, well, negative 7 plus 9 is 2. The square root of 2 is just the square root of 2, right? But 2 is greater than the square root of 2, so this is true. Okay. So for C, you could pick something like, let's say, negative 5. So over here, you'd have the square root of negative 3 minus a negative 5. So that's negative 3 plus 5. So that's going to be 2. This is greater than, you have the square root of negative 5 plus 9 is 4, and the square root of 4 is 2. So basically, the square root of 2 is not greater than 2, right? So this is going to be false. So this will not work. So we're looking for things in B. So in B, we're between negative 9 and negative 6. So let's say that for our solution, let me write this in a different color. So x is going to be greater than negative 9 and less than negative 6. Would negative 9 or negative 6 be included? Well, in terms of negative 6, it solves the related equation, right? So we get the same value on the left as we get on the right. Remember, it's the square root of 3 is equal to the square root of 3. But here we don't have an equal to sign, we have a greater than. So if I had the square root of 3 is greater than square root of 3, that's false, right? So negative 6 would be excluded. Now, what about negative 9? Well, that would actually be included because in this particular case, we're saying that things on the left side of negative 6 would work, right? So that's going down to and including this negative 9 because it is in the domain. But anything to the left of negative 9 has to be rejected because it's not in the domain. So this one would be a less than or equal to, and this would just be a less than. Okay, so negative 9 is included and negative 6 is not. Again, you can always plug in negative 9 and check it if you want. Here, negative 9 plus 9 would be 0, so that's square root of 0. So then over here, negative 3 minus a negative 9 is negative 3 plus 9, which is 6. And we know the square root of 6 would be greater than 0. So that's a true statement. So let's go back up. So we want this one. So x is greater than or equal to negative 9 and less than negative 6. All right, let's take a look at question 10 now. So we want to solve each inequality. And we're going to see the fourth root of 2x minus 5. This will be less than 1. Okay, so the first thing I want to do here is set the radicand as greater than or equal to 0. We have to do this because the index here is even. So we're going to say that 2x minus 5 is greater than or equal to 0. I will add 5 to both sides of the inequality. We'll cancel that and say 2x is greater than or equal to 5. Divide both sides by 2. Cancel that. We'll say x is greater than or equal to 5 halves. So we know the domain here. And let me just write this out. Again, you don't have to go through and do all this. I'm just putting it here for the sake of the video. If I was solving this problem on my own, I would just leave this. So it's the set of all x such that x is greater than or equal to 5 halves. Okay, so the next thing is to solve the related equation. So we have the fourth root of 2x minus 5. Let's make that 4 a little bit better there. This is equal to 1. You could immediately raise both sides to the fourth power since this guy is already isolated. So you would have the radicand here. So 2x minus 5 is equal to 1 to the fourth power is 1. You would add 5 to both sides of the equation. Let's cancel that. We'll come up here and say 2x is equal to 1 plus 5 is 6. Divide both sides by 2. And so x is equal to 6 over 2, or we could say x is equal to 3. Okay, let's check that. We did raise both sides to the fourth power, so you can get extraneous solutions when that happens. So let's say x is equal to 3 here. 2 times 3 is 6. 6 minus 5 is 1, and the fourth root of 1 is 1. So this is good. So from here, I'll put 5 halves, and then here I'll put 3. So you have A, which is less than 5 halves, B between 5 halves and 3, and C greater than 3. So I'm going to write 5 halves as 2.5 just because these numbers are so close together. And basically, I'm just going to put that in A. We're going to automatically reject, right? So this is false because the domain says that x has to be greater than or equal to 5 halves. So it can be 2.5 or 5 halves, however you want to say that, or anything greater, but it can't be less than, so A is an automatic reject. So then we have B and we have C. So we just need to test in B and C. So for B, it's a little bit tricky because you need a number between 2.5 and 3. You could just take 2.75. So let me come down here. And I think this is something you just plug into your calculator. So you say it's the fourth root of 2 times 2.75. And then basically minus 5. Is this less than 1? So we just need a true or false. I'm just going to punch this into the calculator and see what I get. If your calculator doesn't have this fourth root key, you can just raise it to the 1/4 power. But make sure you wrap this in parentheses. So I get about 0.84, and that's definitely going to be less than 1. So let's say that this is true. Now, for the other guy, you would want to pick something greater than 3. So we could just pick, let's say, 4. 2 times 4 would be 8. 8 minus 5 would be 3. So this would be the fourth root of 3. Now, is this less than 1? I'm going to say no, because you could write 1 as the fourth root of 1, right? And this is the fourth root of 3, so it must be larger. If that's confusing for you, you can just punch this into the calculator, and you'll get about 1.32. So that's clearly not less than 1. So this one is false. So to think about our solution, 3 is not going to work, right? Because that gives me 1 is less than 1. That's false. But 2.5 would actually work because things on the left side of 3, those work, right? When we're in B, that's going to be going down to this 2.5 or 5 halves. And you can always plug this in. You would get a 0 over here, right? And 0 is less than 1. So that's a true statement. So we would say that x is greater than or equal to 5 halves and less than this 3. Let me make this a little bit better. So that's what we're going to be looking for. So coming back up, we want this one. So x is greater than or equal to 5 halves and less than 3. All right, let's take a look at question 11. So we want to solve each inequality. So we have the square root of x squared and then minus 4x and then plus 3. Let's extend this a little bit. This is greater than this 2x minus 3. So this type of problem is a bit tedious because you do need to first solve a quadratic inequality. Again, in the real number system, the radicand here for this square root needs to be non-negative, or you could say greater than or equal to 0. So I have to say that x squared minus 4x plus 3 is greater than or equal to 0. So we need to solve this. I'm just going to factor the left side and see what that gives me. So this is x and this is x, two integers that sum to -4 and have a product of positive 3. That's going to be -3 and -1. Now you would set this left side as equal to 0. I think we know that x here would be 3. Let me just write that down. So x would be 3 or x would be 1. Again, that comes from me setting x minus 3 equal to 0, and then also from setting x minus 1 equal to 0 and solving those two equations. So these are your critical values. So let's put a 1 here and a 3 here. Let's call this A, let's call this B, and let's call this C. Because this is non-strict, and this is a quadratic inequality, the 1 and the 3 will both be included in our solution. So for region A, I would work with 0. So you're going to plug that in there, and then also there. And again, all you're doing here is thinking about the sign, or you can get the value. It's up to you. But essentially here, this would be -3, and this would be -1. Well, negative times negative is positive. It's going to be a positive 3, and this is going to be greater than 0. So for A, you could just say that it's going to be true, or things are going to work. So let's say true. Let me write out B and C here just so we can have them. For B, I would pick maybe 2. It's easy to work with. So you're going to plug that in here and also here. So 2 minus 3 is -1, but more importantly, it's a negative. And then 2 minus 1 is 1, but again, more importantly, it's a positive. So you can say that you have -1 times +1, which is -1, or you can just say you have a negative, which is not going to be greater than 0. So this is going to be false. Then in region C, I could pick something like, let's say 4. So let's say 4. And so for this one, 4 minus 3 is 1, and here 4 minus 1 is 3. So again, you get a positive times a positive, which is positive, or you could say you have 1 times 3, which is 3. So either way, that's going to be greater than 0, so this is true. Okay, so we can write our solution now and just say that x is going to be anything in A, and again, the critical value of 1 is included. So we'll say this is less than or equal to 1, then or. We'll also say x can be anything in C, including that critical value of 3. So it's greater than or equal to 3. Okay, so coming back here, I'm just going to say that my domain is the set of all x such that, And then we're going to list this guy right here. So x is less than or equal to 1, or x is greater than or equal to 3. And so from here, what I want to do is replace this inequality symbol with equals and solve the resulting equation. So we're going to have the square root of x squared, and then minus 4x, and then plus 3 is equal to 2x minus 3. All right, from here, I'm going to square both sides. And so on the left, that gives me the radicand. So I get x squared minus 4x, and then plus 3. And this equals, if you square this right-hand side, you use your formula. So 2x being squared is 4x squared. Then minus 2 times 2x times 3. So 2 times 2 is 4. 4 times 3 is 12, and then times x. And then plus 3 squared is 9. Let's subtract x squared away from each side of the equation. This will cancel. Let's add 4x to both sides of the equation. So this will cancel. Let's subtract 3 away from each side of the equation. This would cancel. So this is 0 over here. I'm just going to flip it around since I like my variable to be on the left. So 4x squared minus x squared is going to be 3x squared. Then negative 12x plus 4x would be negative 8x. And then 9 minus 3 is going to be 6, and this equals 0. Now I'm going to tell you in advance that this is not going to be something you can factor. You can use the quadratic formula here, but what you're going to find is that you're going to get two non-real complex solutions. And in this particular case, because we're working with the real number system, these solutions aren't going to do us any good, okay? I'm just going to go through this in case you got stuck on this part, but essentially this is your A, this is your B, and this is your C, right? So the quadratic formula is x is equal to, the negative of negative 8 is 8, then plus or minus the square root of b squared. So negative 8 squared is 64, then minus 4 times A is 3, then times C, which is 6. And 4 times 3 is 12. 12 times 6 is 72. So basically here you have 64 minus 72, which is going to be negative 8. Okay, and we'll fix that in a moment. Let's put this over. 2a, a here is 3. So we'll say that this is over 6. So for this one, you can pull out the negative, and you could also pull out the square root of 4 is 2. So really you could pull out a 2i. You could say this is 2i times the square root of 2. Okay. Now you could cancel a common factor of 2 between the numerator and denominator. So let me just show that really quickly, just so we get a complete answer, even though we're not going to use it. So we'll say x is equal to, factor out of the 2. We have 4 plus or minus I times the square root of 2. This would be over 2 times 3. Let's cancel this with this, and we'll say our answer is x is equal to 4 plus or minus I times the square root of 2 over 3. But again, this doesn't do us any good because we're working with the real number system. So what we have to do is think about where this guy is going to be defined. So it's defined where x is less than or equal to 1, or where x is greater than or equal to 3. So we're just going to test there and see what we get. And then I'll show you on Desmos how you can look at this graphically. So looking at this guy again, I'm just going to use a 1 and a 3. I'll say this is A, I'll say this is B, and I'll say this is C. So for A, when I think about it, I could pick something like, let's say 0. And if you plugged in a 0, let me come down here and do this. If you plugged in a 0, you'd have the square root of 0 squared is 0 minus 4 times 0 is 0. So this is 0, then plus 3. So this is the square root of 3. Is that greater than 2 times 0 is 0? So you basically have negative 3. Well, yeah, the square root of 3 is positive, and then negative 3 is obviously negative. So a positive is greater than a negative. So for A, we'll just say that's going to be true. Now in B, this is an automatic reject, right? Because we're not in the domain of this guy. So we'll just say that this is false. Then for C, we just need to test. And let's pick something like, let's say 4. So you would have 4 squared, which is 16, minus 4 times 4, which is 16. So that's 0. So you're back to your square root of 3 here. Is this greater than 2 times 4 is 8, and then 8 minus 3 is 5. So obviously this is going to be false. And so we would say that our answer here is going to involve region A. So we would say x is less than 1. Now, could x be equal to 1? Remember, if it's 1, this side right here is going to be 0, right? Because this is basically going to be the square root of 0, which is 0. So over here, you'd have 2 times 1, which is 2, and then minus 3, which is negative 1. So is 0 greater than negative 1? Yes. So this would be included, right? So x is less than or equal to 1. So coming back up, we want to circle this one. X is less than or equal to 1. Now, for those of you who are lost on this problem or you just can't quite get it, you can always, again, go to Desmos and you can graph each piece and just think about what's going on. We are saying, where is this guy in red, which is the square root of x squared minus 4x plus 3? Where is that greater than this 2x minus 3, which is just a line? Well, if you look at it, anything starting with this guy right here, which is at 1, 0, right? So an x value of 1, a y value of 0. From there, in anything going to the left, this red graph is above this blue graph, right? So that's where it would be true, and that's what we found. Now, anything where we talk about 3 or to the right, it doesn't work, right? You can see that the red graph is below the blue graph. You can also see that they're never going to intersect, and that's why we couldn't get a solution in the real number system when we set the square root of x squared minus 4x plus 3 equal to 2x minus 3. So that's what's going on. If you're a little bit lost in these types of problems, I know they're difficult, but you can always go to desmos.com and then think about what's going on. All right, let's take a look at question 12 now. So again, we want to solve each inequality. So we have the square root of 2x squared plus 13x minus 7. And this will be greater than 2x minus 1. Okay, so once again, we have another example where we have a quadratic that's underneath the square root symbol. So we have to do a bit of work here. We have to say that 2x squared plus 13x minus 7 is greater than or equal to 0. So first we have to solve this so we can figure out our domain. And so this is something you can factor. I'm going to set this up here. And let's just set it equal to 0. You can put greater than or equal to 0 if you want. You just have to know that you have to set each piece equal to 0 and solve to get your critical values. So this would be a 2x here and an x here. Now, for 7, it's a prime number. So if you put the 7 here and a 1 here, this would be 14. And then minus 1 would get me to 13. Let's make this a plus and this a minus. So that's what we want, right? This would be 14x minus x will give me 13x. Okay. So you have to say that 2x minus 1 is equal to 0, or x plus 7 is equal to 0. So I'm going to add 1 to both sides. This would cancel. You'll get 2x is equal to 1. Divide both sides by 2. This will cancel. So you're going to get x is equal to 1/2. And then over here, just subtract 7 away from each side. So or negative 7. Okay, so we just need the critical values there. We don't care about anything else. And let's put this as negative 7, and this as 1/2. This is A. This is B, and this is C. So for anything less than negative 7, let's just pick something like maybe negative 8 and just plug in and see again, is this positive or negative, or you can just calculate it. It doesn't matter. If you have a calculator, then it's pretty quick either way. So we'll put a negative 8 in there. So 2 times negative 8 is negative 16, and negative 16 minus 1 is going to be negative 17. So this would be a negative 17, or again, you could just say it's a negative. Here, negative 8 plus 7 is going to be negative 1. So this guy right here would be 17, and 17 is going to be greater than 0. So you can say that A is going to be true. Again, you can also just figure out that it's positive, and a positive is always greater than 0. Okay, so for B, we're going to pick 0. I think that's pretty easy to work with. So let me get rid of this and get rid of this and just say this is a 0 going in here and here. So essentially you have negative 1 times 7, which is negative 7. But more importantly, it's a negative, and that's not greater than 0. So this is going to be false. Okay, for C, let's pick 1. I think that would be nice and easy to work with. So 2 times 1 is 2, and then minus 1 is 1. And then over here, 1 plus 7 is 8. So again, you have a positive times a positive. So it's a positive, and so that's going to be greater than 0, or you can say 8 is greater than 0, whatever you want to do. So this is true. Now, because this is non-strict, again, the negative 7 and the 1/2 will be included. So what we'll do is say that x can be less than or equal to negative 7, or x can be greater than or equal to 1/2. Okay, so coming back, let me write out the domain. So we'll say the domain is the set of all x such that, and then I'll just drag this into here. So again, we're saying that x is less than or equal to negative 7, or x is greater than or equal to 1/2. And then essentially from here, I'm just going to replace my inequality symbol with an equal symbol and solve. So we're going to say the square root of 2x squared, and then plus 13x, and then minus 7. This is going to be equal to 2x minus 1. So what I would do is square both sides immediately. And let's see where that gets us. So here I'd have the radicand. So 2x squared, and then plus 13x, and then minus 7. And this equals, if I square 2x, I get 4x squared. And then minus 2 times this guy times this guy. So 2 times 2x is 4x. Then times 1 is still 4x. And then plus 1 being squared is 1. All right, what I'm going to do is subtract 2x squared away from each side of the equation. Let's cancel this. I'll subtract 13x away from each side. Let's cancel this, and let's add 7 to both sides. Let's cancel this. Let's say this is 0. Okay, I'm going to flip this around and say 4x squared minus 2x squared is 2x squared. And then negative 4x minus 13x is negative 17x. And then 1 plus 7 is going to be 8. And of course, this equals 0. All right, so we can solve this one using factoring. Again, you can use the quadratic formula if you want. So for 2, it's prime. So I'm going to go 2x and then x. Now this is a plus here, right? And this is a minus here. So I know this is minus and this is minus. But again, I'm going to think about this in terms of absolute value, and I'm trying to add to get to 17. So for 8, it's either 1 times 8 or it's 2 times 4. Now it can't be 2 times 4 because you'd have a common factor of 2 no matter what you did. So it has to be 1 and 8, and you'd have to put the 8 here and the 1 here. So this is going to be negative 16x, and this is going to be negative x. So negative 16x plus negative x is negative 17x. So that one's actually not that bad. You didn't even need to play with the signs. So what I would do here is just set 2x minus 1 equal to 0, then or x minus 8 equal to 0. Let's add 1 to both sides. This cancels. You get 2x is equal to 1. Divide both sides by 2. This cancels. So you have x is equal to a half. So let's say that x is 1/2. Over here, add 8 to both sides, you get x equals 8. So or x equals 8. Now again, we squared both sides of an equation, so we do need to check. So coming back up here, let's just say this is the square root of. If you do 1/2 squared, you get a 4th. And then 2 times a 4th would be back to a half. And then basically plus 13 times a half is 13 over 2. And then minus, let's just say this is 14 over 2 for 7. So if you do 1 plus 13, that's 14. And 14 minus 14 is going to be 0, right? So 0 over 2 would be 0. So this would be the square root of 0, which is 0. And this equals 2 times a half is 1. 1 minus 1 is 0. So this one's valid, right? You get 0 equals 0. Now for 8, it's a little bit harder to check. So 8 squared is 64, and 2 times 64 is 128. And then this is plus 13 times 8, that's 104, and then minus 7. So 128 plus 104, that's 232. If you subtract away 7, you get 225. And the square root of 225 is 15. So this is 15. Now over here, 2 times 8 is going to be 16. 16 minus 1 is 15, so this one works as well. So we have these two solutions here, 1/2 and then 8. All right, let's come down to this number line here. I've written things in a more compact way so we can try to fit everything. This one's pretty hard to check. So basically, you're going to have a critical value of negative 7. So that's the furthest to the left. Then you have a critical value of 1/2. And then you have a critical value of 8. Okay, so this is going to give us 4 regions. So A, B, C, and D. So A is less than negative 7. Let's write that over here. You're going to have B, which is between negative 7 and a half. We know that violates the domain. So I'm just going to write false here. We don't need to check that. Then we can say we have C between a half and 8. And then we have D, which is greater than 8. Now, when we're checking this, we're probably going to have an easier time working with a factored form. So let's say this is 2x squared plus 13x minus 7. Again, if I factor this, we did this earlier. This is 2x and this is x. You would want a plus 7 here and a minus 1 here. So let's get rid of this. And let's put this as the quantity 2x minus 1 times the quantity x plus 7. Okay, so now we're just going to grab some values. And so for the first region, let's say region A, I'm just going to pick negative 8. So we're going to have the square root of 2 times negative 8 and then minus 1. And this would be negative 8 and then plus 7. This should be greater than, we have 2 times negative 8 and then minus 1. Okay, so let's crank this out. 2 times negative 8 is going to be negative 16, and negative 16 minus 1 would be negative 17. So this would be negative 17. Negative 8 plus 7 is going to be negative 1. So basically, this would be the square root of 17. Over here, 2 times negative 8 is negative 16, and negative 16 minus 1 is negative 17. So this right here is the square root of 17, which is positive, is greater than negative 17, which is obviously negative. So this is a true statement. So coming back up here, I'll say things in A are going to work. Let me make this U a little bit better. All right, for C, that's between a half and 8. So you can pick whatever you want. I'm just going to pick 1. So let's set this up. We have 2 times 1 minus 1. And then we have 1 plus 7. Remember, we're plugging in a 1 for x. So then this should be greater than 2 times 1 minus 1. So 2 times 1 is 2, and then minus 1 is going to be 1. So this is 1 right here, and then 1 plus 7 is going to be 8. Now, in terms of this, this would be 8, and of course, this is 4 times 2, and the square root of 4 is 2. So this is 2 times square root of 2. So 2 times square root of 2. Over here, 2 times 1 is 2, and then minus 1 would be 1. Now, I think that you know that 2 times square root of 2 is greater than 1. But in case you didn't, 2 times square root of 2, if you punch that into your calculator, it's going to be about 2.83, let's say. So obviously that's greater than 1, so we'll just say that this is going to be true. Coming back up, we want to check something in D, so I'm just going to pick 9. So we'll say the square root of this 2 times 9, then minus 1, and then over here, it's going to be 9 plus 7, and this is greater than 2 times 9, and then minus 1. So 2 times 9 is 18. 18 minus 1 is going to be 17. So this right here is 17, and then 9 plus 7 is 16. Now you could obviously simplify this and say it's 4 times the square root of 17, and I got this because the square root of 16 is 4, so I just pulled it out. But I'm actually going to multiply these two numbers together. 17 times 16 is 272, and I'll show you why I'm doing that in a moment. So over here, 2 times 9 is going to be 18, and 18 minus 1 is 17. So this is 17. Now, if I wanted to compare these guys with the square root symbol, then what I could do is actually square 17. I think a lot of you know that's 289, and I could just take the square root of that to get it back to 17. But again, I'm just comparing this in this form, so it's obvious here. The square root of 272 is not going to be greater than the square root of 289. So this is something you could do if you didn't have a calculator. Most of us have a calculator, but if you didn't, you could do something like this. Otherwise, you could just punch this into your calculator and say 4 times square root of 17. So that's going to be about 16 point, let's say 49. Again, depending on how specific you want it to be, you could say it's 16.5 if you wanted to round it that way. But essentially, I'm just going to erase this and say that this is going to be false. So things in D will not work. Okay, so now let's put our solution together. We know that things in A work. So we're going to say that x is going to be less than negative 7. I will consider negative 7 in a moment. Then I'm going to put OR. We know that things in C are going to work. So for C, we're between 1/2 and 8. So x is going to be greater than 1/2 and less than 8. Now, 1/2 and 8 would definitely be excluded. How do we know that? Remember, when we solved the related equation, 1/2 was the solution, and so was 8. So you'd have the same value on the left as you have on the right, and you have a strict inequality, so these would be excluded. In terms of negative 7, you could just plug in and see if it works. So if you put in a negative 7 right there, negative 7 plus 7 is 0. Okay? 0 times whatever this is 0. The square root of 0 is 0. So this left side here would be 0. This side over here, 2 times negative 7, is going to be negative 14. And then negative 14 minus 1 is negative 15. So you would have 0 is greater than negative 15, which is true. Okay, so this would be a less than or equal to here. But again, these would stay strict, right? There would be a less than and then a less than. So this is what we're looking for. So we want this answer right here, which is x is less than or equal to negative 7, or x is greater than 1/2 and less than 8. Okay, so once again, this is a harder problem. So I recommend if you're struggling with this or you can't really get your head around it, you can visit GreeneMath.com and see what's going on, just like we did in the last example. So we have over here the square root of 2x squared plus 13x minus 7. That's in red. And then in blue, we have 2x minus 1. So let's think about our solution. We said first off that x could be anything that's less than or equal to negative 7. So if we come over here, we see that this red graph here, where x is negative 7, is above where this blue graph is way down here. Okay, so that down here, you can see it's where x is negative 7 and y is going to be negative 15, versus up here, you can see when x is negative 7, y is 0. Okay, so clearly the guy in red is above or greater than the guy in blue. So coming over to the other side, we know that where x is 1/2, that's where we're defined again. So at 1/2, these guys are actually equal, right? So here's at 1/2, that's where they cross. And then they also cross when x is 8, right? So we saw that from solving the related equation. So if you're between 1/2 and 8, basically the red guy is going to be above the blue guy. But once you get past 8, right, it's not going to be that way anymore. The blue guy is above the red guy. So that's how we got our full solution. Again, x could be anything that's negative 7 or less. And then x could also be between 1/2 and 8. Again, 1/2 and 8 are excluded because that's where they're equal to each other. So again, if you're having trouble, just visit GreeneMath.com, punch in each part, and then think about what's going on. All right, let's take a look at question 13 now. So we want to solve each inequality. We have 2x minus 1 over 3x plus 4, and this is less than 5. So when you're solving a rational inequality, you want to put a single rational expression on one side, then your inequality symbol, then 0 on the other side. So what I'm going to do is subtract 5 away from each side. So I'm going to say this is 2x minus 1 over 3x plus 4. And then we'll subtract away 5 again from each side, and this is less than 0. You can actually get rid of this one now. You don't need it anymore. And essentially what you want to do here is just get a common denominator. So I'm just going to multiply this by the quantity 3x plus 4 over this 3x plus 4. So we'll say we have 2x minus 1 and then minus. Here's where you have to be really, really careful. You're subtracting this whole thing away. So you can use brackets or parentheses or something like that. 5 times 3x is 15x. And then plus 5 times 4 is going to be 20. Let's close this down. Let's put this over your common denominator, which is 3x plus 4. Now, let's go ahead and say this is less than 0. So over here, we'll say this is 2x minus 1. And then basically, you're going to distribute this negative to each term inside of the brackets. So this is minus 15x and then minus 20. And this would be over your 3x plus 4. And again, this is less than 0. So to finish this part up, 2x minus 15x would be negative 13x. And then negative 1 minus 20 would be minus 21. And this is over your 3x plus 4. And then this is less than 0. Now, what you could do, if you don't like having a leading coefficient that's negative here, you could actually factor out a negative. So you could say this is negative 1 times the quantity 13x plus 21 like this. And then I could multiply both sides by negative 1 to get rid of this. But remember, you have to flip the direction of the inequality symbol. So I'm going to multiply this side by negative 1 and this side by negative 1. And these negatives are going to cancel over here. So this is gone. And then over here, 0 times negative 1 is still 0. But you have to flip the direction of the inequality symbol like this. Okay, so I think this is a little bit easier to work with. If you don't want to do that, you don't have to. It's just basic personal preference. Now, at this point, what I'm going to do is set the numerator equal to 0 and solve that. And then I'm going to set the denominator equal to 0 and solve that. So I'm going to say that 13x plus 21 is equal to 0. And then I'm going to say that 3x plus 4 is equal to 0. Let's solve this one first. So I'll subtract 21 away from each side. Let's cancel that. We'll say this is 13x is equal to negative 21. Let's divide both sides of the equation by 13. We'll cancel that and say x is equal to negative 21 over 13. So that's going to be one critical value here. And I want to note that this is going to be excluded because this makes the numerator 0. So you get 0 over here is greater than 0, which is false. The other critical value, we would say that, again, 3x plus 4 is equal to 0. I would subtract 4 away from each side and cancel this. You get 3x is equal to negative 4. Divide both sides by 3. This cancels. And so you get x is equal to negative 4/3. Now, I would specifically note this if I was on a test or something where we would say that negative 4/3 is not in the domain because it makes the denominator 0. So you can note this. Again, if you're just working this problem on your own, you already know that this guy's not going to work and this guy's not going to work. So you can just make yourself a little note and say neither one of these critical values is going to work. So the domain would be the set of all x, and we'll say such that x is not equal to this negative 4/3. All right, so coming back down here to the number line, I had to rewrite some things to get it to fit. But basically, we want to put this negative 21 over 13 here all the way to the left, and then your negative 4/3 here on the right. And then let's say this is A, this is B, and this is C, right? So we need a test inside of each. And maybe because this is such a tight window, I'll get rid of these things here. We know the domain, we know the critical values, and we know none of these critical values are going to work because this is a strict inequality. Okay, so let's get rid of this so we have just a little bit of room to work. And so I can say that this is A, this is B, and this is C. Okay, so in A, what do we want to pick? Well, you can pick something like, let's say negative 2. So 13 times negative 2 is negative 26. Negative 26 plus 21 is going to be negative 5. This is over. 3 times negative 2 is negative 6. And then negative 6 plus 4 is negative 2. So basically, this is a negative over a negative, which is a positive. And so if we had 5 halves or positive 5 halves, that's greater than 0, right? So this would be true. Okay, so for B, it's a tight window, but you could pick negative 3 halves, or you could say negative 1.5. So 13 times negative 1.5 That's going to be negative 19.5. Then plus 21. Let's just say that's 1.5 to keep it simple. Then for this guy, 3 times negative 1.5, that's going to be negative 4.5. And if I add 4 to that, I get negative 0.5. So the answer here would be negative 3. But more importantly, it's going to be a negative, which is not greater than 0. So let's get rid of this and say that this one is going to be false. And then for C, let's pick 0. And so this would be 21 over 4, which is positive. So a positive is greater than 0, so this is true. Okay, so let's erase this and just put our solution here. And so I would say, again, these critical values are excluded, that basically I want A and I want C. So I want to say here, let me just put this in here, that x is going to be less than negative 21 over 13, then or x is going to be greater than negative 4/3. So coming back here, I want this answer. So x is less than negative 21 over 13, or x is greater than negative 4/3. All right, let's take a look at question 14 now. So again, we want to solve each inequality. So we have 2x minus 1. This is over 8x. We're saying this is less than x plus 1. Okay, so the first thing I'm going to do is subtract x away from each side. So basically, you'll have 2x minus 1 over 8x. And I'll say this is minus x here. And then I'm going to subtract 1 away from each side, so then minus 1. And this is going to be less than 0 now. So you can get rid of this guy. So what you want to do from here, let me just slide this down just a little bit. I want to have a common denominator. So I want to multiply this by 8x over 8x. And then this guy as well. I want to multiply it by 8x over 8x. So this would give me 2x minus 1. And then minus, you have 8x times x, that's 8x squared. And then minus 8x times 1 is 8x. This would be over the common denominator of 8x, and this is less than 0. Okay, so I'm going to put negative 8x squared out in front. Then 2x minus 8x is negative 6x. And then basically I just have this minus 1, and this is over 8x, and this is less than 0. Now again, if you don't like your leading coefficient to be negative, you can use the trick from the last example. Go ahead and pull it out. So this would be 8x squared, then plus 6x, then plus 1. Close that down, put this over 8x, say this is less than 0. You're going to multiply both sides by negative 1. And so what is that going to give me? Let me get rid of this and I'll put this up here. Essentially, these negatives would cancel away, and you'd have 8x squared, then plus 6x, then plus 1. This is over 8x. And then essentially, this is going to flip because I multiplied both sides of an inequality by a negative. So this is greater than now, and 0 times anything is 0. Okay, so from here, what I want to do is set my numerator equal to 0. So 8x squared plus 6x plus 1 is equal to 0. Let's go ahead and factor this. We'll say that for 8, you do have some choices. It could be 8 and 1. So let's go 8x and x. Now for 1, and because everything's a plus here, I would just have to put a 1 here and a 1 here and see if it works. Obviously, it wouldn't, right? So that's not going to work. So the other choice here would be a 2 and a 4, right? So if I put a 4 here and a 2 here, then essentially you would have 4 plus 2, which is 6. So this would be my correct factorization. And I would just say that 4x plus 1 is equal to 0, or 2x plus 1 is equal to 0. Let's subtract 1 away from each side. This is 4x is equal to negative 1. Let's divide both sides by 4. Let's cancel this, and we'll say that x is equal to negative 1/4. Over here, let's subtract 1 away from each side. Cancel this. We get 2x is equal to negative 1. Divide both sides by 2. This cancels. And so x could be negative 1/2. So those two guys are going to make the numerator 0. And maybe you want to keep that in factored form for checking. For the denominator, if you set 8x equal to 0 and you solve that, well, you would just get x is equal to 0, right? And I would note here that the domain is the set of all x such that x is not equal to 0. Let's say this is greater than 0. We know that none of these critical values are going to work, right? 0 is excluded from the domain, so that's why that doesn't work. And then negative 1/4 or negative 1/2, that's going to make the left side 0, and 0 is not greater than 0. Okay, so let's say that this is negative 1/2, this is negative 1/4, and this is 0. Okay, you can actually get rid of this. We know nothing works. Just keep it for your notes if you need it, but for right now, we don't. So let's grab this, move this down. So I'll say this is A, this is B, C, and D. So we have some tight windows here. So essentially for A, it's anything that's less than -1/2. So what could we pick there? We could pick -1, and so you'd have 4 times -1, which is -4, and then -4 plus 1, that's going to be -3. And then over here, 2 times -1 is -2, and -2 plus 1 is going to be -1. So we know this would be a +3, right? You could just write positive if you want. It's up to you. Down here, 8 times -1 is -8. So 3 over -8 is -3/8. Is that greater than 0? No, this is false. Okay, for B, this is where it's going to get a little tricky. You need something between -1/2 and -1/4. So basically, you have -0.5 and -0.25. So you could pick something like maybe -0.3 if you just want to work with the decimal and plug it into your calculator. Let me write this out the long way. So 4 times -0.3, then plus 1, and then this is 2 times -0.3, and then plus 1, and this will be over 8 times -0.3. 4 times -0.3 is -1.2, and plus 1, that's -0.2. So I'm going to erase this and put this as -0.2. Then 2 times -0.3, that's -0.6. Then add 1, and that's 0.4. So before you go any further, this is a negative times a positive, which is going to be a negative. So let's just write that this is a negative to keep it simple. Down here, a positive times a negative is a negative. So this is a negative. Negative over negative is positive, and that's going to be greater than 0. So this is true. All right, for C, I'm going to pick -0.1. So let's write this out. 4 times -0.1, and then plus 1. And then here it's 2 times -0.1, and then plus 1. And this will be over 8 times -0.1. Again, you don't have to go through and do all of the calculations. You know this is going to be a negative. So let's just put this as a negative here. And then 4 times -0.1, that's -0.4. Then plus 1 is 0.6. Let's just put that this is positive. This is positive. 2 times -0.1, that's -0.2. Then plus 1 is 0.8, so this is positive. So you have a positive times a positive, which is a positive. And so you're going to get a positive over a negative, which is a negative, and that's not greater than 0. So this is false. All right, for D, let's just pick 1. That should be easy. So 4 times 1 is 4. Then plus 1 is 5. I'll just put that this is positive. Then 2 times 1 is 2. Plus 1 is 3. So this is positive. And we can see that 8 times 1 would be 8. So that's positive. So you have a positive over a positive, which is a positive. And so this will be greater than 0. So this is true. So again, none of the critical values are going to work here. So we'll just go ahead and say our answer is going to be anything in B. So x is greater than -1/2 and less than -1/4. Then also for D, we'll say or x is greater than 0. All right, so this is the one we want. So x is greater than -1/2 and less than -1/4, or x is greater than 0. All right, let's take a look at question 15. So again, we want to solve each inequality. So I'm going to have x minus 9, and this is over. We have x cubed, and then minus 3x squared, and then plus 3x, and then minus 1. This is greater than or equal to 0. Let me make this fraction bar a little bit better here. Now, this problem looks difficult, but really you just need to be able to factor this denominator. And if you recall, if you have something like x minus 1, quantity cubed, our formula is to cube the first guy, so it's x cubed. Then basically this is a minus 3 times this guy squared times this guy. So 3 times x squared, and then times 1, that's just going to stay as 3x squared. And then basically plus, you would have 3 times this guy times this guy squared. So basically you'd have 3 times x, and then 1 squared is just 1, and multiplying by 1 doesn't change anything. And then minus this last guy here being cubed, so that's 1. So recognizing this guy and going in reverse is the key here. So we want to actually factor this into x minus 1. So x minus 1 quantity cubed. Okay, once we have it in that format, it's pretty easy. We're just going to say that x minus 9 is equal to 0. That's obviously a solution of x is equal to 9. And I would note here that that is going to work, right? Because you'd have 0 is greater than or equal to 0, which is true. Then for the other one, you would say x minus 1. X minus 1 is equal to 0. So that has a solution of x equals 1. So x equals 1. Now for the domain, I would say it's the set of all x such that x is not equal to this one guy here. I'm going to come to the number line. Let's say this is 1 and this is 9. This is A, this is B, and this is C. So let's say we have A, B, and C. And again, we can just test, and here it's going to be pretty easy. For A, you could just use 0, right? So this would be -9, or you could just put a negative here. So then if I plugged in a 0 here, this would be -1. -1 cubed is still -1, so this would be a negative. Now, a negative over a negative is a positive, and that's going to be greater than 0, so this would be true. In B, you could pick something like, let's say 2. 2 minus 9 is -7, so this is negative. This is over. 2 minus 1 is 1. 1 cubed is 1, so this is positive. So negative over positive is negative, and that's not greater than 0, so this is false. And then in C, you could pick 10, right? So 10 minus 9 is 1. Let's put positive. And then 10 minus 1 is 9. 9 cubed is 729, but we only care that it's positive, right? So positive over positive is positive, and that's greater than 0, so this is true. Okay, so we know that 9, the value that makes the numerator 0 is going to be included, and we know that 1, the value that makes the denominator 0 is going to be excluded. So let's get rid of this, and we'll say that x is strictly less than 1, then or x is greater than or equal to 9. Coming back, I want this one, so x is less than 1, or x is greater than or equal to 9. All right, let's take a look at question 16 now. Again, we want to solve each word problem. So here we have, for a vacation trip, Max and Jasmine decided to drive. During the first part of their trip, they took the interstate where they averaged 80 miles per hour. When they got to Lamont County, traffic caused them to decrease their speed down to an average of 30 miles per hour. The distance they drove in Lamont County was 200 miles less than their distance on the interstate. What was their total driving distance? So this is actually the key. Total driving distance if they spent the same time on the interstate as they did in Lamont County. So if you got the wrong answer, you probably didn't pay attention to the question that's asked closely enough. This is, what was their total driving distance? Okay, so you have to sum the two if they spent the same time on the interstate as they did in Lamont County. Okay, so let's break this up into a little table. I've already set everything up for us. So I have interstate and Lamont, okay, and I have distance, rate, and time. So remember, distance equals rate of speed times time traveled. So for the distance, we don't know what that is, right? We just know, if we come back up here, that the distance they drove in Lamont County was 200 miles less than their distance on the interstate. So if the distance they drove on the interstate was x, then x minus 200 is the distance that they drove in Lamont County. So that's where this x and then x minus 200 comes from. We are given the rate of speed for each. Coming back, it says 80 miles per hour. This is on the interstate, and then 30 miles per hour in Lamont County. The time can be found by solving the distance formula for t, right? So distance is equal to rate times time, divide both sides by rate, and I think we can see that time is equal to distance divided by rate. So here, your distance is x divided by your rate, which is 80. Here, your distance is the quantity x minus 200 divided by your rate, which is 30. Okay, so that sets up the table. Now, getting an equation, again, it says they spent the same time on the interstate as they did in Lamont County. So we would say that x over 80, which is your time on the interstate, is equal to the x minus 200 over your 30, which is your time in Lamont County. Now, solving for x will not get you the solution. Okay, you have to sum this distance plus this distance to answer the question. So that's very important. So I'm going to cross multiply here. So you're going to have 80 times the quantity x minus 200. This will be equal to, you're going to have 30x. What I would do is divide both sides of the equation by 10, just to make this a little bit simpler. So this would cancel with this and give me 8. So you have 8 times the quantity x minus 200. And this equals 30 divided by 10 is 3. So this would be 3x. All right, so I would distribute this. This is 8x minus 8 times 200 is 1600. And this equals 3x. Let's get rid of this. I'm just going to subtract 3x away from each side of the equation. And I'm going to add 1600 to both sides of the equation. So let's cancel this and cancel this. 8x minus 3x is 5x. And this equals 1600. I would divide both sides of the equation by 5. And we'd say that x is equal to 320. Now, again, this does not tell me the answer, okay? This tells me the distance that they drove on the interstate. So this, you could cross it out and put 320. And this, you could cross this out and say 320 minus 200. That's going to be 120, right? So the answer that I'm looking for is actually the sum of these two, okay? So 320 plus 120 is 440. So coming back, I want 440 miles. If you selected 320 miles or you selected 120 miles, those are wrong because, again, it says what was their total driving distance. So, again, from the interstate and also plus the Lamont County. So that's why it's 440 miles. Now, you could go back and check to make sure you got the right answer and that the times are equal. So basically, 320 divided by 80 would be 4, so it's 4 hours on the interstate. And then basically 120 divided by 30 is also 4, so it's 4 hours in Lamont County, right? So 320 miles plus 120 miles is 440 miles. So this is the correct answer, 440 miles for the total driving distance. All right, let's take a look at question 17 now. So again, we want to solve each word problem. So at John Wayne Airport, Garfield and Odie are walking to the gate at the same rate to catch their flight to Miami, Florida. Since Garfield wants a window seat, he steps onto the moving sidewalk and continues to walk while Odie uses the stationary sidewalk. If the sidewalk moves at 1 meter per second and Garfield saves 50 seconds covering the 300-meter distance, what is their walking rate? So this is what we're trying to figure out. What is their walking rate? So I have everything set up, again, in a little table just to keep things straight. So again, we're thinking about distance equals rate of speed times time traveled. But here the distance is in terms of meters. We're used to working with miles. And the rate is in terms of meters per second versus miles per hour. And the time now is in seconds. Okay, so that's very important. So the distance, we're told for Odie and Garfield, it's going to be 300 meters, right? They're both starting at the same place and they're going to the same place. If you come back, it says covering the 300-meter distance. Okay, so they're trying to get to the plane and Garfield wants to get there faster. So that's why he uses the moving sidewalk. So the second part of this is the rate. So you see x for Odie and then x plus 1 for Garfield. So let's see why. Coming back up here, you see that they're walking at the same rate, okay? So let's say it's x meters per second. But then Garfield gets on this moving sidewalk, okay, and it moves at 1 meter per second. So basically you take that rate of x and you add 1 to that. And so that's where we get this x for Odie and this x plus 1 for Garfield. All right, so the time, again, just like we saw in the last example, we're just solving the distance formula for time. So that is going to be time is equal to distance divided by rate. And so you get 300, which is the distance, divided by x, which is the rate. And then here 300, which is the distance, divided by the quantity x plus 1, which is the rate. All right, so let's think about how to get an equation going. So we're not just going to set the two times equal to each other because we're specifically told here that Garfield saves 50 seconds. Okay, so he's going to go 50 seconds faster, get there 50 seconds sooner than Odie will. So how do we convert that over? Well, let's think about it. If we have Garfield's time, which is 300 over x plus 1, this is him going 50 seconds faster than Odie. So if I want to set it equal to Odie's time, I need to add 50 seconds to it. And now it will be equal to Odie's time, which is 300 over x. Now you could have done this in a different way. You could have said that 300 over x minus 50 is equal to this 300 over x plus 1. Again, whatever you want to do, there's no right or wrong way here. So let's multiply everything by the LCD, which would be x times the quantity x plus 1. So let's say x times the quantity x plus 1 is multiplied by this 300 over x plus 1. Then plus, you'll have 50 times x times the quantity x plus 1. And this equals, I don't know if this is going to fit. So maybe let me slide this down. I might have to simplify and then just keep going. This would be 300 over x times the quantity x plus 1. Okay, so let's go through and cancel some things. So this would cancel with this, and then this would cancel with this. So that gives me 300x, then plus, you're going to have 50x times the quantity x plus 1. I'm going to simplify that in a moment. And this equals, you're going to have 300 times the quantity x plus 1. Okay, over here, this would be 300x plus 300. Let's get rid of this and slide this up here. And this would be 50x squared plus 50x. Let's get rid of this and slide this up here. Now, you see that you have 300x on each side of the equation. Get rid of that. So basically what you're going to have is 50x squared plus 50x. And then I'm going to subtract 300 away from each side, so minus 300, and this equals 0. Now, let's think about how we could solve this. I think the quickest way to do it would be to divide everything by 50. So divide everything by 50, make these numbers a lot smaller. This would be x squared plus x, and then minus 300 divided by 50. That's going to be 6, and this equals 0 over 50 is 0. Okay, so I'm just going to solve this by factoring. Remember, we do need a check to make sure we're not violating the domain. I'm going to put an x here and an x here. And so two integers that sum to 1 and give me a product of negative 6. That's going to be positive 3 and then negative 2. So your solution here would be x is equal to negative 3. And then or x could be positive 2, right? Set x plus 3 equal to 0. You solve that, you get negative 3. Set x minus 2 equal to 0. You solve that, you get positive 2. Now, the first thing you would do is make sure that none of these solutions are extraneous. I'm going to tell you that negative 3 is something you need to reject anyway because it's not going to make any sense, but we'll talk about that in a moment. For the domain, let me just say that it's a set of all x such that x is not equal to, well, it couldn't be 0, and it also couldn't be negative 1. Now, we don't have any answers like that, so far we're okay. So the walking rate in meters per second is what we're looking for. That's x. So here, negative 3, you have to reject that. That doesn't make any sense. So you're just going to go with 2. So coming back, we would say it's 2 meters per second. Okay, so that's the correct answer. Now, if you wanted to check this, you could think about the fact that Garfield's going to save 50 seconds. So coming back here, let's just think about how long it takes for Odie and how long it takes for Garfield. Well, if this is 2 and this is 2 plus 1 or 3, well, then this is 2 and then this is 2 plus 1 or 3. So the time in seconds for Odie is 300 divided by 2 or 150 seconds. So for Odie, it's going to be 150 seconds. Then for Garfield, it's going to be what? 300 divided by 3, which is 100 seconds. So you can see that this is going to be consistent with what we're told in the problem. Garfield saves 50 seconds by getting on this moving sidewalk. So coming back up, this is the correct answer. What is their walking rate? It's going to be 2 meters per second. All right, let's take a look at question 18. So we want to solve each word problem. So we have that working together, Leslie and Lauren can mow the lawn in 20 minutes. Last week, Leslie mowed the lawn alone, but she took 4 times as long as Lauren did the week prior. How long does it take for Leslie and Lauren to mow the lawn when they work alone? This one is a little bit tricky, but I'm going to first let x be equal to the speed in terms of the amount of minutes it takes for Lauren to mow the lawn. And I'm just going to put Lauren like this. You can write the rest down for your notes if you need them. I'm going to try to fit this on this page. So I'm going to say then, we'll say 4 times that amount, or 4x, is going to be the time for Leslie. Okay, and it tells us that specifically in the problem because it says she took 4 times as long as Lauren. Okay, now, if we're working on a traditional work rate problem or rate of work problem, however you want to say that, you think about Lauren's contribution in 1 minute, okay, or 1 unit of time, and here we're working with minutes. So this is 1 over x. Then plus, what is Leslie's contribution in 1 minute? Well, it's going to be 1 over 4x. If you sum these amounts together, you get the combined amount that they would complete in 1 minute. Well, I know they complete the job in 20 minutes, so this is 1 over 20. And that's all it is, right? So we're just going to solve this equation. It's a very easy equation to solve. I would note that x can't be 0, but basically I would just multiply both sides by 20x, which is going to be your LCD here. Let me put this in the numerator. Let me just put this in the numerator for consistency, just so I can fit everything. And let's put this in the numerator as well. So I just multiplied everything by 20x. So here the x's would cancel. Here the x's would cancel. 20 divided by 4 is 5. Here the 20s would cancel. And so you get 20 plus 5, or 25, is equal to x. So immediately we know that it's going to take 25 minutes for Lauren. Now, how long is it going to take for Leslie? Well, 4 times that amount, or 100 minutes. Now, 100 minutes, if you convert that into hours and minutes, take away 60, and you get 40, right? So you took away an hour, so it's an hour and 40 minutes. So this is the answer we want. For Lauren, it's 25 minutes. That was given by x. And for Leslie, it's 4 times that amount, or 100 minutes, which converts into an hour and 40 minutes. Okay. If you want to check this, very easy. You could say, for Lauren, she does 1 over 25, that amount of that job every minute. She's going to do that for 20 minutes. So this would be 4/5, right? So she's going to do 4/5 of the job. Then if we think about Leslie, she's doing 1 over 100 of the job. She's going to do this for 20 minutes. And so this is 1/5. So 4/5 plus 1/5 is going to give me one completed job, right? The amount that Lauren does, 4/5 is a job, plus the amount that Leslie does, that's 1/5 of the job, that gives me one completed job. So this is our correct answer. Lauren is going to be 25 minutes and Leslie's going to be an hour and 40 minutes, or you could say 100 minutes.